Hi and welcome to this video. In this one, we are going to create a GraphQL API using Go, Gen, and SQLite. Very quickly before the start of the video, if you want to stay updated with the modern web development courses and content releases, please subscribe to my newsletter. The link is in the video description. Happy coding and learning. I am very happy to present to you the second video in this series of Getting Good at Go. In the first video, we created a to-do REST API with Go, Gen, and Postgres, but in this video, we are going to create a habit streak tracker using GraphQL API model or implementation. The underlying technologies for this video are Go, Gen for the framework for the backend web development framework of Golang, and for database, we are going to work with SQLite. Now, before moving forward, I want to talk about the prerequisites for this video. There aren't a lot. You don't have to be a master in Go or Gen or SQLite. In fact, you don't even have to have any experience when it comes to SQLite. I'm going to explain everything from the ground up. But I do want you to be able to create, to know how to create basic variables with Go, like write a function signature, and also be familiar with the signature or the syntax for loops and conditionals. So like these basic programming concepts, which are like universal among all programming languages. And that's it. The rest, I'm going to explain all of them because this video is actually geared towards beginners. Not only am I going to explain all of the concepts when it comes to Go and Gen, but I'm also going to explain the concepts when it comes to our RDBMS, Relational Database Management System, which is SQLite, as well as the terminologies revolving around GraphQL API. So you don't have anything to worry when it comes to having prerequisites. As long as you're just a little bit familiar with Go, you're good to go. So what is this API? What is the idea behind this? Now, this is a GraphQL API as opposed to a RESTful API that we worked on in the first project. And what is a GraphQL API? A GraphQL is a different architecture for creating APIs than a RESTful API. So the idea behind this entire video is to show you how you can come up with GraphQL API, how you can create that, what are the differences between a RESTful API or a REST API versus a GraphQL API, what are some advantages, what are some disadvantages to this. So to be able to understand all of this, you have to go through the entire video. But this is a different way of creating this communication channel between the front end and the back end. One way was REST API, so that's a different communication channel. This is another one. But nonetheless, both of these API implementations, REST and GraphQL, their main job is to provide a channel through which one backend can talk to one front end. Now, since we talk about Go, Gen, and SQLite, we're not going to actually go ahead and create a front end for this. This is purely backend, but of course, you're very welcome to add this or to create a front end using React or whatever technology you're proficient in. You can create a front end for this, but that's not the aim of this video. The aim is just to create the API implementation. So after that, you can come up with your own front end, your own design, however you want to do that. So let's jump in here and let's see what the capabilities of this GraphQL API is. I'm just going to jump in and I'm going to show you how this API is going to work and what are the different features that this API is going to have. So right here in front of us, you can see we have this VS Code. Because there is no front end, I had to show you something. So that's why I just opened this up. And I'm going to go into the terminal. Inside of the terminal, I have two different tabs open. One is Air. So we're going to use Air for this refresh of the server and building the files. And then here, it seems like I have this something that's called SQLite. So if you're not familiar with this, this is just some technology that we use in order to interact with database and in order to store information and retrieve information, aka get information back. So we're going to see how DB commands are actually written and implemented inside of this terminal. And if you are like me, you want to have something that is visual and that works visually, you can take a look at this software. So this is called Beekeeper Studio. I've installed the free version. There is a free version you can install and you can use unlimited. And there are going to be 3 tables inside of this database. We're going to have one table that we're going to use in order to store users. Then we're going to have one table for habits of users and one table for habit logs for specific users. Now let's jump in and let's create the very first user. Now, since this is a GraphQL API, there are just 2 kinds of queries that you can send, 2 kinds of requests. So either it's going to be a mutation, that means you do something on the back and you change something on the DB, or that's query, which is basically loading up information. So the post, the update, the delete, RESTful queries or RESTful requests, they are called mutations in GraphQL. We're going to jump into all of the details throughout this video. That's why this video is too long. And then when you do GET requests inside of REST API, those are called queries inside of GraphQL. Now, what I want to do here is I want to register a new user. So what I'm going to say is I want to change some data or add some data on the DB. So I am saying mutation. And now what is this register? This is basically going to create a new user. And where do these names come from? They actually come from our GraphQL specification. So I'm going to show you how you can create the specification. This is schema.graphql's file. And inside of this file, you can see we just have a lot of different structs that are actually going to help us create or send different kinds of queries and different kinds of responses. And now let's jump into the playground in order to create an account. And I'm going to explain throughout this video, I'm going to explain all of this. For now, I just want to show you the capabilities of this. So I'm going to create an account for Jane Smith. That's the name. So whenever you create an account, you need to provide the name, the email. I'm just going to say Jane-Smith. And yes, we have, I'm going to say at test.com. Yes, we have implemented all kinds of check to check for name, for the correct names. We are going to implement all kinds of check for email, for password. We're going to build a lot of utilities that are going to basically check all of these. And we're going to dive into a lot of details when those sections actually come up. For now, let's just say password. Let's say this is the password. I'm going to say pass@123. Now, this query or this mutation is still not complete because we have implemented the first part of this. This is the request part of it. So I'm sending a request to register a user who has this name, this email address, and this password. That constitutes the request. But what kind of a response do I want to select from here? Now, if you go to this specification that I've created for this, you can see for register, the kind of response that we can get is something that's called auth payload. So I could just pass in token from that auth payload. So if you just click on this, you can see it has token and it also has user. And I've just selected the token from here. Let's send this. There we go. We can see this process was successful. So if I now come to this users table, and if I refresh this table with this button, click this, there we go. So we have Jane Smith. This is the user ID of Jane Smith. This is the email. This is the password. Now that we have created an account, the next step for us is to actually go ahead and log in. So that's going to be login. That's a different mutation. And for login, we just need to pass in the email and the password. The reason that we need to log in is because this API is actually a secured, authenticated API. So as long as you don't log in, you don't have this token, you're not going to be able to do anything with this API. Now, let's go ahead and let's create a habit. So I've copied that. That's going to be create habit. when you create a habit, there are two things that are necessary. The first one is the name of the habit. Let's say morning walk. Let me pass that there. The second thing is the description of the habit. I'm going to say go for a morning walk at least 30 minutes daily. Very good. Let's move on to the next line. Now, this is the habit that I've created. Now, this is the request that I'm sending. We can also take a look at the name of this habit. So let me just move up. The name of the habit, the description of the habit as well. But if I send this like this, without adding that authorization, you can see it says unauthorized. I'm not sure who is trying to create a habit. So what we need to do is to jump inside of the headers, and in here we need to pass in a very specific string, which is called authorization. And then this is actually some specification that we need to go ahead and implement. And now with this token, this user is authorized. Now there is something that I need to clarify here. If you add a front end for this API, users will no longer have to do this. Of course, this is not like user friendly. This is developer friendly. Okay, so this is an API that you can use to create a front end for, and then users can use that front end to interact with this API. Now I'm just going to send this, and there we go. So we have created a habit. This is the name and this is the description. So whenever you see this response, that means it was successful. This creation of the habit is successful. And if I reload this, there we go. And the user ID is exactly ends with B24, which is the user ID of Jane Smith. Now, another feature of this API is that not only you can create a habit, you can also enter logs or register logs for this habit when this habit was actually completed. So let's say you want to pick up a new habit, which is this morning walk. Now, you have been doing it for the past 10 days, or you just started today. Let's say you just started today. So what you're going to do is you just went for a walk and now you want to register this. You're going to say check in habit. And for this check in habit, the only thing you need to provide is the ID of the habit. So you're going to go to the table. Here is the ID. I'm just going to copy this, come right here, put it there. So that's the ID of the habit. Now, what is this mutation going to give us? This mutation is going to give us a few things. I'm just going to select two things from those. One is going to be the completed date. The other one is going to be the created at date. So the completed date specifies when you went for the walk. That's when. But the created at date specifies when you entered this log into the DB. So these, if you enter logs into the DB every day or on the days that you went for a walk, then these two dates are going to be the same. But if you went for a walk yesterday and you forgot to enter that, or you were busy, or you said, okay, I'm going to do it like in a couple of hours, but then you forgot, but you remembered today, then the completed date and the created at date are going to be different, because created at date has nothing to do with that when you implemented the habit. It just says when this record was entered into the DB, but the completed date specifies when you completed that habit, when you went through with that habit. So I just wanted to explain these two, but in this scenario, both of them are going to be the same, but their format is different. So this is the completed date, and this is the date that should be more human readable. This specifies that today on July 3rd, I went for a walk. But I created this record on the DB on the same day. But then for that, I have a specific time component. But the habit doesn't have that time component. And I'm going to show you how you can basically get rid of or truncate that time component, because it doesn't matter. We just worry, or we just think about implementing the habit on that specific day. We don't care at what time it was implemented, as long as you did it on that day. So this is the check-in habit. Now, you can see I have not actually provided a specific date on which I went for this habit, and this completed date defaulted to today. But you can also provide a specific day. Let's say I have been going for a morning walk for the past few days. So here I'm going to say 2026-07-02, and I'm going to send this. So this is another log there. And I'm going to go into the habit logs and I'm going to refresh this, and there we go. So I went for the morning walk yesterday and I went for the morning walk today. But you can see I went for the morning walk yesterday, but I entered it into the DB today. That's why these two dates are now different. So you have users have habits, and then habits have habit logs. So the relationship that users have to habits is the same relationship that habits are going to have to habit logs. Now, that's not just what the API offers. You can also take a look at how many days consecutively you have implemented the habit. So that's something that I called longest streak. That's throughout the lifetime of the habit. Let me show it to you. And then you have something that's called current streak. And then you have another thing which is called total completions. Now, these three things, current streak, longest streak, and total completions, are not something that we store on the DB. And I explained this through this when we get to that part inside of this video. Why we don't add this to the DB. These are some calculations that we do on the fly. But nonetheless, we do have these functionalities. Now I'm going to add the 1st of July to this morning walk. So now let's say I've been going for, so I'm changing this example to actually be able to explain different aspects of this API. Now let's say I've been going for this morning walk since the start of June, but I've gone for the morning walk like 5 days in a row, but then I didn't go one day, then I went 10 days in a row, then I didn't go for a couple of days, then I went like 7 days. So tell me, in the past month, how many days did I actually go for a walk? So you could do that as well. But first, we need to actually go ahead and enter records. So I'm going to add for June 1st. I'm going to add for June 2nd, June 4th. Now, I didn't go for June 5th. This is just hypothetical. But then I went on June 6th. So there is one interruption there. There is a gap in there. June 6th, then 7th. Now, I'm not sure if I entered June 7th or not. Let's just click on this again. And you can see you get a message. You have already checked in for this habit today or on this date. So you can have just one log for one day for one habit. You cannot register 2 logs on the same day for one habit. You can't do that. So let's add 8. Let's add 9. Let's add 10, but I didn't go for a morning walk on 11 and 12. Let's go 13. Just bear with me. This is going to pay off. Don't worry about it. So this is going to be 14, but then I didn't go on 15. It's going to start on 16. You can see there is just a lot of interruptions there. And as soon as you see the DB, there's just a lot of records which are written inside of the DB, which are entered inside of the DB for just one habit for 1 month. So 21st, 22nd, 23rd, let's go 24, 25th, and 26th. But then I didn't go for a walk on 27th, 28th, then 29th. Let's say I went for a walk on 30th, and that's it. That's it. So now, if I go to the logs table, if I refresh this, there we go. So you can see this is just one habit. Imagine you have 10 habits, and for each of them you have hundreds of logs or tens of logs. How do you know which habit you implemented more consistently? So what you do is you call this habits, and what you can pass to this is something that's called total completions. Oh, I don't have autocomplete because this is no longer a mutation. This is a query. So we created information. Now what we want to do is we want to load information. Therefore, I changed the mutation keyword to query. And this is called total completions. Now, as soon as I send this, this is going to show me the habits that I have, and it's also going to show me the number of completions, the number of times I've actually went outside of the house and I went for a walk. So I went for a walk for 24 different days. Now, I want to take a look at my streaks. So for that, we could also use streak here, but I want to show you another query that we have, and that query is going to accept the ID of that specific habit. So if I come to the habit, we know that this is the habit for which we created all of these logs. I'm just going to pass it there, and I'm going to create these curly braces. Let's say I want to know the name of the habit, right? What is the name of the habit? What is total completions? What is the current streak? And what is the longest streak? So let me do current streak and longest streak. And I'm going to explain what current streak is and what longest streak is. So take a look at this. We have 24 days in which we went for a walk. I went for a morning walk. The current streak is 4. So current streak inside of this API starts either from today or yesterday. Since I went for a morning walk today, it starts from today and it goes back in time. So it starts from the newest day, which is today, goes back in time, and it counts days one by one. And as soon as it hits a gap or an interruption, it basically meaning when there is a missing day, it just concludes the calculations. So it went July 3rd, July 2nd, July 1st, and what is the other day? June 30th. And then we don't have anything for June 29th. Therefore, it just stopped there. So take a look at this. If I just do this, so let's come to the end. See, we have July 3rd, July 2nd, July 1st, and June 30th. Therefore, how many days do we have here? We just have 4 consecutive days that start either from today or yesterday. So that constitutes the current streak. But then why don't we count 25, 24, 23? Because before 30th, do we have 25? No, it's 29. And then 28, and then 27, and then 26. So these are gaps. That's why current streak is ending. And that's why it's called current streak, because it starts from today or yesterday. But what is longest streak? Well, longest streak takes a look at the entire lifetime of this habit and how many logs there are. And it takes a look at how many days you went consecutively for a walk and basically the longest that you went without breaking that habit. So the longest that I've gone for a morning walk was 10 days in a row. That's the longest streak. That's the basic explanation for that. And that was, I believe, when we started at 17. So see, take a look at this, 17, 18, 19, 20, 21, 22, 23. So this is a very good streak. And then we go to 24, 25. There we go. See, from 16th to 25. That's the longest streak. I don't have any gaps in here. This is the longest I've gone without breaking this habit. That's why it's called longest streak. So this is the entire API implementation. And of course, this is completely authenticated. No user can create habit for another user. No user can take a look at the habits of another user. Everything is private. Everything is authenticated. No user can create, delete, or update habits or logs from other users. Everyone is just confined to their own part of this API. And finally, what I want to show you inside of this introduction for this project is if you delete the user is going to delete their habits automatically. We are going to implement the pragma foreign key relationships of SQLite. Since this is a little bit more tricky and complicated in SQLite as opposed to Postgres, I'm going to go through all of the details of how you can implement this. Now with Postgres, this was very easy to do. You just turned on some flag. But in SQLite, that's a little bit more complicated than Postgres. but nonetheless, I'm going to show you how you can actually do this. So if you delete one record inside of one table, that's going to delete several records inside of one table, and those several records are in turn going to delete a lot more records inside of another table. So these are all going to be implemented. They're all going to be basically connected together, and we're going to use cascade delete. One more thing about the DB is that I'm going to show you how to implement database indexing as well. That's not something that I showed inside of Postgres, but for SQLite, we're going to create a few indexes, and we're going to talk about what is the idea behind database indexing and how it actually works. But all of these explanations are going to be for someone who has very little knowledge of these areas. So this tutorial is geared towards beginners. That's what most of my videos are. So just towards beginners. Now let's go ahead and let's delete this user. The only thing you need to do is you just write this. Because you have already attached the token, this is just going to delete the user. This is going to say true. And now if I go to, well, I didn't show you the database inside of this terminal. Well, now I've deleted everything. There is nothing in here, but we're going to take a look at this terminal a lot as well. And now if I come to here and if I refresh this, you can see user is gone. Now, because habits belong to user, habits should also go. So once I click on this refresh button, you can see the habit is gone. Now let's jump into the habit logs table, and I'm going to click on refresh, and all of the habit logs are also gone. So this actually concludes the introduction to this API. And in the next step, we are actually going to get started from the absolute basics, from the ground up, and we're going to step by step together, we're going to code this GraphQL API. So I do really hope that you follow along with this video, and I'm sure you're going to learn a lot. So let's jump in and let's get started with coding this API. Before moving forward with the setup of this API, I want to talk about prerequisites for this video. There aren't a lot of them. In fact, there is just one prerequisite, and that is some prior knowledge or some existing knowledge of the Go programming language. And what do I mean by that? I do not require you to be like an intermediate or a senior level developer when it comes to Golang or Go programming language, but what I do want you to have is the ability to create variables, to create simple functions, declare conditional statements and loops, and that's it. So even if you do not have that, I do have a series, another playlist here on YouTube that is 0 to interview ready in 5 different languages, and one of them is Golang. And what you can do is you can watch a few videos of that series and just focus on the Go part inside of that video, since I talk about other 4 languages as well. Or you can just jump into any AI chatbot and you can just start asking questions and understanding the basics of the Go programming language. And I'm pretty sure it won't take more than 30 minutes, tops. So that's the programming language that we're going to use for the HTTP requests that we make to the server, and from server when we send responses, we're going to use a framework of Golang, which is called Gen. So that's going to be the backend framework for making these calls, for handling HTTP requests and responses between the client and the GraphQL server. For our database, where we store data, where we store habits, where we store users, information, streaks, and everything that this API is about, we're going to use SQLite. Now, you don't have to know anything about the Gen framework or the SQLite database. And next up, we are going to talk about GraphQL. For GraphQL, I do not expect any prior knowledge. I'm going to explain everything from the ground up. So this is basically like a tutorial for beginners, and I just need some prior knowledge or a little bit experience with writing Go syntax. So when it comes to GraphQL, we're going to say, okay, we're going to use GraphQL in order to decide what data is requested and how it's how its response is returned. So once user asks for habit or their own information, what do they send in their request? And when then we query our database based on that request, and then we send a response. I'm going to show all of this throughout this video. That's why this is labeled for beginners. We're going to use a few other minor libraries here and there. For example, for password security, we're going to use Bcrypt. We're going to use JWT tokens for user authentication, but they're not the main focus of this video. And I want to emphasize on this. The main focus of this video is to create a GraphQL API with Gen and SQLite. That's the main focus. Other parts that we employ other libraries to help us achieve our goal, they are the secondary level of like our concentration when we go about this API. So that's the first part that we focus on. And then of course we need to talk about here and there some libraries that are going to help us accomplish our goal in a more effective way. All right, and now that we're done with the whole topic of prerequisites, let's jump in and let's get started with the setup. So the first thing that I want you to do is create a folder and open it up with VS Code. The name of the folder is going to be the name of our project. Here it is gqlgen SQLite habit streak GraphQL API. So after this, the first thing that I want to do here is actually go ahead and create a new Go project. And how do we do that? For that, we're going to go to the terminal and I'm going to wait for it to open up. Here, I'm going to say go mod init, and then I'm going to paste in the name of this directory. What this is going to do is this is going to tell Go that this is a Go project, and it's going to set up the dependency tracking for us. And this is going to create a go.mod file in which we're going to eventually put all of our dependencies. So as soon as I hit enter, you're going to see we have that go.mod file. Let me just bring this down. Let's open this up. For now, we don't have like anything significant here. This is the version of Go that we're using in order to work with this project. And above it, module gqlgen SQLite habit streak GraphQL API. That's the name of the module that we have provided. As the next step, I want to go ahead and I want to get started with the folder structure. So I'm going to close that. I'm going to create these folders and I'm going to go over what they actually mean. So the first one, these are going to be in the root of the project. So the first one is going to be called CMD. We use this folder as an entry point of the application. So what this is going to contain is going to be the main.go file that has the main configuration of our server. And inside of here, I'm going to create a new folder and I'm going to call that API. And inside of the API folder, we're going to create a new file that's going to be main.go. Now, you need to keep in mind that we're not going to provide any kind of business logic in here. When you talk about backend and you hear this term business logic, what it basically means is how you handle requests that you receive to your server. So you receive requests for some kind of data, how you do that, the code that you write in order to send a response, that's called business logic. So that's not the job of this main.go. The job of this is just to basically wire all pieces together and connect everything. So that's here. Next up, I'm just going to collapse this. I'm going to close this file. We are going to create inside of the main directory, I'm going to create a new folder and that's going to be internal. The job of this is going to be to contain all private application code. And what do I mean by that? So this is going to contain the configuration for loading environment variables. It's going to contain our database, connection setup. It's going to contain everything that's related to GraphQL API. It's going to contain middlewares, the models, repositories, utils. So this is, you can think of this as like the core of the app that we actually try to write. And I'm going to go over all of the subdirectories that we have here. So the first folder, for now, I'm just creating this folder structure. We're not actually going to go ahead and type the code until the setup is finished. Then we're going to get started with coding. So the first one is going to be called config. The job of this is to handle loading environment variables from the .env file. And that's the only thing you need to know about this. I don't want to dive into too much detail. In just a moment, after we're done, I shouldn't say in a moment, after we're done with the setup, you're going to see, okay, why we need that config and what goes inside of there. The next folder that I'm going to create is going to be called database. And this is the central point. This database folder is the central point that's going to contain the SQLite database connection setup. The next folder that I want to create is going to be graph. And yes, it's short for GraphQL. Everything GraphQL is going to be living in here. I mean, the schema definition, the root resolver, struct, all resolver files are going to be inside of this folder. I'm going to create another folder here that's going to contain all of our resolvers. And again, we are going to come back to these and you're going to understand how all of these fit together. Next up, we have another folder that's called middleware. And what is the job of this middleware? Well, this middleware is going to contain HTTP middleware that runs before requests reach the resolvers. I'm going to explain what are resolvers, what are repository operations. We're going to have like a lot of them. And that's going to be what this folder is going to do, the code that's going to be in here. Next up, I want to create another one that's going to be called models. This is going to contain pure Go structs that represent our data. The user, the habit lock. Here, we're not going to house any kind of logic. This is just going to contain the shape. As you can see in model, it contains the shape of the data as it moves through the applications. Next up, we have repositories. Now, resolvers and repositories, they work in conjunction. And I'm going to explain, okay, what is the job of a repository operation? And what is the job of a field resolver? These are like terms that we're going to work with throughout this entire video. So you don't have to worry about any of this. These are like some specific terminology that we use for Gen framework. I mean like Golang language. And then we use for GraphQL API. And I'm going to give you the distinction between like these differences as well. So here, I'm going to say repository. The job of these repository operations are to contain all of the database operations. What do I mean by this? So every SQL query in the application is going to be written here. Resolvers never write SQL directly, and they always call a repository function. The idea behind this is to keep the GraphQL layer clean and the database layer testable. So we have something that talks to the database in order to get the data. That's the repository operations. And then we need to have something that is going to calculate what kind of response is sent to the front end. And based on this thing or all of the data, the repository operations fed them. They're called resolvers. So this is how they actually work together. And again, we're going to see a ton of them in this video and you're going to be a master by the end of this video. Then I'm going to create the final folder in here, and that's going to be utils. Now, the job of this is to contain utilities. Why do we need this? Because I want to have a shared helper functions, like a folder that's going to contain shared helper functions used across multiple resolvers. I want to show you how to approach this API in a clean way from the start. I don't want to have like, we are going to refactor code here and there, but I don't want to have a lot of jumping from one branch to another. and like have a ton of confusions. So we have these utils in order to not repeat the same logic several times throughout this API. An example for this one is when a user creates a new account, you are going to have that. This is just an example that we're going to implement, but I need to like clarify, since we have config, database, graph, middleware, models, repository, what is the need for utils? We seem to have everything. So the job of utils is, for example, when user wants to sign up, you're going to have some requirements or some checks for the password, right? So you want the password to have a certain length. You want it to contain certain characters like symbols, numbers, uppercase, lowercase. All of this needs a function to be implemented. Now, we could do this several times throughout the life cycle of this API as we're creating it, or we could move it into a separate file and separate folder, which is called utils, and then keep importing this and not have to like redefine the structure or redefine the entire thing that we want to do. So we do this once inside of this utils folder, and then we keep reusing it. Okay, so that's the idea behind this. After that, what I want to do is, so for now we're done inside of the internal. The next folder that I want to create is called migrations. This is a very, very important one as well, migrations. So the job of this is very, very important. So this is going to contain something that we call SQL migrations and Go. What do I mean by migrations? So when we talk about migrations in the context of Go language and the Gen framework, what we actually say is that these migrations, they define the database schema. So you want to create a table. You don't run that specific SQL query that creates a table with predefined columns as well as some checks that you provide for every specific column. You don't run that inside of that SQLite engine that you're running inside of the terminal or wherever. You don't do that. You create a file, you put the SQL query in there, and you run this migration. So you have two kinds of migrations in this context of this API. You have something that's called an up migration that is going to apply the change. For example, it's going to create a table with some columns, let's say a user table with a column that's user ID, username, user email, user password. So that's an up migration because you're adding something. You're changing this for the better. But then if you want to reverse that change for that specific migration that you have created, that up migration, you're going to create something that's called a down migration. So an up migration changes the database. It adds a table. It doesn't add data. That's something that you need to keep in mind. When it comes to SQL databases, you have table. All of them are tables. So for tables, what do you have? You have columns and you have rows. Columns define what kind of rows you can add to that database. So rows are the data that you receive from the front end. So front end gives you the username, the user email, and the user password. You put it inside of those columns. So that's how these actually go together. But before receiving anything from the front end, you need to have this table defined. What kind of info user can send you? Can user send you their date of birth? No, we don't care about that. We just care about the username, the email, and the password. So we specify we write a SQL query that is going to take a look at, okay, I want to create a table called users, and it's going to have 4 columns. One of the columns is going to have auto-generated data. That's the user ID, but the rest of the columns, their data is going to come from the front end. That's the up migration. But then at some point in time, you're saying, okay, no, I don't want this. I want to get rid of this table. instead of going ahead and deleting the table and adding that query or writing this query inside of that database connection that you have with SQLite, you create another migration. So in this way, you have like a clean way and an understandable and an industry standard way of adding something to the database and reversing, like changing the database and then reversing that change. Now keep in mind, whenever you do something to the database, that's the up migration. The down migration must reverse only that up migration. So for every up migration, you just have one down migration. And again, down migration just reverses whatever the up migration did. It doesn't do anything else. So if the up migration creates a table called users with 3 columns, the down migration deletes the table called users with 3 columns. That's it. It doesn't do anything else. And this is something that we call version control. So the schema changes are tracked over time. That's why we do it. Instead of just writing it inside of the database connection that we have inside of the terminal, which I'm going to show you how to do that, we just do it here so we can keep track of how many changes we have done, how many migrations have we implemented. Okay, so a little bit of extra information, but this is extremely important. The next folder that's not going to be inside of migrations, again, these are going to be sibling folders. So all of them are going to be in the root directory. The next one is going to be the data folder. Perhaps the simplest of all of them is this data folder. This is just going to contain one file, and the extension of that file is going to be .db, where we store all of our data. And that's it. So you have, for this database, you're going to have different table. Each table is going to contain either habits, user information, habit logs, whatever. So that's going to be the simplest of all of these. And the final folder that I want to create is going to be scripts. Now, the idea behind the script is something that is closely related to this operating system that I'm working on, but you could do actually this if you're working, if you're like following this video on a Mac. So here I'm using, for my terminal, I'm using PowerShell. Now, instead of, when it comes to implementing migrations and some other common tasks, what I'm going to do is I'm going to have one script and I'm going to run that script, and the script is going to contain some code that is going to either implement the up migration or it's going to implement the down migration. So these migrations, they have like some code that I'm going to write in here, and then I'm just going to call this file and I'm going to give it like the up keyword after the file name. It's going to run an up migration, and then I'm going to, if I want to run a down migration, I'm just going to call the file and add a down in front of it just to run that. You could go ahead and not actually do this, but this makes our task very straightforward. Like instead of writing the entire command to implement an up migration, we just call the name of the file. So we don't have to like memorize all of this every time we run a migration. So that's the job of this scripts. And the next step that I want to go ahead and implement is to create our environment variables. So the job of environment variables is a file, that's a file. The job of it is to store sensitive information. For example, the database path, the port that the server is running on, the JWT secret that we have in order to create tokens for any new user that wants to create an account and wants to create habits, basically work with the app. So env is a file that we do not send to GitHub. When I committed this, if you take a look, if you have downloaded the code, you can see there is no .env file in there. So this is the environment variables, and I'm just going to go ahead and I'm going to create them. The first one is going to be database underscore path. Where is the database path? The reason for this is because SQLite needs to know where to create or find the database file. And you don't have to worry about this. You can create this inside of the data folder, or otherwise SQLite is going to create this automatically if it doesn't exist. This is going to be now. the env file is on the same level as the data folder. So I can just do // and I'm going to go inside of the data folder, and inside of the data folder, I'm going to have a database that's called habits.db. So this is the database path. Now keep in mind, I don't have any commas, semicolon, nothing. That's because this is an environment variables file. You don't have to do any of that. Next up, we're going to have this port that is going to specify on which port this API is going to work, or the server is going to run on. And finally, we have the JWT_secret. And this could be anything. This could be whatever you want. I'm just going to say your secret. This is going to be underscore your secret JWT underscore. I'm going to say your secure JWT secret key, and then you need to change this. I'm just going to add this here. And that's it. That's everything that I wanted to do when it came to environment variables. The next thing that I want to do is create a .get ignore file. Now, the reason you don't see the environment variables file inside of GitHub is because I have this get ignore. This is basically going to ignore everything that I pass in here. So I'm going to say ignore the env file. There is going to be a temporary script file that's going to be generated or created automatically. And then I'm going to say ignore the data folder as well. Now that we're done with the env file and the get ignore file, I'm going to jump back into the main file. What I want to do here is I want to actually go ahead and get started with a very simple route that is going to check the health of the server. So I just want to see everything has been set up perfectly fine. So let's go ahead and let's actually jump in here. Now, when it comes to these to any Go file, you need to have a specific package declared. And here it's going to be the main package. This is required. This is required for any package main. I'm just going to go down. This is required for any file. And this is going to tell us, or basically tell Go, this file is the entry point of an executable program. Some other files that are going to have other packages, but nonetheless, they're going to have some sort of a package. Here, inside of this, we're going to have a main function that is going to be the executable Go program that we are going to basically execute. So this main package requires a main function. Inside of here, we have an FMT library, which I've not imported. This is going to be imported automatically. And on there, we have this println or print line, which is going to print something to the console or to the terminal. Now, I'm not going to type this out. I'm just going to go ahead and I'm going to copy paste this. These are just some texts. And if we see them, we know, okay, that this API is working fine. And you can see this FMT was imported automatically. FMT is format, print line is just printing something to the terminal or to console. I'm going to print the other ones as well. There we go. Now, we are not actually done with the setup of this API. We are going to actually go ahead and get most of the setup, I would say, done, and then we're going to get started with the coding of this app. So for now, what I'm going to do is I'm going to jump into here. I'm going to say go run. Now, what file do I want this terminal to run? The file that's inside of CMD, inside of API, that's called CMD. There we go. That's the file. So CMD API main.go. And as soon as I run this, you can see we have these 4 sentences which are printed to the terminal. That means everything is working fine up until this point. And the next step that I want to go ahead and implement is to actually install some of the necessary or core dependencies in order to get started with this API. The first of them is going to be the Gen framework. Now, You need to keep in mind that Go has a built-in net HTTP package that can handle HTTP requests. However, this Gen framework, it provides us with a cleaner API for defining routes, handling middleware, sending JSON responses, and it is also one of the fastest Go web frameworks. That's why we're going to work with this one. So this is going to be the command that's going to go ahead and install Gen for us. We can open up go.mod file to see the changes that are going to become right here. So this is going to take just a few seconds depending on your internet connection. And we are going to see the result inside of go.mod. And there we go. This Gen framework has been installed, and you're going to see now we installed one package, but then that package depends on some other packages, and those packages, they depend on other packages. So you don't have to worry about any of these. We've installed Gen and that's it. So next up, what I want to do is, first off, let's just go ahead and clear this. I'm going to install a SQLite driver. So when it comes to SQLite itself, that's a database engine. So what do I mean by that? A database engine is the technology that reads and writes to this data where we're in here, where we're going to have a something.db file. Remember, we talked about this? So that's the engine. But then there is no direct link between the Gen framework or Go and this engine. So we need to have some kind of a driver that's going to act as a translator between our Go application and the SQLite engine. And that's why we're going to install something that's called a SQLite driver. And here it is. I'm just going to go ahead and I'm going to hit enter. This is going to go ahead and install that. And there we go. Here is this is the most famous driver. So when creating this project, I tried to take a look at the most important packages, the most famous packages, and of course the fastest ones, the ones that have long time support, so you don't face issues after like a couple of years. So that's the second package. The third one is going to be the .env package that we're going to install. The idea behind this refers back to that .env file that we have actually installed. So we need to load our env file at startup so all of our configuration values are available. And this is the package that we're going to use in order to load data and not actually show sensitive information. So I'm just going to go ahead and hit enter. I am going to come back to this go.sum. We didn't have this. It was created here. And then next up, you could go ahead and actually clean up these dependencies. For that, we have go mod tidy. I am not going to do this because this is going to remove all of the packages that are not being used inside of our code. Now, since we haven't written any kind of like code, all of these packages are just going to go ahead, but that's a command that you can go ahead and you can run. Now, we have these two files. So we have this go.mod file. The idea behind this go.mod file is to contain the dependencies. Now, if you're coming from the world of JavaScript, Node.js, this is equivalent to the package.json file. So it contains all of the packages that we have installed, their names, as well as their versions. Okay, but then we have go.sum. This is the checksums file. Now, after installing packages, Go creates or it updates a go.sum file. And this file contains cryptographic checksums for every downloaded module. Now, why is this important? This is important because this file guarantees that the exact same code is used every time the project is built on any machine. And that's the main idea that we use this. And you can think of this, again, if you're coming from the world of JavaScript, I'm sure you just got an idea. This is like the package lock.json that we have inside of the like Node.js projects or JavaScript projects that we're working with. Now, after all of this, now you know, okay, how these work. Let's go ahead and let's close these. We're going to go ahead and we're going to actually get started with creating a very simple server so we can verify that Gen is working correctly by updating this file. So how do we do that? Let me see. So I have all these 4 statements. I'm just going to keep them up above, and beneath this, we're going to go ahead and we're going to get started with this server. So there are a few things that are really technical when it comes to Gen framework and the way Go operates. So these first few lines of code, what I'm going to do is I'm going to explain these in more depth. And once you understood this, and that's in case you have no prior knowledge of Go or these topics are a little bit tricky or have always been tricky for you. So that's why I'm going to spend a little bit more time in order to explain these. And then once you understood, okay, what they are, how they work, the rest of the code throughout this video is going to make a lot more sense. So it is like a sensible decision for me to put a little bit more time here so you understand this, so we don't have to put this time the next time we write something like this, and we can just move forward. Now, what do I mean by this? So what do we want to do? We want to create a simple Go server. Now, to be able to create a server, the first thing that we need is something that's called a router. Now, you might be asking, what is a router? The first thing that I want to explain is this term router. A router in this Gen framework, in this Gen web framework, is the part of the API, the part of the app that receives incoming HTTP requests. What do I mean by that? So once user wants to create a new account, that's going to be a request that is going to be coming to the server. And that's where router is going to come into work. It's going to come into the picture. It's going to receive that incoming HTTP request. Now, it could be any of the requests. You go ahead, you open up Google, you search for something. So whatever you do in the browser, you're sending something to the server. And that's the request that you send. That's called an HTTP request. Now, the job of this router is to receive that request and to make sure to send it to its relevant department. And what do I mean by that? So if user wants to create a new account, router must send the request to the handler responsible for creating a new account. If user wants to log in, HTTP request is going to be based on login, so router has to send that request to the handler that is going to handle login. Now, what are handlers? We haven't created any of them. We are going to create them. These concepts are very, very simple. I'm just giving you like the overview of how these work. So we have something that receives HTTP requests, and then we have something that handles those HTTP requests. So the thing that receives the HTTP requests is our router, but the thing or things, a collection of handlers, the thing that handles or makes sure to formulate a response based on that request, that's called a handler function. And a handler function, I know I'm like getting ahead of myself, but I just want to mention this. A handler function is going to then talk to a repository operation, which then in turn repository operation talks to our database. So this is how this flow is going to move forward. Okay, so this is why we need a router. Now, we are going to use var, as you know, as I'm sure you know what var is. We use this in order to declare a variable. Router is the name of this variable that we declare. Now, since we are inside of Go, we need to go ahead and actually type annotate this. So the type of this is going to come from the Gen framework. On the Gen framework, we have something very interesting, and that's called engine. And as soon as I hit enter, you can see it imported that Gen package for us that we have installed. Okay. So we have this variable called router. It has a type of gen.engine. So far, everything is okay, right? Everything is cool. But what does this router hold? It holds something that is returned by gen.default. So this should be capital, and there we go. Now I'm going to get rid of this asterisk. I'm going to zoom this in so I can explain this. Now you can see we have some errors, and I'm going to explain why do we have this error. So the important thing is this router has a type of gen.engine. It doesn't have a type of gen or engine. It has a type of gen.engine. Now, the important part is, I would say like this entire thing is important, but then we're going to break this down. So take a look at this. This is called gen.default. So the idea behind this gen.default is to create something, the kind of data structure that contains properties and values. So that data structure in Go, it's called a struct. So let me just type it out. We have, let me comment, struct. So gen.default, this thing, it creates a struct. And then we store that struct inside of router. But since, again, you can see we have some errors, we cannot do this directly. Because the thing that this gen.default returns, it's too big. It's a big struct. It has a lot of properties on it. And not only that, it contains all of the routes, whatever this gen.default returns. It contains our server configuration. So carrying this entire struct around every time we create a router, that's not going to be good. That's going to be expensive, it's going to be wasteful, and it doesn't make this gen framework fast. That's why you can see there is an error, because there is a certain type of code you can write. Gen does not allow you to write whatever you want. So you need to follow by best practices that gen framework allows you to do. So what this returns is this entire thing, this entire object that we need in order to create a router. But since it's too big, we do not create it. We just point to it. AKA, we create the address of that in memory. We find out where it is located in memory, and then we end up with an address. And then we put the address inside of the router instead of putting the entire thing. So think of it like this. You have a house, right? How do you show where your apartment or your house is located? Do you carry it on your back and you show it, okay, this is my house? Or you carry the address of the house, because it's not possible to carry the entire house. It is possible, though, to carry the address of the house here. I live here. This is my house. The same thing happens here. This gen.default, what it returns is too big. We cannot just use it directly. So we grab the address of where that thing or that struct is located, and we put the address inside of router. So whenever we call router is going to go inside of the memory, and it's going to find out where this gen.engine is located. So gen.default returns a memory address for a gen.engine instance that we put inside of the router. How do we specify, okay, this is an address. This is not the actual thing. We just pass in an asterisk, and now you can see the error is gone. So this asterisk makes this router not like a simple variable, but it makes it a pointer variable because it points to something. So wherever you see this asterisk, of course, we use this to create pointers or pointer types. You can see I put it on the type. We put it on the thing that we do not want to return. We know that we return something when we call gen.default, but gen.default returns an instance of gen.engine, which we store inside of router. Since that instance is too big, we just store the memory address of the instance inside of the router. So this, as I stated before, this part, this is the type. This asterisk makes it a pointer type, meaning we just point to it. We don't carry it on our backs everywhere we go. So wherever you see this, when it comes to the types, they are pointer types. That means we just search for the memory address and we store it there. But then we also use this asterisk to dereference, and I'm going to talk about that later. For now, we just talk about this. So just to sum up, we have this asterisk or the star agenda and engine, and this means that the variable router is not going to hold this entire agenda engine struct. Rather, it is going to point to the memory address of where this gen.engine is created. It lives in memory. It's just going to point to it, okay? And how do we get the memory address? This gen.default, this is going to create the gen.engine struct in memory. Then it's, because this is a pointer type, it's going to return the memory address of that, and that memory address is now stored inside of this router. So this, now we can use this router to do whatever we want. We can use this router like this. So I'm going to say router, and as soon as I do the dot, there you go. You can see we just have like a ton of stuff on this router. Would it be easier if we just store all of these inside of the router, or we just have router point to all of these? Pointing is easier, right? That's why Go is really fast, because we do not do like these kind of wasteful operations where we just like copy paste everything. We just use pointer types instead of doing that. So the first thing that we can do is we can define HTTP methods on this router. And what do I mean by HTTP methods? So an HTTP method determines what kind of a request user is allowed to send to your server. So you can just go ahead and search HTTP methods or HTTP verbs, and then it's going to tell you, okay, you have the get method, the post method, the put method, the update, the delete, this and that. Well, this and that is not part of it. I'm just like saying, okay, we have these and we have these. So every kind of these HTTP methods or verbs, they do something. That's why they're called methods or verbs. So when you talk about the get method, the job of this is to load information. So if user wants to load their data, or user wants to load the habits, or user wants to take a look at the list of the habits, one habit or several habits, or the habit log, then user is going to make a router.get, or basically like a get HTTP method kind of request. If you want to create a new account, you could use the post method. If you want to delete your account, you could use the delete method. If you want to update your information, you could use the put method or the post method. Both of them work. So when we do get is just for loading information. That's it. You do not change anything on the database. So get specifies what kind of request we receive from the user. So if we receive a GET request from the user, we know we don't have to change anything on the database. We don't delete or update or create anything. We just load data that has already been stored on the DB. So now that we have this GET method, we need to specify where user can send this method to, or this request to. So when you go to Google, there is a URL. It's google.com. Right? That's where it is. That's where you need to go in order to use Google. Now, where is our URL for our server? Now, I want this to be a simple route and simple server. That's why I'm like explaining all of these in depth. Next time, I'm not going to dive into this much depth. This is the first time and the last time. Next time, we're just going to breeze through it. I'm going to explain it, but I'm not going to jump into too much details. So, inside of these quotes, we specify the URL. We specify where our google.com is. So since this is the main or the home route or the home URL, we specify that by a /. So whenever you see / in any kind of backend code, that's the base URL. That's the home URL. There is nothing in there. And usually that's a GET request because you just want to take a look at, okay, what is inside of there? Now, we have the router, we received a GET request for this URL. Now, what do we want to do with that? Well, I received a request. What should I do next? What do you think we should do next? Well, we need to go ahead and handle that request. And what do I mean by handling the request? Handling request means formulating the response for that request. How do you formulate the response? Now, depending on the HTTP method, which in this case is GET, depending on the URL, which in this case is /, then you're going to take a look at these two things. Then you're going to formulate your response that you're going to send to the server. But formulating that is the job of a handler. That's why here in where you have this highlighted code, you can see, whoops, I'm right here. How can I get that back? You can see these parts are not highlighted because we did this, we did the relative path. Now it's this part that is highlighted. That means we need to define the handler. Now, handler is a function that is going to, again, formulate the response. It's going to handle the response. That's why it's called handler. Now, I do not want to create a separate file for this specific response and put this handler there. I'm just going to do it in place. Now, since we want to do something, we need to go ahead and create a function because we're trying to think about and implement something. And function is the best way to do this, right? We cannot just create a series of variables and just send it. We want to do something. So we want to do something, we need to go ahead and create a function. So this function accepts something that's called a context. Now, what is a context? So a context inside of Gen, it holds everything about the current HTTP request and HTTP response. So instead of writing the entire context word, I'm just going to say C, which is short for context. Then again, this is a variable. I need to specify what the type of this is. So I'm going to go ahead and I'm going to type in Gen, and then on the Gen, I have context with the capital C. Now I have that issue again. This context is too big to store it inside of C. So what do I convert it to? I convert it to a pointer type. There we go. So let's go ahead and let's actually define this function. Now, one thing I actually missed in when I explained this, if you take a look at these capital letters at the start of these structs, we have engine and then this capital C. The idea behind these capital letters at the start of these giant structs that we have available on Gen is very interesting. This capital letter, it signifies or it indicates that we can use Gen outside of the code of the, we could use engine or we could use context outside of the code of the Gen framework itself. So this Gen framework, of course, it has some internal code that it actually is built upon, and engine is in there. But if this E for engine or the C for context, if they were small case letters or lowercase letters, that would have indicated that we are not allowed to use engine or context outside of the Gen framework's native code and inside of our code. We wouldn't have been able to do that. The only reason that we can use engine and context inside of this code that we are writing is because they're capital. That's the indication, that's a convention in Go that when you see this, you know, okay, this is something public that I can use from this library inside of my own code. And whatever my code could be, it could be whatever project that I'm working on. All right, so that's that I want to talk about. Now this C, again, it's short for context. It's the parameter name, and this is actually a convention in Go that we go ahead and we just shorten the context to C, and that's it. So let's go ahead and let's use this context. Again, we have this context where it contains all of the information about the HTTP request and the response. Now remember, router knows the HTTP request. Context knows basically the handler function knows the request and the response. Router itself has no idea what the response is. and that's not its job. The job of the router is to send HTTP requests to the relevant department, aka relevant handler, and that's it. That's the job of the router. And then we handle some middleware with router as well, but in the context of like HTTP request and response, router is just request, and then we have handler, which has to know what the request is so we can formulate a response based on that request. Now, what kind of a response do we want to formulate when user wants to visit the home page of our API or the route or the base route of our API? Well, that depends on you, whatever you want to specify. But there is like a couple of methods that you need to go ahead and use in order to specify that. So we have this context. On the context, we have a method that's called JSON. Now we use this JSON method because we want to send a JSON response to the client. So a JSON response, JSON is JavaScript object notation. Again, it's JavaScript. You have like a series of properties and values, property names, they're in quotes, values are in quotes. This is like the common standard of sending a request to the server and sending a response back to the client. So we are going to work a lot with JSON responses. You're going to master them in no time, so don't worry about it. But this is something that we need to do. Now, once we use this JSON, what it requires is for us to specify something that's called an HTTP status code. So we talked about HTTP methods that define what we can do with our server. HTTP status codes define whether that thing that we have done with our server was successful or there were some errors. If there were errors, where were those errors actually originated from? So was it a database kind of error? Was it a server error? Was it some kind of bad connection? So status specifies, again, how that response is actually performing. If it is a status code which is common 200, you can again just search for HTTP status code. It's just going to take you 5 minutes to learn it. I'm pretty sure you know it by now, but if you don't, it just takes you 5 minutes. So 200 status code is the status code that we're looking for, and that's status code OK. That means request was successful and we're trying to formulate a response for it. Now I could just go ahead and write 200 here, but I don't want to do that. I'm just going to say http.status OK. That's called http.status OK. Now this http.status OK, this is the status, but where is the actual response? Well, we need to go ahead and create it. Now creating JSON responses in Go is extremely simple. We just use hash maps for them. So I'm going to say gen.h. Instead of writing hash map, we're going to just grab the first letter and we're going to say gen.h. And that's the hash map. Now, before creating this hash map, what I want to do is I want to show you what it is that we're actually trying to do. So we're trying to create a map. The type of the properties of this map are of type string. So when I send whatever it is that I want to send, that thing is going to have basically a key that has a type of string, which is the name of the property, and then that key has a corresponding value, which is whatever that property contains. The type of that thing that it contains could be anything, but the type of the property name itself has to be of type string. So that's of type string. Again, this is a convention. We need to go ahead and follow this. Now, the type of the property key is string, but the type of the property value could be anything. So when we say anything, any type inside of Go, we're going to use the interface method. This is actually older code. Newer code, you can just say any type. So if you see interface or any, both of them are the same thing. Okay, so I hope that this is like clear. What is just this gen.h? Why do we work with this? And what is the idea behind this? We want to create a hash map. That's where the h comes from, hash map. And The hash map is going to contain properties and values. The type of properties are going to be string. The type of values, they could be strings, numbers, booleans, another map, etc. That's why we say, okay, it has the any type or the interface type. Okay, now we use this gen.h a lot, so that's why I explained it here thoroughly, so we're on the same page. So next time we see this, we know, okay, I know what this is. Now, what do I want to send? Again, here is where you are like really, you can be flexible. You can say whatever you want. So I am going to say that the property name that I'm going to send is going to be message. Keep in mind, this is of type string, but the property value is also of type string. I'm going to say this thing. I'm just going to copy paste it. I'm not going to type this out. This is going to say habit streak tracker GraphQL API is running. So this is the message. I'm also going to send something else. I'm going to say status is success. There we go. And let me put in a comma there, and that's it. Now, the last thing that we need to go ahead and do here is we need to actually, I call it wake the server up. So we created the server. Now we have to poke it to wake up and actually listen on the port that we have specified. And how do we wake the server up so you can listen for incoming requests on that specific port that we have created? So we have this router, and on the router we have this run method, and what this run method does is it's going to start the HTTP server and tell it which port to listen on. So what we can do here is we can just pass in port 3000, but remember we have this port 3000 inside of our env file, so we can go ahead and import it from there. But we need to remember the format. So we had a colon and then we have 3000. The colon 3000 means that port 3000 is open on our machine. It is accessible via our machine's API address. Anyone who can reach machine can hit this port. But as long as no one has access to your laptop or to your computer, they're not going to be able to actually make requests to the server that we're working here. So we need to have this colon, and then we need to have the port on it. Now let's go ahead and let's actually get the port from the .env file. So for that, I'm going to say we have this port. Now, we need to specify what the type of this is, or there is another way of defining a variable in Go that is called a short variable declaration, in which the type of the variable is inferred, and that is colon $, and this is called short variable declaration. The type of this variable is going to be inferred. Now this is going to be os.getEnv, and in here we are going to pass in this port. I'm going to save this. Let me just go above. We have this net HTTP. We have this OS here. And the problem is that we don't have that go.env package that we have installed. It's not loading that correctly. And this net HTTP this is where we have used this http.status code. That's why it has imported that for us. So let's go ahead and let's go to the mod folder. I'm going to zoom this out a little bit. Let's see where we have this. And there we go. So here it is. I'm just going to go ahead and I'm going to copy this from here. I am going to come right here. I'm going to pass in an underscore to signify not to use this package directly. There we go. And on here, we are going to use something that's called, we're going to load auto load. Let me save this. We still have 3 issues here. These are for packages that we have not actually used. So I think we should be good to go. So we imported the port. Now this port, capital port, this is the name of the variable inside of the .env file. There we go. You can see it's actually capital. And now let's go ahead and let's run this. So that was go run, and there we go. So cmd API main.go. I'm going to go ahead and I'm going to run this. And yeah, this is just a firewall thing. I just allowed this, and there we go. Server is running. You can see here it says server is running on port 3000. So everything is well and good. database will create it. So these are our messages that we have created. I am going to get rid of these. Which one do I want to keep? I'm going to get rid of all 4 of these. I'm going to replace them with this. All right, and what else do I want to do? So let me close this, run this again. We're going to see this issue again. I'm going to get rid of this later. And then here we have this warning where it says you trusted all proxies. This is not safe. We recommend you to set a value. Well, this is not really a big deal since we are just developing on our local machine. This is actually okay. You can just go ahead and ignore this, or what we can do is we can just provide a flag to get rid of this. So here on top of this, I am going to define something in the router. So I need to go beneath the router. I'm going to say here router.set trusted proxies. I'm going to set it to nil. So what this basically is that Go warns us that it trusts all proxy servers by default, and a proxy is a server that sits between the client and our server. And if you trust a proxy, it could be like a malicious one that wants to send a fake API address or whatever. So this is something that we basically say nil. That means we trust no proxies. It's safe for local development since there are no proxies between our browser and the server. But it just gets rid of that error that I do not want to take a look at. So I'm going to close server. I'm going to run this again. Oh, I haven't saved that. Let me just close this, save this file. There we go. And run the server. I don't want this to be too cluttered. This is just for we're running in the debug mode. Okay, that's fine. You can see this is a little bit cleaner and our server is up and running and we're making good progress. And the next step is to actually go ahead and get started with GraphQL and its dependencies. But before doing that, I just want to say a few words about GraphQL. GraphQL is actually a query language for APIs. It's, in simple terms, it's a way for us to get data from an API that is talking to backend. So you have 2 main ways of doing this. You have a REST API and a GraphQL API. I already have created a to-do REST API with Go, Gen, Postgres. And again, the REST API, that's a to-do API. It's in the same playlist that this video is in, Getting Good at Go. You can take a look at that video and there you're going to see, okay, we use REST API to get to-dos, for example, to create a new to-do, to delete a to-do, whatever we want to do with that API. Now, when it comes to GraphQL, you can do the same things, but in a more efficient way. For example, in a REST API, you can do one thing with one endpoint, but in a GraphQL API, you can do a lot of things with just one endpoint. So you can specify exactly what you need from the backend or from the API, and you're going to get those things. But when it comes to the REST API, for example, you're going to say, okay, just give me the titles of the habits. REST API is not going to be able to do that, but a GraphQL API is able to do that. So if you want to do that with a REST API, you need to go ahead and specifically code that. And you are going to create a new endpoint for it. But we are going to use just one endpoint, that is /GraphQL, for everything. And you need to be very specific when it comes to GraphQL to exactly what fields you want. And server, as you are specific, server is also specific and it only returns what you asked for, nothing more, nothing less. But that's not the way REST API works. And I don't want to talk about too much about this. If you want, if you're interested, you could watch that video if you haven't already after watching this one. And then you're going to have like a clear picture of, okay, what is the difference between a REST API and a GraphQL API? Cool. So let's go ahead and let's actually get started in order to install GraphQL dependencies. The first thing that I'm going to install is going to be GraphQL Gen, this gqlgen. This is actually a package that we're going to install that is going to help us to build the GraphQL server and generate code from our schema. And no, I'm not talking about AI code generation. Since this is gen, it generates GraphQL code based on the kind of schema that we define. It has nothing to do with AI. So I'm just going to hit enter. This is going to install everything that we need. And the next step is going to be the configuration of GraphQL. So we need a few files to be generated automatically. So you can see here, we have this CMD folder, data, internal migrations and scripts. Inside of internal, we have these folders. So what I'm going to do is I am going to go ahead. Let me just copy the command. I'm going to initialize this. This is just going to create a few files for us. We're going to take a look at that. And there we go. You can see here, we have this graph folder, which we didn't have. So this folder right here, we had a graph folder inside of the internal, but then it created that another one here. So what I'm going to do first is I'm just going to grab that, put it inside of the internal, just move it there. So all of this code is inside of the internal folder. Now, if you take a look at what this has created, you can see several files. So you can see this folder, that's model. You have the generated.go resolver, schema.graphqls, schema.resolvers.go. So these are all the files that it has created for us. I'm going to get started explaining what these are. So here, I'm going to talk about this first. So this is an auto-generated GraphQL runtime code. We do not edit this. So what you can do is you can just double click on this and you're going to take a look at the contents of this, and you can actually go over this. And this is, again, even though this is generated GraphQL code, you can see the extension is Go. If you know Go code, this is going to be easy for you to understand. So this is actually the GraphQL engine that GraphQLgen generates all of the complex wiring code in here. It's going to parse incoming GraphQL requests. It's going to match them to their correct resolver. It's going to validate that the data matches the schema types. So everything is right here. After this, we have this resolver.go. This is actually our main resolver struct. So again, a struct in Go is a blueprint that defines the shape of data. This particular struct acts as the central hub that holds all of the dependencies. What do I mean by that? It holds database connections, repositories. We're going to talk about all of these that every resolver needs to do its job. So that's here. Cool. Then we have schema.graphql. So this is also very important. This is the GraphQL schema file. This is where we're going to define all of our types. For example, we have the user type in order to create a user. We have the habit type in order to create a habit. We have the habit log and all of the other types that we need. So then we have schema.resolvers.go. This is actually where we have things that are called stub. So let me just, where can I type that? So here I'm going to say function stubs. So what are function stubs? A stub is an empty function that has been declared but not yet implemented. It exists, but it does not do anything. Whenever we create some kind of a resolver, aka field resolver, that's going to be in clash with a resolver that we have inside of this file, inside of this schema.resolvers.go. So when we define a resolver outside of this, why do we define a resolver or a handler? That's because we receive a request. We want to do something based on that request. For example, user wants to log in. We receive a request for login. Then we need to handle that request. So that's going to go into resolver's code. Then that resolver is going to be in clash with a function stub inside of this file. And then we need to go ahead and get rid of that stub because now we have code that is going to replace that stub. So you can think of it like some placeholder code so our server does not break. Now I talked about all of these. I didn't talk about this model. So if I just click here, you can see we already have this models underscore gen.go. This is when GraphQL Gen reads our schema and sees a type like, let's say, user or habit, and then it generates a matching Go struct or blueprint here automatically. You can just go ahead and take a look at this. All right, I'm going to explain all of these. You don't have to worry about this. You can see these are some like boilerplate kind of stuff, that boiler code that has been created in here. So what else do we have? I explained everything inside of this graph. Yep. And we do have 2 more files here. One of the files is this GraphQLgen.yaml. So the idea behind this is actually a configuration file. So if you come from the world of JavaScript, you have like some kind of a configuration file that is in the format of JSON, or in Go, we also have TOML, T-O-M-L, but this one is in the format of YAML. This is going to be where our schema is we're going to basically specify where we put our schema, where we put our generated files, and which Go packages contain our models. And finally, we have this server.go. This is going to be a basic example entry point that GraphQL generates to show you how to wire everything together. So let me just open this up, double click on it. You can see this is just a basic server, and it tells you, okay, where the server is going to be running on. Very good. Now that you know what it has generated, there are a few things that I want to change here and there. So the first thing that I want to do is I want to just change the configuration. I'm going to get rid of everything, and I'm just going to give you my configuration. I had to like really work a lot with these to make them, to get them to work. And I need to go over what do we have here. So we have this executable, we have package generated, layout, file name. We go to internal graph. And then, so for this generated, what I want to do is I want to put it inside a folder. Again, this is just for organizational purposes. This makes more sense to me. That's why I do it generated. And I'm going to put this in there, move it. Generated. Yeah, very good. Let me close this. Now, what else do I want to do here? We have the model, inside of which we have model.gen. I'm gonna create another folder for these resolvers. Since we're gonna have a lot of them, based on one action, we want to create one resolver, and then that resolver is going to talk to the repository, corresponding repository operation. Again, I'm going to explain all of this, so don't worry about it. This is going to be a resolver since we're going to have more than one. I'm going to put this resolver.go in there. And what else do I want to do? We have this schema.graphqls, which I'm going to keep it there. But then the schema.resolvers.go is going to go into this folder. And I'm going to move it there. Very good. So we have inside of the graph folder, we have something that's called generated. We have something that's called model. We have something that's called resolvers. And finally, we have schema.graphqls. Very good. You should see this here as well. You can see we have internal graph model, models.gen. What else? We have resolvers folder. And then the name of the resolver, the resolvers also goes there. That's it. Again, some configuration file that you do not have to worry about. And one last thing that I want to do here is I want to get rid of this server file. We do not need this. Okay, very good. So GraphQL setup is almost done. We are going to go ahead and we're going to install another package that's called Air. So Air is actually a package that's going to allow us to make change to our Go server. And we don't have to close the server, open the server up to see the changes. Now, what it does is it's going to have a live reload for us in order to update the server, make the necessary changes, so we don't have to like break the smooth process of coding and take a look at the API inside of the GraphQL playground. Again, if you're coming from the world of JavaScript, it's like Node-mon that we use for Node.js. So it's just a package that allows us to basically detect saved file changes, rebuild the binary, kill the old running server, and start a new server with our changes. So for this, I'm going to go ahead and I'm going to paste this command. This is going to be the command that's going to install air for us. And then once we run air, we should be able to see its version. So for now, it's downloading this. I'm going to pause the video. And there we go. Air is installed. As the next step, let me just go ahead and run air. And let's see. So if I'll check the spelling of name or path is main.exe. Is not recognized as the name of this. So it did fail to, let me initialize this. I'm going to close this internal, just collapse that. We need to have another configuration file for air. So for this one, I'm going to say air init. Let's run this. There we go. It is air 1.65.1 and it generated this .air.toml file. So toml stands for Tom's Obvious Minimal Language. And in here, we're going to make some changes. Basically, I'm going to copy everything that I have. And let me just copy everything, delete this, and I'm going to paste everything here. I'm basically specifying where the build is, where our main.exe file is, where the main server file is. So just some changes here and there. You don't have to worry about any of this. Again, these are configuration files. I do not want to bore you with this. So that's why I'm just copy pasting this. And now we should be able to run this. Let me clear. I'm going to say air. If there are any issues, I will go ahead and solve them. So now it's building and then it says it's running. Let me just wait for this. We should see that message that we used to see. Okay, like the port is live on this. And main.exe. Yep. So let me show you how you can actually get rid of this issue. So for now, I'm going to say allow this, right? You need to go to your settings. Here you're going to have Windows Defender. I mean, like you have to like really type it. This is Windows Defender, and you click on this allow an app or a feature through Windows Defender. So you're going to click on there and then you have this change. Can I zoom this in? Apparently I can't. So I can't. You're going to say change settings. And then we're going to say allow another app. Here, we're going to need to go ahead and find out where main.exe is, the file that threw that exception. So here I'm going to run air again. Let's wait for it. Oh, we don't see this anyway. But what you would do is you're going to go ahead and see where that file is located. For example, for Go, I selected this, Go, and then I said open. And then what you're going to do is you're going to specify the public and private networks, and that's it. It's not going to throw that. It's a Windows thing. As you know, like there is a lot of issues currently with Windows. So this is one of those, I guess. I didn't have this before. It just like it comes out of nowhere that you have these servers that you're currently connecting to. So nonetheless, it is working fine. You can see our message, starting habit streak tracker GraphQL API. Very good. So this is also set up. We are still talking about setup, and I'm explaining this so you don't have to be like confused anytime you want to start a new project. So next up, we have our database setup and configuration. So for this one, what we are going to do is we are going to go ahead and install SQLite. So let me just close this. So first things first, I am going to go ahead and I'm going to create a file that's going to be called SQLite.go. So inside of the database, we have nothing. Here it's going to be SQLite.go. This is going to be a dedicated file for our database connection logic. SQLite.go. This is going to be that file, and we're going to write the connection setup in here. And this is very easy to actually write the connection logic for SQLite in Go. This is extremely simple. And I'm going to explain this in depth so you can really understand, okay, what is going on here. We're not going to come back to this. We're just going to write it once and we're going to move forward. So what do we want to do generally? We want to create a function that is going to determine where our database is, and it is going to leverage something called a connection pool in order to create database connections. Why do we want database connection? In order to query for data and send it to the front end. So how does this work? Well, we know this is how we get started by creating a function. The name of this function, I'm going to call it initDB, and this function is going to accept one argument, and that argument is going to be data source name. So what is this data source name? This is the path to the SQLite.db file that we have not created yet. You could just pass the path directly to this, or you can use this in order to be a little bit more flexible. And the type of this is string. Now, what this function accepts is very easy, but what this returns is a little bit not easy. So what it returns is something that's called a standard SQL package, and that is SQL.db. And now you can see it's .db. The first letter is capital. So when it is capital, we know it's a package from something. In this scenario, it is SQL. When we talked about the engine or the context inside of the main.go, they belonged to the gen framework. So here, engine belongs to the gen, default belongs to gen, but here, DB belongs to SQL. So what is the idea behind this? This is, again, a standard SQL database package. And it doesn't just represent a single connection, it represents a connection pool, as I stated earlier. So what is a connection pool? A connection pool is a connection, so like this. Maybe I'm not pronouncing this right, I feel like. So connection pool is equal to collection of DB connections. Okay, it's a pool of connection. It's a collection of database connections. Is this correct? Yeah. So it's a collection of database connections that are created once and reused across multiple requests, rather than opening and closing a new connection for every single query. Now, why do we do this? Because this is how Go goes about this when it comes to production level applications. This is more efficient. Instead of creating a connection every time, our entire API leverages one specific connection pool, and that's it. So this SQL.db returns a connection pool. Since this DB is too big, we are going to say, okay, this is going to be a pointer type. Now, whenever we return something like a pointer type from these kind of functions, we have two things. We either return that connection or we return error. So this is how we know, okay, whether or not the operation that we are trying to implement is successful or not. Now, how does this work? Well, SQLite stores the entire database as a single file on disk. So we're going to leverage OS and we're going to say mk dir all. So the idea behind this method is it's going to create the directory and any missing parent directories. This is not going to create anything if this data folder already exists. So we are going to create this folder. The name of this folder is going to be data, And then we need to give it a Unix file permission setting, right? And that's going to be 0755. Where do I have my cursor? It should be 0755. Now, I want to explain this, but I do not want to jump into too many details when it comes to what I'm talking about. You can just go ahead and search for a Unix file permission setting written in octal or base 8 notation, and you're going to be able to find like a ton of information on that. So the idea behind this is this number is a standard permission for directories. So the owner has full control and others can navigate into this file, but they cannot modify it. So that's why I gave this number. But I'm going to use a short variable declaration for this. I am not sure what is happening. Let me just, and that is going to be error. Let me save this file, close this. SQLite.go. Yeah, sometimes this happens and I have no idea how to actually fix this. The cursor goes bold and whenever I type, it's going to read or eat what's in front of it. So anyway, this is going to return error. So I'm going to use short variable declaration because I do not want to type annotate this. Now, it doesn't return error, but if there is any error in this process, we are going to grab it and store it inside of error. So that was os.mk dir. I think K is lowercase, dir, and then all, we're going to pass in the name of the folder, that's data, and then we have 0755. Let me go above this. I didn't actually import our main package. Maybe that is package. That is the issue. So package. Now this is a database package. That's why I'm just going to say database. So we have this OS. Let me save this. There we go. We imported database SQL. We need to import OS as well. So let me just surround this with parentheses. And then I'm going to say, give me OS. There we go. Very good. All right, so what do we do if we have any errors in this process? So we are going to say if error is not equal to nil, that means we do have some kind of an error here. Then we need to actually go ahead and print what that error is. But keep in mind, what is the return type of this function? It is a pointer type. That's the return type. So when you're working with pointers, you either return that struct or you return nil. So you need to specify that if you have errors, we're going to say we're going to return nil. All right, we're going to return nil from the function, from this initDB function, but then we're going to print a message as well so we know, okay, at which stage this actually failed. So we're going to say fmt.errorf, and I'm going to say failed to, this is going to be failed to create data directory. And then we're going to provide a placeholder for the error that's going to come right there. And let me close this quote, add a comma, and then we're going to pass in the error there. Very good. So again, we return nil, that's for the function. And this is the structure or the way that we're going to go with all of the resolvers that we're going to create. We return nil if there are any errors because we are basically returning pointer type. And then we print the statement of the error. Okay, what was wrong there? Okay, so next up, what we need to do is we need to open up a connection to the SQL database file. Remember, we have not actually created that file. We're going to create it. But for now, let's just go ahead and let's do this. So this is going to return either error or the DB connection. And we're going to say SQL.open. Now, this is a very interesting method. SQL.open actually is a method that is going to take two arguments. It's going to take the driver name that we have installed. So if you remember, driver name was SQLite 3. And it also needs to have the path to that DB file that we have not created yet. Have I created that? I don't think so. So data, you can see we don't have anything in here. We have not created that. So it's going to take that as well. And that was the data source name. There we go. And this should be uppercase. O is uppercase. Very good. So if error, again, it's the same thing. I could just go ahead and copy paste this. We're going to say if error is not equal to nil, we return nil from the function, and then we paste in, sorry, we just show in what the error is. So we're going to say failed to open data. Let me just do it here. Failed to open database. Let me get rid of that. And yep, I think that is it. So this is for the opening of the database. But then we have, now when it comes to SQLite, there is something that we call pragma. I do not want to jump into too many details when it comes to SQLite or this connection, because again, at the end of the day, with this API, what I want to do is I want to teach you GraphQL. I don't want to like dive into the core of SQLite and SQL and how they work. But what the idea behind pragma is that I'm about to create here is that whenever we delete a user from our database or through a request, well, typically through a request, we don't delete it from the database, but this is how we talk about it. So we delete a user from the database. We want that user's habits and habit log to be deleted as well. So everything that belongs to that user has to go as soon as user is gone. So when it came to Postgres, the good thing with Postgres was it implemented something that was called foreign keys. So foreign key constraints are things that you connect two tables together. So one entry inside of one table is connected to an entire other table. But we don't have such thing inside of SQLite, so we need to actually go ahead and do something else. So we can use something that's called a cascade delete. That's when a user is deleted, all of their habits are automatically deleted. When a habit is deleted, all of its logs are automatically deleted. So that's what we do. But again, the problem is SQLite ignores all of this by default. So foreign key constraints do nothing unless you specifically turn them on with something that's called pragma, foreign keys. So we need to use pragma in order to actually make sure that this actually works. And pragma is not an acronym, it's just a keyword that SQLite uses in order to signify, okay, that we are working with pragma. We want to have foreign keys enabled. So here I do not want to return anything from I do not want to have anything from the database because this is just a database execution, basically command. But if there are any errors, I want to take a look at that. And here we're going to select DB, and on DB we have this method execute. This method is going to accept, it basically executes a SQL statement and it doesn't return any rows. So we use this underscore in order to discard the first return value, which is the result, since pragma does not return any kind of data. Because we only care if pragma foreign keys succeeded or not. So we need to pass in that SQL statement here. That is pragma. There we go, pragma. And then we're going to say foreign key. I always misspell foreign key. So it is EIGN underscore keys. I'm going to set it to on. It should be capital on. And we need to terminate this as well and do this. So let me get rid of that space there. Now, what if we have any error? Well, we do the same thing. If we have any error, we're going to print that. Let me save this. So we're going to first return nil from the function. That means pointer function doesn't do anything. And then we say failed to enable for EIGN keys failed to enable foreign keys. I'm going to specify the placeholder. Let me get rid of that. I should get rid of that colon and put it there. Very good. And then we're going to pass in the error and parentheses. Very good. And the last thing that I want to do here is something that's called a database ping. So if there are any errors, we're going to return that. That's going to be db.ping. So what is this? Now we used SQL.open, but it doesn't verify that the connection actually works. So it is possible for us to open the database, but the connection might fail. So what we do is we send a lightweight test query to the database to confirm the connection is truly live and working. And ping is like just, we want to verify, okay, that the connection is alive. So that's going to be the ping. And again, if we want this to, if there were any errors, we're just going to return it. Let's save this. So if error is not null, we're going to return this and we're going to say failed to ping database. Get rid of this. And finally, what do we return from this? We return db and null. Save that. Now remember, now keep in mind here, we return db first. That means everything succeeded. We return the sql.db handle to the caller, but then, so this order is very important. SQLDB returns this db, and we return null for the error. If none of these throws any errors and we come here, that means we return our database and we return null for the error. So now the only thing else for us is to actually jump in here inside of our main package and actually go ahead and establish the database connection here. So the first thing that I'm going to do is, let me see where I want to put this. That's going to go above there. Here we're going to have the DB as well as the error, short variable declaration. I'm going to say database dot init db. There we go. And where is our db file? So we said, now we are inside of the main.go file. We need to go inside of the data file. And from the data file, we need to select this habits.db, which is our database essentially. So we're going to say data, and from there, I'm going to select a file that's going to be called habits.db. So that's our database. Again, if we have any errors, we are going to log them. We're going to say if error is not equal to null, what does that mean? It means we could just log .fatal. And what is that going to be? That's going to be failed to connect to database, and then show me the error. So it ends there. I'm going to pass in error and let's save this. It did an import log. Let me import log myself. Fatal. Very good. And how can I, let me just cut this entire thing. If I put it there, see, that's the issue. So I need to just copy paste this entire thing. I think I need to close VS Code and open it up again. And this nil has just one L inside of it. But what if database is successful? Well, we know that this is just going to call this initDB. Now, what are we going to do? Because we have not used this DB. Now, what if we close our server, which is this main.go file? We don't want our database connection to leak information. So we're going to say db.close, but again, I need to just cut this. We are going to say defer, which means run this line. So I'm going to say defer, and then this, we're going to say run this line when the main function returns, because we want to make sure that the database connection is always closed cleanly when the server shuts down. even if something goes wrong. And I think that should be it here. I don't think I want to do anything else. Let's go. Let me save everything. Let's go ahead and let's run this. If there are any issues, we're going to fix them. And now it's time for us to go ahead and start air so we can see the database connect successfully. But before doing that, I'm going to add a print statement here that's going to just say database connected successfully. And now as soon as I do air, we shouldn't see this. So this is failed to open database, SQL unknown driver, SQLite 3 forgotten import. So I feel like yeah, I've forgotten to import SQLite 3 package or module here, which I just did. And now, since this is air, it's going to try to build this again. SQLite Go has changed. All right. We should have, if this works perfectly fine, with no errors, we should have that database file created inside of the data folder automatically, but we need to wait for this to actually finish building that. And the file is, where is it? So we call that here, it's habits.db. That's going to be the file that should be generated. And we're going to come to these issues that we have with this GraphQL initialization. We're going to come to this later. For now, I'm just waiting and I want to see what the issue is. So it says program main.exe failed to run. Now that program is inside of here. You can see inside of this temporary, it actually builds your project and it shows the result of that for you. But we can see this has failed. Now, I actually faced this issue when I was first starting to work with this. I actually started working on this API. So as you know, I actually use two different laptops. So this, I think I've mentioned that several times by now in different videos. So this laptop that I'm recording on, this is not my work laptop. I have a different one where I spend 90% of my time working on, and this is just something that I keep just for recording, so it stays light and it doesn't jam. As you know, with Windows, there is just a ton of issues. So sometimes I have some setup there, and then 20 days later, I forgot what I set up there, and I see these kind of issues. So the problem here is it's actually a very simple problem. It is not a simple problem, but we can find a simple solution for it. So I'm going to clear this. The problem is actually this. So if I go to mod, the problem is this library that we have installed, this this SQLite driver. So that's the issue. So this is the problem. And if you go ahead and if you go online and check this, you're going to see that this actually depends on a C compiler. And if you want this to actually work, you need to go ahead and you actually configure a C compiler, GCC as well. So that's really, depending on the system you're working on, that could be very tedious. And that's not something that I want to actually go over here, because that has nothing to do with what I'm actually trying to teach here. GraphQL is learning how to create a GraphQL API, so it has nothing to do with that. So what I'm going to do is actually go ahead and give you another driver. So we're going to get rid of this. We're going to use another driver. I am going to get rid of this from here. And that driver doesn't actually need any kind of compiler. So this SQLite 3, Matin SQLite 3, this needs a C compiler for Go plus GCC to compile. Now this causes platform-specific build failures on Windows. So what I want to do is I want to get rid of that package and I want to install this one. So this is the package. It's go get modern C.org/SQLite. So this is actually a pure Go port. It doesn't need any CGO, it doesn't need GCC, it doesn't have any platform issues. So I'm going to go ahead and I'm going to hit this to install. This is just going to take a few seconds to install, and then we're going to run our code with this one. There shouldn't be, so the completed code of this API was initially with SQLite 3 package, the other one, but then I migrated that to this, and I haven't faced any kind of issues just for this specific laptop. So I can just teach it without diving too much into other kind of setup. So now what we're going to do is we're going to come right here and we're going to use this package instead. There are a few changes that we need to actually carry out. Now, I imported this modernc.org, so I imported that. We need to actually convert the SQLite 3 to SQLite. Now, when it comes to SQLite, we're using its third version, but the SQLite 3 is also in the name of this package. So that's something that you need to keep in mind. Very good. And I've actually created a .md file, a markdown file, showing you how to like go from one to the other, and just talks about the issues that arise when we use that SQLite 3 SQLite 3 module. So here is where I'm going to say go mod tidy. This is going to tidy up the packages here. It's going to get rid of the ones that we do not use. Now we don't see this. It didn't install. Let me just go ahead and install this again. Now this issue should go. Very good. The issue is gone. Let me close this file. Open this up again. We should see it here. We don't see that there. That could be another issue. But for now, we don't see any problem inside of the file. Let me just go ahead and run air again. Let's see what that's going to print for us. We're going to wait. Now it's one thing I should have done was now you can see it actually ran. That's good. It says database connected successfully. But as a next step, and you can see we have this habits.db file that is created there. So that's very good. But next time, make sure you actually delete these two, like delete the old version of this, clean the cache, and then you go ahead and you actually start air again. So I'm going to show you how that works. So we are going to say, let's go ahead and let's delete this. Go clean -cache. And we're going to run air again. And this is going to create that temp folder again. There we go. You can see it just created that. And it just tries to build the project again. And collapse sidebar. We should wait a few seconds for this. So this is the first build. That's why it's taking a little bit time. And let's see what happens. I'm going to pause the video until this is done. There we go. Listening and serving HTTP on port 3000. So we can see that database connected successfully. There are no issues. Everything is working fine. So there is something else that I want to do here as well. I'm going to close this one, clear this. And now we are going to have to go ahead. Now keep in mind, we're still in the phase of like setting up this project. We're writing some code here and there, but we're trying to keep all the pieces, bring all the pieces together. Now the next thing that I want to install is actually called Golang migrate. Now again, this is something that I explained like a while ago, that instead of writing SQL queries or statements or commands, we are going to create migration files so we can keep track of what kind of changes we have brought into the code base when as it goes to show the database changes. So the best way to do this and the best practice way to do this is actually install something that's called migration. So you have up migrations and you have down migrations. Any migration that changes something on the database, like creates a table, that's going to be called an up migration. And when you reverse that specific migration, that's called a down migration. But then we need to go ahead and actually install this package as well. So I'm going to give you the command for this. This is go install -tax SQLite. And this is where you're going to get this. So github.com, golang migrate version 4, cmd, migrate at latest. Now you need to provide some kind of version. I'm writing at latest. You can just get rid of this and go with another version, but you need to specify a version. So I'm going to hit enter. And we're going to wait for this to go through. And now that this has gone through, we're going to check for the version. I'm going to say migrate -version. We need to see something here. Sometimes you see this div, sometimes you see a specific version, but that's okay. So the next step for us is actually go ahead and configure GraphQL schema. And I'm going to show you how you can actually do that. Now, what is a GraphQL schema? So a GraphQL schema, in simple terms, you can think of it as a contract between the API, like backend, and the client. So it is something that describes what types of data exist in our API, what field each type has. For example, it determines that, for example, we have a type that's called user. That's the type. It determines what fields there are inside of the user type, meaning ID, name, email, habits, whatever. It determines queries. That means the things that we send, the requests that we send to the backend, or we query the backend in order to load data. And finally, it contains mutations that clients can use in order to change data on the backend. So there are 4 things. We have types like users, like habits, habit logs. We're going to talk about all of them. We have fields, which are different properties within these types. You have queries that you load data, and you have mutations that you actually change data with. So what we're going to do next is, let me just close this. I'm going to close this file as well. Let's open up the sidebar. So here you can see that this file inside of this graph, the graph folder. I'm going to collapse this one as well. We have the schema.graphqls. And here there is a comment that says GraphQL schema example. This is an example, right? So what we are going to do is we're going to get rid of all of these, and we're going to create our own schema. And now you know, okay, what is a schema, what it contains. And so what is the first type that we're going to get started with? That's going to be type user. Now, another thing that you need to keep in mind when it comes to these GraphQL schemas is these schemas determine what clients can get. If client requests for something that is not defined inside of the schema, they're not going to be able to get it. So it's like you go to a restaurant, you can get everything that's available on the menu. You cannot get something that's not on the menu. Perhaps that's not like a really good analogy, but this gives you like a picture of how this works. So you get everything that is defined inside of the schema.graphqls that are defined as GraphQL schemas. So if you want something for user to get, you need to define it in here. The first thing that I want to define is the type user. Why? Because this is the type that is going to determine that our user can sign up for this API or for the service. Now, what kind of information do we want from user when user signs up initially? Well, that's simple. The first thing that we want from user is going to be the user ID. Now, this user ID is going to be something that's going to be automatically generated in the backend. This is going to be a UUID string inside of our database. This is a unique identifier that differentiates between different users. And I'm going to add an exclamation mark here. This is going to determine that this cannot be null, meaning it must always be present. The second thing is I want all of the users, all of them, to have name. Now, so name is what I want users to have, but what is the type of the input of name? So once user writes a name, can name be a number? Can name be a string? So you need to specify what is the type of name. I'm going to say this is going to be of type string and it should be not null. It means we require from users to provide their name. The next one is email. This is going to be of type string as well, and this is going to be non-null, meaning this is required. Then we're going to have, now for every user, we're going to have arrays or a list of all of the habits that belong to that specific user. And I'm going to call that habits, but what is the type of that? The type of that is going to be habit, but a list of it or an array of it. But since if user doesn't have any kind of habit, I want this to return an empty list for me. I'm going to pass in an exclamation mark in there. And when there is an exclamation mark in there, this is going to return an empty list. It's not going to return null. We want to see, okay, the user exists, but user doesn't have any kind of habits. So that's what this is going to return. And the final two are going to be when this user was created or when user created their account. That's going to be of type string. And finally, if user updates something on their account like name or email, we're going to say that's going to be the updated date. So this is the first type. Now keep in mind, this entire thing is called a type. These things inside of these curly braces, they're called fields. So this type has 1, 2, 3, 4, 5, 6 fields. So we specified one type with 6 fields. Let's go ahead and let's specify the next type. So what is going to be the next step? What do you think? It's going to be type habit. So what kind of information are we going to select from user or want from user or require from user when user wants to create a habit? Of course, the first thing that we want to do is ID because we want each habit to be different from the other one. Then habits must have names. That's going to be required. Habits must have description. That is going to be of type string. So the description must be of type string. Then we are going to have a few things that we are going to talk about later inside of this API, and that is the streak valuations, okay? So we have how many days in a row for the starting from today backwards, how many days has user like logged in or checked in for this specific habit. That's going to be called current streak. Now, again, this is something that we're going to use way later inside of this API. These are like the last things that we're going to do inside of the API. And if it doesn't make any sense now, that's okay, because we do not have like this worked out yet. We're going to come back to this, but current streak is today. Let's say I have like this morning walk habit that I want to like make it into a habit, morning walk. I did the morning walk today, I did it yesterday, and I did it the day before yesterday. So that makes it 3 days in a row. But the day before yesterday, I didn't do it. So I broke the streak, but I did it 3 days in a row up until today. That means the current streak is 3. So if I had done it for 10 days and then I don't do it for 1 day, the streak is going to break. But then if I start again, that streak number is going to go 0. So it's like a counter. Whenever you break it, counter goes 0. Counter resets. So these are some things that are very technical about this API that we're going to talk about. But then we have something else that's called longest streak. So let's say the longest I've gone in like making this habit of morning walk has been like 10 days in a row. That's going to be longest streak. Now, longest streak comes from the entire lifetime of that habit. So let's say I'm using this API to track my habits for the past year. For the past year, the longest streak that I've had in like morning walk has been 10 days, 10 consecutive days. Yes, I go for a morning walk. Sometimes I'd go 4 days a week, 4 days consecutively, like 4 days one after the other. And then I don't go one day, then that breaks the streak. But the longest that I've gone is 10 days without having any break in between them. That's going to be the longest streak. And the type of these are going to be integer. So int stands for integer. Then we're going to have logs that are going to keep track of these streaks. The type of that is going to be habit log. Again, if user has habits, it is not necessary. So first user signs up. Once user signs up, it's not necessary for user to have habits. Then user creates some habits, but then it's not required for users to have habit logs. So that's why it is okay if we return an empty array as logs for a specific user. Now I'm explaining this a lot because we're not going to come back to this. We're not going to talk about this anymore. Okay. So these are like, this is the backbone of this entire thing, this entire API. If you understand this, you understand how GraphQL works. And again, the idea behind this video is not so much on Go and Gen and SQLite. SQLite is like the easiest part. The setup of it is the most difficult, but the actual code is the simplest of all the other parts of the API. But the main focus of this is actually GraphQL. How do you declare schemas in GraphQL? These are like very important when you start a new project. When you want to like have a personal project, you want to learn GraphQL in the context of Go and Gen. This is like the starting point. That's why I'm like taking more time to explain this. Now, each of these habits, it's going to have an owner. And the owner is going to be called user, the type of which I've already created above. Then we're going to have two things for this specific habit that we have actually had here. So you can create, created at is going to determine when the habit was created at, and then you can also update the habit as well. Next type that I want to talk about is going to be, so far we have created two types with several fields inside of each of these types. After we have created the types and their fields, we're going to go to the next step. And the next step is the other two parts of this GraphQL schema, which I said, okay, this is a contract. It has 4 parts. It has types and it has fields. Something these two are we are implementing right now, but we also have query and mutation, and that comes once we have actually created some resolvers. We have created the repository operations, and the first time that I create an account, you're going to see, okay, this entire picture is going to click. And I'm just seeing I did not add an exclamation mark there. So the next one is going to be habit log. This is the third type. Each habit log, so the idea behind the habit log is that it keeps track of how many times you have checked in for a habit. So if in a year, out of 365 days, I've gone for a walk, let's say 300 days of the year, that means I have 300 logs for one specific habit. And the type of each of these logs is going to be this. So this is why we need this, okay? So that's going to be ID. After the ID, we're going to have habit. Now, each log is going to belong to a specific habit. That's why we need to determine, okay, which habit has which logs. That's how this goes. We're going to have a completed date for a specific habit log. And this is actually the date the habit was completed. So let's say today I went for a morning walk. That's the completed date in the day that I actually tried to implement that habit. All right, so I followed through with my promise. That's the completed date. This is going to be string. And finally, we're going to have the created at, which is going to be of type string as well. So completed date, when the habit was completed, for which specific day, and then we have the created date as well. So this is the third type, and we're going to talk about the next one, which is going to be called, let me just type it, auth payload. Now we need this type because this API is actually a secure API. We use JWT, which is JSON Web Tokens, in order to make sure one user cannot access the account of another user, aka one user cannot access the habits and habit logs of another user. And this auth payload actually refers to the process of making this API secure. So we are going to work with JSON Web Tokens, JWT, and that's going to be used in order to make sure that one user cannot access the habits of another user. So this auth payload is going to have two different types on it. One is going to be token, the type of which is going to be string. Now, this auth payload is going to be returned after a user successfully registers or user successfully logs in. But both of these operations, they are mutation operations. They're not going to be query, all right? I'm going to come back to what is the difference between a query and mutation. And once you understand them, it doesn't matter in which context you use GraphQL, like Node.js or Go and Gen, the concepts are the same. So we have a token. Token is going to be like a very long string that we're going to ask user. So when user signs up or user logs in, they're going to be able to generate a unique token, which is basically like a long string of alphanumeric characters. And then if user wants to create a habit for their own account, user has to give us that token that they received. Otherwise, we don't know if it is the same user who wants to create the account. Who wants to create the habit. So this is a way for us to distinguish if it is the correct user who is accessing their own account and wants to create a habit for their own, for themselves, I would say. So that's going to be the auth payload. And the next type is going to be type query. So this type query, this is going to define all of the read operations available in our API. So what do I mean by read operations? Now, once you register or you log in, they're not read operations. If you want to take a look at your own information, like name, email, whatever, that's a read operation. It's like the get HTTP get method of a REST API. So you load information, you don't change anything on the database. So that's going to be a query, and the name suggests it. So we query for information. That means we look stuff up. We don't change anything. We just say, okay, show me how many habits I have. Just show them to me. Okay, now show me how many times I have followed through with a specific habit. So all of these are queries. And now let's see what kind of them we can have. The first one is going to be user. Now, when it comes to query, we do not want to fix this. So if you query for a user, like you want to query for yourself to see your own information, this is not required. You can say, okay, maybe when I'm querying for my habits, I want to take a look at what kind of habits I've entered. I do not want to see my own information. So we're going to say, okay, this is not like required when you're querying data, but you can add it nonetheless. Next up, we can query for habits. Let me just check something. So inside of the habits log, habit is individual. Inside of I'm just cross-referencing a couple of things. So inside of the user type, habits key is also plural. Yeah, and that's good. Then the type is habit. Very good. Here, the habit is going to be also plural. And then this is going to be habit. Now, if user doesn't have any habits, we're just going to return an empty array. The next one is going to be, so this habits that I just wrote here as an empty array, this is when you query for more than one habit. So if you say habits and you're querying for information, you want to take a look at information, load information. It's going to show you all of your habits. But what if you want a specific habit? That's going to be this one. So we're going to say, give me, I'm going to ask you as the developer and you as the user, give me the ID of the habit. And if you're looking for a habit, you must give me the ID. So it should not, it is not like arbitrary. It is required. And then I'm going to give you the habit depending on that. But sometimes you might want to look at habit logs, how many times you have implemented that habit for one specific habit. So that's going to be habit logs. And in here, I'm going to pass in, I'm going to ask you, okay, give me the ID of the habit. So that's habit ID. That's required. You need to tell me which logs, for which habit you want to have the logs, like the record of how many times the habit was completed. And then I'm going to give you that. So that's going to be habit log. And if you don't have anything, if you have not implemented the habit, that's going to be an empty array. Next up, we have type mutation. Now, type mutation is different than type query. This is where we have all of the write operations inside of our API. So you can think of these as the insert, update, delete queries inside of SQL. But the query is just the select query inside of SQL. So that's how this goes. What do we have for mutation? We're going to have register. So if user wants to register, what kind of information must the user actually give us? User must give us their name. This is sign up. So when user wants to sign up, we must have their name. We must have their email address. So that's type string. And user must provide password. So password that is of type string, that is also a must. And then what is the return type from this operation? That's going to have an auth payload type. Very good, which is going to be required as well. Okay, register is done. The next one is user wants to log in, right? So I'm going to just copy paste this. This is going to be log in. If user wants to log in, what kind of information do we want from user? We just want the email and the password. So I'm going to get rid of the name. Email is going to be string. Password is going to be of type string. And then what do we give user? We give user auth payload. What is auth payload? Auth payload is that token that they need in order to do something on the API. And what else? Also the user information. So that's going to be auth payload. Next up, we have now this is all the capabilities of this API. That's all of them are right here. And then our entire time is going to be spent on actually trying to implement these. So that's how this goes. We create all of the types, we created the queries, and now we create the mutations. So if you want to add another functionality for your API, you better specify that here and at the start. So you need to have like this proper idea of, okay, what it is that I'm trying to do. Of course, you can change these. Like initially when I created the API, when I did not ask users to provide their names and it looked really weird. Okay, I said, okay, user has an email address and a password, but what are they called? I'm not sure. So then I changed all of the code. That was Midway API. And I said, okay, I want name as well. So you can do that as well. The reason that I'm like going from top to bottom is that honestly, I've already created this entire API. I'm just like looking at my completed code and teaching from it. But I'm also explaining the process that it went into this and that have made me actually be able to create this. So these are the two most important ones. Then I'm going to provide some space. I'm going to take a look at this register. I'm going to copy this register again. The next functionality that I want to give my users is to be able to update their information. Now, it's a very important distinction that I'm going to make here is that you need to pay really close attention. For register, I said this name is required. Email is also required. See this exclamation mark? I said password is also required. So if you want to register, you must give me all these three information. But for update user, I am going to say they're not required. Why? You can like take a second, pause the video, think about this. But the reason behind this is because when user wants to update their information, it could be that user just wants to update their name. They want to keep their email and they want to keep their password. So if I say email is required, password is required, that means every time user wants to update their their name, they must update their email and password. That doesn't make sense. Maybe user just wants to update their email. They do not want to change their name and their password. So these are optional. It depends. If you're calling this mutation, then you can update any of these three, or you can update all three of them, or you can update two of them interchangeably. But as soon as I say required, every time you call this mutation, you must update all three of them. But then what does this update user return? It doesn't return an auth payload. It returns the updated user. It must return that. The next the next mutation that I want to add here is delete user. So what if user is fed up? User wants to delete their account. Then user should be able to do that, right? The type of this is going to be Boolean. So why Boolean? Why not some information? Because user just deleted everything. If user deletes their account, then all of their habits, all of their habit logs, everything is going to go away. There is nothing left in there for us to actually show. We can just show a true message indicating, okay, you did delete everything and there is nothing left here for you to do. All right? So that's going to be the delete user. So this is the second batch of mutations. The first batch was for register login. The second batch is for the user information itself. The next batch is for creating a habit. So that's going to be called create habit. Now, the idea behind this is to create habits, right? When user wants to create a habit, what kind of information do we want from user? And they're required. That's going to be the name of the habit. I want that. I want to have the description of the habit. You must give me that. And that's it. What about the other information? So if I go to the habit, I asked from the user the name and the description. I didn't say give me the ID, because ID is something that SQL is going to generate. I don't worry about it. I didn't say give me the current streak. That's something that I'm going to calculate myself. Give me the longest streak. That's something that we're going to write code to be calculated. Created that and updated that, they're going to be handled by SQL. So we just need name and description. Much like here, we needed name, email. Oh, I didn't add password here. We should have password. ID, name, email. Now, I'm not going to add password because we want to actually not have it as something that's going to go to the front end. Because you can see this is type user. And where do we return this type user? If you go to mutations, if user wants to update their information, we're going to send user to the client. Like we're going to send user their own information. If I add password here, the new user is going to see their password. That doesn't make sense, right? We should not send password to the front end. And then that password is not going to make sense in another way. And that way is that it's going to be hashed password. User is not going to know, okay, what that means. So it's just better if we do not send it to the front end. So let's move forward with this one here. When we create a habit, what do we return to the user? Now, after the colon here, what I'm writing, that's what the client is going to see as a response. This is what they're going to see. All right. So that's going to be the create habit. Next up, we are going to allow users to actually be able to update their habits as well. So if you have created a habit, then you want to change its name, you should be able to do that. And that's what we do here. But again, we remove these required flags because we do not ask users to like update both of them. Like, okay, which one do you want to update? Like you must update the name and description together. That's not something that we want, but I want something from user, and that's the ID of the habit. So that's going to be ID. You need to give me which habit it is that you want to update, so I know, okay, you want to update this habit. After this, we are going to have the delete habit. This is, now, if user deletes a habit, user must give us, okay, what habit it is that you want to delete. And then for update habit, we return a habit, but for delete habit, we just return a Boolean because there is nothing to return. So this is the second batch. The third batch, they belong to the logs that we create for one specific habit. Now, again, these are all the mutations. It means these are all the write or like update or delete functionalities that this API has. If you want to extend the functionality of the API, you should start here. So if user wants to check in for a habit, for example, yesterday and the day before yesterday, I went for a morning walk. I went for a morning walk today as well, this morning. And now I want to record that. That's going to be check-in habit. So check-in habit is going to be the mutation that is going to set or basically record a specific day in which the habit was accomplished. For this one, we need to know the habit ID. I need to know which habit I accomplished today. That's going to be the habit ID. And then when I accomplished that habit, that's going to be this one. And that's going to be, what is this going to return? It's going to return a habit log type. Now, when it comes to check-in, we know that we need to have a date. When did we complete that? It is not required because you can provide a specific date, or you can just leave it empty and we're going to write code that is going to default to the day. So that's why it's just the ID that we require. And finally, we have the delete habit log. So you have like for the past, like you wanted to have, so how do I formulate it? For example, you wanted to read a book for 30 days every night, like for 15 minutes before bed. You implemented all of that, and now you want to get rid of the habit log. You want to like start again with a different one. So you just say delete habit log, and that's going to delete all of the logs that you have registered for that specific habit. But then we need to know, okay, which log it is that you want to delete. And then since there is nothing after deletion, this is going to have a type of Boolean. Very good. So this is all of the GraphQL types that I specified here. And just one reminder when it comes to types in GraphQL, they actually specify the shape of a piece of data. So a type in GraphQL, as you can see, this is a struct. It has properties and it has values. So it has keys and it has values. And we need to go by this shape. whenever user wants to access some kind of information, if user sends us a query that is not available in any of these types, we're not going to be able to implement it. But we are able to implement just one field of one of these types. That's the flexibility that a REST API does not have. So now that we are done with this, let's move on to the next step. In the next one, what I want to do is, now I want to generate some code. I want to generate these schema GraphQLs, these types. I'm going to talk about, okay, what I mean actually by that, but we need to have a placeholder. So inside of this, let me collapse this one. So we have, this is our project structure. Inside of the internal, we have this models folder. Inside of the models folder, we need to go ahead and actually create an empty something. There should be some kind of package. And in here, I am going to create something that's called models.go, and I'm just going to import one line. Why did I do this? Now, this is a very, very important step. We want to generate some GraphQL code. And specifically, what I want to say is we want to generate function stubs. And once we have generated those stubs, the entire time that we're going to spend here is going to be to replace those generated stubs with the functionality that we want to implement. But since we have specified, okay, these are my types. These are my queries. These are my mutations. They need function stubs. They need some kind of placeholder functions that we are going to replace with our actual code. But the problem is that we have not had anything created inside of this models.go. And if you go to the GraphQLgen, here is where we actually, let me just show it to you. So here, when we say auto bind, we say, you're going to find all of my models, all of the shapes of the data that I've specified inside of this folder. It's internal and models, and you're going to go in there and you're going to expect to find a models.go file. Now, this is the auto bind here. And what is this auto bind? Auto bind basically tells our GraphQL generate, like before generating types from the schema, look inside this package first. If you find a Go struct that matches a type inside of the schema, we use that struct instead of generating a new one. So you need to actually bind these types with the GraphQL schemas that we have created to generate something called function stub. And I'm going to show you how they're created. We're going to replace this models.go with our own specific models. We are going to have a user model. Now keep in mind, this is GraphQL. The code that I've written here inside of the schema.graphqls, this is not Go code. This is GraphQL code. You can see the extension is .graphql. These determine what kind of information user can ask for. But shouldn't we have all of this in the form of Go so they talk to our database? We should specify tags as well. So when we go to actually this models, you can see this models. Now let me collapse these. Take a look at this internal folder. We have the internal folder, we have the config, the database, the graph, the middleware, and then we have the models. Graph is a different folder than models. Inside of graph, we have everything that's related to GraphQL. But inside of models, we have everything that is related to Go. So you need to be able to distinguish between these two and why we need them. So for every specific type that you have inside of GraphQL, even though I said, okay, a type is like a Go struct, you need to have a Go struct for that type because you need to scan the data that you receive from the front end into those specific table columns or table rows that we are going to create. So all of this is very important that they should be weaved together. So that's why we need to have something inside of our models that we can show GraphQL, okay, here is what I have. I haven't created anything else. Take this, generate function stubs for me. Then, based on function stubs, I am going to create resolvers, repository operations, the user. I'm going to have a user struct, which is going to talk about the type user of GraphQL schema. Then I'm going to have another one for habit, another one for habit log, and so on and so forth. So this is how this goes. Because we want to generate, essentially we're generating GraphQL code. We need to have something inside of the models. So they have this connection together. And in our upcoming, I would say in next few minutes or next couple of hours, I'm going to just show you all of this and how all of this actually talk to one another. So now that we have this models.go, you can see this is Go code. This doesn't have anything to do with the GraphQL code that we have. Now, what we're going to do is we need to actually go ahead and generate function stubs from this. So I am going to come right here. Now we do have some issues here. Let's go ahead and let's actually talk about them. We have this issue. The problem with this is, now this is generated. Whenever it says generated code, you should not touch this. This is auto-generated, and it is going to be, even if you make any changes, it's not going to make any sense. So the problem with this is it thinks that graph folder is inside of this main directory. But no, the graph folder is actually inside of the internal. So inside of the internal. It's not inside of this because we moved it from there, remember? And then we have the same issue here where it says this. So what we can do is we can actually go ahead and delete these files because we're not supposed to touch these. So I'm going to delete these two. There is one more here. So I'm going to delete this. I've selected all three of them. I'm going to delete them. And we're going to call that generate code or generate command again. So that was go run. I could just copy paste it. Let me put that here. We have already ran this. So I'm going to run this again. And now you can see here is the issue. It is saying, okay, we need to provide all of these packages here. That's the other issue that we have here. And the reason behind this is once you run go mod tidy, that's going to get rid of all of the packages that are not currently being used. So what I'm going to do is in the project root, I'm just going to collapse internal here. I am going to create a file that's going to be called tools.go. And inside of this, the only thing that I want to add is, let me just come right here, the only couple of things. So the first one is going to be package tools. And then we're going to import this GraphQLgen package that we want to install. So now you can see it says it's not actually installed. We need to go ahead and install this. The command for this one is here. I'm just going to run this. And there we go. You can see 4 of the issues are gone. There is just one remaining. Package tools. What is the issue? It doesn't, not import package, import. So, okay, for now, I am going to just ignore that. Now let's go ahead and let's run generate again. I could say go mod tidy. Okay, we just have this one issue here. And now we're going to generate function stubs again. Now let's take a look at our folder graph. We don't have anything inside of generated. We don't have anything inside of model. We just have this resolver.go. And let's go ahead and let's run this. Let's see what kind of error we're going to get. I'm going to zoom this out just a little bit so I can see everything better. So it says validation failed. It did create these files. So found package, graph, resolver, and resolvers, exit status 1, resolvers, exit status 1. So if I take a look, it did generate these. What seems to be the package resolvers. Let me take a look at the resolver.go. It says package graph. This should say package resolver. And resolvers, sorry. Save this. Let me generate this again. Okay. Nothing. That's very good. Collapse that. So we still have this issue inside of tools. Get rid of this. And generated. Now you can see there is no error because it now knows where that is located. Models.gen. Very good. Model auth payload. This is very good. So this is something that was generated based on the types and the query and the mutation that we created. Schema that resolvers. And there we go. This is what I was talking about. These are all of the function stubs that eventually we are going to create mutations and queries for. So all of these are going to be replaced, and there is not going to be, like, except for these, there is not going to be anything else here. And we're going to replace all of these with our own resolvers, whether query resolvers or mutation resolvers. So that's good. Let's actually talk about this. And I'm going to come right here, go to the problem. And for this one, we need to actually have this here. We're going to have go build tools. And we don't really have to worry about this. These are like some VS Code issues, and they will not hinder the process of actually coding. So if I run air, you can see everything is working fine. You could create a settings.json. I could create that in the direct in here, but again, I do not want to waste too much time with this. So everything is working fine. We have created all of the stubs that we want to. These are, again, all of the, you can see the mutation resolver tag. And also you can see the query resolver. What about the other types? They're not resolvers. So resolver is something that user can do with the types. Okay, so you can either query for some data or you can change some data. But then this is all the functionalities of this API. And now as the next step, what I want to do is I want to set up GraphQL server inside of main server file. So here, the first thing that I'm going to do is I'm going to create the GraphQL handler. So let me see where I want to put it. So that's going to be right after the database. Here we're going to have, let me zoom this in. This is going to be called GraphQL handler. And the idea behind this is to create a GraphQL server. So GraphQL handler, aka GraphQL server. And for this one, we're going to use a short variable declaration that's going to be handler dot. On the handler, we have new default server. So this is going to create a new GraphQL server. Why do we do this? Because we want to have that some way to send requests to the server. So we could either use Postman or we could use the GraphQL playground. Now, since we talk about GraphQL, I want to use the GraphQL playground, not the GraphQL, not Postman. Okay, so this is going to be the GraphQL handler. And this new default server, this handler, it accepts one argument that is generated dot new executable schema. The executable schema is actually our generated code that wires the schema definition to our resolver implementation. where are our resolver implementations? Well, we haven't created any implementations. We generated, or GraphQL generated the stubs. We're going to create the resolver definition and get rid of the stubs. And we're going to talk about, okay, what is the difference between these two and why do we need them? Now, again, you need to keep in mind that this is generated new executable schema. This is generated by GraphQL gen that we ran from our schema. So remember we specified schemas, and this takes a generated.config object or struct that is going to hold our root resolver. So that's going to be, I'm going to say generated.config. And this is a struct, so we need to open up the syntax for it. And this is going to contain the main or the root resolver. How many root resolvers have we created up until now? We just have one. So if you go to resolver.go, open this up. What is this? This is the first one. This is the first one, and this is going to be the last one. We just have one root resolver, but then inside of this, we're going to specify what kind of repository operations we can implement. So here I am going to say resolvers. We need to point to the root resolver that is inside of graph. So I'm going to say graph.resolver. That's a struct, and I'm going to pass in the ampersand here as well. Now, right now, this root resolver, as I just showed you, is empty. In our next steps, what we are going to do is, one of the things that we are going to do is we're actually going to specify, we're going to add or specify the database and repository dependencies here. And this is going to be done incrementally. So once we want to implement something, we're going to add that here. For now, what we want to do is we just want to see the GraphQL server up and running. So here that's done. I'm going to go beneath these trusted proxies. So let me see where I can find. So we have this home route where we actually added the health check. On this, what I could do is on the home route, I'm going to add playground. And for this, again, you need to have some kind of a function, an anonymous function that is going to implement the business logic once user goes to this. Now that I'm thinking about this, what I could do is I could just comment this part out, just copy it down below, uncomment it. You could keep the health check if you want to, but since I'm changing the code, I want you to have this like the first original code that we had. So this is going to be playground. So whenever user goes to /playground, what do we want user to see? We want to show user the GraphQL playground. We don't want to show user this. So instead of this, what I'm going to do is I'm going to say playground dot. As soon as I do dot, I have the handler available on it. So handler, that's uppercase H. Now, what is this handler going to do? This is going to actually create an HTTP handler for the playground UI. Now, the first thing that we need to pass to this one, it's going to have a couple of arguments. The first argument is going to be the string GraphQL playground. Playground. And the second one, so I'm going to go outside of there. The second one is going to be the endpoint that the playground is going to send queries to. Remember, towards the start of this video, I said, instead of having it one endpoint in REST for one specific action or handler or controller, we're going to have like one in GraphQL for everything. So if you want to implement 10 things on your backend, you want to have 10 different responses, you need to have 10 different endpoints in REST API. But even if you want to implement 100 different things inside of GraphQL, you just need one endpoint, and that is /GraphQL. That's it. And then on here we have a function that is serve HTTP. Serve HTTP function is something that we need for Gen framework. So what we are going to do is we are trying to make this compatible with Gen framework. So in Gen framework, you need to return something called gen.handler_func, which I've really talked about a lot in the previous video that I talked about REST API. So we need to wrap this by calling serve HTTP, and then we're going to pass in c.writer, that's writer. This is going to be the gen's response writer, and then we have c.request, which is going to grab the incoming requests. Right, so this part is done. Let me save all of this. The reason it doesn't know what this is because we have not actually imported that. We are going to come to the, I'm going to show you, I'm going to do the imports later. For now, I just want to complete the code. The next thing that I want to do is I want to register the GraphQL endpoint as well. That's going to be router.post. Now, whenever we receive requests to the actual /GraphQL endpoint, all of them are going to have a type of post. This is going to be context, and we know what the type of this is. We have talked extensively about gen.context and gen.engine. Now this, again, this /GraphQL, this does everything. This is one single endpoint that is going to handle everything. It's going to handle reads and writes and updates and everything. And we need to basically wrap this in the same way that we wrap the playground. We're going to say GraphQL handler dot serve HTTP c.writer, and then we have c.request. Save c.request. There are two pairs of parentheses. We just need one. Writer. Very good. So we just have that. Let me give you two print statements that are going to point to the playground, where playground is going to live. So localhost 3000 /playground, that's the playground, and this is the GraphQL. Now let's talk about the imports. I'm going to go beneath here. I'm going to import this one. This is generated, redeclared in this block. So, we have this handler imported already. Let me get rid of this. Save this, and yeah, we have three more issues. This graph, undefined graph. Let me import this as well. This is going to be the graph that contains our root resolver. So let me put that here. Let's see. Yeah, that issue is gone. Let me import. So we have how can I put all of these together? So we have graph and then internal graph there. Let me get rid of. This is the one that I imported just now. I am going to actually copy paste all of the inputs, and then we're going to see what the issue is after that. So just give me 1 second so I can arrange all of my notes. I'm going to grab all of these and I'm going to replace them with these, save this, and let's see what the issue is now. Okay, so we have this graph that says could not import graph. Current file is not included in a workspace module. Package main. This should be package main. The rest of the issues are gone. Let me see. if I comment this one out, yep, we need it for that. Then again, internal graph. So this is here. I'm not sure. Open main.go. No packages found. And let me just add resolvers here. It got rid of that. Not used. And I think I need to add that. I'm not sure. It's not in your code.mod file. It's not WebSocket. Go mod tidy. So this is gone. Very good. Okay, so that part is over. Let's clear this. Let me run air. Let's see if there are any issues here. It didn't build anything. It says package graph internal is not in standard library. Graph is not in main.go 1902. So it's talking about this. If I get rid of this, then it's this one is this is the one that is screaming. Config. So we have handler. Let me hit enter. Hit enter here. Just put it there. Save this. Undefined graph. Undefined graph. Gen. Resolver. But the path is correct. Just save this. We still have the same issue. So what I can do is I could say resolvers. Oh, that fixed it. Oh yeah, so it's in resolvers. We were saying, okay, it's in graph that resolvers. No, we actually changed its place. So in case you're wondering, I just changed. It wasn't in graph that resolvers. It's in resolvers.resolver. So it's in that directory. So it's basically some mishap. Anyway, now if I take a look at this, you can see it's actually trying to build it. This is the playground, and there we go. Very good. Congratulations. We actually did the setup. If you come right here, you're going to see the query types. You're going to see the mutation type. Very cool stuff. Let's go back. You can have the user type. You can see all of your types here. These are GraphQL schemas. Of course, you should be able to see them here. If you click on query, you can have the me, the habits, habit ID. So all these 4 fields inside of the query. Here is, so this is the playground. If you haven't seen it before, this is really interesting. And so we're going to get rid of all of this. Whenever you do something, you click on this, it's going to, so this, let me just go a little bit better. So the part that we have, so here, this is where user is going to make the request. This is where user is going to receive the response. So this is essentially the client. This is client. And this is what the server sends to the client. And then once user creates a token, they're going to add it to here to headers. Cool. So you can prettify the code if you want to. You can take a look at the history of all of, I think there's going to be like 20 or something history of the queries or mutations that you've implemented, but there we go. This is where we're going to spend most of our time. And this is the /GraphQL. You don't have to go there. That's wired internally. You don't have to worry about it. And with this setup has actually come to an end. We did set up everything. We fixed all of the issues. Let me take a look. So go build.mod actually did not fix this issue, but it did fix the issue that we had inside of the main.go. And from the next steps onwards, what we are going to do is we're actually going to go ahead and implement the rest of this API. So what we need to do next is we need to go ahead and create the migrations. And what do I mean by migrations? Well, remember we actually implemented migrations. We ran that command. Now we need to go ahead and create migrations inside of the migrations folder, where we are going to specify what kind of SQL changes we want to bring inside of the API. But before getting started with the migration topic, implementing the SQL statements, creating the files, I want to give you some resources. So I'm just going to paste it in the folder in which this VS Code is open, this project is open. So you're going to see a folder right after this data folder. There is going to be another folder between the data and internal, and that'll be called guides. So if you just open this, just click on it, you're going to see 3 files in there. I feel like I've ran a lot of terminal commands. They're longer in nature, like you have to pause the video and actually take a look at them. So you have this guides, and inside of here you have this habit streak tracker setup guide. If you double click on it, this is something that I created just so you can know, okay, what are the prerequisites, what are the commands to install different things. So this is the setup guide, all of the commands that we run, and then I created 2 more. One is how to install SQLite 3 on Windows, very important, and you can just go step by step, and this is going to show you how to install SQLite 3. I'm not going to go over this. And then we have this migrate SQLite driver. Remember, I installed this library first, but then we migrated to this one because I didn't want to worry about the C compiler. We just went with pure Go. So I wanted to show you these, that you have access to them if you want to take a look at them and use them. I'm sure they're going to be useful to you. And now back to the topic of migrations. So the idea behind a database migration is a version controlled SQL file that is going to define a change in our database schema. You can think of this as Git, but for your database. Just like Git tracks changes your code, migrations, they track changes to your database structure over time. So if you want to add something, or if you want to change your database in some way, you can track it using migrations. If you want to undo that change, you can also track that in migrations. Now, one of the important ideas behind database migrations is that, imagine, I'm just going to show, say this very simple example, and then short and simple example, and then we're going to move forward. Now, you can imagine you're working on a team, you create, let's just keep it very simple. You create a users table on your computer, on your machine. Now, your teammate clones this project, their database is empty. And the person who has copied this has no idea what kind of tables to create or what columns they need. Now, without a migration, you would have to tell every developer, oh, run this SQL command every time the database changes. Now, this approach is, of course, possible, but this is error prone and it's very difficult if you want to scale your database. So with migrations, what we can do is we can have every schema change in a file committed to GitHub, and any developer can run the migrations and get the exact same database structure. You always know the history of how the database has evolved, and if something goes wrong, you can reverse a migration. aka you can roll it down. So when it comes to database migrations, we have files that are going to be labeled up. They're going to, what that means is they apply change. For example, they create a table that's called users table. And then you have files that are denoted with down. You write the down keyword in their name. And that file reverses the change that was created in the up file. So the down file is directly connected, it's tightly connected to the up file. Whatever the up file does, the down file reverses that. For example, it drops the table. Now, when it comes to these migration files, the first thing you need to do is you need to actually add these numbers. They are for version control, so they have to run in numeric orders. So I have 5 zeros, and then I'm going to add 1. So what this says, this is going to be, okay, this is our very first migration. I'm going to add underscore. Then I'm going to say what this migration is going to do. Basically, I need to provide a descriptive name of what this migration does. I'm going to say create underscore, create what? Users what? Table. Okay, so this is our migration. Now, this migration is going to contain SQL code. If we have a file that is going to contain Go code, the extension is going to be .go. For SQL, it is going to be .sql. But before adding .sql, we need to signify whether this is an up migration or this is a down migration. How do we signify that? We're going to say .up and then the extension of the file .sql. And you can see the database icon in there. And I'm going to hit enter. So this is a migration. This is an up migration in which if we run this migration, this is going to create a table called users. Now, we are going to go ahead and we're going to create another file that's going to be the down migration of this one. So I can very well just copy paste this and rename that. Now, instead of up, I'm going to say down. The same thing. So it's going to be this exact same file. Now, why is their name the same thing? Like the number? It's because this down migration belongs to this up migration. It reverses what this up migration does. And that's going to be the down migration. Now let's go ahead and let's actually see what it is that we want to write inside of the up migration. Now, whatever I'm about to write here, it has nothing to do with Go. This is SQL code. In simple terms, this is code that we use for SQLite, which is an RDBMS of SQL. So this is database language. This is not Go code. So what is it that we want to do? We want to create a users table. Why do we want to create a users table? Because this table is going to contain the specific columns that are going to allow users to sign up. So when users sign up, what kind of information do we want from the users? Well, we have already created them, remember? And where did we do that? Just think about it before actually going ahead and opening the file. So we did that inside of internal, graph, and inside of this GraphQL schemas. So we said if we want to accept data for a user, we need to have all of this. That's for that specific user. But when user wants to sign up, we don't have habits at that specific point in time. So we're going to select ID, we're going to select the name, we're going to select the email, created at, updated at, but then what else do we have to add? We have to add the password for users. So this is how we actually go ahead and do this. So these two actually go hand in hand. Now, to be able to create a table, you're going to say create table. Now this uppercase is a SQL convention. So we're just going to go with that. We're going to say create a table if it does not already exists. So I'm going to say create table if not exists. And what is the name of table? It is users. And if this is the first time that you're writing SQL, this might seem really easy. And yes, database language, SQL language is extremely easy. You can think of this like pure English. It's just very normal to talk about it and to actually write it. You just have to know the right keywords, and it's very simple to understand and very simple to work with. So this is going to be the table. Now remember, we're talking about a table. When we talk about a table, what does a table have? A table has columns and a table has rows. What is the job of the column and what is the job of a row? The job of the column is to specify what kind of data we can accept. The job of the row is the actual data the user sends us. So before having the rows, we need to have the columns to specify what kind of data user can send us. So the first thing is going to be the ID, because this is the primary key. This is going to determine and distinguish users from one another. The type of this is going to be text. Now, ID is the name of the column, but then you need to specify the type of that column and then some conditions on that. So the type of ID is text, but then I'm going to say this is going to be primary key, which basically means this is going to be a unique identifier for each user. Then we're going to say default. Oh, I need to provide space. So default to signify that I want SQL or SQLite to automatically create this. So, but this default does not come alone. We need to specify what kind of an ID we want to create. We want to create a UUID, which stands for Universal Unique Identifier, for every new user, right? So we need to have this be very specific. Now I am going to use this method that's called, first off, I'm just going to write the method that's called random blob, and I'm going to pass in 16. What this random blob 16 is going to do is this is going to generate 16 random bytes. The next step that we are going to do is we're going to convert these bytes into a hexadecimal string. So I'm going to surround this by another method that is going to be called hex, that is going to do what I just said. After that, we need to go ahead and actually lowercase this. So I'm going to select this entire thing and I'm going to call the lower method on it. And then we are going to surround all of this with a pair of parentheses as well. So this is going to look like something like this. So I'm going to remove this comment, of course. This is going to look like something like a combination of alphanumeric characters. All right. So this is going to be unique for every specific user. For every user, this is going to be unique. Now, this is the ID. After the ID, what do we have? We have name. Now, again, name, this N-A-M-E, that's what the column is called. But what is the type of this? The type of this is going to be text. And then I want this to be required. So I'm going to say non-null. That means this is going to be required. I want users to 100% provide me with a name. And then I want users to provide me with another thing as well, and that's called email. Now, when it comes to emails, what kind of conditions do I want to specify? First, I need to specify what type of email I'm going to accept. That's going to be of type text. Now, when it comes to the actual email itself, the structure of that we need to have the @ sign, we need to have dot something at the end. That's the job of the Go code. Here, we're just creating a table with columns. That's it. So I'm going to say email is going to have a type of text. Then I'm going to say this email is going to be unique. So you cannot create two accounts with the same email. And then I need this as well. That's going to be not null. What else do we have here? Well, for every user, we want to have password, right? So I'm going to create another column where I'm going to put the password of user there. That's going to be of type text. And this is going to be null. Sorry, this is not null, not non-null. And now we need to have two more columns. One is going to be when user has created their account. So one is going to be created _at. Now, these columns I want to be populated automatically. From the user, what I want is, I just want name, email, and password. ID is going to be created by SQLite as well as created at and updated at. So the type of this is going to be date, time. So if I want this to be created automatically, what is the keyword that I'm going to use? I'm going to use default, much like above for ID. So I'm going to say default, but then default needs something else in front of it, right? I'm going to say current _ time stamp. So it depends on which timestamp it is. This is going to automatically set this to the current date and time of when a new row is inserted. So we don't have to provide any kind of value. So let me just check the spelling. And after this, we have updated at, which is going to be the same thing in type, as well as this automatic generation of this. So this is it. That's it. If this was the first time you did this, you need to add a semicolon at the end, save this. If this was the very first time that you were writing this SQL, I congratulate you. It's extremely simple. See, that's it. Every time you want to create a users table, this is going to be the most relevant information. Of course, you can add a lot more if you want to. Now, let's jump into the down table. The down table is always going to be easier than the up table because it's always easy to destroy something, right? It's going to take time to build it, but destruction is very easy. We're going to say drop table if exists. Now, what table am I referring to? Users. And that's it. See? We spent so much time curating this, and we just destroyed with this. We just dropped the table. We say drop table if exists, users, and that's it. And now the next step is to actually go ahead and run the up migration so we can actually see the table being created, and then we can run the down migration to see the table being destroyed. So the first thing that I want to do is I want you to make sure that you have this habits.db. This is our database that's going to contain these tables so we can actually take a look at them. So here, now the way you can run migration is that you can have like a long string. I'm just going to collapse internal. You can run that every time you want to run migrations. Or what I like to do is I want to create another folder inside of this, inside of the main directory, right? So I have the scripts here, which is the folder that I've already created. And in here, I am going to create a new file that's going to be called migrate.ps1. PS stands for PowerShell. Now, again, if you're using any other kind of system that doesn't use PowerShell, this is not going to work for you. So you need to find out, okay, what is it that you use? Since I'm on Windows, I will be using PowerShell. Now I'm going to copy paste here a command that we're going to run that's going to take a look at whether we are passing the up migration or we're passing the down migration. And I'm going to sort of explain this, but I don't want to jump too much into the details of this. So migrate-path migrations, this is going to run migrations in Go, right? So we say database exists at this location. And then what we do is we select, so when we run the migration, after selecting the name of the file, this migrate.ps1, we're going to add a space. And then, so it goes like this. I'm going to say dot /, see, I already have that. So I have dot / scripts / migrate.ps1. What is this? What am I doing here? So here I'm referencing the file. Which file? I'm referencing the file in which I have this code. And then after that, I pass in an argument. So that's what this means. So this means arguments, which is going to be a slice, selects the first one, the one with the index of 0. It means this. Why do we do this? So we can understand whether or not this is an up migration or this is a down migration. Now, if you want to see when it comes to these, how we do these migrations in the context of if you have more than one migration, how you can be selective, you can visit, you can take a look at my GitHub for that gqlgen Postgres to-do REST API. In there, what I've done is, let me just pull this up. I'm just going to pause the video just to show it to you. And here is my GitHub. In case you're wondering and you want to just follow me here, and or you want to take a look at the code here, you need to go to my GitHub, and that's under name. You can search for Arna Code or Muslim Hilali. You're going to see this. So you're going to come to repositories, and in repositories, see this is the project that I did on December 3rd, 2025. gqlgen Postgres to do REST API. And this is the first project that I did here on YouTube. And the reason that I'm showing you this is because of these scripts, because we're going to have 3 different migrations. And these migrations, I'm not going to write the code that is going to specifically run one specific up migration or one specific down migration. So if you want to do the down migration, you're going to get rid of all of the tables. But if you want to be specific, you can take a look at this code. I've actually taught it in the video that is here in this playlist on YouTube. Or you can just take a look at this code and understand it. And then you can run the migration and you can add a version. Okay, which version of the migrations you want to run up or you want to run it down. So you need to have all of this, but I'm not going to do that. So what I am going to do is I'm just going to say, okay, when you say up, then it's going to run all of the up migrations. When you say down, consequently, it's going to run all of the down migrations. Now, what we want to do here is we want to be able to do this. So I'm referencing the scripts folder, and from scripts folder, I'm referencing this file. And then as soon as I say up and hit enter, if there are no other issues, this should go ahead and run the up migrations for us. And it should say, okay, like this has been created. Now, but here we see we have an issue that it says SQLite 3. It's not like it doesn't know what that is. Let me get rid of the name from here from SQLite 3. Let me just go ahead and run this again. And then it says we have some kind of a syntax error. So you need to read this carefully. It says SQL logic error near this, syntax error in line 0. So create table if not exists users. So what seems to be the problem? Let me just take a look at this. And so we have the final semicolon that's required. You need to have a comma. Oh, the last one doesn't need a comma. So I'm going to get rid of that and clear the subc. It's going to take dirty database version fix and force version. Now we need to actually, dirty database basically means there was an issue with the database. So it's easy. So it's, you need to go ahead and clean this up and then run this again. Okay, so what I'm going to do is I'm going to run the down migration. It says, are you sure you want to apply all down migrations? I'm going to say yes. And it says applying all down migrations, and it gives me the same issue. So what I can do is I can actually force this. So instead of up and down, I can say force 1, hit enter, version, please specify version argument. What we can do is we can actually go ahead and change this. So I'm going to get rid of this 0 from here. That means you're going to take a look at all of the arguments vector, not just specifically the first one. So I'm going to clear all of this. I'm going to run this again, and you can see there are no issues. And then we're going to run the up migration. And it says no change. So now let me go ahead and let's run the down migration. Yes. and it says applying all down migrations, create users table. So what this means is we actually created a table and then we got rid of it using the down migration. So what I'm going to do next is I'm actually going to go ahead and I'm going to create the table again. So you can see this, right? You can create this table and then you can drop the table. So here we're going to say the up migration, create users table, 21 milliseconds. Now, how can I take a look at this? How can I see where the table is? Well, we need to connect to our database. So I'm going to say SQLite 3. Now, I already have this command, of course. So we are going to say SQLite 3. That basically means the SQLite version. That is SQLite 3. And then data folder. And inside of the data folder, we have the habits.db file. I'm going to close this. So we basically grab this DB and I'm going to hit enter. And now there we go. So as soon as you see something like this, or basically this, it means it is ready for us to show us our tables. So for SQLite, the syntax is a little bit different than Postgres, but it's very easy to understand. We're going to say dot tables. This is going to list all of the tables. So we have schema migrations table, which we're not going to touch. This is Golang migrates tracking table. This is going to have records with migrations that have run. We're not going to touch that. But users table is the one that we have newly created. So what we can do is we can say dot schema users, and I'm going to hit enter, and there we go. This is exactly what we have actually created. Now, we could also say select everything from users table, semicolon, hit enter. We don't see anything. Why? Because this table is empty. And then how do we get out of here? We're going to say dot exit, and there we go. So this is how we created the database, we actually connected to it, and then we exited from that as well. Now we could, I'm going to show you a website. I'm going to show you basically a tool. Let me just open it up. So there we go. This is a tool that I use sometimes, especially when I'm working with SQL-based databases. There are like DB browser for SQLite that you can go ahead and use. Like what I mean is a GUI software where you have like an interface. You can work with this. So you can work with MySQL, Postgres, SQLite, SQL Server, and more. And the good thing with this is free. So the only thing you need to give is your email address. You just give your email address, you download this, and you install it, and you just select this DB file. But what I'm going to do is I haven't actually decided to install this software on this laptop, because as I mentioned, this is not like a really powerful laptop, so I have to be very careful with what I'm installing. I'm using OBS for recording, but if I like go crazy with installations of different software, then OBS is not going to be able to record. So there is going to be a lot of memory usage, and OBS is not going to be able to decode the videos. So that's why I am really reluctant to use this, install this, even though I know this is going to give us a lot of benefits. You can just go from one table to the next table. And another main reason that I am using this is because of the dark mode. This software actually has dark mode available. So now that I'm thinking about it, you know what? I'm going to go ahead and install it, and fingers crossed, this is not going to make any issues. Installation of this is very easy. You can just search for Beekeeper Studio and install the free version. There are going to be some pop-ups here and there, but that's okay. So it's going to give you something like this. You can run SQL queries here, which we are not going to do. We're just going to take a look at the table, but we can see the table from the terminal as well. But at some point in our API, there is just going to be a lot of copy pasting from the habit ID to the user ID to the habit log. So like navigating these windows, that's going to be a little bit tedious in in just one terminal. So in that time, or at that time, we could go ahead and actually use this. So this is just something, a very useful software that I found and I wanted to share with you. So now that we have our table, what it is that we want to do next? Well, the next thing that we want to do here is we need to actually go ahead and create models. Now, we created the schema, GraphQL schemas, but we have no way of knowing how those schemas are going to basically talk to our database. So we don't have this link in between them. And that's where Go comes in. So we need to actually write code that is going to determine what kind of data we accept from the user. And that data that comes from the user, that's in the form of JSON. Where do we send that data? Where do we send that data? And how do we want to store it? So you need to actually trace column by column. And that's something that I want to do next. The first thing that I'm going to do here is I'm going to jump into the internal. In here, we have this models folder. Now, this models folder is directly inside of the internal. We're not talking about the model folder, singular, that is inside of the graph. I'm going to open that up first just to show it to you. So these models, they are generated automatically. And in here, you can see it says, do not edit. So these are some things that GraphQLgen generated automatically based on the schema.graphql that we added. All right, but there is a problem with this. This is every time we run that generate command, all of these are going to be regenerated. So even if I make any change, that's not going to work. It's just going to go away. So that's the first problem with this. The second problem is that we do not have something that's called DB struct in here. So we have its corresponding JSON struct, but we do not have they're basically called DB struct tags. So we have the JSON tag, but we do not have the DB tag. And I'm going to explain why don't we suffice to this one? Because in that scenario, we will not be able to actually scan data to our database and from our database. And what that means, I'm going to keep explaining this. So that's the issue with this. So that's why what we are going to do is we're going to go to this models folder. So I collapse the graph folder. We're going to go to the models folder. Here we have the models.go file, which we created a while back in order to just prevent some errors that GraphQL generate command would have thrown, because it needs to have like something here. So here what we are going to do is the first thing is to create the user model. Now, what is a model? Well, a model is basically an object. It's a struct that represents a piece of data inside of our application, inside of this API that we're working on. It basically defines what shape of data or what fields that specific type is going to have. For example, if we talk about the user type, what fields will it have? That's what a model is going to determine. Now, once we define this, using the auto-bind feature of this GraphQLgen inside of the YAML file, we're going to tell GraphQLgen to use these types instead of the ones that we have inside of the models_go, we're going to use these types. Another benefit of this is that we actually separate these concerns. So this way, every part of the application, meaning repositories, which we're going to talk about, resolvers, middleware, they can import the same user model, the same struct definitions from one place. We don't have any duplications, and there are not going to be any confusion about which user type to actually use. So how do you go about this? Well, we're going to say type. That's something that is going to start this. And what should be the name of this? Well, we say type user, and we know that this is a struct. So let me just provide a space there. This is struct, which basically means there are going to be key value pairs. So the first one is going to be ID. This is the first one. So when I say user, the first thing that comes to mind is going to be ID. the type of this is going to be string. And now we talk about something that's called JSON tag. And then we also have something that's called DB tag. And here is where I'm going to explain this. So we have two things when it comes to actually creating any kind of field inside of a struct in a Go model. And this is called a struct tag. This is some extra information that you could say you tag along to that specific field. I'm gonna zoom this in, collapse the sidebar. So you can see I have used backticks. That's part of the syntax. Now each tag is actually a key value pair. So you have the key, that's the name of the tag, and then you have value that's going to determine what the tag is going to contain. So the first key value is that we are going to have JSON. So this is the name of the key, but what is this key going to represent? This is going to represent ID. So what is the meaning behind this? Well, this JSON ID, you can see ID is the same ID as the name of the field, but it is in lowercase. So this basically tells Go's JSON encoder decoder what name to use for this field when we are converting our response to JSON, or we are converting from JSON. So we are converting to JSON, or we are converting from JSON. But without this tag, Go would use the exact field name, which is uppercase ID. So the field name would be ID, which is this uppercase, but here we say, okay, if it comes through the request, if it goes through the response, it's not going to be ID. Just say in JSON, we're going to lowercase that, we're going to say ID. So that's the idea behind this one. And then what I'm going to do is I'm going to provide a space, and then we are going to have another thing that's called a DB tag. So a DB tag is easier to understand. DB tag is basically going to tell the database scanning library. Now, we have not actually talked about scanning. That part comes when we actually talk about repositories and resolvers. That's going to be made really clear later when we actually write that code. But for now, what this basically means is which column inside of our database. Now remember, we created a table, we created a database, we have one table which is called users in there, and then you have inside of that one column that's called ID. So we should be able to map this ID field of the user that we receive with our request to its corresponding column inside of the database. That's why we pass in the DB tag, because we want to match these two together. So I say the ID of the user from the request, which is lowercase ID, goes to the table of users to the column, which is lowercase ID. And then if I want to send that back, where am I going to look at? Because I traced it to the database, I can scan it from the database again. So I'm going to go to the database, I'm going to go to the users table, and I'm going to go to the ID column. I'm going to see what's in there for that specific user, scan it, and I'm going to send it to the front end as the response. So this basically binds what we have in the request and what we send to the database. Now, when you send a request, you're going to see the response immediately. So the request response, even though we first send the request, then we have the response, they are going to happen. If it is like a fast framework like Gen, they might look like they happen simultaneously. There are going to be maybe a little bit of delay, like a millisecond or a couple of milliseconds. But nonetheless, we have the request and immediately we have the response. So what this means is we send the ID to the database, to that specific column, and immediately we read from that database. Because once we receive a request, we read from database, we scan the database for the response so we can send it to the front end. So that's the idea behind this JSON tag. And then we have the DB tag. They basically represent where a specific field of a user struct should go. So I want this ID data to be converted to ID, and it should be scanned into and from the DB column. That's called ID. So that's the idea behind this one. And now you might be asking, okay, why is this ID capital? Now I'm gonna send your attention or convey, how can I say, I'm going to redirect your attention to that engine. Remember, the first letter was capital. That indicated that we could use engine outside of the native code of the we could use engine outside of the actual code of the gen framework. The same idea is here. Because we want our repositories and resolvers, aka handlers, to be able to use this ID, we're going to make sure that this is capital. If this were lowercase, then that would mean we would not be able to use it in any other file aside from this package, which is called models. So that's why it's capital. When you see field names inside of Go structs, capital, that's the idea behind it. So it is exported automatically. And then that's why we actually lowercase this in JSON and we lowercase that in the database so we can map it correctly to its correct column. So now that you know what is the idea behind this, I'm going to move forward. Now, all of them are going to go the same way. So the next one is we have name. Remember, so it's capital name. This is going to be of type string. And then what is the struct? What are the struct tags for this one? The same thing. We have JSON. That's going to be name. Then we have DB. That's going to be name as well, because that's the name of the column that we have specified. And now that this is done, let's move on to, so we have the ID, we have the name. Next up, we have the email. This is going to be also of type string. What are the JSON tags? You know that this is going to be email. And which column do we scan this field into inside of the database? That's going to be the email column. Now, remember, without the scanning, database will not know where to get its data from. So database is not going to know, okay, this email, it comes actually from this email field. So these are really important. Now, here is something interesting. We did not have this password inside of the models_gen file that I just opened up. So that's where we have it. The type of this is also going to be string. And this is going to be JSON. Now we need to convert it to lowercase. That's going to be password. And DB for column, that's going to be password. Of course, we're not going to store password as it is. We are going to hash the password. So we do not know, even us, we do not know what the password is. And if user forgets their password, they're going to just go ahead and reset it. We don't know what the password is. So this is going to be created at. The type of this is going to be time dot. Now, time is the package. I want to select a type or a specific member of this package. Now, if I say time, this is not going to work because lowercase t is actually the tool or the method that we use inside of the time package itself, like its native code. But if we want to export this time module from this package, we need to go ahead and use the uppercase one, much like the engine. Remember? So here we have the JSON. This is going to, now what did we call this JSON? What did we call it? We said created_at. And what did we call the database table? So we could just take a look at that. If you go to migrations, you go to up, this is it. See? We created this, we called this created at, and we called it updated_at. So even though the field name is different, because we scan it into its proper column, that's going to work. So I could just copy the name from here. And now we can see, now each of these, as you know, they're one column inside of the user's table. So if I just pass it there, created at is going to be scanned into this column and it's going to be read from this column as well. So now that this is done, let's move on to the last one for user struct, and that is updated at. Let me save this. It's going to rearrange it so it's actually better visible. And we do have something here, and it says basically we just copy pasted this part. So this is going to be updated at. Very good. So this is the first struct that I wanted to create here. Let me see, updated. Oh, this should be updated at as well. Updated at. The second one inside of this user is going to, inside of this user model is going to be very important. That is the user input. So we are going to talk about all of these structs that are going to be relevant for this user. And this is, again, this is going to be of type struct. What are going to be the different fields? If user wants to log in, we're going to accept only two information. We're going to accept email, which is going to be of type string. And we're going to accept password, which is going to be of type string. And this should be lowercase s. So what are going to be the tags for this one? It's going to be a little bit different. So the JSON one is the one that we lowercase this. And then since we already have all of this information inside of the database, what we want to do is when user actually tries to log in, what we want to do is we want to process this and we want to make sure that user actually gives us the email address. So for that, we are going to pass in something that's called binding. So binding is going to be required. This simply means that this is a validation tag and it tells Gen to validate the incoming JSON request body and return an error if email is not provided. And I'm going to pass in email. For the password, we are going to have almost the same thing. We're going to change it a little bit. Just copy that. This is some basic validation that you can add here. So first off, we have password. And the binding for this one, of course, it's going to be required, but then I can pass in something else in here. And that's going to be minimum 6. Or you could say minimum 8 characters or 6 characters. So these are, again, this is the validation tag. It validates that this password is required and it's minimum 6 characters long. This binding says email is required. And when we pass an email here, this binding is going to check the incoming email based on some email requirements that we have. Like we need to make sure that this is a valid email address. These are some basic checks that you can pass in when you create this model. And I just wanted, even though we are going to implement all of these in Go, like in code, but you could pass like these on a basic level here as well. Next up, we have the auth payload, which is going to be also a struct. So struct, this is going to have token. So what do we send back if user has successfully logged in? We're going to pass in the token. We're going to give user the token. Now, at this point, we are not going to trace this to our database. This is going to be token. And I'm going to actually ask you, why don't we actually scan this into our database? You can just take a moment to think about this. Now, the type of this user is actually the user type. We have already created this. And JSON for this one is going to be user, lowercase. I hope you have paused the video and thought about why don't we like scan these into database. The reason for this is this auth. There are a couple of reasons. The first reason is that this auth payload is something that user is going to send us to basically make sure that user is authorized to create a habit using our API. So that's the first reason behind this. The second reason is that we do not store tokens inside of database. Tokens expire and they are generated every time user either signs up or logs in. So there is no point in actually storing this inside of the database. So that's the second reason. So the actual reason is that this comes from the client to the backend so we can actually make sure that user is authorized. That's why it says auth payload. We're going to take a look at the token that user sends us, and we're going to take a look at the user itself. Now, why did I pass this asterisk here? Because this user is actually a pointer type. Why? Because pointers can have some data, but pointers can also be nil. If there is any error, like user perhaps sent us the wrong token, there is some problem somewhere, then auth payload is going to be nil. This user is going to be nil. So we need to have that possibility. That's why this is a pointer type. Now, the next thing that I want to do is just save this. We need to go ahead and actually run the GraphQLgen again. So what it does is it is going to generate based on the user and auth payload structs that we have defined here. So that auto-bind feature inside of the GraphQLgen.yaml file, that is going to use these structs instead of generating its own. So what was the command? That was go run. It was this, right? github.com 99 designs gqlgen generate. So I'm going to hit enter. Let's wait for this one. And there we go. It was completed. Now I'm going to zoom this out. This is too zoomed in. So where do I want to actually check? Let's go to close this. We're going to go to graph. Inside of the resolvers, we're going to take a look at the schema, the resolvers. And here you can see it uses this internal models. That is very important. That's what we did. So it uses our structs. And another way for you to actually check this, so you can see these are all of the stubs that we have that we need to, these are actually resolvers that we're going to replace with our own resolvers. You can see it generated this not implemented login, not implemented register, not implemented update user. So all of these. Now, the way you can actually check this, that this is actually working fine, and it actually did what we asked it, take a look at this. Models.auth payload everywhere. Models.user. So this is, if you just take a look at this register that says models.auth payload, that means it has started using our own model structs. So this up until now, this operation was successful. So the next thing that I want to do is to create some utilities that we can use in order to actually write significantly less code and in order to actually end up with less repetition of our code. Now, what do I mean by this? Now here, I am going to show you a folder. So let me collapse this one. Here you can see we have this utils folder where for now, this is actually empty. So in here, the first thing that I want to do is I want to create a utility for checking the requirements that a user has to follow in order to write a name. Now, what do I mean by this? If we want users to sign up for the API, there should be some checks provided for when a user enters their name, their email address, and their password. For example, I don't want name field to be empty, so I need to write code for that. I don't want name to be less than 2 characters. So if user just passes an A or B or C, that's not going to be a name. A name at least has to be 2 characters. And then I'm going to say, okay, name cannot be more than 100 characters. So these are some rules that I want to enforce so we can have like a proper working API. Now here, the first thing I'm going to do is I'm going to create a new file that's going to be name.go. Now keep in mind, this is inside of the utilities folder, inside of the utils folder. We are going to separate the requirements that we need from users for name into a separate file. Then we're going to have one for password, one for email, one for JWT. So all of these are going to be separate. And this is actually a good convention. And you can see that it's really easy to understand, easy to navigate. And if anyone takes a look at this project, after like 5 minutes, they're going to understand, okay, where each piece of code actually resides. All right, let's get back to this one. Now, what do I want to do here? Of course, I want to create a utility that does something. That means I'm going to create a function. These are, for the most part, these are going to be all of them functions, right? Because functions perform stuff. I'm going to call this validate name. Now, Within the parentheses, I'm going to provide what this function accepts. It accepts name, the type of which is going to be string. And the only thing that this is going to return is going to be error, if we have any kind of error. So what are the conditions that I want to have in here? The first thing is that I want name not to be empty. So how do I implement this? Now, since name has a type of string, we have this strings library. On the strings library, we have a method that's called trim space, and I'm going to provide name in there. Let me save this. Well, we don't have the main package, the actual package that we use for this file. Let me just type it correctly. So this is going to be package utils. Package, and A is missing, and there we go. So as soon as you add that package keyword, you save the file, it's just going to import the necessary modules automatically. Now we're going to select name, trim all of the white spaces from it, and then if there is nothing in there, that means user did not provide us with a name. So now here are going to be a series of if statements that we're going to write. They're going to be extremely simple. So I have this len method where it's going to give me the length of a string. If the length of this string is equal to 0, now keep in mind, I'm trimming the white spaces from the start and from the end of this. Now, if there is nothing in there, that means user did not give us a name. It was basically empty. So we are going to return errors. That's another package that we're going to use, and I'm going to say new. And what is going to be the error? The error is going to be name cannot be empty. Save this. Error is imported. Let's move on to the next one. What if after removing all of the white spaces, I could just keep on copy pasting this. After removing all of the white spaces, the number of characters falls below 2. In that scenario, we're going to say name must be at least 2 characters long. Very good. This is the next check. Let me just come right here and just paste this again. So next one, what if name is too long? It's greater than, let's say, now these are some checks that I provide. You are very welcome to go ahead and actually change these. I'm going to say name cannot, I'm going to keep that, exceed ED 100 characters. Very good, right? Should I provide a point? No, I don't have to. Very good. What is the next check? Let's say we want to know what each character of the name exactly is. So for that, we are going to actually iterate over this name. In the iteration, we're going to accept the index of each of the letters inside of that name, which I'm going to pass in the blank identifier, which is this underscore, which means I do not want to take a look at the index. I'm ignoring it. But then after the index, what do I have? I have this char. Now I'm going to use short variable declarations. I'm going to select name, but then we need something that is going to iterate over it. So we have this range, and this is going to allow us to actually loop through every character in the name to validate each one. Now you need to keep in mind the for keyword itself, this for loop actually iterates. We use range in order to basically return each character as a rune. Now a rune, R-U-N-E, is Go's type for single Unicode character. So it basically like splits them up. So we can actually handle characters from any language, not just ASCII. All right. So that's why we use the range. Now, what do we want to do here? Well, we need to first take a look at if it is actually a Unicode character, if it is uppercase A to uppercase Z, lowercase a to lowercase z. Perhaps the letters are from a different language like Chinese or Arabic. We need to be able to actually accommodate those as well. So I'm going to say if Unicode dot is, so we have this method which is called isLetter, and then I'm going to pass in not name that specific character. If this returns true, we are going to say continue. That means this is okay. We are going to accept this. Now let's move on to the next condition. So the next check. Now keep in mind, now we are taking a look at each individual character that user has given us. So we have looked at each individual character. We know that they follow the Unicode standard, then we move on. Now, what if a name has 2 words inside of it? So we need to actually accommodate that one as well. So we are going to say if at any point I hit a space inside of this name, what does that mean? That means that name has 2 words inside of it, and I'm going to allow it. I'm going to say that is actually allowed. So let me just provide this and provide a space there. There we go. Next up, we check if any of the characters inside of that name has a hyphen. For example, if it is like a 2-word name and it has a hyphen in the middle, we are going to allow that as well. So we're going to say continue. Then I'm going to say if a character has, if the name contains an apostrophe. There are some names in English that contain apostrophe, so we need to actually go ahead and accommodate those as well. There we go. I passed in the apostrophe in there. And then we're going to say continue for those names as well, which basically means we accept that. Now, if the character is none of the above, not a letter, space, hyphen, apostrophe, then that means the name contains an invalid character. So what we do is we return an error immediately without checking the rest. So I'm going to say return errors.new. And what do we say here? We say name can only contain letters, spaces, hyphens, and apostrophes. Is that correct? Apostrophe, yeah. So that's what we return from this for loop. And finally, what do we return from the function? We're going to say return null. So if all characters passed validation, we return null. That means there is no error. Everything is okay. And that's it. That's every check that I wanted to write for name. Now I'm going to close this and I don't have to worry about this again. This is the good thing about having these utilities. And that's exactly why I separated these. We could have implemented these name checks. Remember, we could have implemented these when we write the resolver or the handler for users to be able to create an account. So we would have implemented all of these checks, which would have like bloated that specific resolver function really bad. And then we would have to make all of these checks or carry all of these checks into the login resolver, which is a different resolver. So that makes it actually repetitive, redundant code. So we are using the same code in 2 different places. Now, when it comes to name checks, resolvers have no control over this. They should not have control over this, right? We just call this function validate name in there, but the actual specifics and business logic of this name.go file, this has nothing to do with our resolver. All right. So that's why we have this utilities folder where we don't have like these specific functions we don't know where to put them. We just put them inside of utilities and we keep reusing them. And in this way, we end up with 2 very important advantages. Our code is separated, right? We know where each code lives. And the second one is that extra bloat, extra logic that has nothing to do with a resolver or repository is actually extracted from there, and it has no idea how that works. So if you want to see how that works, you just have to go to the utilities. Now, next up, I want to go in order. So we had the name. After the name, we have the email. So for this one, I'm going to say email.go. And this is going to be where we're going to write some utilities for email and how to check if email has the correct structure. And checking email and to see how if it contains the correct structure, that's actually very easy. The first thing that I want to do is I want to call package utils. I'm going to create a function since we want to validate email. Now, if I'm trying to validate email, what it is that I'm accepting the email. What is the type of that? The type of that is going to be string. Now we return error because if there is no error, this function is going to return nil. It's going to return nothing. But if we have an error, we're going to return that. Now what I want to do is, first I want to trim all of the white spaces that are around the email. So that's going to be strings.trim space. There we go. And I'm going to pass an email in there. Now, what do I have? I have this email. So I'm going to say if length of email after I've gotten rid of all of the white spaces is equal to 0, that means email is empty. So I'm going to say return errors.new. And what am I going to pass? I'm going to say email cannot be empty. So it is very important. It's imperative for users to provide their email address when creating a new account. So next up, we are going to say that email cannot exceed a specific number of characters. You could limit it to 100, 200, but the official email standard, which is RFC 5321, it defines that the maximum number of characters for an email is 254. So that's what I'm going to write. That is just researched information right there. So we're going to say email address is too long. It's too long. Next up, what I want to do is I want to actually give you a regular expression, and I'm going to go over what are the different parts of it. I am not going to type this out. This is going to take me 10 minutes. So we have this regexp or regexp, which is regular expressions. Now I'm pretty sure you're familiar with this, regular expressions. This is something that we use a lot in JavaScript, like in almost all languages we have this. These are some of the regular expressions are some of the most feared parts of programming. So everyone fears them for some reason. Now, what is the idea behind this? The idea behind this is to provide a structure with which we can actually go ahead and check if our email contains those specific things that we want it to contain. One of these specific things is this @ sign. So that's the first one. The second, these are the important ones. The second one is this period that we have after the @. So we have something @ something dot something. So this @ and dot, they're very important. So the first something is this. So we say A to Z lowercase, we say A to Z uppercase, and then you can see we have numbers 0 to 9. We can accept underscore as well. We can also accept, as you can see, let me just show it to you like this, the percentage sign as well. We are going to accept hyphen if we want to. We're going to accept plus if you want to add it there. Then you have this plus. So this plus is this first part of email plus @, then the second part of email. And you can see we have almost the same thing. And then dot, we have almost the same thing. Now we pass in this to this, the other check that we have here. And the reason behind this is we want this last part to have 2 or more letters for the top level domain. So for example, this is .org, .io, .ai, which is very famous these days. So this is going to have at least 2 characters and onwards. It cannot be less than that. So this is our regular expression. What do we want to do with this regular expression is that we want to check our email against this regular expression. If it passes the test, then it is a valid email address. Now, with name, I did write a lot of things, but we have these kind of regular expressions for email and we have for password, which actually makes our job very easy. And so how does this work? I'm going to select the email. So what is the name of that? It's email regex.matchString is the method, and I'm going to pass in the email. Now, if this matches, then everything is okay. But what if, so that's why I'm going to flip this. What if it doesn't match? then what am I going to do? I'm going to say return errors.new. And what am I going to pass? I'm going to say email address is not valid. Very simple. And finally, what am I going to return from the function? If there are no issues, we're just going to return nil. So how does this work? Why did we flip this? We said if this matches, so if I don't flip this, it would mean if this has a match, then throw this error. But that's not correct. We throw this error only if regular expression does not match. If it does not match, which is this negative, not, then we throw this. Otherwise, we're not going to do anything. So this is the email one that we have created. And next up, we're going to go to the password one. So we have this password.go, which is in which we're just going to talk about the password utility. To get started with the password utility, we are going to create a function that's going to be func. Let me collapse the sidebar. We can call this validate password strength. And what is this function going to accept? This is going to accept password, the type of which is string. And what is this going to return? In case there are any errors, we're going to return that. Now I need to go to the top of this file and I need to import the package utils so all of our other packages can be imported better. Now, the first thing that I want to do is I want to check if password has 6 characters inside of it. Or we can change that to password having 8 characters. So if I go to the user model, here is where we specified 6. I'm going to change this to 8, which is more standard for passwords to have 8 characters. Now here we are going to have, of course, our own code, which is going to determine that. We're going to say if the length of password falls below 8, then we're going to throw an error. So we're going to say return. This is going to be errors dot new. And as soon as I save this, errors package is going to be imported. I'm going to say password must be at least 8 characters long. So this is the first check that we have implemented. Next up, we need to talk about what other kind of checks do we want to implement here. So let's see, we want the password to have at least 1 uppercase character. We want password to have at least 1 lowercase character. So that's 2 checks. The third one is we want password to have a number, and also we want the password to have a symbol inside of it. So these are 4 checks. What we can do is we can actually create these as one single variable. Not one single variable, like using one declaration, we can just determine all of them. Now these are going to be password checks. We see, does the password contain this, like an uppercase, yes or no? So I'm going to specify these types as booleans. Then we're going to say lower, I'm going to say has lower bool. So does it contain lowercase characters? Boolean, it's going to be true. Yes, it does. False, no, it doesn't. So boolean is the right type to use for these. We're going to say number, then that's going to be boolean. And finally, I'm going to say symbol is going to be bool as well. Now, to be able to actually take a look at every single character of the password to see that it is a character, it has uppercase, lowercase, number, and symbol, we need to actually use a for loop. So we're going to say for underscore, and again, underscore is that we say we do not care about the index, but we care the actual char or character. Then we're going to say range password. Now, what do I want to do? The first thing is that I want to actually take a look at if password contains uppercase characters. So these are going to be, we could use a series of if statements, or we could just change it up and we could use switch statements, which I'm going to do. I'm going to use switch statements in which we're going to have 4 different cases. So the first case is if the password, any one character of the password is at least an uppercase character. So how do we check that? We have this Unicode on which we have is, that's going to be is upper. That's the method or the member that we have on the Unicode package. And I'm going to pass in char. So if this is true, then what do I want to do? I'm going to say has upper is set to true. There we go. Very easy, right? So that's going to be the first case. The next case, you could see all of them are going to be like this. So we're going to say case Unicode dot is lower, and I'm going to pass in the character. Now we are going character by character. Keep that in mind. We're not going like that password string itself. We need to take a look at what's inside of the password. That's why we need to take a look at each of the characters inside of the password individually. This is going to be has lower set to true. If this condition is set to true, then if this case is true, then we are going to say, okay, this password contains at least one lowercase character. The next case is Unicode dot is digit, and I'm going to pass in the character in there. Then we're going to say has number is set to true. And after this, the next one and the final one is Unicode dot is punct. Now this method, what is this going to do? It is going to check for punctuations like the period, the comma, the exclamation mark, the question mark, the colon, and the semicolon. So I'm going to pass that there. And then I need to check for symbols as well. So I could say, or Unicode dot is symbol, and I'm going to pass in the char. So symbol is going to check for the pound sign, the at sign, percentage sign, so like ampersand and these characters. If any of these two is set to true, then we're going to say has symbol is set to true as well. And now that we're done with all of these cases, we need to actually return some errors if any of these cases does not return true. For example, if has upper is set to false, then we're going to return an error. Now, how can we check if has upper is set to false? Well, we can just flip this. We say if has upper is set to false, then we're going to say return. This is very easy. Errors dot new, and what is going to be the error? We're going to say password must contain at least one upper case, or this should be together, uppercase letter. So this is for the upper, and we need to copy this 1, 2, 3 more times for the other ones as well. So the next one is going to be has lower. We're going to say one lowercase. So this is going to be lowercase letter. Password must contain at least one lowercase letter. Then we have has number. We're going to say password must contain at least one number. That's going to be number. And for the final one, this is going to be has symbol. We're going to say password must contain at least one symbol. Very good. So these are all of the checks that we did. And finally, if there are no issues, we're just going to return nil. So these are the checks for the password. But we do not want to save passwords as plain texts or as strings inside of our database. Now imagine if your database gets hacked, or if any database of any major social media website gets hacked, and if they stored passwords, if they were to store the passwords as a plain text, the attacker would now have everyone's password. Since the passwords are not hashed, they would know, okay, what the email address is and what their password is, and essentially that website is compromised. So what we do is we actually hash passwords. So hashing, the way hashing works is it's a one-way transformation of data. We take a password like 1, 2, 3, 4, 5, 6, 7, 8, and we use some kind of an algorithm that's called a hashing algorithm on the password, And the end result, so I'm just giving you like the summarized version of this. So the end result of that password, whatever the password is going to be something that's really unrecognizable from the initial password. That's why once users forget their passwords, they're not going to be able to recover that because we do not know what their password was. We don't know what that is because we changed it so many times that it is essentially technically unrecognizable from the initial password that user has typed. So if user forgets their password, they just have to create a new one. Now, in order to do this, we need to actually go ahead and install another package, and that package is called Bcrypt. Bcrypt is a password hashing algorithm specifically designed for hashing password. So how do we go ahead and actually install this? This is going to be the command for it. We're going to say go get golang.org/x, then crypto, then we have the Bcrypt. I'm going to hit enter, and this has just installed that package for us. So whenever you go ahead and you actually convert a password into a hash password, once we have actually hashed a specific password, I'm going to explain to you, okay, what each part actually means and how it actually works. Of course, we're just going to talk about it like really superficially. I don't want to jump too deep into this topic. I just want you to know that we do not store plain passwords, plain text password on the database. We change it so it is unrecognizable. And then you might have this question, okay, if we change it once user creates an account, then how do we know if user has provided the correct password once user wants to log in? That's a different question, right? And I'm going to come back to that as well. For now, let's go ahead and actually write code in order to hash the password. I'm going to write that code here as well because we just hash password once user has created the account. And we do not want this to be like any other code's concern. This is just going to be inside of our password utility. So this function is going to be responsible for it. This is going to receive. Now keep in mind, we provide this hash password. We hash the password. Once all of the password checks have been completed, then we hash the password. So we know, okay, password has 8 characters. It has an uppercase, lowercase, number, and symbol, at least one of these characters inside of it. So then we are going to say this function is going to return either the string that is the hashed password, or it's going to return error. And what I want you to know is there are some things that we need to do here and that relate to conventions in Go. The first thing is that we need to go ahead and convert the type of password. So we want to convert it into something that's called a slice of bytes, because that's what that Bcrypt library that we installed, that we got, actually works with. It works with a slice or an array of bytes. It doesn't work with strings. So how do we do that? This is a slice, this is a byte, and we have here the parentheses, which basically means this is a method. We're going to pass in the password. So this is now converted our password, which was a string, into a slice of bytes. Now we need to store this somewhere. I'm going to store this inside of this variable. This is going to be password bytes, and I'm going to use short variable declaration in here. Now, how do we actually get started with hashing the password? We have this Bcrypt library, and on there we have a specific method that is called generate from password. So this generate from password, what it accepts is 2 parameters, or when we are calling the method, we should call it arguments. So what this accepts is, as the first argument is going to be that password that we have converted into bytes. And the second one is something that's called a cost factor. And I'm going to pass that 12. So the most common cost factors are 10, 12, and then 14. You could go above, but these are like the most common ones. Now, what does this mean, cost factor? Well, what you need to take away from cost factor is that the higher the cost factor, the more secure your password is going to be, the more difficult it is for users to actually find out your password from the hashed string, but the slower this process is going to be. So cost factor of 12, so cost factor of 10 is good for our development purposes. It's fast. Cost factor of 12, that's slower. It's better for production. It's harder to brute force the password. And I'm going to talk about what brute forcing actually means. Now, cost factor of 14 is very, very slow. So what do I mean by it's being slow? So when you sign up for a website, you provide your password, it is going to take some time for that website to convert your password to a hashed password or hash your password. So that time depends on the cost factor that they have selected for their algorithm. So if cost factor is 14, usually, this is not the case always, it takes 1.5 seconds to hash one password. Now, this cost factor, the definition of it actually says that it controls how computationally expensive the hashing operation is. So in Bcrypt, the cost factor is a number. It's usually between 10 and 14. You could use 10. I'm using 12. That's the middle ground here. And the higher the cost factor, of course, the secure the password. So I'm going to give you one example so you know, okay, you can like relate to this cost factor. So for a real user logging in, let's say cost factor of 10, it takes 100 milliseconds to hash one password. So these are just some assumptions that we make. So cost factor 10, it takes 100 milliseconds. Let's say cost factor of 12, it takes 400 milliseconds. So milliseconds. A cost factor of 14 takes 1.5 seconds. So for this example, I'm going to take a look at the 10, which is 100 milliseconds. So every time user signs up for this API, it's going to take 100 milliseconds. This is just a ballpark for the password to be hashed. Now, let's say someone is trying to attack our website. Someone is trying to brute force or basically like force our website by providing thousands of passwords per second so they can find exactly what the password is. So for example, they have an algorithm that has thousands and hundreds of thousands of different password combinations, and they're trying to brute force or force their way into our website. So if a cost factor is 10, that means the attacker can only send 10 passwords per second to our website. That's going to be 10 passwords per 1 second. And that attacker is not going to be able to send us millions of like passwords per second, only 10. But if you increase this to 12, that attacker is just going to be able to almost send us like 2 to 3 attacks or passwords per second. But if you increase it to 14, it's going to take like in 1 minute, that user is only going to be able to send us close to 40 passwords in 1 minute. So that's why we say if you increase the cost factor, it's going to take more time to hash. Also, it's going to take more time. It's going to make it virtually impossible for attackers to guess our password. So that's why this cost factor is really important, and that's why I just went on the side quest to actually explain it to you so you know, okay, why cost factor is important and what this number 12 actually means. So what is this going to return? What this generate from password is going to return? It's going to return something that's called hashed bytes or error if there was any error. So I'm just going to say error and we're going to move on. So I'm going to save this so it just prettifies it. We're going to say if error is not nil, that means there is some error. Then what do? Well, we return an empty string. That means we do not want to generate something because there was an error, and we return the error. Very good, right? So these if statements, they're getting very familiar to your eyes. This is how we go about this. Then Okay, so if we didn't have any errors, then what we are going to do, we're going to grab this hashed bytes, we're going to return it. Now, I did not actually type this string method. It was just completed automatically, because what we want to do is with hashed bytes is we want to go ahead and convert it back to a string, and we want to return it, right? So at the end of the day, what we return from this hash password function is a string. So we put in a string of password, we receive a string that is hashed. And for error, we're going to pass in nil. Now that we have successfully hashed the password, it's time for us to compare these passwords, right? So we need to make sure that user who has signed up with that password, whatever the password was, should be able to log in with that password as well. Since we have changed that so many times, how can we check that? Well, that's where this function comes in. This is called compare password. Very good. Now, what do we pass in here? Well, we need to pass in here the hashed password. There we go. The type of this is going to be of type string, and we need to pass in our plain password as well. The type of which is going to be string as well. Now, what we return is going to be error. Now, why do we return error? An error gives us more information. Why? Because we need to distinguish whether the password was wrong or there was something wrong with the comparison. Some code was wrong. Some code returned an error, or the password was wrong. And also, there is another reason that we return error from these kind of functions, is that returning an error for failure is the standard Go convention. So here, what we do is we have this Bcrypt library. You can see it already gives me this, this pop-up. It says bcrypt.compare hash and password. And that's exactly the method that I want to use. So the way this works is when you hash a password, you have a few parts for that password. For that hashed password, you have the algorithm used to encrypt the password. You have the cost factor, which we talked about a lot. You have the salt, and you have the hashed password itself. So we talked about the cost factor. The algorithm is something that I can just say, okay, it's an algorithm that we use in order to encrypt that password. So these are two parts. Another important part that is basically the vital part of comparing a hash with a password is something that's called a salt. And I'm going to come back to salt. For now, we need to go ahead and complete this, and then I want to talk about salt, not like this in theory. Once we have actually converted a password, we have hashed it, then I want to talk about salt, and I want to show you, okay, what is salt? How does this actually work? But superficially and just theoretically, I'm going to give you a couple of sentences now after I've completed this. So we have this bytes method to which I'm going to pass in the hashed password, which is going to convert it into bytes, because again, Bcrypt works with bytes. It doesn't work with strings, but our hash password is actually a string. So that's going to be the hash password, and then we need to do the same thing for the plain password. There we go. I'm going to pass in the plain password. Now, where do we pass in the plain password and the hash password? That's when we actually call this compare function. This compare password function. Now keep in mind, we're not calling these functions, we're just defining them. When the time comes to call these, then we are going to actually go ahead and pass in the hash password and the plain password. So how does this compare hash and password work? I'm going to give you like a simple description of this, and then once we hash a password, you're going to see exactly what I mean. So you can go like this. The compare hash and password handle this comparison like this. So they go ahead. So this method, it first extracts salt from the stored hashed password. Salt is the third part when you actually try to hash a password. So when you hash a password, you have the algorithm, which we didn't talk about. The algorithm has 4 characters. It determines what algorithm we use in order to encrypt, not decrypt, to encrypt that password. Then after the 4 characters of the algorithm, we have 3 characters for the cost factor, which is 12, and then a $sign in there. Then we have 22 characters, which is salt. So we extract the salt from the password that user used when user registered for the API for the first time. So we extract that salt and we have it stored in memory. Then once user signs up, user has to give us their password, right? So we, using the same salt, the same 22 characters, hash that password again. If the end result of the registered password hash with the login password hash is the same thing, we know it's the same user. So this is how this process actually goes ahead. All right. Now, I don't want to jump into more details. This is going to be visible, really visible to you once we actually go ahead and make sure to implement the register functionality and the login functionality for users. For now, what you need to take away from this file is we validated the password strength, we hashed the password, we also checked if it is the same user who has signed up who wants to log in. Next up, I want to talk about another utility, and that is the JWT utility, and that is the token. Now, hashing the password is something else, token is something else. These two are completely different. So when we say we hash the password, we say we want to change the password so if someone has access to our database, they cannot know what the password of the user is. But token actually specifies the authority of a user. So you have something that's called authenticated, and then you have something that's called authorized. So authentication says who you are, authorization says what you can do. So these are two completely different things. Now, when we say token, we talk about authorization, what a user is authorized to do with our API. That's what we specify inside of the JWT.go. That's why I wanted to create separate file for this. Now you can see these are very, when you think about it, and especially if this is the first time, they could be a little bit overwhelming. That's why I said it's a good idea to separate them into different files. Now let's get started with JWT. JWT stands for JSON Web Token. Now JSON Web Token, the way it works is, after a user logs in, server is going to create a token that is going to contain user's ID directly inside of it. So what did I just say? I said user logs in, server creates a token. Token is a string. I didn't say that, but token is actually a string that contains user ID directly inside of it. Then server gives this token to the client, and on every subsequent request, client sends the token, and server is going to read user's ID directly from the token, so no database lookup is going to be needed. Now, keep in mind, server does not store the token. Token is self-contained, that's why it's called stateless authentication. Now again, I do not want to jump into too many details when it comes to this, but we use token in order to make sure user is authorized to change their name, change their email, change their password, create habits, create habit logs. That's just for authorization. Now a token has 3 parts. It's very, very important for you to understand this. These 3 parts are separated by points, by dots, and I'm going to show you how this works. For now, you just have to take away that token has a header, a payload, and a signature. The header specifies what kind of an encoding the token has. That's it. That's what the header says. It gives more information. The most important part is the payload, which we also call claims. Okay, I'm going to come back to claims later. And the third part is called signature. Well, signature is what makes the token trustworthy. It is created by the some encoded. Again, I'm trying not to dive too much into this. We basically have the header, which gives us information about the token. We have the payload, which is the most important part of the token. We have the signature that allows us to understand, okay, how we have gone ahead and encrypted that token. For now, what I want to do is I want to install this JWT library to generate and validate tokens. And here is the string for that. Sorry, the command for it. I'm going to hit enter. This is going to install this. And what I want to do is I want to take a look at this guides, where I just want to see if I have given you this these two commands as well. If not, I need to go ahead and actually add these there. So we have, let's go from the top. We have step 1, initialize. That's going to be step 2. Install gen, SQLite driver, go.env. This is GraphQL server and its initialization, air. Configure air, install migrate, GQL, and complete installation summary. Go get versus some more information. No, unfortunately, I have not given you these. So I'm going to try to remember to add these and give these two. One was for Bcrypt, the other one was for this JWT. So let's get started with this. The first thing that I want to do is I want to determine the package that we are going to use. Again, we are inside of the utils. This is very important to write here. Now, I said something about that's called claims, right? So the first thing that I want to do is something that's called claims. So what does a claim mean in simple English? Well, you claim something. I claim who I am. I claim these are my thoughts. I claim this is the lesson that I'm trying to create. So these are some claims. When you claim something, you need to be able to prove that as well. So I'm going to give you an example. A claim is in JWT comes from the legal or identity world. For example, if I am going to another country, at the border, I need to show my passport, my passport. And then my passport claims things about me. It says my passport, now let's say my passport is talking. My passport is going to say this person's name is, let's say, John. Then I claim that they are born in this country, on this date. I claim that they're a citizen of this country. All right. So I am not proving these things in real time. I'm presenting a document that asserts these. And then the border officer is going to trust the document because it was issued and signed by yet another trusted authority, which was the government. So that's a claim. A claim is something you say about yourself and about what you can do. Now, in the world of JWT, it works in the same way. The server is the trusted authority. After a login, server is going to issue a token that is going to claim things about the user. It's going to say, I claim this token belongs to user ID, let's say ABCD123. I claim it was issued at this time. I claim it expires in 24 hours. Now, the client carries this token and presents it with every request that the client sends us. Then the server trusts these claims because it recognizes its own signature. A claim in JWT asserts facts about its holder. Who is the holder of that JWT? It's the user. Now, in short, claims, they define the structure of the data that we store inside of the JWT token payload. And the reason that we use a struct for this is because of two reasons. We serialize our data. That means when we generate the token. And then the second thing is that we need to deserialize the data back out of the token when we want to validate, okay, it is the same person who wants to do this specific thing. Now, what are the members of the struct? The first one is user ID, and you know why we need user ID. The type of this is going to be string, but we need to have a JSON tag for this one. What is this going to map to? That's going to map to user ID with a lowercase u. So the idea behind this is that when JWT library serializes the struct into the token payload JSON, this will be written as lowercase user ID. And when we deserialize this, we're going to map it to this user ID with a lowercase u. So that's the first thing that we need inside of here. The second thing is something that's called a registered claims. So that's available on JWT. That's called registered claims. So what do we do with this registered claim? This registered claim is actually an object. It's a struct that is given to us by JWT library. It contains all of the standard JWT claims. What are those claims? I'm going to go on top and I'm going to give you a few examples of these. So let's start from the beginning. We're going to say ID. That's the first claim. It also has subject inside of it. It has issuer. Oh, come on, what am I doing? It has issuer. So ID is a unique ID for this token. Subject is who the token is about. Issuer is who issued the token. And then we also have not before. These are what we have inside of this register claims. And I'm going to tell you which ones we're going to use. Now, not before is when token becomes valid. And then we also have expires at, and then we also have issued at. So the things or the members that we are going to use from this register claims is just the expires at and the issued at. So the issued at is when the token was created, and then we need to also see, much like a passport that has an expiration date, our tokens, they also have expiration dates. So if if we set the expiration date to, let's say, 6 hours, when user is logged into our API, they work with the API for 6 hours. In the 7th hour, they're going to be logged out. So they have to start a new session. They have to log back in again. So this is everything that I wanted to. I talked really a lot about this. I'm pretty sure you understood what the idea behind this is. Now let's move on and let's generate the JWT. Once you see what this JWT looks like, all of this is going to make sense. So we have user ID that's going to be accepted by this function as a parameter. We have this secret, which is very important. That's what makes it unique for every specific person. I am going to talk about secret as well. Now, these are some things that we're going to explore once, but then we're not going to come back to these again. So when we say generate JWT, what we want to do is we want to create our claims struct with the data to embed it or to put it inside of the token. And this is going to become the payload, which is the second part of the JWT token itself. Now, remember, we created this claims. What do we have inside of this claims? We have the user ID. This is equal to the user ID that we pass into this function. And then we have something that was called JWT.registerClaims. And inside of here, what I'm going to do is I'm going to select two things from here. We have expires. You know what? I need to give you the method first. So that's JWT.new numeric date. And I'm going to pass in time. This is going to be time.now. Now, the first one is expires at. So let me define that as well, so you know what it is that I'm trying to do. Expires at. We're going to use short variable declaration. This is when, well, since this is an object, I don't need the equality in there. Okay, let me save this. Let's go up. So I remove the equality sign. We say expires at. Its value comes from new numeric date, time.now. And on this, we're going to say add. So how many hours do you want to add to it? I'm going to say 24 multiplied by time.hour. Now this expires at determines that the token will not be valid after this time. It will be invalid. So the JWT library is going to automatically during the validation. It's going to reject tokens where the current time is past the expires time. Next up, we have, let me pass in comma here. I'm going to copy paste this down below. We have issued, issued at, and that is going to be JWT new numeric date. When is this issued? This is issued at this current time. So this is going to record or basically register when this token was created. Now this claim struct, it returns to us something that we can call claims, and we can store inside of this variable. Do I need to pass in a comma? No. What is missing in here? Oh, I need to store this inside of a variable as well. That's going to be registered claims is going to be equal to this. And we don't need a colon in there. There seems to be some typo in here. Let's add a comma. Save this. Very good. Everything is fixed. So next up, what we need to do is we need to actually create an unassigned JWT token object with our claims. So this is the part where we create the JWT token. So we're going to say new with claims. And to this, I'm going to pass in JWT.signing. Now, this is the signing method. I do not want to dive too deep into this. I've already explained this a lot. The signing method is something that we actually use to create this token, to sign this, all right? That's going to be the algorithm that we're going to use for signing or for creating this token. So let me see which one I have used. I've used signing method HS256. So this is the one. Signing method HS256. I'm going to use that, and I'm going to pass in the claims struct in here as well. Now, what is this going to return? This is going to return our token. And let me just see. So that's going to be the token. Let's move forward. Then we need to actually create the completed token string. This is the signing method that we used to sign our token, but then we're going to select the token and we're going to say signed string. To this one, I'm going to pass in something that's called a secret. And remember where secret is? Where did we create our secret? Let's go to the .env file. There we go. So depending on this secret, your JWT is going to be different. What you need to do is you need to make sure that this is different after you're done with this video. But of course, this is like for personal project. You don't have to worry too much about this, but this is extremely important, right? So we're going to use that secret in here, but then again, we need to convert it into an array of bytes. That's going to be secret. And what is this going to return? Let me save this. What is this going to return for us? That's going to be token string and error. We're going to say if error is not nil, that means there is some error, and that means we do not want to generate the token, aka we return an empty string and we return the token. What seems to be, oh, I forgot the variable declaration. Very good. I think this method, this is signed string, not signing string. That was the incorrect method that I was using. Now, after all of this, we know that there are no issues and we have successfully created our token string. And for error, we're going to pass in nil. Very good, right? Now, much like hash password, what we need to do is we need to actually go ahead and validate this JWT. So for that, I'm going to create a function that's going to be called validate JWT. So we generate JWT, and then we need to go ahead and validate that as well. We're going to pass in the token string that has a type of string. Then we're going to pass in secret that has a type of string. What is this function going to return? This function is going to return either a string validation or error. Much like before, this is very similar to the way we compared the hash password. First off, I need to explain why we need this validate JWT. So if we go above, you can see we have generate JWT. That is when we generate the token, so we can check that if a user, so when a user logs in or signs up, they can create a token, and then we're going to ask those users to provide us with their token if they want to do anything with the API. Now, once users give us their token, we need to know if this token belongs to this specific user. That's why we need to have this validate JWT function in order to validate this. Now, I'm going to go step by step. This is going to be a little bit technical when it comes to the validation of JWT, but I'm going to try to explain all of this in depth. Now, the first step that we need to go ahead and follow is that we need to parse the JWT and actually validate the token. Now, we have this method. So we have this JWT. On the JWT, we have this method that's called parse with claims. Now, this parse with claims, it accepts several things. The first thing that I'm going to pass in here is going to be token string. Now, what it does is, as the first step, it's going to split this token string into its consisting parts. What are the consisting parts for a token? It's the header, we have the payload, and then we have the cryptographic signature. Now, this is going to split it into the header, payload, and the signature. Next up, we need to actually, I'm going to provide a comma here. We need to actually go ahead and pass in an empty struct, an empty claims struct. Now, that's the second thing that I'm going to pass in here. I could just hit enter so all of this is better visible. So the first one was the token string, and the second argument is a claims struct, but we are going to pass a pointer, and pointer is going to point to the memory address of this claims struct. Now keep in mind, this struct or object is actually empty. Why is this empty? Because this parse with claims function or method, it's going to fill in the fields of this empty struct with the token's data. That's why we need to pass it there. That's the second. And the third argument is an anonymous function. Now, we use this anonymous function, or parse with claims method uses this anonymous function during the parsing of this token to provide the secret key for what? For signature verification. So you have two parts of this parsing of the token being done directly by the parse with claims. That's extracting the header and extracting the payload. But when it comes to that cryptographic signature, we need to have an anonymous function. That's the way this works. So this anonymous function, what it accepts is the token. This is going to be token. We need to pass the token there so it can extract that signature from there. Token is going to have a type that is JWT token. Again, this is a pointer type, and we have talked about that before. What is this going to return? So this is either going to return an interface. This is like a struct that has the any type members inside of it. Or if this is not successful, we are going to return an error. So now what do we want to do within this function? Now the idea behind this anonymous function is that this function is actually called by the JWT library during parsing of the token. It is going to receive the partially parsed token, that is the header and the payload, but it's not going to receive the signature, and this function has to return the secret key. So how does it actually work? We have token, and on the token we have the method. So this is what's going to define that signing method, remember, that we used a while back, a few minutes ago. So where was that? This signing method HS256. Now, this is going to be something that we need to actually go ahead and assert the type. But again, these are some very technical stuff. I do not want to dive too deep. Our focus is GraphQL. These things are very important when it comes to securing our API. You need to have like knowledge of these. But again, I have to balance how much I want to jump or dive deep into these concepts. So this secret key, this initially has this type. So it's JWT dot signing method. So where is it? It has this type. But this is not the type that we require. We need to have signing method HMAC. That is the type that we are interested in. That's why we force this type or we assert this type. Now, why do we need this signing method HMAC is because, or HMAC, is because this signing method, this specific signing method contains that HS256 that we created above. So if we want to find that out, in order to validate this token, we need to actually enforce this type. So what is this going to give us? This is going to give us two things. One is going to be the value that we do not care. We just want to see if this operation is successful. And the other one is okay. If this operation is successful, that's going to be okay. If okay is not true, so if okay is not true, that means this might have been a possible attack, and we could just throw an error in that sense, like something like that. We could say return nil, do not return anything, return nothing, and then we're going to say errors.new, and in here I'm going to say unexpected signing method. Not that anyone is going to attack this API, but still, we need to talk about these at some point in time in our tutorial. So that's why I'm like covering this here. There is actually a part that I skipped over, and that is some kind of an attack which is called an algorithm confusion attack. So again, as I said, there is just a ton of technicality in here, even though this seems very superficial. Okay, we just implement JWT and that's it. But I did not want to jump too deep into this topic. You could always go ahead and actually research this, but that's where I'm going to leave this. And then if we return the secret key, we need to actually go ahead and type annotate that. So again, this function is going to accept the token, find out what the signature signing method is, but it's going to return the secret. So it's going to return secret. I'm going to hit enter. I'm going to select this entire thing, surround this. This should be a slice of what? Slice of byte, a byte slice rather. And nil for the fact that we did not have any issues. Now, it seems like there is some problems here. If it is not okay, let me save this. What is missing here? This function ends there. This ends here. This is where this function ends. Let me just tab this. Okay. If return nil, everything seems okay. I think I missed a comma here. Yeah, that's good. Very good. Everything is okay. Now we need to actually take a look at the errors that are going to arise from these operations. First off, we need to actually store this. So this is going to return something that we need to actually go ahead and store. That's either going to be our token. So let me just type token, or that's going to be error. And we are going to use short variable declaration. Very good. Now, if we have some kind of an error, that would mean that parse with claims method failed for some reason. I don't know what the reason is, but it failed for some reason. We could take a look at that reason. So I'm going to say if error is not nil, that means there was error. Nil means nothing. So if error is nil, that means there is no error. But if error is not nil, that means error is not empty. It means there is something in there. So I do not know what that is, but I am interested in finding it out. Therefore, we're going to return an empty string, no token. Keep in mind, when we are returning from the function, what is the function return? Function returns the token string and the secret, which are both, these are, I'm like explaining this in reverse. So this is the parameter type. We have the parameter part. We have the token string that this function accepts, and it accepts the secret, but what it returns is the string or error. Now, since we are inside of this like top level function, inside of the function itself, we need to know, okay, we return an empty quote for string, and for error, we just return that error to see what that is. Now, this is going to satisfy the return type of this function. The next thing that I want to verify is that we need to verify if token is marked as valid by the JWT library, and this is a Boolean. So we could say token dot valid. If token is not, see, I'm reversing it. So token dot valid, if token dot valid, that's a Boolean true. I'm saying if token dot valid is not true, meaning false, then again, we do not return anything for that string that we have. So we said, okay, we return a string and an error. What do we return for error? We're going to say errors.new, and in here I'm going to say invalid token. We're going to see this error a lot once we actually get to testing, actually get to the playground. So after this, we have to go ahead and extract our claims from the parsed token. So we have this token dot claims, and again, we need to go ahead and type annotate this. The type of this is claims, but this is going to be a pointer type. Very good. What is this going to return? This is going to return claims. Where am I typing? I need to type here. This is going to return claims, and it is going to return OK. Now, the reason that we are type annotate or asserting the type here is because we need to assert that the value stored inside of token.claims is specifically the claims has specifically this type. We need to assert this type. So let me just come back here. Now, and we do this because we're interested in user ID. Remember user ID? And we said, okay, user ID is something that is presented here. That's why we type annotate this. So if anything happens that it is not okay, right? So okay is false and we do not get the user ID, we need to actually take a look at that error. So we are going to say if okay is false, that means there was something wrong. Again, we do not return any kind of string. That's going to be an empty string. And this is going to be errors.new, and it is going to say could not extract claims from token. So this is why I'm like trying to explain this a lot. So once you understand how all of these pieces fit together, it's going to be very easy to like see the big picture. Okay, we created the claims, we generated JWT. Now, when we validate that, we validate it against what? Against the user ID, because remember, user ID is included inside of the payload. That's where we actually take a look at this. So the final step, if everything is gone according to plan and there are no issues, we're going to grab claims. And as soon as I do the dot, you can see I have this member. It is user ID, and I'm going to return that. Now, this is what I'm returning for the string part of the return type of the function. What do I return for the error? Nil. There is nothing. And that's it. So take a look at this. So would this have been a good idea to include inside of its resolver, let's say, inside of the resolver? A lot of unnecessary like concepts to be included in a resolver. That's why it's a very good idea to actually create these kind of utilities where we have this utility. That's the idea behind utilities, to just create them and keep using them wherever you want. And then it makes it very easy to actually follow up with what part of the code we have completed and what part of the code we have not completed. Now, so what do we want to do next? We are going step by step when we're actually implementing this. Now I've created all of these utilities. The next step, we did the setup, we created everything. Now we created these utilities. The next step that I want to actually go ahead and fulfill or complete is actually something that's called repository. So when it comes to these kind of APIs, we have something that's talking to the database. That's something that we call a repository layer. Repository is a layer in our API that is responsible for only one thing. And that makes repositories very easy to understand because they just have one job. Their job is to talk to the database. Now, how do we talk to the database? Well, database has a specific language. Now, remember, we had these migrations where we created this kind of like, okay, I said, I'm creating a table, and then I could drop that table. The reason that I'm adding this inside of migrations is for version control of my database, much like I have GitHub for version control of my repo. Now, this is just the general overview of what we did with SQL. But then this created a table for us, right? So I'm going to just crack this Beekeeper Studio open. I did decide to install this. This is like another tool that you can actually take a look at, and a new version is no, not now. And this is going to show you the basically the database in a better way. Now I'm not sure which database is this one. So we just have users. Yeah, this is our database. So how does this work? We are going to actually close this. Let's actually disconnect. So you're going to open this. For me, this is dark. Yeah, from here you can see, I think by default, the theme is set to system. Now I am going to switch to light. So brace, so brace for your eyes. And there you go. Like it's a big flash. If I keep it at that, this is not possible to work with, right? So that's why I keep it at dark, much better. So dark, it's easy. If I go dark and light, it's extremely unpleasant and it's going to drive a lot of you away. So now when you open this, you can see it here. It says new connection. So you can go to the top, select this, MySQL, and a lot of DBs here. But we are looking for SQLite. And then from there, we're going to say choose files. Remember that DB, that habits.db file that we created, which is on my desktop. So this is the project that we're working with. You can see the guides folder here. So I go to the data, I select this DB file. Select the DB file, not the Go file, the .db file. Select this and just say connect. It's going to open this up, close this, because you can run SQL queries here as well, but that is like not a good thing because we need to actually write this. This is going to change database. The only way that we want to change database, it's like adding something to it or deleting something from it, is through the code. We do not want to directly talk to a database using this GUI. So we have these two tables. You know that we have these two tables. You could verify this as well by, let me just kill this one and create another one. You could say SQLite 3 data folder habits.db. And now if you search for tables, you can see it says schema migrations and users. So we have both of them here. These two tables are the ones that we created. So if you double click on the user, you could zoom this in by Control+. These are all of the fields that we have created. So we have ID, name, email, password. Password is going to be very interesting. I'm going to show you, okay, like that entire hashing. I'm going to try to explain it shortly when we see the password. We have created that and updated that. We're going to have two more tables here, and then that's going to be it. So this is the database that we created along with the table using this migration. So the migration, we created the database using that SQLite setup, but then we created the table along with the columns using this migration. But is there anything in here? It says no data. How do we populate this? How do we populate it? How do we add data in here? How do we add rows? How do we add well, we have added columns. We're not going to add columns. We're just going to add rows of data. That's the job of a repository operation. If you don't have a repository operation, you cannot fill this table with data. Okay, so that's why we need to go ahead and create a repository. So when we say a repository talks to the database, what do we mean? We mean that it is going to write SQL queries that are going to either add some data to database, delete some data, update some data, shift some data. So everything goes inside of these repositories. Now, since we are going to get started by creating our very first repository, you need to hold on because there is going to be a lot of explanation here, because that is our very first repository that we want to create. So for this one, if you take a look at this project structure, where am I supposed to put the repository file? Well, I'm going to put it inside of here. You can see this is empty. I'm going to right click, I'm going to say new file, and that is, now, first off, we want to complete user repository. And why do we want to do that? We want to make sure we have a user who can register, log in, then we have that user create habits. So this is how I'm going to go. First, I'm going to create users, then we're going to talk about habits, and then we're going to talk about habit logs or check-in logs, where user has completed a habit for a specific day. So this is user underscore repository. User underscore repository dot go. Yes, this is .go. We're going to write Go code inside of here. The first thing that we need to do is we need to specify the package. So all of that control safe that we do, that actually works in here. Now, the first thing that I want to do here is I want to create a user repository struct. This user repository struct is going to hold only one field, and that is the DB field. And the reason that we do this is because we want to centralize database operations. So what I'm basically saying is that every database operation related to users is a method on this struct. This design basically means to do anything with users inside of the database, you have to go through this user repository and you never bypass it and write SQL queries elsewhere. Now that's why we use this user repository struct, again, just to centralize things that are related to user when it comes to database operations. But the type of this is an interesting thing. The type of this is something that's called SQL.db. But this is, again, you can see it's DB capital on the SQL package. That means we need to pass in a pointer so that this has a pointer type. Now, DB is actually our connection pool. Now, to understand what a connection pool is, the first thing you need to understand is what is a database connection. As I said, there is going to be a lot of talking here because we need to really understand what this is, and then we just keep reusing it, and we don't have to explain it again. So, a database connection is a communication channel between our API and the database. You can think of it like a phone call. I like to give you analogies. So before you talk to someone, you need to dial their number and establish the call. Similarly, before our API can send a query to the database, it needs to establish a connection with the database. Now, in our case, for SQLite, this means opening the database file and setting up the session to read and write it. So that's what a database connection is. Now, what is the problem? So we have a problem, and the solution of that is using a connection pool. So what is the problem? First, we need to understand what the problem is. So the problem is opening a connection for every request. So establishing a connection takes time and resources. If we want to open a brand new connection every time we run a query, every time we receive a request from the client, and then we need to immediately close that. Our application is going to basically, or our API is going to spend a lot of time opening database connections, closing them, opening database connections, closing them. So an analogy for this one would be, this is like you call someone, you say one sentence, you hang the phone up, and then you pick the phone up again, you call them, you say another sentence, and you hang it up. So for every one sentence you say, you're gonna like break the connection and reestablish the connection. Now, if you have like in our API 100 requests per second or gigantic applications, millions and millions of requests per second, you can understand how easily everything is going to break up. So the solution is something that's called a connection pool. So a connection pool is a collection, keep in mind, a connection. So this is connection pool is a collection of DB or database connections. So you don't have one connection, you have a pool of connections. That means you have more than one. Now, the good thing about these connections is that these database connections, they are created once after our API starts, and then we reuse them across many requests. So think of it like this. Instead of opening a new connection every time, we borrow one from the pool, use it, return it after we're done. And the connection is going to stay alive in the pool, ready for the next request immediately. So that's the idea behind this. I would want to give you another analogy for this one, but I do not want to waste too much of your time. So that's what we mean by connection pool, and that's what I meant by DB is actually this DB that we have. It is a connection pool. The type of this is a pointer type SQL.db. And now why do we need to actually pass this as a pointer type is because pointers, they store the memory address of this DB struct. So this DB struct is too big. That's available on the SQL package. We do not want to carry this around. We imagine if Go would copy this entire pool every time we create or pass a user repository, meaning each copy would have its own independent pool reference. That actually defeats the purpose of having one shared pool. But if we convert this into a pointer type, we store the address, and every user repository method that we create, it's going to access the same pool in memory through that address. So we have, in short, we have one pool shared everywhere. And we also need this connection pool because if you remember a while back, we said SQL.open, that is not going to just open the SQL open method that we talked about. That is not just going to return a single connection. It creates a pool manager. So when we run our first query, the pool opens a connection. When the query finishes, it returns the connection to the pool instead of closing it. The next query borrows that same connection again, so there is no reconnection needed. This is what makes the database access efficient, especially if we have a lot of users. After this user repository struct, we're actually ready to go ahead and create our very first repository function or repository operation. But what I want to do is I want to actually show you how you can create constructors in Go. Since Go does not have any built-in constructor keyword, I want to show you how you can do this if you come across this in any Go code base, or if you want to use this inside of your projects. But this is not actually a requirement. This is just a Go convention. So what are constructors? A constructor is a function that returns a properly initialized instance of a specific type. And there is a certain naming convention that we use in Go to actually create a constructor. So we want to create a constructor for user repository. So wherever we actually reference this user repository, we're going to reference this constructor instead, because if we directly reference user repository, then what we need to do is if we add some other fields to this struct of user repository, then we need to update that reference of user repository everywhere we have used that. But if you use a constructor, we're just going to update the constructor, and everywhere we use the constructor, it's going to be updated automatically. So that's one of the good things when it comes to constructors. Of course, in this API, we just use this user repository inside of the main.go, inside of our main server. We don't have any other middlewares where we're going to use this. We don't have any like tests that we're going to use this. This is like a very short, very simple API. But in larger projects, there's always this possibility that you're going to use this several times in different places. Now, let's get back to how we can define this. Now, again, this is a function, so it needs to accept some parameters, but the naming convention is very, very cool. So whatever the name of the struct is, this is the name of the struct. We're going to put that there, but at the start of it, we're going to add new. So this is going to be a new instantiation of this struct, and that's it. So this is how you can create a constructor, but then what is this constructor going to accept? This is going to accept DB that has SQL.db type. Now this SQL.db is actually our connection pool inside of the main server file. So if I go to the main.go file, if I come right here, you can see we have this db.initdb. This actually creates a connection pool that we reference here, right here. So this is what this function accepts. What is this function going to return? Now keep in mind, it has to return a struct, an object. What is that object? It's the, let me just copy paste the name so you can really see where that's coming from. It's this user repository that this function returns. But there is something that you need to keep in mind. It returns the memory address of this user repository, meaning it returns a pointer to the newly created user repository. So we return a pointer, so the caller holds the memory address of the struct, not a copy. So everyone who uses this repository takes the same pointer, but not user repository itself or a copy of it. It's going to return a pointer to this newly created struct. So we return a pointer to the caller that holds the memory address of this struct. We don't return a copy of it. The reason for this is that so every other resolver that talks to this repository, it's going to talk to the same instance. We're not creating different instances. We're not instantiating this differently every time. So it's the same struct, user repository, that we actually return. So what is this function going to return? We know what the return type of this is. We talked a lot about it. That's user repository. So I'm going to pass in user repository. But then once I call user repository, what do I need to pass? I need to pass DB. That is going to be this DB. Oh, I need to actually convert these parentheses to a pair of curly braces because this user repository is actually a struct. Now, since we return the memory address of this struct, we need to pass in the ampersand sign. And now we can see the issues are gone. So this line, return user repository DB is going to be DB. It actually does three things in one expression. It creates a new repository struct. Second thing, it sets its DB field to the connection pool that we received. Remember, the one in the server file. And then we actually send the address of this user repository. We return the memory address of this struct. We do not return the struct itself. Okay? And we have already talked about if we work with pointers, that makes our job a lot easier. It makes this whole process faster. Now, So we have this constructor once per repository. We don't have this constructor once per repository operation. So we have this user repository, one file, how many constructors? One constructor, because we're going to use this once generally inside of the main file. But then these repository operations, they're going to talk to their respective handlers, which we actually call in GraphQL world resolvers. So a resolver is going to carry out the business logic, what it is that we want to do when we receive a GraphQL query. That's what a resolver is going to do. So the way this goes is, so far we just completed the setup for this user repository. But next, what I'm going to do here is, this is going to be our very first repository operation. So we have one repository operation that is going to talk to what? To database. That's the only thing a repository operation does. And then, well, it doesn't do anything with that GraphQL query. We need to have something for that as well. We have something that's called a handler, or in the world of REST API, we call it a handler, but in GraphQL, we call it a resolver. Both of them are the same things. So that's where we actually calculate some stuff, depending on what kind of query we receive, what kind of request we receive. So resolver is going to talk to repository operation, repository is going to talk to database, it's going to get the data, send it to the resolver. So repository gets the data from the DB, sends it to the resolver. Resolver is going to calculate the response, send it to the GraphQL playground. I was about to say background. So this is how this process actually goes. Now we're actually done with the setup. We're getting started with the very first repository operation, which is creating a user, aka register. So any of these repository operations, they actually accept what a normal function accepts. So they have some parameters, they have a return type. And now let's actually go ahead and define this. So we have create user, which is the name of this repository operation. But there is something that is going to come before this create user, which I'm going to write right after I'm done with the parameters and the return type of the function. So the function parameters, they are going to be three things. We have name, which is of type string. Now keep in mind, we want to create a user. So what kind of information do we want? We want name from the user, right? Then we want the email of the user. So that's going to be email. Type of this is string. And what is the third and the final thing? That's the hashed password. This is going to also be a string. Now, you know what name is, you know what email is, but why do we select hashed password instead of the plain password, the one that user writes? The reason for that is this, because user repository or a repository just talks to the database. It has nothing to do with the implementation of business logic. So business logic is something that does the calculations, that carries out the functions. This operation, repository operation, it just talks to the database. It puts some data in and it gets some data out. That's it. How we manipulate that data, that's the job of the resolver. So in the resolver, we will have converted the password to a hashed password, then we would have sent it to the create user repository operation, and then this would just send it to the database. All right, so that's why we use this. We need to have hashed password instead of the plain password. Here, we don't know what the plain password is because we do not store that in the database. Remember, we hash it, then we store it. So this thing that talks to the database, it must not know what the password is. Otherwise, it's just going to store the plain password into the database. So that's why we talk to hash password, or we work with that here. Now, what is this repository operation going to return? Now, we know that this is going to return two things. One of the two things is obvious. It's going to return an error if something has gone wrong. But then it's going to return something that's called user. So we have this models. If I do the dot, how many types, how many structs do I have there? I have three. Which one am I going to select? I'm going to select user. And I just imported that as well. And that is very, very important for you to understand. Now we seem to have like a squiggly there because we do not want to have user copied here. Now the common convention is not to return user itself, not to return a copy of it, but return the memory address of it. Because when we say that we return this pointer type instead of the actual value, we can say that a pointer can be nil. So in error cases, we return nil. That means we do not return anything. All right. So what does that mean? It means there is no user. And then we show to the user, here is what went wrong. But as opposed to this, if we say models.user, that would mean that we are returning a value. A value cannot be nil. Also, we know that by now when we return a pointer type, we actually avoid copying the entire user struct. And this makes our API a little bit efficient. So I did say there is something that's going to come before the name of this function. That's between the func keyword and the name of this repository. And that's where we need to actually pass a reference to the user repository. Now, keep in mind, I said we're going to create a user repository struct, and then we're going to keep reusing that. So we're going to pass that user repository here, but again, that's going to be a pointer type. Now, instead of using user repository, then user repository, then user repository, I can shorten this with R. So instead of saying user repository dot some database method, I'm going to say R dot some database method. And R is a pointer to our user repository struct that we have created above. And now that you know what this R user repository is, let's move forward. The first thing that I want to do in here is I want to find out what the current time is. And I can just call time.now method. That is going to give us the current time. I'm going to save this. There we go. Next up, what I want to do is I want to generate random IDs for every user who is actually starting or who wants to register. So I'm going to create using var. Let me just bring this down. And I could zoom this in a little bit so you can really see what's happening. So using the var keyword, I'm going to create a variable that's named ID that is going to have a type of string. Now, what we want to do is we want to create ID and put it in its place inside of the database table. So how do we do that? Remember, in order to reference our user repository, we use R. On the R, the first thing that we need to reference is actually this connection pool that we have stored. So remember, we talked a lot about this connection pool. I do not want to jump into details anymore. Next up, we have a method that's called query row. So what query row does is it's going to execute a SQL query that is going to return exactly one row. And we use this because in this specific scenario, we're expecting only one result. It's like fetching the user ID for us. So how do we actually go ahead and create a new user ID for a new user? Well, we need to go ahead and write a SQL statement that is going to generate this. So we're going to say select lower. Now we have already talked about this method. So let me start from the within. We want to generate something that's called random blob 16. Then we are going to make sure that it is in the format of hex. So random blob 16 means we generate 16 random bytes, then we convert these 16 bytes into hexadecimal string, which is 32 characters. And then what do? We lowercase this. So I'm going to surround this again with parentheses, and I'm just going to call the lower method on this. Very good. Now that we have generated this, where do we put it? Where do we put this? Well, we need to scan it into this variable that's called ID that we created above. And you're going to hear me say scan, scan, scan a lot. When we talk about repository operations, scan is actually Very, very important. So in this scenario, when I say scan and I select the ID, this basically means that I'm reading the single value returned by the query into our ID variable. Now, I'm going to pass in an ampersand, which is going to mean the address of the operator. It gives the scan method the memory address of the ID. So what scan does is it does not copy ID, it actually writes the value directly into the memory at this specific address. So we work with a lot of pointers in this API. And by now, I'm pretty sure that you've understood what the idea behind them is. Now, this operation, it could be successful or it could return an error. So let's get that error. This is going to be the error. Well, so using this. Now that we have all the fields, it's time to actually put it inside of the database. So again, we reference our user repository, the connection pool, and here we have a method that's called execute. What this execute method does is it is going to execute a SQL statement that does not return rows. So we use this execute for when we want to put data inside of database, aka insert. We want to change already created data on the database, aka update, or delete already created database, aka delete operations. We're going to use this exec. So you need to be very clear the way this data flows. Create repository receives name, email, hashed password from the resolver. Then create user repository, creates the ID, creates the created at and updated at times. So there are 6 fields, 3 fields we receive, 3 fields we create here. So what are those 6 fields? We need to be very, very intentional with them. Now, we said this is going to execute a SQL query. So the thing that I'm about to write inside of these quotes, that is actually SQL code. So we say insert. Now keep in mind, we have already created our table. We have talked about it, right? We have seen it. We want to say insert into this table. What is the name of it? The name of it is users. We need to be very, as I said, very intentional. So, aka, we need to be very specific. So what are the columns that I want to put data in as rows? So remember, we have those columns, then we need to have data for them as well. Data is going to be the rows of the table. So the first column is going to be the ID. The second column is going to be the name. What is the third one? In order. Remember, in order. Third one is email. Then we have the password. Then we have the created underscore at. What did we have after that? We said updated underscore at. Now, since I want to create something that's called in SQL a prepared statement, I need to specify some placeholders for the values. And then I'm going to give you just a couple of sentences on why we actually go about this like this. So we have 1, 2, 3, 4, 5, 6 different columns. That means we need to have actually 6 different placeholders. And these placeholders are actually question marks. So we have 1 question mark, 2, 3, this is the 4th one, 5th one, and the 6th one. So that's the first thing that this execute method accepts. What is the second thing? Well, the second thing is these values. We need to specify where these values come. Now we said insert into users, ID, name, etc. That's the table columns. But where do the values come from? That's an email, that's ID, name, email, and then hashed password, remember? But what do we specify for created at time? We say now. What do we specify for updated at time? We say now. Now, why do we use these question marks as placeholder text? The reason that we do this is because we want to prevent a SQL injection attack. So what does that mean? It means if we do not go like this, someone who wants to, for example, sign up for our API, they could, instead of sending, let's say, their email address or sending their name, since we said, okay, you can send me 100 characters for your name, they could send a SQL statement as their name in order to attack our database. And they could say, like, insert this malicious data inside of your database, or you have to go ahead and drop your table of users, right? Delete your database. So something that actually damages our database. Now, if we provide this question mark, the database is going to treat these values as pure data. It's not going to basically translate these as SQL. Now, no matter what user provides, it cannot be interpreted as a SQL command. If we do not do this, then if they send a SQL command, we're just going to execute it on the backend. But in this way, this actually is going to prevent SQL injection attacks. So that's why we actually go ahead with these question marks. But you need to be very specific when it comes to these. You need to have 6 columns, 6 question marks, and then 6 variables in order to store them. Now, what this execute function returns is going to be actually 2 things. It returns something that's called SQL result, which we're not interested in. Therefore, I'm just going to provide an underscore for that. But then it also returns an error. An error is something that I'm interested in. An error basically says that, okay, this operation was not successful. I'm going to get rid of this colon. We do not need it. So we say if error, again, this is very simple. If error is not nil, what do we do? Well, we need to go ahead and actually write the correct structure for this if statement. Now here it's a little bit complicated when it comes to SQLite, because SQLite does not have specific error codes. If we face any kind of error, for example, if this insertion fails, if there are any problems with any of the constraints that we have had, like it should not be null, it should be unique, that's going to be very difficult for us to know which of these constraints was violated or which of them actually failed. Therefore, we actually use a method. So that's going to be another if statement. I'm going to say the strings library, there is going to be a contains method. It accepts 2 things. It accepts A and it accepts B. Now, the way that this actually works is this is going to return true if the substring, as you can see here, the substring appears anywhere inside of the main string S, or you can just call it A or B or whatever. So if the second argument appears anywhere inside of the first argument. So the first argument is error. We just take a look at the error. I have no idea what the error is. Let's just go ahead and take a look at it. But then we need to see if any of these constraints has been violated. And I'm just going to provide just one constraint that is going to be violated, and that is the unique one. So if there is a duplicate email, we're going to say unique constraint, and I'm going to say failed. Come on. Very good. So this is going to be the conditional for the if statement. So if this condition holds true, then that means this unique constraint failed is a part of error.error. That's one of the issues. Then what do? Well, we return null. Remember, we return null for that function because we need to return a pointer type. For the pointer, which is user, we return null. But then what is going to be the error? So the error is going to be fmt.errorf. This is going to be now something that user understands. Email already registered. Very good. Email is already registered. But then that's something that's inside of SQLite. But outside of SQLite, we're just going to say, okay, we were not able to create this user. So again, we return null. That was just for the constraint. And then this is fmt.errorf, failed to create user. And then we could provide a placeholder for this, and I'm going to pass in error there. Very good. So putting data inside of the database is completed. What should we do next? Well, once we create a user and once user actually signs up, they send us their name, email, and hashed password from the resolver into this repository operation. So now what we did was we put ID, name, email, password, created at, and updated at into the database. What do we do next? Well, we need to actually be able to formulate a response and send it back to the user. And the response in this world of backend is just the data that we just received, we just send that data back. There is going to be like this this password that's going to be different. So user gives us 1, 2, 3, 4, 5, 6, 7, 8. What do we give the user? We give user the hashed version of the password, or perhaps we don't even give that to the user, all right? So that's going to be the only thing. So we put the data inside of the database and we immediately call that data, but we do not delete the data from the database. We need to know that this operation of creating user or registering was successful. And the way we can understand this to know for sure is to send that data back to the user. And when user sees that, they know, okay, I was able to create an account. So that's going to be var user. Now that's our user struct that we put the data in. But what is the type of this? Remember, we have already created this. This is var user. How many fields that this user has? Take a look at this. So I just hover on it and I have the ID, I have the name, I have the email, password. So that's 4, and then 5, and then 6. So that's the type of this. I don't need this. I'm going to get rid of that. I'm going to come down here. Now we have this user struct. It has its fields, but it doesn't have data. How do we put data inside of here? That's very, very, very easy. We've already done something like this using query row. Remember, it returns a row of data. So when one user registers, how many rows of data have we basically put inside of the table? How many rows? Just one, because one user, one row of our table. Now, how many rows from the table do we take out for that specific user? Just one. So there is one user, one row belongs to that user inside of our users table, and then we take a look at one row as well. That's why we use query row. So again, r.db, our connection pool, we talked about this, query row. Now, we need to reference which columns it is. So query row is going to return that data for us, but we need to specify which columns do we want the data from. Now, since we are trying to send all of the data to the user, we're going to select all of the columns. So I'm going to say, again, query row, this is database operation. So this is SQL code. This is going to be select ID, name, email, password, created _at. Keep in mind, these should match the column names. And then we also have updated _at. So these are the column names. Where do we get this data from? We get this from users. Okay. Now, which user it is? Which one? We know that we have distinguished between users using their ID. So that's going to be the key. That's going to be where ID is equal to what? I don't know. I'm just going to provide a placeholder for it. Now, where is the ID coming from? It's coming from the variable that I created above. So what is this query row giving me now? It's giving me one row of data for that specific user that I'm looking for. What do I do once I get that data? Well, I need to put it inside of this user struct that has this squiggly under it, right? And then for that, what did we do? If we want to put data inside of a struct, the data that we receive from the database, which method do we use? Well, we already used that. We use the scan method. That's what the scan method does. And again, I'm explaining this in depth because next time I'm not going to explain it in this depth. And we're doing the scan a lot. So scan is going to take a look at the different fields that are already created inside of the user, ID, name, email, password, created at, and updated at. And you can see. So if I hover on this, this is why we have these database tags. So DB, even though here it says ID, scan doesn't know what this ID is. Scan knows what this ID is. Scan doesn't know what this name is. Scan knows what this name is. So that's why you need to be very specific when you're creating like your database model inside of Go. So take a look at all of these. All of these, they have their corresponding database tags. And we're looking at these tags in order to create a struct that is going to have these members, right? ID, name, email, password, created at, and updated at. Now, scan does not create these members. It just gives them data. Which data? The data that query row has returned. So now we need to actually scan all of these one by one. But what we do is we do not pass copies to these struct. We pass references, which means we just go to that specific part in memory and we actually populate data in there. AKA, what do? We grab pointers, right? So we have the ampersand user.id. That's the first one, right? The second one is ampersand user.name. There we go. You can see we already have this auto generation. After that, we have dot password. Very good. Then what do we have? So we have name. Oh, sorry. We need to have email as well. And I'm going to put it above password. After the password, we are going to have created at, and then we have updated at. So again, query row selected ID, name, email, password, created at, and updated at from the users table for one specific user who has this specific ID. Then scan method is on top of, or it's a chain on to the query row, and it populates our user struct. With the ID is going to be the ID that we received from the database, the name that we had on the database. So scan, essentially, this populates this user struct. Now this user struct has information. Which information? It has the information of the user who just signed up. Now again, when we do something like this, it does tend to return something, right? What does it return? It returns user. We got it. It returns something else as well. That is error. Why? Because this operation might fail. We're going to say if error is not equal to null, if there was something wrong with this operation. Now keep in mind, we have some operation and then we have some error. If error. Now this error belongs to this one, not the previous ones. Okay, so we are just reassigning this, redefining this. If we have this, now we are inside of the function body. What do we return for the user pointer type? We return null. But then what do we return as the string of our error? We say fmt.errorf, and I'm going to say, what should I say here? Think about this. So every error should be very, very easy to understand, and it should refer to that specific failed operation. What is the failed operation here? You can pause the video and think about this. So the failed operation is that we created the user, right? So that's not the failed operation. We created the ID, we put the data of the user using execute into the database. So these two are not failed, right? Here, what did we do? We selected ID, name, email, password, created at, and updated at from users table, where the ID of the user is the ID that we actually created for that user. Okay, so what do we do here? we are actually selecting information from the database and putting it inside of what? Inside of this model. So I need to just remove that space so you can see how this works. And not model, this struct. So the operation that failed is the operation that we were not able to populate this struct with the information that we received from the database. Now, this is a very long description. We need to actually shorten this. Basically, the operation is that we could not get information for this created user. So we're going to say failed to retrieve. So I know, like, I need to explain it in simple terms, but we need to keep these programming jargons alive somehow. So we're going to say failed to retrieve created user. So just make it sound fancy. And then we need to pass in the error, right? But again, why do we return null? Because this function returns a pointer type. Null is for that. No data. No data. Pointer type can have null, but a value cannot have that. So when we say return null, that means no user. And then we have the error. What is the error? Error is this. Finally, if all of these have worked and there is no error, what do? We need to return that user, right? But then we need to return we need to return a pointer to the user. And again, the reason that we return a pointer to this user is because the function signature, we declared that inside of the function signature. Also, returning a pointer avoids copying the entire user struct. And finally, a pointer can be null when we have errors. A plain value cannot be null. So wherever we call this create user repository method, the caller is going to receive the address of our user struct, the memory address, remember, and it can access all of its fields. It can access the ID, the name, the email, whatever, through this pointer. So it has to do user.id and then user.email and etc. And that's it. So congratulations, you just created, I'm going to zoom this out, you just created your very first repository operation. Now, what do you think the next step is? Well, the next step is to actually go ahead and create the resolver that is going to send this hashed password. That is going to send these three information. So name, email, and hashed password. So then we need to actually talk about what is the resolver, why do we need it, why do we even have to write it if we have like everything figured out here. But at the first glance, if you take a look at this, you can see it has nothing to do with the query, with the GraphQL query. It has no information what kind of a query that is, whether that is to delete something, whether that is, we don't know what kind of information we get. We don't know whether that's a query or mutation. So do we load information or do we change information? Do we create new information? We have no idea. So where we call this create user, that's where we know what it is that we are trying to do. So the first thing is that we need to actually go ahead and wire this user repository. So we created this file, user repository. We need to actually go ahead and update the resolver package in order to wire this up. And that's something that we actually do once per the repository file that we create. So we're going to go inside of the graph. Let's go, I'm going slow, inside of the resolvers. And from there, we're going to go to resolver.go. And you can see we have this one. And it says this file will not be generated automatically. It serves as dependency injection for your app. So what is the dependency that we actually add here? What is the resolver that we add here? What did we create? Remember, we created user repository. But this user repository is available on this should be .repository, which I just imported. So internal repository. But then again, what is this? This is a pointer type. Now here, since we are here, we can actually give it a shorthand as well. Should we say like star repository.user repository, or we could just say user repo? Isn't that sweeter and easier to actually work with? The reason that we need to put this here is that this file actually belongs to our resolvers package, and it defines the resolver struct. You can see the resolver with the big R. And what it basically does is it serves as the central dependency container that all resolver methods are going to be attached to. So every resolver, whether that's called register, login, habits, that's going to be a method on this resolver struct. And this is how we connect the repository operation that is talking to the database, that the thing that we just spent so much time working with and creating it, this create user inside of the user_repository.go file. And then we need to connect it to the resolver as well. And this is where all resolvers actually merge or take the root, whatever analogy works for you. So we have specified that here. And next up, we need to actually make sure that our server file knows about this. So we need to go to here and we need to actually put it right here. So we have this resolvers.resolver. See, we have this empty struct. Here I'm going to say user repo. And what is this? This is user repo. Now user repo is something that we need to actually go ahead and create. So I'm just going to go on top of the GraphQL handler. So what is this that we want to create? Well, we need to actually instantiate that constructor function that we created. Remember? The constructor that I said that we are going to use this once, but if we want to update it, we just update it here. We don't have to update it anywhere else. We didn't use that. That is an instantiation of this struct, of this user repository struct. So we have this repository. On the repository, see, I have new user repository, which is the constructor. And what do I have to pass in here? What does this accept? It needs to have the connection pool. There we go. Remember, we have connection pool. It has a lot of connections. We select the connection from the connection pool, work with it, return it back, and then borrow it again for another query. This is fast. This is efficient. That's our connection pool. Where is this coming from? It's right here. So everything about database originates here. That's why it's called initDB, initialize database. And this is our connection pool that we pass. And now we can see how all these pieces fit together. So this returns what? It returns a user repo that I passed in here. So take a look at this. We have the connection pool that we pass to the constructor. Constructor is a method available on repository. This is basically the way we import it. So if you take a look at this, there we go. Here it is. So if I get rid of it, there is going to be an error. It's going to say, I don't know what this repository is. As soon as I save this, it's going to import it back. This, and here it is. Just highlight it like this. Very good, right? So we have this connection pool that we got from this, that we got from this. And then we passed it to the constructor new user repository. We talked about that. What is this going to give us? It's going to give us user repo. And then again, we need to connect it, right? We need to connect user repo to the resolvers, to the GraphQL handler. They should be connected together. So now you can say you're done with your very first repository operation. The next step for us is actually go ahead and talk about our very first resolver. Now, before moving forward and actually writing our very first resolver, we need to understand what a resolver is and why we need it. So a resolver is actually a function, and it does one thing, and that thing is very specific. It carries out or fulfills a GraphQL operation. So you can think of it like this. We have a client that is going to send us a GraphQL mutation to change data on the server, or a GraphQL query to load data from the server. Now, when the GraphQL server, aka gqlgen, parses it, it finds the matching resolver function, and then it calls it. Now, what is the matching resolver function? So far, we have a repository operation, and that is to create a user. But the repository operation has no way of actually talking to the GraphQL, talking to the business logic that is going to actually carry out the creation of a user. So we create a resolver that's going to create a user, meaning it's going to validate the inputs. It's going to call the repository operation that we created in the user repository. It's going to call the utilities that we created. So we created JWT, hashing password, name utility, email password, but we never called any of these. So that's where resolver comes into the picture. So the first thing that we need to do is actually go ahead and jump into the project directory. Here you can see inside of this resolvers, this is where we're going to put another file. Why? Because I want to separate all of these. Now this is going to be called mutation.go. Hit enter. And why is it called mutation.go? Because this file is going to contain all of the resolvers that pertain to mutating data on the server. What does that mean? It means if user sends us some kind of a request that changes data on the server, either by creating data or updating existing ones or deleting data, then that's a mutation. That's the language that GraphQL uses. So all of the resolvers that are responsible for these kind of GraphQL requests, they're going to live in this file. But then we have a bunch of resolvers that do not do anything on the server except to load data. And they're going to live in another file that we are going to call query.go. So that's actually the language, again, GraphQL uses. We have this mutation, and then we're also going to have a query.go. So how do we get started with this? The first step is to remember back. What is a resolver? A resolver is a function. Now you can think of these resolvers, especially if you have some knowledge of REST API, as handlers. So in REST API, we call these handlers. They handle the business logic. That means whatever you want to do for that specific request so you can formulate the response, that's where you do it. That's the handler. So in the REST API context, we call this handlers or controllers, also controllers. But here in GraphQL, we call them resolvers because they resolve GraphQL queries. So this is the interface that is going to talk to the client. It's going to receive the request. And then once it receives the request, it's going to do something that we're about to write. So what do we want this to do for us? Again, this is a function. Now we want this function to not be standalone. We want this to be connected to the root resolver. So you can see here we have this type resolver struct, but this is actually here inside of the schema.resolvers. Remember, GraphQL server actually generated this code. We called these function stubs because they carry some content, some placeholder content, right? Remember? And here is, so let me just show it to you like this. Here is that register one. So what are we going to do? We're trying to recreate this. So I could just very well copy this, put it right here, and then change what's inside of this function. I'm going to save this. I'm going to explain all these parts, but I'm just showing to you that, as I said previously, during the entirety of this video, like from this point onwards, our entire job is to just replace these with their implemented versions. So we have this register, it just prints this error, but we replace it with this one, so the function signature must match. It has to be the same thing, right? Now, again, where is this? How do we connect this function to its significant or to its respective mutation resolver. So that's down below. So if you go to schema.resolvers.go, remember the GraphQL server actually generated these based on our schema that we defined. Here are all three of them. See? So we have the first type, which is mutation resolver. You can see it has a type of, it's a resolver struct. Then we have query resolver, and then we have user resolver. So we want to bind, as the correct technical term is, we want to bind a function that has a name of register to what? To the mutation resolver. Where is this mutation resolver? It's right here. Here it is. So we want to bind that function register, which is called register, inside of the mutation.go file to this struct right here. So these two must be connected. Why do we want to connect it to this? Because this is connected to our repository layer, right? So we want this resolver to be connected to the repository layer that we created here. Why do we want it to be connected to this? So we can implement operations on the database. We either get data or we change data. So this is how these pieces actually come together. And that's why I just copy pasted the function signature from here. And later on, once we're done with this function inside of mutation.go, we need to go ahead and actually delete the function from here. And we are going to keep deleting and deleting all of these until we're just left with these. And that's it. So that's the aim of this entire video. And now you can see, okay, how we move along with this one. So now getting back to this function right here, this is the func keyword that we use. I know that this seems a little bit overwhelming, so let's just break it step by step. As I said, this is the function keyword. This is the function name. This is what the function accepts as parameters, right? And this is what the function returns. So models.authPayload and error. So what does the function accept? It accepts context, CTX. I'm going to come back to this, what this is. It accepts name, email, and password. So how many things does the function accept? 4 things. How many things does the function return? It returns 2 things. It returns either auth payload that has a pointer type, sorry for that. So it has a pointer type, or it returns an error. So if user registers successfully, we return the auth payload. What does the auth payload contain? You can just go ahead and take a look at the here. This is user.go file. It returns the token and it returns the user. So that's our auth payload that we created. If there was some kind of an error, we're going to return that error. But since here we have this pointer type, what do we return for the pointer type? We return nil. Okay, so this part is done. The part where the function accepts these parameters are done. What the function returns is also done. There is one more part, and that is here. It's before the name of the function, so it's in between the function keyword and the name of the function. This is called binding. So what this does is, this is actually called, technically this is called a receiver. So this is a receiver that is going to connect this function register to this mutation resolver. Why? So we can connect it to user repository, to this file. Okay, so that's what it does. And we just shorten this, we say R. So whenever inside of this function I say R, that's the reference that I'm going to have to make to actually talk to our database. So if I want to talk to my database, or I want to talk to my database through the user repositories, right? So we just have this create user here. If I want to talk to my database, I need to go through this function. So how do I call this create user? Well, that's available on this mutation resolver, and I'm going to show it to you how this actually works. So this is the entire background of this and how this works. And for the remainder of this entire like all the other mutations, it's almost going to be the same thing. Now, I need to actually direct your attention to another part that I said I'm going to come back to this. So we know once user wants to register, they must give us their name, their email, and their password. That's something that we know. But what is this context? So every resolver actually receives a context as its first parameter. Now, a context in Go is a mechanism that is going to carry request scoped values across function calls. And what do I mean by that? What I simply mean is that this context contains user ID, it contains the JWT token. All of these are stored inside of this context. And if we want to identify, okay, that everything is moving along perfectly fine, then we need to actually extract these information from inside of this context. That's why we actually need this context. And this context is something that is actually given to this function. So this function receives this context. But as far as this register function is concerned, so all resolvers, they have this context, but in the context, or in the case of this register function, we receive the context, but we do not use it because register is actually a public operation that is not going to require authentication. We still must accept it because GraphQLgen generates the function signature and all resolvers must match it exactly. All right. So again, you can see I copy pasted this from inside of our file that gqlgen or GraphQLgen or GraphQL server created. So it passes it there, even though we do not use it inside of the register, we need to accept it nonetheless, so their structure matches. So now you know what this context is. It basically contains sensitive information. That's it. So let's move forward and let's actually create the rest of the function. So if we want user to be able to register, what are the checks that we need to do? The first check is going to be the name check. So I have this utils package, I would say, inside of this. On the utils, I have something that's called validate name. Now remember, this validate name is something that we created a while back. So if I go to utils, here is the name. Here is the validate name. So we created these utilities. Remember, we created these 1, 2, 3, 4 utilities here. And then I said, okay, we're going to use them later. So now we're actually using them. So this utils.validate name, what it's going to do is it's going to accept the name and it's going to validate the name for us. Now, it is so much better, right, that we have delegated, is it called delegation? We have sent this specific logic into its utilities file, and here we just call it. Imagine how cluttered and how crowded this resolver would have seemed if we would have to write all of the logic for name validation, email validation, and password validation inside of this file. Very, very unreadable. But now we just call it from the utils package or folder that we created a while back. Now what this returns is either this is going to validate the name for us or it's going to return the error. So error is going to be returned if any cases that we had inside of this validate name function, which we talked about significantly, if any of them fail, then it's going to return an error. And that means error is not nil. So if error is not nil, that means there is some error. So now keep in mind, this is very interesting. Let me just zoom this out a little bit so you can really see what's happening, or maybe zoom this in. I'm going to zoom this out. So again, you have this part that is what the function accepts, the name of the function and the parameters. But this part is what the function returns. Keep in mind, we have one and then we have two things that the function returns. So if we are returning from the function inside of this if statement, what should I do? I need to pay attention to what this function returns. So for this part, which is pointer, what am I going to return? Since there was an error, that means user did not register successfully, I'm going to return nil for the pointer. But what am I going to return for the other thing, which is the error? I need to return the error, what kind of an error it was. So I could say fmt.errorf, and then in here, I'm going to say invalid. Now, what does this error refer to? It refers to the validation of the email that failed. So I'm going to say invalid name. And then I'm going to provide placeholder for this one. And let's go out and let's write the error in here. And there we go. You can see it works so good. So I'm going to zoom this back in just one level. So if there is any issue with the validation of the name, we're just going to say invalid name and then whatever the issue was, whether the lack of more than two or more characters, whether there was a lot of characters, or whatever the reason was. So this is the validation for name. And I'm explaining this once because for the next ones, I'm not going to explain this more. So next up, what do we have? We have validate email. And to validate email, what am I going to pass? I'm going to pass an email. Now, if email validation fails, what am I going to say? I'm going to say invalid email, and then whatever the validation was. Now, since we have here the error once initialized, here we cannot use this variable declaration, so we need to get rid of that colon. So this is for email. Let me just copy paste this. This is for what? Validate password strength. And what do you pass there? You pass in password. And if there was any errors, that means if error is not nil, that means error has something inside of it. So what did we just return? Invalid password and whatever the issue was, right? What do we do next? So if email is correct, if name is correct, email is correct, and password is correct, that means everything is correct. All the input validation is done. So we move forward and we actually hash the password. That's going to be the next step. So I have this utils, and remember our utils library, I would say, that we created. Then we are going to call a function that's going to be called hash password. So to hashed password, what do we pass? We pass in the password. What does this return? Well, this is going to return two things. It's either going to return hashed password or it's going to return error. Now, for now, I'm not interested in the hashed password. I'm just going to say if, let me just copy paste this, it's easier. So if error is not nil, that means we were not successful in hashing the password. So I could just say failed to hash password. But what if we did not fail? We actually were able to hash the password. Then what do we do? Now here is where we actually create the user. So we have this create user, which is available on, you can see, user repo, and user repo is available on what? On the main mutation resolver. I'm going to hit enter and so it's going to complete it. So we have this R that was inside of the function definition. So remember, this R that has a type of mutation resolver right here above. Here it is. User repo is available on there, and on the user repo, what do we have? We have create user. What is create user? Create user is our repository operation. So if I don't have this R right here, if I don't have this, how am I going to connect this function to the repository operation? I don't have any other way. This is the only way. Now, why do we want to connect this? Because we want to create the user. And if we want to create the user, we need to put user information in our database. And that's what this create user does. Remember, we talked about all of these, the way we call execute. If there are any errors, we're going to talk about that. So we talked about this extensively. Now, if I hover on this create user, it accepts name, it accepts email, it accepts hashed password. So what do we need to do? We need to pass these information there. So if I go to the create user, what does it accept? It accepts name, email, hashed password. So let's pass all three of these there. So I'm going to pass in name, I'm going to pass in email, and then do I store password, like text password, or do I store hashed password? I store hashed password. So that's going to be hashed password that's going to go into the database. We need to actually add a colon here. That's going to fix the typo. So what is this operation going to return? It's going to return two things, user and error. And there we go. We're going to come back to the user. For now, we're going to say if error is not nil, that means there is some error. We return nil for the payload, and then we return the error. So if we move forward from this last if statement, that means everything was successful. And if everything was successful, it's time to actually generate our JWT. Now here I want to actually give you a tip. If user signs up, like here user registers, you do not have to actually go ahead and create a token, because it doesn't matter if user signs up or not. Unless user logs in, they're not going to be able to actually do anything. So even if user signs up, the convention is that they're going to be redirected to a page where they need to provide their information back. But if you do not want to follow that convention and you say, okay, user signs up, they're going to be directly navigated to the home page of the API for whatever front end you use for this API. Okay, they're going to be directed to the home page. They will be logged in immediately. Then JWT is very, very important. You have to create it. But if you are intending on actually directing users to the login page right after they have registered so they can provide their email address and their password, then JWT is not important here. But then I'm going to give you like both ways, so it's up to you which way you want to go about this. So what we do is we generate a JWT once user signs up or registers, and then we generate one JWT once user logs in to give you this flexibility which I just talked about. So we have this utils. On this we have generate JWT. This needs the user ID. We have this user. On the user, you can see we have the ID. This is the good thing about autocomplete. What is the next thing that this this generate JSON Web Token requires? It requires our string. Our secret that has a type of string. Now, where is the secret? It's inside of the .env file. So we need to actually go to the OS package. We're going to say get env, which is the method that is going to get our JWT underscore secret. So the name of the variable is JWT underscore secret. You can go ahead and double check that. Yeah, there we go. So OS is just going to jump into that file and it's going to select the secret and it's going to put it right here. So next up, what do we do? Well, it depends on what this function returns. This operation returns. It either returns token or error. Now, if we have any errors, I could just copy this, put it right here. So if we have any error, that means error is not nil. We are going to return nil or nothing for the payload, for the auth payload, but then we are going to return an error as well, failed to generate token. Very good. So I think that's it. So finally, the last thing is what it is that we want to return from this function. So we are going to return models dot auth payload. There we go. And since this auth payload is a struct, we need to provide fields. What kind of fields does it have? It has a token field, which is going to be equal to the token that we created above. So let me just show it to you. So this token is the same token that is here. We pass it to this field. And what is the next field that it accepts? It accepts user. And where is user? Where user is right here. So let's pass user there. Very good. And now this is for the first part. And here is the part that I'm talking about. So it's models.auth payload. And the second part is this error part. So if we have reached this stage inside of the function, that means there is no errors. So since, if you're wondering about this ampersand, this is actually the way that we pass in a reference as well. So we basically denote this auth payload is a pointer type, and we've talked about this, why this is a pointer type. We refrain from copying these structs. We just pass in the memory address. So we go there and we change the content there, as opposed to copying the struct itself every time we make some change. So since the function signature also requires models.auth payload, we need to pass in a pointer. And we signify that using an ampersand as well. Now, what does auth payload accept? You can see here, it needs to have a token and it needs to have a user. So we passed in the token, we passed in the user, and nil is for the error. Since there was no error, the error is going to be nil. Now we have this error where it says it is already declared in this mutation.go. So what we need to do is we either get rid of this entirely or we just comment this one out. For your reference, I'm just going to comment this one out so you can see how much progress we have actually made. So what is going to be the next step for us? Well, the next step for us is going to be to actually go ahead and create this user. Actually go ahead and register, but we need to actually first implement a couple of more resolvers. And let me take a look at them. So we need to have something for the created at date and for the for the updated at date. So we need to actually go ahead and implement those, and right after them we are going to jump into the GraphQL playground where we actually going to create a new user. Now what we could do is we could actually specify these two stubs, or basically these resolvers, inside of the mutation or inside of the query. But what I'm going to do is I'm going to create a new file for them. But before doing that, I didn't actually show these to you. So let me just go down. It's going to be where we have this models.user. It's right here. So I'm talking about these two. The reason that we need to implement these is because that GraphQL gen that generated these two stubs, it cannot automatically convert these. The type of these is time.time. Remember that from the user.go file. So it cannot convert that to a string. So what we need to do is we need to actually go ahead and do that and implement that conversion. All right. So we need to actually say, okay, what it is that we want to do here. So we're trying to implement these two. And for this, I'm going to, now I am inside of the resolvers. Keep in mind, we have a user.go file that's inside of the models folder. This is our models, right? But then I'm going to go inside of the resolvers folder, which is inside of the graph. And in here, I'm going to create a file that resembles this user.go. You can see it's the same file. The name of the file is the same, but we are going to actually provide more different code in here. We want to implement as a couple of resolvers in here. So what we could do is we could actually copy both of these. So I'm going to copy created at and updated at, and we could jump in here and I could just paste that here. And up above, let's go ahead and let's import package resolvers. And there we go. Now, the reason that it throws these errors is because we already have them here. And implementing this is going to be very simple. So we are going to get rid of this panic. I'm going to delete that inside of the created at, and I'm going to delete it inside of the updated at. First, let's take a look at the function structure. So we have the func keyword, we have the function name, we have the part where function accepts its parameters. We can see we have the context where we have information about the incoming request. Cool. We have this object that is the user, that has a user type. Then what the function returns is either a string, see, we are converting it into a string, or we're going to return null. But this operation is going to be very simple, so we know that there is not going to be any error. And the same goes for this one, for the updated at, and what binds the receiver that binds this function to our schema.resolvers is going to be this one, this user resolver. This depends on the user resolver. Okay, so how are we going to implement this? We are going to return basically some created at time. So I'm going to say obj dot, as soon as I do dot, we should have this created at. So what is this obg.created at? You saw as soon as I did the dot, it actually gave me that struct that we created inside of our user.go. I should probably just have that open. So it has access to this one. It has access to specifically this part, time.time. So we have this time member on this time module or time package. And this obg has access to it. So we are going to, when I say created at, it's going to select the time that is included inside of that time.time, which is inside of the user.go file. And then what do I do with that time? I format it. You can see I format it. Now, for time formatting in Go, we have a standard that's called RFC 3339. We're going to use that standard. And it's basically going to have the year, the month, the day, the hour, the minute, the second. So it's all going to be from left to right. That's just a time format that is very popular with Go, and APIs work with that very easily without any custom code. So here we're going to say RFC 3339. And then I'm going to return null for the error because I'm sure this is not going to throw an error. So this is for the created at. We're basically going to do the same thing for the updated at. So let's copy that. Let's put that here. Now we look at the object, but we don't select the created at, rather the updated at. There we go. So let's save this. So we have object.created at and object.updated at, and then we need to get rid of these. So I'm going to comment these ones out. And now we can see we are actually decreasing the number of resolvers that we have inside of this file. So now that this is done, what is the next step? The next step is actually for us to go ahead and create our very first user. So let's jump into the terminal. This is where everything is going to come together for us to actually register a user. So a user can sign up. And in here, of course, we're going to use air. Hopefully, there are not going to be any issues. So it should show us the playground. There we go. We're not going to go to /GraphQL. That's the main route. That's the final endpoint. And it's going to have all post methods. But we are just going to go to the... it opened it inside of VS Code. But what I can do is I can just copy this. I'm going to select Chrome. And I'm going to open it up in Chrome. And here we are. So you can see so the server is live, and and when I'm refreshing the page or doing something here, it's actually sending some requests. You can see it takes 2 milliseconds. It's really fast, really, really awesome. So let's get rid of, we have already talked about this GraphQL playground, the different segments that it has, but let's go ahead and actually create a user. So how do we write our very first GraphQL query? I'm going to zoom this to 150. So the first thing you need to do is you need to define or basically state whether you want to send a mutation, you want to create a mutation, or you want to create a query. Remember, register is a mutation. We specified that inside of the mutation file. That's a mutation because it adds some data to the database. It changes database in some way. So then we are going to open up curly braces. Let's just zoom this in. Then the name of that. What name did we give it? Now, how do we know what name we gave this? What was the name of this? So I'm going to go to here. You can see we have these mutations. I'm going to click. So I went to the docs. This is the docs for our current API. So I'm going to go to the mutation, and I seem to have these things in here. Where are these things coming from? So let's jump into the code. I want to show you where these actually come from. So we're going to click on this. Remember the schema.graphqls? I'm going to click on it, open it up, and there we go. So we're trying to specify this. This is register. This is a mutation. See, it's inside of the mutation struct, and it is the very first one that we implemented. So for this mutation, we need to pass, must, because there is an exclamation mark. We must pass name, email, password. What do we get? We get an auth payload. What is an auth payload? Well, an auth payload is the token and the created user. And we are sure 100% that we're going to get that. If we do not get it, then we get an error because we implemented this register, right? So I'm going to close this because I have too many files open up here. Now, we have this. So we are basically going to create this. What is the name of it? The name of it is register. Of course, you are going to get autocomplete. So I'm going to open up a pair of parentheses. What is the first thing that I need to provide? It's name. So I'm going to say name. I'm going to provide a colon, and then I'm going to provide whatever the name is. So this is perhaps John Smith. That's the name, right? I should zoom this out so you can really see what's happening. I'm trying to put it on one line. So that's the name. I'm going to provide a comma, move forward. Then I have email. You can see I have autocomplete. This is jsmith at, I don't know, test.com. Cool. First, we're going to actually try to do this. Then we have the password. Remember the criteria for the password? It was that we need to have uppercase, lowercase, and all of the other things. So I'm going to say pass at 123. So it has 8 characters. It has an uppercase and at least one uppercase and one lowercase character. It has numbers and it has symbols. Very good. So now you have effectively created your very first mutation. So you provided name, email, and password. I'm going to close this so we can actually take a look at the result here. So what am I going to show you next? Well, the next thing that I want to show you is that this is what you have sent here. What you have done here is that you've actually sent the information to the backend to create a user. But if I hover on this, you can see it actually throws an error. It says field register of type this must have a selection of subfields. Did you mean register? Because you need to specify what you want to select. So that's curly braces. And I'm going to say, give me the token. Now you need to understand how this works. This is very important. This part that I just highlighted, this is the request that user sends to our API. What is this request? The request clearly states that user wants to register for the API with this name, email, and password. Cool. But what happens after I open up this pair of curly braces and I pass in token? That's the response that I send from my API to the user. So the response, the request response cycle, it is very, very tightly coupled together when it comes to GraphQL. So you specify, okay, this token is the response that I'm going to send to the user. What else am I going to send? Well, I'm going to send the user itself. So that's the token. And then I could just hit space or I could hit enter and I'm going to say user. Now I know this user has several things on it, right? Remember? So if I hover on this, it is going to say user. We have this user, click on it. We have the ID, name, email, habits, created at, and updated at. You could say, give me all these, or you could say, give me one of this, or two of these, or three of these, or four of these, or five of these, or in any manner, you could say, okay, give me ID and email. Or give me name and email, or give me name and created at, or name and updated at. So you could actually mix and match. This is something that you cannot do with a REST API. It's extremely difficult and impossible to actually have one endpoint be so flexible when it comes to a REST API. But when it comes to GraphQL, this is something you can do. This is one of the benefits. So I'm going to say, give me the ID of the user, give me the name of the user, give me the email of the user. Remember, we do not provide password we do not send password to the front end. We could also say, give me created at and give me updated at. And the good thing is that I have autocomplete. So now you know how this actually works. Cool. Here is a function, here is a button. You can say, okay, prettify query. and it's just going to prettify it, and it did nothing. Usually what it does is it gets rid of this mutation keyword, but I want it to be there so we know that this is a mutation. So if there are no issues, we should have this work. And there you go. Congratulations. This is the very first real thing that you did with our API. So let's dig in. What do we have here? We have the token, which is here. Remember what I told you about the token. Token has three parts. This is the first part. That is the header. This provides, okay, what type of a token it is. Then we have, and these are separated by these dots. Then we have the second part, which is the payload. So it starts from this EY and it ends right here at this FQ dot. That's the second part. And the third part is that cryptographic signature that we use to encode the token. So this is our token and the three parts. And then we have this user, which is a struct. We know why this is a struct. This is the auto-generated ID. You can see it's a sequence of alphanumeric characters. This is the name, this is the email, and this is the created at, and this is the updated at. Now we implemented a lot of like safety checks for name, for email, for password, for all of these. Like we should not have duplicate emails. We should not have names that are less than 2 characters. We should not have an email that has a wrong format or a password that doesn't contain at least one uppercase, lowercase number or symbol. So all of these checks, I'm going to implement all of them. But before doing that, what I want to do is actually show you how to see this inside of the database. So for this, we are going to come right here. So it's very easy to do this. You're going to go to the terminal, click on this plus. It's going to create a new terminal. So the air terminal is right here. This is our air server that is running. I'm not going to like destroy this. I'm going to go to the next one, which I created using this plus. And in here, I'm going to say SQLite 3 data habits.db. So now I'm inside of the SQLite 3. What I can do is I can say, give me the tables. Just to recap, we have these two tables. And on these two tables, what do? We can select one of these two tables, and it is going to give us, okay, or show us what we have actually created. So this is SQL command. I'm going to say select. As soon as you say select in SQL, you need to specify the column. So selecting means, okay, I want to take a look at data, but then data from which column? From the column of ID, from the column of row, name, email, password, what? What kind of data do you want to see? But if you want to see, okay, what kind of columns you have, you can just say schema, users. So you're going to say schema, and then you pass in the name of the table, and it's going to show you what kind of columns you have. So you have ID, name, email, password, created at, and updated at. Now here you're also flexible. You can say, give me ID and name, or give me ID, name, email. So you can come up with any kind of combination of columns you want. But if you pass in the star, that's going to give you all of the columns. So I want to see all rows in the users table to confirm that our user was inserted. So I'm going to say, give me all of the columns from where? From the users table. Then you need to terminate this using semicolon. And I'm going to hit enter, and there we go. Congratulations. This is the database. Oh, I should zoom this in. It didn't make much of a difference. So take a look at it. This is very beautiful, right? So what do we have? We have the ID column clearly specified. This is the same ID. 44 starts with 44, ends with E6C. The same user. There we go. 44 E6C. It's the same user. We just see it here inside of the database. In fact, this struct that you can see here, it selects the data. We actually used, remember that scan method that we talked about a lot? Scan method actually populated this struct with the data from the database. So this is the original place where we have our data. And if I go to the user repository, just bring this down a little bit. Remember the scan method? This is the unsung hero, this scan method, which is right here. And it's scanned, or populated our user struct with the correct information. And it read the database. How did it read? It read what this db.query row returned. See, it read that. So this is, in my eyes, this is like one of the most beautiful things, that everything comes together and it actually works. And not only that, it's not like something that you don't understand how this was created. You know exactly how this was created. So that's what actually makes it so much more rewarding. Now let's take a look at the Beekeeper Studio. I'm just going to click on this. So I decided to install this and I said, okay, I'm going to install this. But I find this presentation way more beautiful than the one that is inside of the Beekeeper. I'm really attached to this terminal, and I usually work with that more, and I'm trying to show you how that works if you want to just stick to the terminal. In fact, in the previous app that I built with the first one inside of this playlist that we did like that to-do API, to-do REST API, we just stuck to the terminal. We didn't use any kind of GUI. So here, again, you're going to select SQLite. In case this is the first time you see this app, it's extremely simple. There are just 3 things you need to do. You need to select your kind of connection or database, or DBMS, I would say. That's SQLite. You're going to choose the file. So if I go to the desktop, this is the project that I am actually currently teaching. That's inside of the data folder. And I need to select this file. You can see the icon of this is the Beekeeper Studio icon down below. So I'm going to select this, and the type of this is DB. I know that it's small, but still, I'm sure you can see this. You're going to say open, and then you're going to say connect. Next time, you don't have to do this because if you go to the recently open databases, you're just going to see that. So now we know that we have 2 tables. Remember, that's what we got from our query as well. We said, show me the tables. We had schema migrations and users. We can confirm both of them here. We can click on, double click on the user, and you can see this is users. I'm going to collapse this one. Let's expand this. I could double click on it, double click on the name. I am going to have to actually talk about this password a little bit. But before going there, can I zoom this in? Yeah, there we go. I think that's enough. So we have the created at time. This is the created at time, and this is the updated at time. I know both of them are like similar now, but once we implement the updated or the updating functionality for the user, and user changes some data, this is going to change. So this is the password which we need to talk about. This is the email, the name that we specified, and this ID is auto-generated. This is a UUID. You never have to worry about this if you have selected UUID. Now, why do we need to talk about the password is because we said that there are some parts about the password that we need to actually go over. So I'm really zoomed in. I'm going to zoom out in a bit. And what I want to do is actually show you what are the different parts of this. So let's actually get started. I think I need to zoom this even more. So let me just click here. I'm going to say, how much can I go? And let me just go here. I seem to have lost everything. So let's just zoom this out much better, or a little bit more. I think that's enough. And now I'm pretty sure you can see that very well. So this is what I meant by seeing some pop-up from here from time to time when it comes to Beekeeper Studio, like a while back. So you just have to close it. Don't worry about it. So we have 4 different parts, which we talked about, but we didn't actually see them, how they worked. So the first part is this part. So you have like this 2A, which is surrounded by $2 These 4 characters that represent the algorithm that we used in order to create, with which to create this hash. I'm going to leave it at that. So that's the algorithm, that's the hashing algorithm, okay? The second part is more familiar to you, 12. This is the cost factor. So these three characters, 12, along with that $sign, that's the cost factor. So it determines how secure your password is, and the more secure the password, the more time it'll take to hash that password. So we talked about that extensively. Now, one of the very, very important parts is actually salt, which is 22 characters, which starts right with at this H, including H, and you can count where we have like 22 characters. So I have 2, 4, 6, 8, 10, and then I have 12, 14, 16, 18, 20, and then I have 22 right here, if I'm not mistaken. So these are 22 characters of salt. And this is very important because once user wants to log in, what we actually do is we select the salt, this salt from when user signed up. And once user gives us their password when user wants to log in, we use the salt, these 22 characters, to hash that password again. If these two hashes, they match, then it means the user who signed up is the same user who wants to log in. All right, so that's the idea behind this salt. And this is why it's important. And the actual hashing part is 31 characters right after the salt. You can just count this or give it to a chatbot and it's going to count it for you. So in total, how many characters do we have? We have 22 characters for salt, 31 for hash, which is at the end. That's going to be 53. We have 3 characters for cost factor, that's 56. And then we have 4 characters for algorithm, and that makes it 60 characters. And there we go. This is the hashed password. So from this password, it's not possible. It's not possible to find out what the password of the user was once user signed up. So you receive, as a backend developer, you receive this. You cannot know, it's not possible to know what the password is from this. Okay? So this is why we actually hash this password. And now that you know what this is, I'm just gonna reduce the length of or the thickness of this column. I'm gonna zoom this out so we can see everything clearly, right? Now you can see which are different parts. So where do these columns come from? We specified them, right? That we wanna have these columns inside of our database. Remember? We had database migrations. Let me just bring this down a little bit. Or maybe get rid of it. I'm just going to collapse the terminal. I'm not closing the terminal, I'm just collapsing it using control backtick. Yeah, this is backtick. The one with the squiggly icon or the eyebrow icon. So if you go to the migrations, we had the down and the up migration. Here we specified how many columns we want. So we specified that ID is going to be default. It is going to be created on its own. Created at and updated at is going to go to the datetime package, and that's going to determine, okay, we're going to create them as user gives us their information. But what we want from user is just their name, email, and password. The rest we can handle. And we did handle, right? Now it's time for us to actually move away from this conversation. I'm going to keep this database open. We're going to have that session inside of the terminal as well. So if you just go, let me collapse sidebar. You can see this is the air that is running. There are no issues, Gen framework. And this is the database inside of here. And I'm going to collapse this. Now let's try to create a user, another user, but try to give out false information. Like try to violate the checks that we have specified. For example, I am going to try to create, I'm not going to do anything else, anything for now. I'm just going to try to create this user again. So I'm going to hit enter there so I can just arrange this better so we can see that. And we stay on this zoomed in screen. I don't want to zoom this out. So you can see this is much better. So now let's see if we can create a user with the same email twice, like a duplicate email. As soon as I send this, there we go. So this is the very first check. Message, email already registered. Where is this coming from? So I'm going to trace a couple of these or a few of these, but then the rest is up to you. You can actually do this. Email, cannot email address. I believe we did that inside of the migrations. We said that email, it should be unique. And then let's go to user repository. Failed to create. There we go. So here is where we actually specified that. So if it contains, if the unique constraint is violated, we send this error, right? So that's something that was database related. We found that out. Very good. So this is the first one. Let's try to create a different user, but we're going to violate. So that's going to be jsmith1, the same password. So when you hash the password, if password is the same for two users, it doesn't matter. The hash is going to be different. So for the same password, every time hash is going to be different. So email is different. Password is the same, doesn't matter, as long as password contains those checks. Uppercase, lowercase, number, and symbol, and minimum 8 characters. But name clearly violates this. You can see there is just one character. I'm going to send this. There we go. Invalid name. Name must be at least 2 characters long. Let's take a look at the error. What is that throwing? So here you can see it's actually showing us that these are post requests, but because, remember, we're catching the error, it's not breaking our server. We caught the error and we sent it back to the user. So what is the application of this? Why do we send this? Well, this is very important because this is not going to be the final product that you're going to give to the user, to the end user. You are going to have to create some kind of a front end for this. Now, instead of coding all of this inside of the front end, what you do with your fetching library or API or whatever method or package you want to use, whether that is the fetch API or you want to go with Axios, the only thing you need to do is actually catch this message and provide it with a placeholder inside of the UI. I've actually created at this point in time, that was like a couple of months ago. So it depends on when you're watching this video. There is, I have another playlist here on YouTube that's MERN Stack Web Development, where I have created like a complete application backend to front end. That's using the MERN Stack JavaScript thing. That's MERN Stack. And there I created the backend. I handled like all of these error handling, but that was like Node.js and Express. So like JavaScript related, but the API was REST API on the backend. So I created everything. And then the only thing I did in the front end, which I created the front end since it's MERN, that's going to be React. I just showed those errors that were that I was receiving from the backend. I did not do any error handling on the front end. Everything was configured on the backend, like here. I just showed it on the front end to the user. So what you do is you just say invalid name. Name must be at least 2 characters long. That's it. And user is going to know. So now name is JS, 2 characters long. But then password lacks this .com part. I'm going to send this. It says invalid email. Sorry, I said password. I should have said email. It says invalid email. Email address is not valid. Now, I'm going to make sure that email address is also valid, but I'm going to get rid of the symbol from this password. The first thing it's going to say is going to be the length of the password, because now the length of the password is 7. But I'm going to make sure the length of the password is 8. And now it's going to send us password must be at least must contain at least 1 symbol. Isn't this beautiful? This is. So now what we can do is we can create another account for Jane Smith. And that's going to be, so that was J Smith. This is going to be full name like Jane. We could use .smith or -smith just to differentiate between these 2 emails. And we're going to send this, and there we go. So we created 2 users. Now, how do you take a look at that inside of the Beekeeper Studio? you have this refresh icon. Just click on it, and there we go. It created all of that for us. Now, the good thing, again, with the salt is, you can see, these two parts are the same. So the cost factor is something that we coded, the algorithm is something that we selected, but the rest is different. And you saw that the password is the same thing, right? The password is the same thing. @123, yeah, pass @123. So you don't forget this. Password is the same thing, but the users are completely different. John Smith, J Smith, these are the email addresses. And there we go. Very good. Very, very good. Let me just bring this here. We don't need to take a look at all of this information. Whoops. I don't think this is going to stay here. But I'm going to, oh, come on, buddy. And why do I keep bringing that? Anyway, so we have all of these, and if we just take a look at this again, so where do we see this inside of the database, SQLite? You just have to select all of them again. And now you see two entries here. You see John Smith and you see Jane Smith. This is very beautiful to look at, isn't it? There we go. So this is how you create these, and now you know where every one of these actually come from. And the next one is going to be login. We need to actually go ahead and implement login. So for now, what we did was we actually implemented signup, and the next one is going to be login. So for that, the first thing that we need to do is we need to actually go ahead and create the repository for it. So here is the repository for the create user. I'm going to collapse this. I'm going to come right beneath this. And here is where we're going to create the one for actually being able to get user that has already created an account on or using our API. The first thing that I want to do is create the function. So this function is going to reference the user repository, because we want to have some kind of a way for us to actually be able to log in a user. So here we are going to say R, and the type of this is going to be user repository. There we go. What should be the name of this function? We could call this get user by email. So if user wants to log in, what kind of information are we going to accept from this user? So let me pass that. So we're going to ask for email, which is going to have a type of string. Now you might be asking, okay, why are we selecting password also from the database since we are here? Technically, we're writing a repository operation which directly communicates with the database. The idea behind this is because we want to fetch the user first, then we're going to verify if their password is correct. So we first need to sift through the database and to make sure that this user even exists. After it exists, then we are going to take a look at, okay, I'm going to select all of the information from this user. So first I'm going to query the database using this email address. Once I found that specific row that I want to find, then I'm going to select the ID, the name, email, password created at and updated at from that specific row. So that's why we pass this here. And we know what this actually returns. This is going to return model dot. This is going to return a user for us, or this is going to return error. So now we know how this actually works. We have already created a user. We know that we need to have some kind of a struct here. So we can use the scan method to populate that struct with the information. And then we're going to send that struct to a resolver, which is going to talk to the GraphQL query. So that's something that we did inside of the create user as well. So if you come down here, you can see here, we actually created this user struct. We referenced this user struct since we have already created that inside of the models. And then we used the scan method, which is right here, which you can see all of these fields were populated within the struct method, within the struct, using the scan method. So that's something that we are going to do here as well. So that's going to be user. I'm just going to call this user. The type of this is going to be models.user. Now, how do we reference our database? We know that's available on R. So on the R or user repository, we have DB. So I want to select what do I want to select from the database? I want to select one row from the database, because if any user wants to log in, they just have one row inside of the user's table. One user cannot have two rows, aka we cannot have two duplicate emails, like they are going to occupy two rows inside of database. That's not going to work. So one row of our user's table, that's going to be basically reserved for one user only. So that's why we're going to use the query row method, because this returns only one row. So one row is going to be one user. Now we need to specify what kind of information do we want from that. We want to select all of the information, right? So we are going to say select. Now this is the SQL query that we write. We are going to say select the ID column, the name column, the email, password. Why do we need password? So we can match. Remember, we need to hash the login password using the same salt that we used for the sign up hash. If both of them match, that means it's the correct user and the password is the same. Login password is the same password that user used once user signed up. So that's why we need to select the password. We could select the created_at as well as the updated_at. Now again, because we want to avoid SQL injection kind of basically attacks, we need to use the question mark as our placeholder, but I'm going to get there. We need to say, where do we want to select these columns? We're going to say selected from users table, where email is equal to this placeholder, which is this question mark. And then I'm going to say this email is going to be passed to this function. So let me just show it to you. So here I have this email. It's the same email as here. So we select this and then we put it here, right after this question mark. And we have already, instead of this question mark, I would say this is the placeholder for this email. And we have already talked about why we are actually using this convention. So let's move forward. What else do I want to do? What is this going to return? This is going to return either one row, or this is going to return an error for us. So we're going to get to the error, but for now, we know that this query row actually has another method which is going to be attached to it, and that's the scan method. And now we basically do exactly what we did here. Where was I? It's right here. Yeah, we basically do this. So we select ID, we put it into the ID field, we select name, we select email, password, created at, and updated at. We basically do the same thing because we want to return the struct to the front end, right? There we go. But what if this operation is not successful? What if there is an error? What if error is not null? So all of these are synonyms. Error is not null. It means there was some kind of error. Now, it depends what kind of an error it was. One of the ways that we can actually find out what the error was is that we know that this, for example, user wants to log in, but they have not actually signed up. So that's going to be a no rows found error. So first off, let's actually go ahead and handle that. I'm going to say if errors dot is, the S should be lowercase, error, and I'm going to pass in SQL dot. So what was the name of this? It is error no rows. Whoops. Where am I? No rows. Very good. If this is the error, what does this mean? It means we were not able to find this specific email address. Now remember what this function returns. This function returns either a user, for which I'm going to pass in null, or this returns error. So what am I going to pass in for the error? I'm going to say fmt.errorf, and I'm going to say invalid email or password. We couldn't find this on the database. That's something that we weren't able to do. But what if there is any other error? For example, there is a database connection issue, there's a corrupted file, something else. We don't know what that is, so we need to provide like a structure for it. So I'm going to say return nil. I'm not going to return any user to the front end. There is not going to be anything else. Now, I just want to reiterate this, that we are inside of the repository operation, and this just talks to it communicates to the backend. Once we call this inside of its relevant resolver, then we're actually going to see these results. But for now, this get user by email, it just talks to the backend. Sorry, it just talks to the database. So if there is any other kind of error, I'm not sure what that is, but I can provide a specific structure and like some kind of generic errors. I'm going to say failed to find user, and then whatever the error was. So there we go. I just passed in a placeholder for that as well. Now, if we do not go inside of this if statement, meaning if we do not have any kind of errors and everything is successful, what do we return? We return user. So now since that's a pointer type, we need to actually pass in the ampersand here. And what do we return for the error? We return null, since there was no error. So that's it. This is the repository operation. The next step for us is actually to go ahead and jump into the resolver for this one. So let me save this. Let's jump. So we go to the mutation, right? So here we have the register mutation, which we completed. I'm going to collapse that. And right after the register mutation, we talked about that. Okay, so we had the repository operation. Then we have the specific resolver for it, and then we should be able to actually log in. But I did not type this. We actually copy pasted that from here. And you can see here we have this login that a GraphQL server or gqlgen already generated for us. So I'm just going to copy this just to make sure the structure of this function or the definition of the function matches that we have here inside of this schema.resolvers.go. So I'm going to copy this. I'm going to come right here. I'm not going to type this. I'm just going to put that there, and I'm going to get rid of this error, this panic. We have already talked about all of these. The signature is the same. It's just what the function accepts, that's going to be different. Sometimes what the function produces, that's going to be different. And those are the parts that change. But aside from that, you can see the receiver is the same. We have this R, mutation resolver. We have the same thing here. The context is always going to be the same because context, it contains that critical information about the user that we need, right? Like user ID. But then what the function accepts is going to be dependent on what the resolver wants to do. For the register resolver, we had these three: name, email, password, because we said if user wants to sign up, they have to give us a name, an email, and password. And then what the function produced was payload and error. Here, it's the same thing. That's what the function produces. So payload has our token and the user information itself, right? So this is all about the definition of this function. What we need to do is we need to actually go ahead and write the actual code, the actual business logic. Now, the way I want to go about this is I want to give you like a plan of attack so you can know, okay, I could go through these steps so I know exactly what I'm going to do inside of this login. So the first step is that we need to actually go ahead and call this repository operation, which is get user by email. Now, where is this available? It's available on this mutation resolver. So if I do r dot, I'm going to have user repo. That's inside of the user repo. Remember, that's the struct that so we have this user repository and we bound it to this user repo. There we go. So this user repository is a type on this repository, and we named the actual key user repo. So that's why if I do user repo and if I do dot, that is available, get user by email. There we go. So what is this going to accept, this get user by email? I need to pass an email to this. And what is this going to produce? This is going to produce two things. This is either going to give me a user that it found, like that row of the database, or it's going to return an error. And that would mean that it was not able to find that user. Now, if error is not null, aka empty, I want to take a look at the error. So for the payload, I'm going to return null. Now keep in mind, this resolver is actually going to fulfill or implement a GraphQL query. So we receive a query that says this user wants to log in, but we do not have that user on our DB. So what does that mean? It means user must go ahead and sign up first, then they can log in. They have to register first. Now, since we do not have that user on the database, what do we return for the payload? This payload, auth payload, we return nil, nothing, because we don't have this user. But what do we return for the error? I don't know what kind of an error that is, so I'm just going to pass the error here. All right, so I hope this makes sense. This is very easy to do, and this is our very first step. I could actually comment this out. This is going to be step 1. In the first step, what do? We fetch, this is going to be fetch user by email. This is step 1. Where is 1? There we go. So this is step 1. Let's move on to step 2. Step 2 basically means that we were able to find the user. So once we were able to find that user, what do we do next? We verify the password. Okay, so I have you in my database, but I need to make sure it is you who is actually trying to log in, not someone else. So I need to verify the password that you're giving me is actually correct. So how do we verify the password? So we have utils where we created compare password. So to this compare password, what am I going to pass? So remember, this user repository, this get user by email repository operation, it returns either user or it returns an error. If it returns a user, what does that mean? What does that mean if it returns a user? So if it returns error, we know we handle the error right here. But what if we found the user? Then what does that mean? Well, we need to take a look at our scan method. So if it returns a user, it means this. It means user has ID, name, email, password, created at, and updated at. So user has all of these information available on what? On this user struct. So remember the struct right here? This is very important. So we have all of the information on this user. Now, when I say compare password, what am I comparing? I'm comparing this password that I received. Now, this password that I'm highlighting, this is the password that I received with my GraphQL query. This is that password. So user wants to log in. User gives me their email and their password. So this is the password that I received from the front end. I am going to pass this as the second argument to this compare password. Compare password is going to accept this as the second argument. What is the first argument? The first argument is the password, the already hashed password of this user, where? On the database. And how did we get that? We got it using the scan method. Remember? So query row returned a row for the user, and scan method put it inside of here. And now this user on the database has a password, right? That's going to be user. This is the user that we received from the database. Keep that in mind. This is our database row or table row. If I do the dot, you can see everything that's available there. What am I interested in? Email, ID, name, password, created at, updated at. I'm interested in password. And there we go. So now you know what this is. This is what we received from the repository operation, what that scan method did. So scan method does one thing. It just talks to the DB. and this is what we received from frontend. So now what do we do? We hash this password that we received from the frontend with the salt that is available inside of the already created password on our DB. If the resulting operation is that both of them have the same hash, that means it's the same password. So this is how we actually compare this. Now, what is this going to return? If it is not successful, this is going to return an error. If the error is not null, this means well, we weren't able to actually verify that this is the same user. So here is where we're going to talk about a convention. So for the payload, I'm going to return null, but what am I going to return for the password? For the error. So remember, this function returns two things. This is the first thing. This is the second thing. The first thing, we passed in a null for it. So this payload is, so we have this null, which is for this payload, auth payload. And for the error, we pass in this error, this fmt.errorf. That's for the error. What am I going to write here? Well, I know that this user exists in my database, right? So at this point, I'm sure that this user exists, and there is just one thing that is wrong. That's invalid password. So I could very well say invalid password. But imagine if someone is attacking your database. At this point, they would know, okay, that this user exists. They just have to find out the password somehow. This is not actually a good convention. So what we do is we throw them off. We say either email or password is invalid. So even at this stage that I'm sure that email exists on my DB, if someone is trying to brute force, I'm not going to tell them, okay, invalid password. Then they immediately know, okay, email exists. So I found out the email address that was used on this, especially if it is a very, very sensitive website like social media. This is very important. So what we say is, we say it could be email that's wrong or password. I'm not going to tell you which one it is. So if you are trying to log in and you are genuine and you just want to log into your API or website, you can just pay attention. Okay, what was my email and what was my password, and just be more careful when you're typing them out. Otherwise, you're not going to know which one. So that's why instead of just saying, okay, invalid, I know at this point, line 59 is just password, but I'm not going to tell you. So that's another convention that we use here. So this was step 2. Next up, we have step 3. In step 3, what we do is we generate a token, so this user becomes an authenticated user. If user is authenticated, we know who they are, and then they are authorized to do something with our API. What kind of thing? They can create, for example, they can update their profile information, they can create habits, they can check in for habits. So whatever our API provides, they should be able to do that. So how do we actually generate the token? First off, let me write this. Generate a JWT. Well, JWT contains token, but I'm going to write it again for the authenticated user. At this point, I know user is authenticated, right? So I have this utils. Remember, that's why we created those utilities. And here we're going to have this generate JWT. We have already talked about this. What is this going to accept? This is going to accept the ID of the user, the ID of the authenticated user. Where is the ID of the authenticated user? This resolver just accepts email and password. Where should we refer to find out the ID of the authenticated user? Well, we should refer to the backend. But is this resolver going to talk to the DB directly? No. We talk to the DB using the repository operation, which we already called here. So this get user by email, this is our repository operation, which returned, remember this user, where we used it here. So we can use that again. We can say user.id. As soon as I say ID, this is the ID of the user. That is on the DB, which that repo operation gave us. So this is something we passed in. And then again, we want to generate JWT. We need to have our secret, the secret as well. That's going to be os.getEnv. We need to jump into the environment variables and select one variable from there. And that was JWT secret. That's why you do not commit that to GitHub. No one should know what your secret is. Now, what is this operation going to return? We already know that this is going to return token or error. Let's first off handle the error. So I'm going to say if error is not equal to null, then what do? I say return. Again, I do not want to create a payload, an authentication payload, if there is an issue here. If at any stage with our login resolver there is an issue, that means I do not want to generate a token. I do not want to send user information or token information to the front end. I don't want to do that. So for auth payload, I'm going to pass in null, and fmt.errorf, I'm going to pass in like the message if they were if this operation failed. So I'm going to say failed to generate token, and then we're going to pass in the error itself. But what if we were able to create the token? Then what are we going to do? Well, we're just going to send the token to the front end, right? So here I'm going to say we have this models.auth payload. We create a struct because auth payload struct, right? It has two things inside of it. It has token. For token, we're going to pass something, and then it also has user. So very good. What do we pass in for token? Now this token and this user is already available on the auth payload. They're available, but they need values. The value of this token comes from here. So let me show it to you. There we go. So this token is going to be this one, and this user is the user that we selected, which is barely being seen here. So let me just go up. There we go. Token. And then I already have the lowercase user as well. Now let's see what the issue is. It is saying that not enough return values. Have, this is very good. See, this is extremely good. So we already have what we want for the auth payload. I have the struct, but I want the error as well. So we have this, but we want this. This is an extremely understandable and easy error. So what does that mean? It means we have two things that we return from this function, the auth payload and the error. We returned auth payload, but we did not return anything for the error. So for the error at this stage, at the final stage, I know there are no errors. So I'm just going to pass in null. And there we go. Right? Very good. Very good. So we did this. Now we have this issue because this is duplicate. So we comment this one out. I'm going to keep this here so you can see your progress. Every repository operation is going to result in a resolver, and then that resolver is going to result in one of these stubs, one of these function stubs to be commented out. And this is how we create our API one by one. Very good. And we should be done here. Now we need to actually go ahead and jump into the GraphQL playground. So let me just open this up. Again, it just opens it up here. Let me take a look at that. Let me bring this down. So we have it here, but I need to zoom this out a lot. Okay, but I don't want this to be here. I want this to be opened up in Chrome. Oops, I clicked on Postman by accident. Sorry for this. Close this window. Let's go here. There we go. So we already have this information. This is for register, remember? So we actually registered 2 users. Let me just open this up. We already have them inside of the DB. So if I go to the SQLite 3, there we go. So we have a John Smith and a Jane Smith. Both of them have the same password. Even though their hashes are different, but their email addresses are going to be different. They are different. Just click on this one, double click on it, and there we go. You can see that inside of Beekeeper Studio as well. So now what do we want to do? We want to log in. So we need to actually change this to login. So instead of register, I'm going to say login. Where is this name coming from? Let's go to mutations. These are the types that we specified. Remember, this is the login. This is the schema.graphql's file. What do we need to pass? We need to pass email and password. Very good. Seems logical. If we want to log in, we need to pass in email and password. But now it says we don't know what this name is, so I'm going to get rid of it because I already have this account. I just want to log in. Now, once I logged in, what kind of information do I want to select? I could select all of these from the user, right? I'm going to click on this, and there we go. Login successful. But if I try to change the password, if I try to say click on this, invalid email or password, even though password is invalid. I'm going to I'm going to make sure the password is correct. I'm going to change the email. Again, the same issue. So it's not going to tell you what is wrong with this. Let's try to log in the other user as well. And there we go. So this is the token that we have, and we need to actually copy this, put it inside of headers, inside of an authentication struct in here, and then we should be able to do whatever we want with this. But for now, it's just important that we have this resolver working correctly. That's very good. Very good. So this is going to be it for the second resolver that is working fine. We need to actually jump in, and as the next step, we need to actually go ahead and create some kind of authentication middleware. And the reason that we need an authentication middleware is because this middleware is a function that sits between the incoming HTTP requests and their final destination, which is any specific resolver. So every request is going to pass through this middleware before reaching its respected resolver. Now, why do we need this kind of a middleware? We have been able to create the register resolver, and we created the login resolver, and we did not need this middleware. So the question is, why do we need it now? So this is something that I want to explain first before moving forward, so you can really see, okay, why do we need this? Now, the function stubs that we have already implemented are commented out. We have talked about them extensively, and you know why we did this. So this is the one that users are going to use in order to register for the API, aka this is the first time that they see this API and want to create an account. And this is the one that is going to allow them to log in. We have implemented a couple more. So if I come right here, we have one for the created at, one for the updated at, when the account was created. But we did not need this so-called authentication middleware. And why do we need it now? The reason that we need it now is we need to actually have a systematic way of knowing if this, so if I go to the database, take a look at this. So we have two users inside of the database. What we want to do is we must have a way of actually being able to make sure that if John wants to change his name or his email address or whatever, or wants to create a habit or check in for a habit, then John can only do so in his own account. He should not be able to change the account that belongs to this user, to Jane. And the same goes for Jane. So Jane, if Jane wants to create habits for herself, check-ins for herself for those habits, she only can do that in this context of her own account. So we need to have like these different accounts being distinguished among one another. And the criteria that we use in order to distinguish these accounts from one another is this ID. So this ID is very, very important. That's why we have to have this auto-generated and not really worry about it. So there are no duplicates in there. So this is the reason for it. We need to make sure that John can only access his own account, and so Jane can only access her own account. How do we know this? Well, we went the way of JWT, so we created JWT tokens, and now that we have those JWT tokens, we created them using our secret, the JWT secret that was inside of the environment variables files. So now what we need to do is, once user logs in, so either user signs up or logs in, they are going to get a token. We need to actually validate that token. So we need to make sure that the token that was generated for the John's account actually belongs to the John's user ID. So this is something that we need to actually do. So that's why we actually connect a token to UUID. It's easier, it's a common practice, that's why we do it. And if somewhere else in the world, in some other part of the world, Jane wants to log in and wants to create an account, we need to make sure the token that she created for her account when she logged in, that must be connected to this ID. So we can distinguish, okay, this account belongs to John, this account belongs to Jane. Two different accounts, two different people from two different parts of the world. They should not be able to access one another's account. All right? Imagine what the chaos if anyone could access the social media credentials of any other person and they could like post whatever they wanted. So just imagine the chaos. Like if it happens once or a year or a few years once, you can see what happens online. So this is why this is very important. But the other question is that why didn't we do this for the register and for the login? Because these two are public routes. Register is a route that we do not want to protect. I pronounced that incorrectly. Register is a route that we do not want to protect. The same goes for login. We don't want to protect that. If I make this register route private, so no one can access it without having a token, and you get a token once you create an account, then we have a dilemma, right? That chicken and egg dilemma. So I need to allow users to create an account, to log in, to then generate the token. If I close those two routes, how are users supposed to create tokens? They can't. So that's why we did not actually need to implement register and login authentication middleware, because these are something that's called public routes, but then the rest of them are private routes. For example, if user wants to update their information, this is the function stub, which we're going to use, which we're going to basically replace with our own business logic. That's for updating of the user. This is a very crucial one, deletion of a user. So if user has like, let's say thousands of posts, hundreds of images, a lot of like maybe 20 years of posting or 10 years or 15 years of posting or emails or whatever. So it could be anything. And you just delete that user, everything is going to go away. So that's why we need to make sure that this account belongs to John, and it is John who wants to delete his own account. The same goes for creation of habits, updating, deleting, check-in, and all of the other ones. So we keep a couple public, so it doesn't matter which website it is. If you go to that website, the login and the sign up, they're public. But if you want to, for example, post an image, if you want to upload a video, you have to create an account. Then you can do that, because then you have like this like reserved space for your own account that you can do all of these things in that confined space that is dedicated to you, or allocated to you. So now we're done actually with this theory of why we need this authentication middleware. It's actually time for us to go ahead and implement it. Now, where is this going to actually go ahead and run? I mean, this authentication middleware, it's going to be between that. So we receive a request from the front end, right? And as the request is traveling to the backend, where is it going to go? Is it going to go directly to the DB? Is it going to go to the repository operation? Or is it going to go to resolvers? We know that one resolver is responsible for implementing or for fulfilling one GraphQL query or one GraphQL operation. So when you receive a GraphQL operation, which is like an HTTP request, that is going to go directly to the resolver. The repository operation has nothing to do with that, because repositories, they are just interfaces that we use to work with our database. And then we can just take this interface and put it inside of the resolver to then work with, for example, creating a new habit, putting all of the information of the user on the DB, and then logging, like a new login, so you can select all of the information, match everything with one another, so you can make sure, okay, this user has an account, their email is correct, their password is correct, now they can log in. So this request is going to come to the resolver, which is either a mutation or a query. Then from resolver, it's going to go to the repository and to the other areas of the API. So where is this auth middleware going to sit? It's going to sit between this communication channel from the request to the resolver. So that's going to be the first step that this auth middleware is going to occupy. Before it reaches the resolver, we need to make sure that this user exists. So if user wants to create a new habit or update their information, first off, we need to see, okay, that this user with this user ID who has this token. So the token, if you remember, token contains payload, payload contains the UID, the user ID. So we match all of these together and then we find this out. Okay, this is the correct user. Now you can go ahead and update your information. So this is how we go about it. Now for middleware, what I don't want to do is actually put it like willy-nilly here. We have this middleware folder, and in here I'm going to create a new file, and I'm just going to call this auth_middleware.go. Hit enter. Now this is going to be something that we actually implement once and just keep reusing this. Now, the first thing that I want to do here is, of course, we need to have our package middleware. So we need to find out what the user ID is. So I'm going to create a variable. I'm going to call this user ID key. And I'm going to give this a very specific type. And I'm going to talk about it, why we need to actually give it this type. So the type of this is something that's called context key. And this context key, you can see the C in this context is lowercase. And when a type is lowercase in Go, that means we can only use it inside of this file, aka unexported type. So this is unexported type, and I do not want this to be available in any other places. I'm going to come back to why. So this is going to be user ID. User ID is extremely important. Now, what is this context key? Context key is actually a custom unexported type for context keys. And what is a context key? User ID is a context key. Now, why do we actually change this as opposed to actually using like string type directly? I'm going to explain that as well. So what is this context key? This is going to have a type of context key. The type of this is going to be string. Now, the reason that I want to actually create this context key and give it a type like this is because, let me first just correct this so there shouldn't be any error, is because I want this to actually be a custom type. So perhaps there might be some other type that we use inside of Go that might clash with this. That's why I'm specifying it like this. So this is how this is going to be specified. I'm just going to comment this one out. This is going to be context key, and then this is going to have a type that is user ID. So this is not equal to string that has user ID inside of it. Now, the context key is a custom type that is completely different from this string type. So this means no other package can accidentally overwrite or read our context value. And since this is unexported, this just can only be used inside of this auth middleware. You cannot use it anywhere else. And you cannot change this. You cannot access this because this is very important. There is also another reason for this, and that is we are going to actually use another method that is going to be called with value. And if we just go ahead and pass this user ID just directly in there, and if there is any other package that is using the same string, that is going to collide with this context key. So we just want to make sure that this is unique, this is unexported, this has a custom, even though the type of this is string, but this is a custom string type. So we just need to make sure that there are no other clashes with any other part of this app. So now that we have this context key, that is user ID key. Now context key is the type, the actual variable is user ID key, which is equal to user ID. Now we need to actually go ahead and create this middleware function. So this is going to be auth middleware. What is this going to accept? This is not going to accept anything, but what this actually returns is going to be a gen middleware function that is going to validate JWT tokens. So that's going to be the type of the thing that this returns. And that is called gen.handler func, which I just imported. So there we go. Now you might be asking, okay, why does this function need to return another function instead of just being a handler itself? Well, because this is a common Go pattern, which is called a middleware factory. So what we do is by returning a gen.handler func, we can configure the middleware with any parameters we need before registering it. And it also makes the middleware composable, which means you can stack multiple middleware functions on a route. So now how do we specify this, or how do we write this? That's going to be return and then func. What is this going to accept? Well, we're talking about incoming requests, so we need to accept the context. That's going to be gen.context, and this is going to be a pointer type. We have already talked extensively about the context. In this specific scenario, again, context is something that has all the information about that HTTP request. And why do we need to select it? Because we need to know what we received with that HTTP request. Now, before moving forward, I would like to show you something. We have not actually done this or written this inside of the playground, so I need to actually do this here. When we try to send this token from frontend, or we want to couple this token with our request and send it to the backend, we need to actually follow a specific standard. And that standard contains this struct key, which is called authorization. This is the struct key or the object key. And then it also contains a value. The value is surrounded by quotes, and there is something called bearer. So bearer, in simple English, it means like someone who holds something, right? The bearer, whoever holds this. So bearer basically means, okay, someone holds this, and then you have a sequence of like alphanumeric characters, which is going to be your token. So I'm just going to get rid of all of that. I'm just going to provide 3 dots. So the important part to know is how these different parts are actually separated from one another. So we need to have this authorization here, then this colon, which doesn't really matter here. Then we need to have this bearer, and right after the bearer there must be a space, and then we have these 3 dots which indicate that we have some kind of a token here. So this is the format of how we are going to receive tokens to the backend, and what exactly it is that we're looking for once user sends us a token. So all of this information is available on this little c, which is called context. So if I do c dot get header, I have this get header method, which is going to read a specific HTTP header from the incoming request. What was that header called? It is called authorization. Remember, I just put it right here. So we take a look at this header. which is called authorization, and we need to make sure that the incoming HTTP request actually contains this. And I'm going to call this auth header. Now, we're not going to have this for all of the incoming requests. Remember, for register and for login, we do not have this. So we are going to say if auth header is actually equal to an empty string, that means we do not have this. We are going to move forward to the next part of the middleware. So this next, again, you can see all of these are available. All of these little methods are available on this little c, which is context. So what this does is it is going to tell Gen to proceed to the next handler in the chain. Now, if we do not call this next here, this request, it would stop here. And then we need to return from the if statement. Now, we need to move forward. Why aren't we stopping the request if the auth header is empty? Why aren't we doing that? The reason for it is because, again, we have the register route, and then we have the login. If I were to stop auth header right here, if it was empty, you remember, we do not have an auth header or an authorization header for the sign up. We do not have one for the login. If we were to stop them here, to stop the request here, then user will not be able to sign up or log in for the account. But we still keep continuing. We still continue because we are going to move forward and actually check the other parts of the token. So the next part is actually this. We are going to see, okay, once we have the auth header, for example, maybe it's empty. If auth header is empty, will it have this bearer inside of it? No, it won't. So let's go ahead and let's check that. So I'm going to say if on the strings library, I have a method that's called has prefix. What am I going to pass here? I'm going to pass in the auth header, and then I'm going to see, okay, do you have this prefix bearer space? Now keep in mind, I'm not looking for the token. I'm just looking if we have this bearer. So we have different parts when it comes to that token that is being sent to the backend, and we're checking every part individually so we can like throw an error if there is any error. So this basically means is that this auth header starts with bearer space. So this is going to be the JWT standard that is going to require tokens to have this bearer space and then the token itself. So I'm looking if this does not exist, but this if statement is looking for if it does exist. If we want to look for if it does not exist, then we're just going to flip this value. So here I'm going to say, now I'm sending a response to the front end. I'm not merely like sending an error. I'm sending a response. So we need to actually formulate it in the JSON format. This is going to be HTTP. There should be an error code, right? That's going to be status, http.status unauthorized. There we go. And then remember, we need to have like some kind of a hash map to have like a key and a value so we can send it to the front end. That was gen.h. H stands for this hash map that we want to use. And you can see the type here, it's a map that has its keys as types of string, but the values of the map, they could be any type. Now, since this is a hash map, we need to open up curly braces. Here we're going to say, okay, this is the error. And I know at this point, there is just one kind of error, and that is invalid authorization header format. So we're lacking that bearer part, and that comes into the format part. And then if there is any error here, do we want to continue or do we want to abort this? We want to abort this. We don't want to continue, and then we return from this if statement as well. Okay, if I go outside of this if statement, that means we did have this prefix. There are no issues here. So what do we do as the next step? Well, if I have this bearer space token, I'm sure that I have an auth header, I have this bearer space token. I'm interested in the token because token contains that specific user ID. So now it's time for us to actually trim this prefix. We took a look at it. We said, okay, if it has prefix, now we are going to trim prefix. Again, on the strings library, we have this trim prefix, very handy little built-in methods that Go gives us, which makes our lives very easy. So here we have auth header. So from auth header, what do I want to do? I want to trim this bearer space. Now keep in mind, I'm passing bearer and then space because right after space, I have my token. So this is where I want to trim this. And then what is this going to return? This is going to return something that I am going to call token string. Very good. Now we have a token string at this point in time, right? What is this token string? It's this. So we have this. Now that we have this, we need to actually go ahead and validate this. We need to know, okay, if this is correct or if this is not correct. So how do we validate it? Remember our utilities, we have this validate JWT. We created them a while back. We need to pass in the token. And then we need to, how do we validate this? We need to compare it against our JWT secret. So that was os.getEnv. And this is going to take a look at our environment variables, and that's going to be JWT_secret. What is this going to return? This is going to return one of two things. It's either going to return user ID or it's going to return error. So first, let's talk about the error. If error is not nil, that means this process was not successful. That means we were not able to validate token. If we were not able to validate token, there are two possibilities. Either token is incorrect or token is expired. So again, we need to actually go ahead and formulate a response that is going to go to the front end. So how do we formulate a response? We have already done that. I'm just going to copy that from here and I'm going to paste it there, save this, and just change this. So it's going to be c.json http.status unauthorized. We're going to keep it there. Gen.h, we've talked about what this is, error. Now instead of invalid authorization, we're going to say invalid or expired token. We abort the operation here and then we return from this. But what if we didn't have any errors? What if it was fine? We were able to extract user ID from there. Now, the next step for us is if and only if the token is valid, which means user ID contains the authenticated user's UUID, right? Remember that UUID that I showed you inside of this. So this user ID is going to contain this UUID. Then we're going to move forward. So the way it works as the next step in GraphQL is that we cannot just pass this user ID as a function parameter because resolver signatures are actually fixed by GraphQL, by GraphQLgen or the GraphQL server. So the solution for us is to actually attach this to the request context. Basically attach this to that little C that we're working with. So if I take a look at this context, on the context, I have a method that is called with value. So what is this method? This method with value is going to create a new context. Remember, it's going to create a new context that is a copy of the existing one. So we already have a context, right? This is going to create a new one that is a copy of the existing context, but with one additional key value pair added to it. What are those additional key value pairs added to it? So first off, I'm going to pass in. So the first argument that this accepts is going to be the existing context. What is the existing context? It is c.request.context. That's the existing context. But what is the key value pair that we add? First off, the key. What is the key? Our key is right here. This is the first thing that we created. User ID key. That's the key. user ID key. What is the type of that? Well, the type of that is a custom string, a custom context key type that is of type string. So the next thing, if you take a look at inside of this pop-up, it says, so we passed in the key and then it selects the value. So what is the value? It's this user ID. So I'm going to copy that. I'm going to put it here. Oh, I'm not sure about this window, why it appears, not what this is, because I have some shortcuts. I'm using this Epic Pen just to highlight some stuff. And for some reason, it has clashed with this shortcut. So when I do Control-Shift-A, it also does this arrow and it also opens up this window, which is weird. So it doesn't allow me to actually work. So I need to fix that later. Now you have this user ID that we passed right here as the value for the user ID key. Very good. So this is the context. What is this going to return? This is going to return a new context and we're going to call it CTX. Now that we have an updated version of the context, we're going to create a new HTTP request that is identical to the original, but uses our new context. So how do we do that? We have this lowercase c dot request dot with context. And what do I pass in as the new context? CTX, which is above. So see, this again, you can see this is just too stupid. Again, I cannot highlight this. Sorry for this. Anyway, so we have the CTX here, and then I need to pass that CTX here. This is going to create a new context, which where am I going to store it? Where was the original one? The original one, remember, is on c.request. So I need to store it to c.request. And there we go. And then what are we going to do? We're just going to say c.next so we can move on to the next stage of this handler. Save this. So this is like the bread and butter of this, everything that I needed to do here. But then what I want to do next is actually be able to extract the authenticated user's ID from the context so we can keep using it for any function stub that we feel must be private. So update user is going to be private. Then update user must have a way to extract user's ID from the context so it knows, okay, this process is authenticated. So, this user is authenticated and this communication channel is secure. All right, so that's why we're going to select this, this user ID. And here I'm going to create a function that's going to be get user ID. What is this going to accept? This is going to accept CTX that has a type of context. That context, what is this going to return? This is going to return the string, which is going to be the user ID only and only if it is authenticated. Otherwise, we're just going to return empty. And then Boolean, which also going to signify that Boolean is going to be true if user ID was found. Otherwise, Boolean is going to be false. So there we go. So how do we select this? We have CTX. On the CTX, we have this value method, which is going to do what? This is going to retrieve the value stored under user ID key. It's going to basically select that for us from the context. So what do I need to pass in here? I'm going to pass in user ID key. And then what I need to do next is something that's called an interface type. So let me just comment this one out. So once we extract this user ID key, what this is going to return is this user interface. And this is basically Go's way of saying that any type. So interface, this pair of curly braces, means it's basically equal to this in newer syntax. This means any type. Now, the reason for this is because context can store values of any type and does not know the type that we have stored it in. So that's why we need to actually go ahead and force this type, aka we need to assert this type. So what it does is it's going to convert this interface type value into a string. And how do we do that? You're going to open up a pair of parentheses and you're going to pass in string, which is going to do the conversion. Then what is this going to return? This is either going to return user ID or error, and this is not going to return error, sorry, this is going to return OK. Now, before moving forward, I want to explain this part, basically these two things here. So we have user ID. User ID is simpler to understand. It's what we receive from this user ID key that has an asserted type of string. That's easy to understand. But then what is this OK? Well, this is like a safe version of this selecting and conversion. So what this basically means is if user ID has a type of string, or if the value is a string, I should explain it like this. So if the thing that's inside of user ID is a string, OK is going to be set to true. OK is true. It means this operation was successful. If, on the other hand, user ID, the value is not a string, or maybe it's nil, it's empty, then this OK is going to be set to false. Now, using the two-value form prevents an error, or in Go's language, a panic, if the context has no user ID. For example, when do we not have a user ID? In two cases, once user registers and once user logs in. So, for example, on our public operations like register and login, we do not want to throw a panic, aka we do not want to throw an error, so that error is going to stop our API from working. Therefore, we're going to say, okay, this is just going to return true or false for us. If it is true, then all is okay. If it returns false, then nothing is okay. But our application is not going to crash. So what do we return? We return user ID and we return OK, which is going to be for Boolean. And that's it. So this is what we did for this middleware. The last thing that we need to actually do here is actually wire this up to the main route. So now I am inside of the main.go file. And if I come right here, of these two routes that we have, this one and this one, which one is the main one? Playground is not the main one. Remember, all of the HTTP requests that receive, they're actually received on this /GraphQL, and they're post requests. That's how this GraphQL works. So we are going to attach this auth middleware to this /GraphQL, which is like, this is like the mother route for all of the routes that we have here. So how do we do this? We say middleware. On the middleware, we have auth middleware, and I'm just going to call it here as well. So how does this work? Well, this router post, it has 1, 2, and 3 arguments. It actually accepts these arguments. The first argument that is going to be running first is going to be this middleware.auth middleware. This is going to validate the token for us. And the second middleware, well, this is the route. We do not actually count this. So technically, this just has 2 arguments. It has this middleware and it has this GraphQL handler that we have specified here. So we first go ahead and authenticate that token. We validate that token. And then we go ahead and we run this. Now, what this actually does is, what this means is every GraphQL operation that we do, it doesn't matter if they're queries or mutations, aka queries and mutations alike, they are going to pass through this auth middleware. We have a couple of public operations like register and login, and they will be allowed because the middleware is going to let through requests with no token. But protected operations like updating profile or creating habits, they are going to check the context themselves, and they're going to reject requests if no user ID is actually injected, which is the term that I try to avoid using. So when the user ID is injected into the middleware. So after this authentication is done, we're actually injecting the user ID into the middleware, where we can use this method, this function, in order to select that user ID from there. Okay, so this is how this actually works. This is very simple. We have this auth middleware, we have implemented it. We're not going to do anything with it. We actually wired it up to here, and then every other, now keep in mind, every other private operation that we have, private resolver that we are going to have, that's going to go ahead and actually use this this middleware, and it's going to extract from there that injected user ID. So for example, the next one that we're going to actually work with is going to be a repository operation that is going to allow users or allow us to go ahead and update our account information. But now that I'm thinking about this, what we can do is we can actually make a couple of tests. What I mean by that is, I just thought of something. So take a look at this. We attached middleware.auth middleware to the main route, to the home route. And I did say that the public operations that are going to go through, because we have actually allowed for this, for our, so where was that? Let me just show it to you, auth middleware. So we allowed, if we do not have an authentication header. So we allowed this request to pass on to the next part of the handler if we do not have this authorization. So we allowed it. But that does not mean that, as I said before, that public operations are going to be private and like anyone is going to be able to create any kind of habit. What this means is sign up and login, they're public, but the rest of them, they're going to need that user ID. So far we do not have any kind of private operation like updating user or deleting user or some other kind of operation. We just have two public ones. So what we can do is we can actually test both of them to make sure that this middleware actually passes or lets users actually log in without having a token. So let's do that. I'm going to go to the GraphQL playground. And in here, we already have this JSmith email. And then we have the password, and you can see it's clearly the login mutation. So if I click on this, you can see we are able to log in. Even though if you go to the headers, you don't have anything in here. You don't have the auth header because authentication middleware lets this pass. We can go to the previous ones, for example, to the register one. In this process, we could create a new account. Let's call it I'm going to say Bob Smith, and that's going to be B-Smith, the same password. I'm going to keep the password the same so I don't have to like memorize it. Pass at 123. As soon as I send this, there we go. We were able to create a new user. So now you can see the login mutation and the register mutation, even though we have implemented this authentication middleware, both of them are able to pass through. Let's take a look at our database. Now, I'm just going to call this again. There we go. Now we have three users. We have John Smith, Jane Smith, Bob Smith. Everything is working fine. So I did say that the next step would be to actually try to implement the functionality for users to be able to change their user information. But before doing that, I actually thought about this. I want to implement something else, and then we're going to come back to this. So inside of this, if I go to the mutation, so we have this login mutation, we have this register mutation. So far, we have these two that we just tested. And in here, take a look at this. So we already have something that allows us to get user information from the database. What is this get user by email? This is a repository operation in the user department. And the job of this repository operation, if you go to this repo here, get user by email, you can take a look at this. The job of this is to select users from our database. So select one row of user information from the users table based on the user email. So in simple terms, what this means is I receive to my repository operation a request for user information, but they're going to give me the email. So I receive an email and then I show all of the information related to that email address and no other email address. So it must be the correct email address. And then we use that information to log in. You can see we used it inside of the login mutation resolver. However, there is another thing that we have to implement here as well. So this login actually works if we find users by email address. But after user is already logged in, how can you trace different habits to different users? Remember, we implemented authentication middleware, and the authentication middleware's job is to trace user ID, because user email is used to log in, but once user is logged in, how do we trace user from one repository operation, or I should say one resolver to the other, whether they can do this or they can do that? That is going to be through something that's called user ID. So what this means in simple terms is, after a login, every subsequent request is going to carry a JWT token. The token contains what? User's ID, but it does not contain user's email address. Then the authentication middleware is going to extract the ID from the token and it is going to inject it into the context. That's why we carry around this context. Context has all of the information. Then when a protected resolver, like updating the user or deleting the user, is going to run, they are going to have to read user ID from the context, so they are able to fetch the entire user information from the database. And the way we search that is using user ID. So that's why we have one repository operation for getting user information when it comes to their email address. So getting user information by their email address. But then we also have this other repository operation that is going to help us get user information based on their ID. So let's jump into here. So this is the one that we're going to implement, and this is going to be the me resolver. The me resolver is going to give you all of the information based on the current logged in user. So that's what we're going to implement. So we have implemented this function user repository get user by email address. I can select all of this function signature. I can paste it right here. Instead of saying get user by email, I'm going to say get user by ID, both of them capital. Instead of email, we're going to need to have the ID of the user, so we can find all of the relevant information of the user inside of our database. Now, how does this actually move forward? There is going to be a lot of overlaps with the previous method that we have used. So we're going to have to, I could go ahead and actually type this out. So I'm going to create a user struct. The type of this is going to be models.user. Now, how am I going to populate this user struct? That's going to be this resolver. Under resolver, I have my database pool. And from there, we're going to call this query row, which is going to fetch one row from the database. Now, what do we want? What kind of information do we want from that row? What I mean is, what kind of columns? So we're going to say select the ID column, the name column, the email column. Then, do we want to have the password of the user be sent to the front end? No, we don't. So we're going to say we could show them the created at time. Here is where you can decide what kind of information you want to show to the user if they want to take a look at their own information. But a hashed password is not going to make any sense. So we can just skip that, or you can add it. And then this is going to be from which table? from users table. Now keep in mind, we select all of these information from the users table based on some searching criteria. What is that searching criteria? That is where ID is equal to this question mark. And we know we use this question mark to avoid SQL injection. So this is always going to be read as pure text. And this is the ID. Now this ID that I just passed, that's the ID that this function has received. Very good. Now this query row, it returns a row. Then we use the scan method to scan the information of that row into that user struct that we have created. So what kind of information do we want to scan? It's all right here. So we got the ID, name, email, password, created that and updated that. But do we want to show password? No. So I'm going to get rid of it. There we go. Let's just do this. So I think that is it. Let's see what this is going to return. This is the same thing. This is the same thing. It either returns a database row and then we scan it into this user. Otherwise, or what it does is it actually returns error, which we are going to take a look at it. So we're going to say error. And what happens if we have any error? The error is gonna be different than this one. So it's not going to be invalid email or invalid password. What I can do is I can just copy all of this and then we can go over this. So the error is not going to be invalid email or password. It's going to be that we were not able to find this user. User not found. But at this point, we should have all the information that we want from the user. But if you talk about this API only in the context of backend, this is a very important distinction that you need to make, that you need to actually create this get user by ID. But if you talk about it in the context of frontend, you're not going to get to this point in the API, in the app, without having an account and without logging in. But that's not always the case. So not every user is going to access your API through the browser, through an interface. People who want to attack your website, they're going to use other interfaces. So this is like more for that kind of attack. So it's going to be a little bit more secure if someone wants to take a look at your information, but you don't have that user ID stored, then you need to actually stop them there. You're going to say user not found. What you're doing is it's not going to work. Okay, we do not have this user here. That's going to be errors. So if error is not null, we have errors.is, we pass in this error and error no rows. That's going to be the specific error that we have here. But aside from this, we're going to keep in mind in both cases, we return null. That's going to be for the authenticated user. And then we return that, whatever the error is. So here we say failed to find user. Yeah, that should be okay. It's the same thing. So we did not find the user. But finally, if everything is okay, what we do is we just return that user and we return null for the error. So let me save this. This part is also done. Then collapse this. This is the get user by ID. I think we're done here. Now, next up, what we need to do is we need to actually go ahead and create the resolver for this. That is going to select the user information. So let's go to Mutation and let's talk about this. I am trying to load user information. I'm not trying to do anything. What am I trying to do? I'm trying to load user information. With get user by email and create user, there was like an exchange of data. Like I needed to select something from the front end, and in response, I needed to give them something back, like the token and this kind of information. And the very fact that you have a login resolver indicates that it is a post method. It is a mutation. But when you just want to load information of the user who is already signed in, perhaps who is already signed in, who has a token, then the only thing that you need to do is you need to keep in mind that this is a query operation. This is no longer a mutation operation. And the other reason for this is, the other reason for this being a GraphQL query is that it returns the profile of the currently authenticated user. So the client does not pass a user ID as an argument. All right. Instead, the server is going to figure out who the current user is from their JWT token. So that's another reason why this is going to be a query as opposed to being a mutation. So let's go ahead, and since we just have a mutation, we have not created queries, query files. So take a look at this. This is the resolvers folder. All of our resolvers, they're going to reside here. We have this mutation, which is going to change data on the backend. It's going to do something aside from loading information, or something in conjunction with loading information. So what we want to do is we want to create a new file, and the name of this new file is going to be query.go. So there is like a lot of resolvers in this API that do not do anything, but they just load information. For example, you load all of your habits. That's a query operation. So we're going to put it here. Now that we have created this, what I can do is I can put it right next to this mutation, and we are going to keep it here. So the first thing that I want to do inside of here is going to be package resolvers. So all of our inputs, they are going to work perfectly fine without having to like worry about anything. Now, we already have the signature inside of this schema.resolvers.go. So what I can do is I can just copy this, put it right here, because this is the same thing that we're trying to do. I'm going to save this. It just did 3 imports. And then we're going to get rid of this panic, and we're going to write our custom logic in here. Now, what did I say about this resolver? It shows the profile or the user information of the currently authenticated user. So if a user is currently authenticated, what does that mean? It means there is a user ID extracted from the extracted by the middleware from the token that we need to inject into this resolver. How do we do that? Well, first off, let's go ahead and let's actually call our middleware. So I'm going to call the middleware. The middleware is right there. I'm going to do the dot. You can see we have 2 methods or 2 functions on this middleware. The first one is auth middleware. The second one is get user ID. I'm looking for the user ID, because user ID is the ID or the UUID of the currently authenticated user. So I'm going to say get user by ID, but what does it accept? It accepts context. We talked about it. It just changes context in a way that it attaches that user ID to it. So I'm going to pass in context. Now, context is something that this function accepts as a parameter. So what is this going to return? This is going to return user ID and OK. And we have already talked about this. But let's reiterate this one more time. If OK is false, we know OK is Boolean. If OK is false, that means no user ID is going to be injected into the context. There could be like one of several reasons why OK is false. For example, client has not sent us any auth header or authorization header. The middleware could have let the request pass through because it had no token. It's like there could be something wrong, but either way, we need to actually check this. So if it's not okay, then what do we do? Now this function returns the authenticated user, like that user information for which we pass in nil, and it also returns the error. So the error at this point, we know what that is. It's error F, and that's unauthorized. Very good. Now let's move forward. Once I'm moving forward, what does that mean? It means this process was successful. We actually were able to inject user ID into the context, and now we have access to it. So what do we do with that user ID? What do we do with it? This is a resolver. Resolver's job is to communicate to the repository operation, and the repository is going to select some data from the database. So what was the repository operation that we created that used, take a look at, now everything is going to make sense. what was the repository operation that we created that accepted the user ID and gave us all of these information about the user? It's this get user by ID. So if I call get user by ID and I pass user ID to it, I should have user ID, name, email, created that and updated that information. I should have that. Technically, that should work. And where is my user ID? There we go. I got it from this middleware. Okay, so we have, now I want to reference a user repository, like a repository operation. How do we reference repository operations? You can go to the mutation folder, mutation file, and in here, this is how we reference repository operations. You have R, which in this case, it stands for mutation resolver, but in the case of query, it stands for query resolver. There we go. That's the difference, right? So R has a pointer type, which is query resolver. Where was I? So mutation, there we go. So here you select R because you want to reference that specific repository operation. Then you specify which repo it is you want to select. You could have like 10 different repositories. You could have 1,000 repositories, but we are trying to reference the user repo. On the user repository, we have this get user by email. So this is the same structure. And then what does this return? It returns either our user and the error. And then if there is any error, we're just going to throw it. And for the user, we're going to return nil. So that's the same structure. The reason that I'm showing you all of this is so you know that it's not like some magic that we're trying to do here. It's actually the same patterns that we keep following, but we change it slightly based on the resolver that we're working with. So it's not like some voodoo that we are doing here. Everything is simple. There is a structure to what we're doing. And I'm trying to give you the structure. So once you tackle your other, like any other personal project, or you see this at work, you're going to see, okay, this is how all of these are weaved together. So here we want to select a repository operation that's available on R. What is that repository operation? That was get user. Now, do we want to have user by email or user by ID? Now, I want to pass the ID of the user. I don't know at this point inside of this resolver. I'm not sure what the email is. I don't know what that is, but I do know what the ID of the user is, and it is called user ID. So this user ID is the same thing that is here. So these two are the same thing. It's the same thing that I passed here. We got it from our authentication middleware. This is going to return user and error. What if we have any error? Then we're going to say if error is not nil, then what do? We return nil. And so we return nil for what? We return nil. This nil is going to be for this user. Because this is a pointer type, pointer types could return nothing. But for error, what do we return? We return the error. I'm not sure. In here, there could be like a lot of errors from like a different bunch of things. But what if we don't have any errors? What if everything is fine? So then we return that user, and then for the error, we return nil. And that's it. So that's what I wanted to do here. What is the next step? You can see we have an error here because now we have this duplicate resolver. This is a function stub that we implemented, and we added to it business logic depending on what we want to do. We no longer need this placeholder, so I'm just going to comment this one out, but I'm going to keep it so you can see all of these that we have implemented, and we have actually commented them out, and you can see how our API is actually taking shape. So now, save this. We're going to go to here. What can we do? Well, we need to find out the information of the current user, the currently authenticated user. Keep that in mind. So I have all of this. The first thing that I want to do is the first thing that I want to do is I want to call our query, which is the me query, and let's see if it shows us something. Since we have not actually logged in, there should not be any authenticated user. Okay? So let's go ahead and let's do that. Now, this is your very first query in this API, so I'm just going to go and I'm going to explain this in depth. The first thing you do is you write query and then open up curly braces and then you write the name of the query. Where is the name of the query coming from? I don't know. Let's take a look at it. It's in the schema.graphqls. Here we have all of the mutation types, but since that's a query, we're going to go to the query type. So we're specifically looking for this me query. If you take a look at it, you can see me has a type of user. What does that mean? It means I should be able to access any of these information, any of them. So I am going to type, let's just go step by step. I'm going to type me, and then the type of this, the information that's in here, that's another struct. So I'm going to open up curly braces, hit enter, and that struct has several fields. I can select ID, name, email, created and updated at. We don't have any habits now, so we're just going to select ID, name, email, created at, and updated at. Let's go ahead and let's send this, and there we go. This is the good thing about it. So this is not an authenticated user. That's why we got this error. So take a look at it. That's exactly the message that we wrote there. If there is no user ID injected into the context, just return unauthorized. And it doesn't matter how many times you click on this. You're not going to see anything. You're not going to see past this. Let me close that. Let's go to error. And you can see even though it says 200, because it returned the error successfully to the front end. There we go. So you can see all of these calls that we're making, they're going through that like /GraphQL. And this is like extremely fast, 0 seconds, 1 millisecond, microsecond, such a fast server. Okay, so how can we fix this? Well, the way that we can fix this is we could, let me Control Z here. This is the mutation register. I could change this to login. Login does not accept the name. It just accepts email and password. I'm going to log in. Then I'm going to select the token. I could select it with the quotes, right? I'm going to select the token. Go to here. So you go to the headers. So you just click on this arrow. Click on the headers. And in here, what you're going to do is you're going to open up curly braces. That's the format. You're going to write authorization in quotes because this is JSON, authorization. And then you're going to pass in your token. But this is not going to work because we actually checked for this, that this token should have that bearer hyphen, remember, but still, let's go ahead and let's take a look at this. So I should be able to get rid of all of this. Let's do a query. I'm going to do me, an ID, name, email, created at, and updated at. Let me click on this. I just prettified it and it got rid of the query keyword. I could just put it there just to make sure that, okay, this is a query. Now I'm going to send this. There we go. We got another error. Where is this error coming from? This is coming from our authentication middleware. So let me just collapse that, close this. I'm going to click on query. Then I'm going to open up our authentication middleware. It says, take a look at it. This is the error. If auth header does not contain bearer space, what do we return? See, this is the response that we sent. This is the status code, and this is the response. Invalid. Oh, that's mistyped as well. Invalid. Okay, good. And I'm sure you got that. You noticed it. I didn't. I just noticed that. And then I'm going to copy it. I'm going to put it here as well. Do we have anything else? Authorization. Yeah, cool. So this is the error that we showed. Let me save this. We aborted this and we returned from the function. And there we go. Invalid. So I'm going to click on it and you can see it just fixed that typo. Now, what should we do? We should add bearer space. Let me take a look at it. This should be uppercase bearer. There we go. Let's send this and there we go. Congratulations, you created your very first query of this API. And you can see everything is making sense, right? So this is, you have this me, which is a struct, which includes exactly what we told it to include right here. So if I say, do not show me the created at and updated at, just tell me the name of this person or the name of the authenticated user along with the email. There we go. You cannot do this with REST API. It's going to, every one of these is going to be one different handler or controller that you need to go ahead and create. But it's extremely easy to do it with with GraphQL. Now, if you want to take a look at any other user's information, you need to keep this in mind that it shows the information of the currently authenticated user. How do we know which user is authenticated? We take a look at their token. Token contains user ID, this token, and that user ID is basically extracted from this token and injected into the context. Injected into the context, and we select it here. We pass it to the repository operation, and then we show it to the user. Okay, so we have all of. So if I were to log in with the account information for Jane Smith, that would have produced a different token, and then by running the me query, I would have seen the information of Jane. In fact, let's go ahead and let's do this. So I'm going to copy this email address of Jane. I'm going to come right here. Let's click on login. I'm going to pass this. I could say I do not want to take a look at the user. I just want to you know what? I'm going to take a look at the user, but just give me their name, nothing else, just to shorten this. Send this. There we go. So it's, you can see Jane Smith. We got this. So now I'm going to copy that, go to header. What do? We say authorization. What should I pass? I'm going to pass in the token, but to the front of the token, what am I going to pass? I'm going to say bearer, this token. Now let's run the me query. That's query me. We could say, give me the ID, not the ID. We don't care about that. Give me the name and give me the email. There we go. So you can see, because I changed the token, the authenticated user changed, and there is not going to be any overlap. And at this point, I think we are actually done with this discussion. Yeah, let's move on. Let me just collapse this. Let's see what I want to do next. So I'm gonna keep that here. So the next thing that I want to do is, I want to get started by implementing more mutations so we can actually change user information and we can use other, we can code other parts of this API. Now, the next thing that I want to implement is for us to be able to actually update user information. So what kind of information can we update that's going to be either name or email or password? That's it. So for that, the first thing that we need to do is actually come up with the repository operation that is going to talk to the database. And then what we need to do is we need to have some kind of a resolver. We need to come up with some kind of a resolver that is going to fulfill that specific GraphQL query. But before that, let me just take a look at these files. We seem to have a lot of them. Let's see which ones we can get rid of. So I'm going to close this resolver. I'm going to close this main file. We need to have these mutations. We're going to keep working with these. We're going to need them. Yeah, so I'm going to keep this, and the same goes for query. We're going to close these two files once we're done with all the repositories relating user. Now, this is the authentication file, and we talked extensively about this. We looked at all the different kinds of errors. You know how this works. There are chapters in the video description. If you want to go back to that, you can just click on that, and you're going to go to the start of the section that in which, or the start of the part of the video in which we talk about this. So let's close that. Now let's come here. This is the get user by ID. Sorry, this is the user repository in which the last repository operation is get user by ID. So here, what is it that we want to do? We want to create a function. Now the function definition is going to be almost like this. So what I can do is I can just copy this part. We're going to like change some stuff up in here. So I'm going to put that there. What is going to be the repository operation name? That's going to be update user. So is this a user repository operation? Yes. So I'm going to keep it like that. Now, what kind of information is this function going to accept? It's not just going to accept the ID. Here is where we actually get started by implementing this update user. So the ID is something that we need to actually match. Okay, this user, we need to find this user by its ID. But then after we found the user by its ID, there are three things user can change when it comes to their profile. It's either going to be name or email or password. So password. I didn't specify the types for these. I'm going to come to those types, but first. So what do we want to do with this? Do we want, when it comes to the updating of the user information, that user should be fixed when user wants to update their name, they must update their email and they must update their password, or we want to be flexible and tell user, okay, you can update any part of this. You can update any one of these. You can update only the name, or you can update only the email, or you can update only the password. Or perhaps you just want to update email and password, or name and email. And this is the better approach. So we are not going to ask if user wants to update their information and they just want to change their name. We are not going to tell user, now that you have changed your name, you must change your email and you must change your password. No, that's a bad design. User just wants to update their name. So we need to be flexible. When it comes to this flexibility, when we are specifying these types, now keep in mind, these are of type string. The thing with string is that once I specify these as strings, user must provide them. If user doesn't provide them, what do we end up with? So let me just open up the block of the function. We're going to end up with an empty string. So a non-null value for a string, like an empty string, is this. It is quotes in which there is nothing. And this empty quotes basically means user either didn't give us anything, or then perhaps they might have like added like a few spaces. Once we get rid of that empty spaces, we end up with nothing. But the problem with this is that if we receive this on our server, we are going to remove the name of the user from the database. User name, like that row of that column, is going to be set to an empty string. Do you want that? Do you want to have like a user who doesn't have a name or an email, like all of these issues that are going to arise from that? So that's the problem with having these as strings. Now, how do we solve this? We can just change them to pointer types by adding this asterisk there. So I'm going to add asterisk there, and I'm going to add asterisk there. Now, if these, now that these are pointer types, they can be nil. If they are nil, that means user didn't give us anything. And we are not going to update that part of the database. We're not going to update. So user just gives us email. We just update the email. We don't update name and password. We update them as long as we get something. All right. So now that this part is clear, I want to talk about something that is called a dynamic SQL. So first off, I'm going to write this, and then we're going to go ahead and we're going to talk about this. So we are going to have two different slices. One of the slices is going to have a type of string, which means the values inside of this set clauses slice is going, the values, they're going to be of only strings. You can't have anything else in there. But then I'm also going to create another one, which I'm going to call arguments or args. And the type of this is going to be interface. So interface, which basically means the any type. Now, when it comes to interface, you can actually change this with the any type. Both of them are going to be the same thing, but I'm going to keep it as interface. So interface is going to be another slice, but the type of the values that you can provide inside of the slice, they are flexible. They could be like a string, a number, a date type, whatever. Now, why do we have these? So the reason that we have these is if we update user information on the database, we need to run a specific SQL command, right? What kind of a command do we want to run? So first, let me go ahead and actually give you that specific command. Here is the command. We're going to say update users, and then I'm going to say set name is going to be equal to, again, we're going to use these placeholders, question mark, email is going to be question mark, and then we're going to have password is going to be question mark. And then we need to have like a condition. So we find the right user whose information we want to update. And then I'm going to say where the user ID or the ID is equal to this. So this is the final SQL statement that I'm going to need to have to create in order to update user information, right? But what is the problem with this? Why can't I use this directly? Because what this needs is it must have name, it must have email, it must have password. So if user just wants to update their email, they should give us their name and give us their password as well. So this is again where we actually lose that flexibility which I talked about. So this is the problem. What is the solution? The solution is for us to create these parts dynamically. This middle part of the string or the SQL query, the solution is to create this dynamically. What do I mean by that? I mean, if user gave us a name, we're just going to provide name here. How would that look like? Let me show it to you. It would look like, where am I clicking? So let me click there. So if user just gave us name, we're not going to ask user for email and password. And we're going to end up with this SQL statement. But what if user wants to update their email, not their name? Then we're going to have a dynamic SQL like this. And now you can see why I keep calling this a dynamic SQL, because this is dynamic. We never end up with like this here. We never end up with this, but we end up with a dynamic statement that changes based on what user gives us. So if user gives us name, we're going to update name. If user gives us email, we're going to update email. What about password? Password is going to go the same way. I'm just going to get rid of these other two. Now you can see in these three statements, I'm not requiring users to give me all three. I'm just saying, if you gave me name, I'm going to update name. If you gave me email, then email, password, then password. But what if user gives us two? Then since we create this dynamically, we can say, if you gave me name and email, I'm going to update it like this. And it could go for any possible number of combinations. Name, email, name, password, email, name, email, password. And then like I think for password, we have already covered that. So this is how we are going to create this. But this is dynamic SQL. That's why we have these. So what is the idea behind set clauses and what is the idea behind arguments? When it comes to set clauses actually talks about the SQL fragment. Keep in mind, I'm saying SQL fragment because this is not a complete thing. Why? Because this set clauses is basically talking about this part that I'm just highlighting. If we receive name, set clauses is going to contain a string, which is going to be this thing that I've highlighted, literally this thing. If we receive email, then it's going to set clauses is going to contain this. If we receive password, it's going to contain this. If we receive name and email that user wants to update, by receiving, I mean user wants to update them, then set clauses is going to contain this. But keep in mind, set clauses is never going to contain their values. It's just going to contain a SQL fragment. So I could type this on top of it. So these are like really detailed like stuff when it comes to how SQLite works, how you create dynamic. These are like really real world stuff. That's why I'm focusing more on these and I'm explaining this so you can really understand. And this says Go convention. So if you see this anywhere else, you're going to understand that very easily. Set clauses is going to have SQL fragment. Now I'm calling this fragment because that's what it is. It doesn't have the complete statement. So keep in mind, what we have here is SQL statement. A statement is made up of fragments. Set clauses is going to contain fragments, but then we need to give data to the fragments as well. And arguments is going to contain data. So I'm going to give you some examples here. So once you like really see how this is, then we can just go ahead with coding, and that's just going to take a few minutes. So how is this going to work? We have set clauses. This is going to be equal to this slice. Now keep in mind, this is a slice, so we need to use square brackets. Let's say user has given us their name. They just want to update the name. So this is what set clauses is going to contain. That's it. You can see this is a fragment. Where do we see this fragment? Where do we see this? We see it right here. So we see this entire SQL statement in which we have a fragment. Why do we create this fragment and not the other fragments, like the update, the user, the set? Because they are the common parts. They are the static parts of the statement. It doesn't matter what user wants to update. You're going to have update users set. And then you're going to have, see, these are static parts where ID is this, ID and ID. So where we talk about IDs, they are not going to be dynamic. So because they are shared among every version of this SQL statement, that's why we don't include it. But which part is dynamic? It's the part where user gives us what they want to update. So that's why we put that here, because that's the changing part. That's the dynamic part. Dynamic basically means like changing. It's not like in one form, it always changes like its form or it's like letters, that sort of thing. So it's dynamic, it's evolving, it's moving forward or moving backward, whatever. It's not going to stay the same. That means dynamic. So that's set clauses. But where is data that user has given me to update their name? That's going to be args. So args is going to be this. Again, that is another slice, but this slice just contains the name of the user that user wants to update. For example, Samantha is the name of the user that user wants to update. See, so what do we do then? We put these two parts together and then we update our database. But we update it in a dynamic way. You can see this is very beautiful to look at. I get really excited about these kind of things. So what if user wants to update their email? It's going to be this. So set clauses. Now I'm writing email here because user just wants to update their email address. So that's going to be Samantha-Smith@test.com. So this is the new email. What if user gives us their password? Then that's going to be here. This is going to be password. And you can see these are the dynamic parts. This is the part where it is actually, it keeps changing. And this is password. It could be whatever. So it could be my pass at this thing, whatever. But if you have two things inside of the set clauses, for example, you have the name and also the email. You want to update both of them. So I'm going to select this, put it here. Then you have the name. You provide a comma, and then you select this one. You put that here, and you select this one, you put that here, and there we go. So now you can see how we keep creating this statement dynamically. And once we have all the pieces together, we write this entire statement, because this is a SQL fragment. It's not a statement. If you run it on the database, it's not going to do anything. You need to put it inside of this whole query or statement, then it is going to run. So this is why we have set clauses and set arguments, because we don't want to fix users or force them to update all three fields. We want to give them flexibility. If they want to update their name, they should be able to actually go ahead and update their name. There is two more things that I want to mention about these. These two slices, these set clauses and the args, they grow in parallel. So if one of them has one member, the other one is going to have one member. There is no way that one of them is going to have something and the other one is going to be empty. That's one thing. The second thing is that their indices must match. And this is the importance. So take a look at here. The first item with an index of 0 is name, and inside of the args, the first item with an index of 0 is Samantha. The second item with an index of 1 is email, and in args we have the email value. They must grow. They grow in parallel, which means their indices must match. That's a must. Otherwise, everything is going to be like out of order. So that's the last thing that I wanted to mention when it comes to this. Now let's move forward and let's actually keep creating this. Now keep in mind, we have actually created these slices, but at this point, they are empty slices. There is nothing inside of them. You can see it says declared and not used. They're empty slices. Now, how do we populate these slices? That's the first thing that we do. After we have populated them, then we're going to create that big SQL statement. I'm going to show you how you can do that. But first, how do we add this? So we're going to say if. This is going to be like a series of if statements, right? Where I don't know if user has given me their name or not. That's flexible. Okay, so user, it's optional. If user's name is not nil, what does this mean? It means user has given me an updated name. And it is this part. It is this part. If it is that part, I need to put this specific fragment, inside of the set clauses, and I must select the value that user has given me, and I must put it inside of the arguments. So I have two slices that I need to put content inside of, and which method do you use? We use the append method. So let's go ahead and let's do this. Now you can see, once you have understood the theory behind it, creating it is extremely simple. You says, I'm going to select set clauses. I'm going to append to set clauses. What am I going to append? Am I going to append email? This is going to be a string. Am I going to append email or password or name? Which one? Since name is not empty. Now, why can I say name is not nil? Because name is actually a pointer type. Pointer types can be nil. But if they are not nil, that means they do have some data. So here, I just have to write that name because I'm talking about name here. So I put this fragment inside of the set clauses. Now, what is the next step? The next step is to get the data and put it inside of the args. How do I put that? Well, I select the name, but keep in mind, this is a pointer type, and there we go. That's it. So if user gives us their name, we are going to implement these two things. But what if user gives us, now keep in mind, we are not chaining these if statements together because we want users to be flexible. If user gives us their email, we're going to put this string inside of set clauses and this email inside of args. Simple stuff, right? And then we do the same thing for password. But keep in mind, two of these can be true at the same time. because they're independent of one another. If user gives us their name, we are going to put name inside of set clauses and the value inside of arguments. Then we see that, okay, user has given us a new and updated email. We're going to put that inside of set clauses right after email. And the email value is going to be right after the name value. We're going to end up with something like this. Because they're independent, all three of them can be true at the same time. That's if user has given us these information. And this is the password. Now that we have actually considered and targeted all of the different states, let's go ahead and let's see if user has given us anything. So if user wants to invoke this operation, which is update user, user must give us at least something to update, right? So I'm going to say if the length of one of these is empty, like set clauses, if the length of this slice is equal to 0, what does this mean? It means user didn't give us name or email or password. There is nothing in there. Then I'm going to return. Now keep in mind, the first thing that this function returns is a type user. So we're going to return nil for that. And what is going to be the error? We're going to say fmt.errorf. And I'm going to say no fields provided to update. You have to give me at least one thing that you want to update. Oh, come on. No fields provided to update. Very good. Now, after this, if we move forward, if we move down from this if statement, that means user has given us something, right? So next thing that I want to do is I need to change the updated time of the user information, right? So if I go to the database, this is when the user was created, but then once user changes any of these information, so any of these, then we need to update this updated at time. So for that, I need to know what time it is. So that's going to be now. I am going to say time.now. There we go. This is going to give me the time for now, which we're going to use for our updated time. And the next thing that I want to do is I'm going to grab my set clauses. Now again, since this is still a fragment, I'm going to append to it that updated at. So updated _at. Now again, you need to pay attention to the order of these. User has given us their name, and then we know, okay, user wants to do some change. We need to update the updated at time. Regardless of what the change is, as long as there is a change, we must provide this updated at time, right? So that's why I'm giving it to set clauses, but where is the value coming from? This is the SQL fragment. SQL fragment does not contain the value because we don't want to expose our database to SQL injection attacks. That's why we have separated these two from one another, and arguments contains the value. So I'm going to say append to arguments the value, which is now. There we go. See this now, which I got from there. The value is going to be here. And how does this work? Well, SQL driver is going to do this automatically for us. It's going to select this time value, that is this now, and it's going to assign it to this updated at. You don't have to worry about it. Now, let's move forward and let's actually try to join all of the clauses that we have. In case user wants to update their name, email, and password, or update more than one, we need to actually go ahead and join these. So I'm going to say set clauses, and this is going to be strings.join. And what do I want to join? I want to join all of the set clauses with what? With a comma. Okay, so that's going to be the set clauses. What is for strings.join? Oh, I'm actually reusing this variable name. That's going to be set clause. So I'm joining all these clauses together using this comma and space, and that's going to become a set clause. So we're trying to do this. Okay, so we are putting all of these. If there is more than one, we're going to be putting them together. Okay, So now that that is done, we need to come up with our SQL statement. So here is where we're going to create the SQL statement, aka query, which we are going to run on the database. So I'm going to say query. You could call it statement, you could call it query, it doesn't matter. I'm going to say fmt.print, sprintf. Come on, sprintf. Now the reason that we use sprintf is because this sprintf is actually going to format this string. Keep in mind, SQL statement is a string. It's going to format the string by replacing it with some placeholder values. I'm going to show it to you how this works. So remember this big statement that we had. What was that? It was this, right? So let me just copy this entire thing. We said that that is the statement that we're going to run on the database, right? But we want to have these parts dynamic. So I'm going to get rid of them. I don't know which of these user has provided, but I'm ready to be flexible. So if name, then name, email, password, we have talked about different combinations. So that's why I'm going to provide %s. So this is the placeholder for a string value. And what value is going to be here is going to be inserted here. That's going to be the value of set clause. So I'm going to say set clause. If I can type it correctly, there we go. Now keep in mind, we do not put set clauses, the plural here. No, we put the singular here because all of the plurals, they were joined into the singular. So this singular is the one that we put here because all the plurals, they went into the singular. So set clauses, right? So name, email, password, in case user wants to update all three of them are now one list or one slice, and we select that slice and we put it here. Why don't we put set clauses directly? Because if user, let's say user wants to update all three, they are going to be three different kinds of set clauses. That's why we don't put it. We just go ahead and join all three of them together, and then we put this big one in here. Cool. So that's going to be inserted there, and this is our query that we're going to run on the database. But again, these need their data. So I'm going to select the ID that user is going to give us with their request, and I'm going to put it right here. So this is the ID, and now we're going to go ahead and we're going to run this in on our database. How do we run this? We have r.db database connection dot execute. This is going to execute this line. Okay, so what do we want to execute here? We first need to provide the query or SQL statement, and then we need to provide the values for specific parts, for the parts that need to have value. What are the values? That's the args. So this is the final thing that we run to put all these two together, everything together. And you can see the SQL statement or query is separate from the arguments, from their values. We don't put them together. SQL driver does that for us. Now, arguments is a slice, so I need to select values from the slice, and I'm going to spread them using these three dots in here. If you do not provide these three dots, you would just put the slice like Jane, and then you would have some kind of an email. I'm just going to say this. Then you are going to have some kind of a password. But this is, you can see this is a slice. We need to spread the slice, which means you need to get rid of these brackets, and then you need to put it like this. So that's why we select args and we do three dots. Let me lowercase this, and there we go. And this returns something that I'm going to say I don't need it, and it also returns error. So what is this underscore? We know that when you use this execute method, it is going to return two values, a SQL.result and an error. Error is the one that we're interested in. The SQL result is going to be the ID of the last inserted row, as well as how many rows were affected by the query. Now, for this update user, we don't need this SQL result. we just go ahead and take a look at the error if there were any errors. So when I say underscore here, I'm actually telling Go, I know a value is being returned here, but I'm deliberately not using it. Okay, so that's what this means. Now let's go ahead and let's talk about the error. If error is not null, that means there was some problem. And what could be that problem? The first thing is I'm going to say if strings dot contains, I'm going to say error dot error. I'm going to, okay, that should not be inside of quotes. Error dot error. There we go. There we go. Let me run that as well. Perhaps we are violating that unique constraint. So I need to actually provide that unique constraint failed. So if this is the error, then we're going to say, this is going to be for the email. We're going to say return null. This is going to be for the user. And I'm going to say fmt.errorf email already in use. This is the most important one that we care about when it comes to these errors. Why is it throwing any error? If error is not null, undefined. Oh, there should be a colon there as well. So if it is this unique constraint, like you're trying to use an email that is already used, then we are going to say, okay, you cannot do this, but if there is any kind of error, we're going to just put it here. So again, for the authenticated user, we don't return anything, we return null, and then we're going to say error f. This is going to be failed to update user. And I'm going to put it right here. We've already seen this, and this is going to be the error. So %w is going to be replaced by that error, whatever the error was. Now that we have gotten out of the error, that means everything was successful, then what do we need? So after updating, the last thing that we do is we fetch the completed user from the database. And how do we do this? We're going to say r.get user by ID, and I'm going to pass this ID of this user, and that's it. That's everything that we want to do here. And we talked about a lot of things because we actually we haven't had the opportunity to create something like dynamic SQL. So I just wanted to take like extra time to be able to explain how that works and how we can go with that. So now that that is created, we are going to move forward. The next thing that we need to do is we need to actually go ahead and create the mutation for this, because we're changing some data on the backend. We're not going to go with the query, which is this query resolver. We're going to go with the mutation resolver. So for that, I'm going to jump into the schema.resolvers.go, and from here, I'm going to select the update user. Where is it? This is the update user. I'm going to copy it. Let's come to the mutation. I'm going to paste it here. Instead of this code, we're going to actually work with that query that we're going to receive from the front end. So how do we do this? Now keep in mind, we are outside of these two public operations. We're no longer inside of register. We're no longer inside of login. So this operation, update user, this is a private operation. This refers to one user only. And user must be authenticated, aka we should know what the user ID is before we can move forward and implement this. Now remember, we did some things inside of our middleware. So I should just open that up again so I can just show it to you. I said, so we had two functions. We had this auth middleware where we did all of these validations and trimming and finding out the headers. But then we also had this. The job of this get user ID was to select the ID of the user from here and put it inside of the context. Remember? So that's what we did. Now, because we said the token contains the user ID, user ID is the UUID of the user that we have on the backend on our database. And we need to know that. So because the reason for it is because we are allowing register and login to pass through and to work. We're allowing these to pass through the middleware, authentication middleware and work, even though they do not have that user ID. So if you take a look at login, you can see we don't extract user ID. Take a look at register, we don't extract user ID, but they still work because they're public. But this is not public, so we need to extract user ID, aka we need to make sure that user has given us a token so we can extract user ID from there, put it to inside of the context. Where is the context? Context is right here. So we need to update the context with this information. So how do we do that? That's extremely simple. We just go ahead and we say middleware dot, you can see I have two members. I'm interested in the user ID. So I'm going to select user ID and I'm going to pass in the context. So what is this going to do? This is going to read the user ID from the request context that the auth middleware has injected in there after it validated the JWT token. Now, what is this going to return? So again, this happens after JWT token is validated. Again, this is going to give us user ID, and then it's going to give us go. Sorry, it's going to give us okay, not go. We're going to say if not okay, then there is something wrong, right? So for the models.user, for the authenticated user, we're going to return null. For the error, we are going to say unauthorized. Unauthorized. Simple. Simple and short. You don't have the authorization to implement this because there was no way for me to actually make sure that you are authenticated. Now that we have gotten out of this if statement, meaning user is authenticated, we need to take a look at what has user given us. So if name is not null, then it means user has given us a new name that they want to replace their old name with, aka they want to update their name. So if they want to update their name, what am I going to do? What am I going to do with that new name? Remember, we have utilities to check some conditions for name. We're going to call those. So I'm going to say utils dot. Now I am inside of the block for name. I'm going to select validate name. That's why I said it's good to create these utilities, put them in different files, standalone files. So that was a while ago. So if you've forgotten them, it's right here. We created these utilities here because we said we're going to keep reusing them. It's a better idea to create them once, reuse them everywhere, as opposed to just keep defining them again and again and again. So what is this going to accept? We know that this accepts only one thing, and that is going to be name. Again, this is a pointer type. We talked about it. Okay. So this is going to validate the name. And if this returns an error, I'm going to select it here. I'm going to say if this operation returns an error, that means, what does that mean? That means error is not, I'm actually chaining these together. This basically means that if this returns an error, that means error is not null. We return from the function, from the update user resolver right here. We say return null for the authenticated user, and for the error, I'm going to say fmt.errorf. What is the error? I know it's invalid name. What specifically is wrong with the error? We could provide a placeholder for it, and that is the %W. That's going to specify what specific, maybe the length was less than 2 characters. I don't know. I know that the name is invalid. So there we go. If user gives us their name, we're going to validate the name. But what if user gives us their email? We are going to validate their email. So if this is email, if email is not null, that means user has given us their email. Then we validate email. So we say validate email. Remember, we created validate email. I'm going to say this is going to be email, and the rest is the same. Here, I'm going to say invalid email, and then whatever the error is. Let's move forward. What if user wants to update their password? So the new password must match the validation. It must pass the validation. And there we go. We have utils.validate password strength. This is going to be password. Password. Very good. Very good. Now, if user has given us a password, which basically means password is not nil, we need to actually go ahead and hash that new password as well. So I'm going to go on top of this. This should be password. So I'm going to go on top of this statement here. I'm going to create a new variable that's going to be hashed password. Why do we hash it? Because user just gave us a new password. So a new password is not hashed. Let's go ahead and let's hash it. So that hashing is going to happen inside of this if statement, and we're going to follow the same steps. We have another utility that is going to hash password. There we go. What is this going to accept? This is going to accept the password. What is this going to return? We have already talked about this. This is going to return hash, and this is going to return error. We're going to move forward. We're going to say if error is not nil, that means there is something wrong with this hashing process. So at any point, if we face an issue, then we just return from this entire resolver. That's very critical to keep in mind. Then we have error F. I know inside of this if statement, there is just one possibility: failed to hash password. I'm going to provide where is the percentage sign? The placeholder for it. And then we're going to have, okay, this is the error. But what if this hash was successful? Then we're going to say the hashed password is now equal to this hash password. Now since this password is actually a pointer type, we need to select the memory address from that pointer type. That's why we pass in the ampersand sign, which is going to signal that we are trying to update the password. So this is all three conditions. If name, then this. If email, then this. If password, then not only we check the password, we validate the password string, but we also must hash the password if user has given us a new one. So now let's go ahead and let's update this. Let's update the repository. So we're going to say r.user repo dot. So from the user repository, which repository operation do I want to select? It's this repository operation where we talked about a lot of SQL. The name of it is update user. So I don't have to really copy it. As soon as I do dot, you can see we have create user, this, but we want to select update user. Now, what does update user require? It needs to have user ID. That's the first thing you can see. Now, the bold part is the name. We're going to pass in name. Again, name is optional. If user has given us name is going to be here. If user has not given us name, it's not going to be here. So you can see it's not yelling because these are optional. Password, and we do not pass in password. We pass in the hashed password because update user is repository operation. Repository operation communicates directly to the database. So when you talk to the database should not know what the plain password is. Rather, it should know what the hashed password is. This is either going to return user or error. Again, you can see the structure is the same. We say if there is some kind of an error, aka error is not nil, we return nil for the authenticated user, and then we return the error, whatever the error is. But if we move past this, that means we do have a user, right? Everything was successful. And then for error, I'm going to pass in nil. So error is nil. What is going to be our next step? Well, our next step is going to be to comment this one out. See? It's very simple. You implement the repository operation, and then you implement its specific, whether that's a mutation or that's a query, and then you remove that from the schema resolvers that GraphQLgen or the GraphQL server has created, and then you go ahead and you test that. So what do we want to do? I am going to log in with this user, for this Jane email, Jane user, I haven't actually opened up Beekeeper Studio. We can take a look at it there, but I'm going to look at it here as well. So we're talking about this user, this middle, whoops. A new version is available. No, not now, maybe later. So we are talking about this. Let's say we want to change this name from Jane Smith to, I don't know, Jane J. Smith. Perhaps this user wants to provide like a middle name or family name here. Perhaps Jane Samantha Smith or Jane S. Smith. So that's like one of the ways you can add middle names. You just provide the first letter and you provide a dot, and okay, that's going to be the middle name. You usually do not like express it. You say, okay, Jane S. Smith, whatever. Okay, so let's go ahead and let's log in. So I just logged in. Why do we need to log in? Because we need to have this token. I'm going to copy that, come into the here. That's going to be authorization. Authorization. I'm going to pass in bearer. I actually copied the quotes. I don't need the quotes. We're going to check this without this authorization, but for now, let's actually see if this works fine for us. So what do we want to do here? We want to create that mutation. So again, this is a mutation. How do you know what is the structure of this query that you want to send, or this mutation, this request that you want to send to the user? What is its structure? You might have forgotten that. So you come to this docs, see this part here, it's docs. Perhaps I've forgotten that. I don't want to go into my code. I just want to see it here. You go to mutation. So we are not talking about register. We're not talking about login. We talk about update user. So we need to have something like this. Update user, okay? So first off, you have this mutation. Then what you do is you call, and it's going to give you that like autocomplete as well. So when you want to update user, you need to, now we track users with this authorization, right? So that's how we track which user it is. I think I've provided the authorization incorrectly, or haven't I? You know what? Just to make sure it's correct, I'm going to copy it. Come on, up until here. What am I doing here? Let me just get rid of this entire thing. Oh, I copied it incorrectly. So let me copy that. Error. If you have like a front end for this, that's going to be simpler, because this process is you're just going to code it once and it's going to happen like automatically. So we have this update user. Let's say I just want to update the name. I should be able to just update the name. I'm going to say Jane S. What is the current name? Let me just double check. So Jane Smith. I want to add a middle name. So I'm going to say Jane S. Smith. Okay. This is the update user. Okay. We need to have, we need to have the function body here. What do we want to select? We could select the updated name. We could select the email, no comma, and we could select the password. Okay. We cannot select the password. We could select the updated at instead of that. Okay. Very good. Let me provide this. If I prettify it, it's going to get rid of mutation. I don't want to do that. So let's send this. Invalid name can only contain letters, spaces, hyphens, and apostrophes. So this is a good thing. It actually threw what this means is the validation is working fine. So we cannot do s dot. Name can only contain letters, spaces, hyphens, and apostrophes. Perhaps this is a good wake-up call for us to jump into this name validation. Here, continue. I could say if it contains a dot, then that's okay, right? let's see. So I haven't actually implemented that in the final version of the app. So if it contains spaces, that's okay. If it contains hyphens, if it contains this apostrophe, that's okay. Then I'm going to say name can only contain letters. And then I'm going to say periods or points. Which one is points? Or it's actually called periods. Spaces, this. Okay, so let's save this. Let's try this again. And failed to fetch. Something has happened here. Periods, let me provide a comma there. Save this. Let's go to the error building. Let's wait for it. It's actually building this. There we go. Now it has built that again. Oh boy. So what am I going to do with this? This should be working. There we go. We were able to update this. So I actually, we changed the name validation. We changed the validation to be able to, I didn't actually pay attention to this. It just came to my mind that what if someone wants to add middle name? So this is one of the ways you add middle name, right? So you should have dots in between your names, right? So, okay, so this is the result. Let's select the database connection inside of here. There we go. We have this, where is, oh, it is already updated. There we go. Jane, S dot, then Smith. We were able to update the name of the user without updating the email, without updating the password. And you can see, you can take a look at the updated at time. So I created this on 13th of May, but then unfortunately there is just, I got sick and I had a lot to do with like at work. And with this, like there is just a ton of things happening here. So I haven't been able to record videos for past few days. You can see here, I updated this at the 22, so 9 days. That's why I like these videos, they take longer. It just, it's too much for like someone who is single, like solo, I shouldn't say single, solo developer. It just takes a long time. Now we need to refetch this. So updated at time is changed. And this name is changed. So as soon as I refetch this, select, where am I typing, buddy? Anyway, I'm going to type select this from users. There we go. If you take a look at this, it's updated here and this is updated here as well. And you saw that validation works. What if we provide just one character? It's not going to work. It must have at least 2 characters. Very good. What if I want to update my email and I do this? Invalid email. You can update your email address as well. For example, this user wants to update their email address. So this is their current email address. Maybe that's -s, then -smith. There we go. Email address is updated. So if you come right here, you just click on this. You can see email address is updated and it should be updated here as well. There we go. There we go. It's updated. You should be able to update your password if you want to. So password. I am very reluctant in updating the password because I forget that. You can see there's just a lot of gap. Oh boy. So that's going to be my pass at 123. Okay. So let's update the password. Password is updated. Now this hash that is 5UHG, this should change. And there we go. You can see it changed. And it is going to change here as well. If you just reload it, you saw that change in real time as I reloaded this. And then I'm going to change it back to pass at 123. There we go. What if I get rid of the authorization and I send it? I'm going to say unauthorized. Who are you who wants to update the information for this user? because the token gives us the username, the user ID. If you get rid of the token, or if token is incorrect in any way, let me just remove a few characters from it, then you are not going to be able to extract token, the user ID from there. Invalid or expired token. So you did give me the token, but it is either invalid or expired. I'm not sure which it is, but there isn't a problem there. But if I select it, whoops, oh, I thought I had it in copy. Anyway, you could log in and you could do that again if you want to. But you can see all of the errors, they're working perfectly fine. Very good. Our validations, the validations, they are working fine as well. We need to actually move forward to the next repository operation. The next one is our ability to actually delete user information, like delete the account of a user. So if user wants to delete their account, they should be able to do that as well. And to get started with this process, the first thing that we do is we create the repository operation for deletion of a user. So we have this repository. The type of this is going to be user repository. The name of the function, or the name of this operation, is going to be delete user. What is this going to accept? So the only thing that we need in order to delete one user from our database is going to be the ID of that user. That is going to be the string. That's going to have a type of string. And what does this function return? This function either returns a Boolean, that's going to be whether or not we were able to delete the user, and the error. Now you might be asking, okay, when it comes to the deletion of this user, why are we returning bool and then also error? So we could have just said, okay, if we deleted the user, then that could have been like a true operation, but otherwise, like if there are any errors, we would have just used the Boolean no, or the thing that is the opposite of the true, the Boolean false, right? But here is the thing. There are actually two things that we need to consider here. The Boolean here refers to whether or not this operation was successful. The job of it is not to provide information on that specific error. So if the operation is successful, this is going to return true, and that means user was found, number one, and two, deleted. But if this bool returns false, that means we were not able to actually find the user. So why weren't we able to find the user? That's the job of this error. So we are actually differentiating between these two. This one returns true when I find and then delete the user, but it returns false if I can't find the user. Now, why wasn't I able to find the user? Why couldn't I find the user? The reason is inside of this error. So I think this is like a better way of going about this. It gives more information as to what the problem was. Okay, now that we know this, we want to do something here that is going to change a record or a row on our database. Now keep in mind, this is user repository. The things that we do here, they are directly in contact with the DB. They do something on the database, okay? So we want to run, what do we want to do specifically? We want to run one SQL query or statement that is going to delete one row from the users table based on the ID of that user. So if we receive a request for the account that belongs to Jane, we know that what is the user ID of this account, and then we just delete that account. Now imagine if you were to delete for example, if you wanted to delete your own account on any social media website or anywhere else, then you would have like ended up deleting 10 other accounts or one other account. That wouldn't like make sense, right? So you can delete other people's account. No, we trace users based on what the ID says. So if the ID matches this account, then we delete it. So ID is like this standard that we go by, because as we said, ID is the best differentiating factor among users. Okay, so everyone has a unique ID, so we know which account belongs to whom. So we reference the resolver, we go into the database connection, we can run one specific command. Now, what is the SQL command to delete something? So you can say delete from, now you need to specify what the table is. It's the users table, then you need to specify your condition. This is where ID is equal to, now do I dare pass ID here inside of this string? No, because of SQL injection, remember. So I provide a question mark, so SQL driver does it for me, and then I pass an ID here. Now, this is the SQL command that is going to delete one row from the users table. And what does one row represent? It represents one user. So eventually we delete one user from the users table. What is this going to return? This is going to return, remember, it's going to return result, and it is going to return an error. So first off, we talk about the error. So if error is not nil, that means, unfortunately, there was an error. For this operation, we return false. For this Boolean operation. So we said that if it is true, we were successful, we found the user and we deleted that user. If false, then that means we weren't able to find the user, right? So we return false for the bool part, but then what is the specific error? The specific error is this. We are going to say failed to delete user. This is the specific error, but then we need to actually jump into the details of that. Why weren't we able to delete that user? And then we have that specific error there. Very good, right? So now that this is done, then we take a look at the specific result. And what do we look at specifically? When we take a look at this result has a method available on it. So I'm going to show it to you. As soon as you do the dot, you can see here is a method that says rows affected. So the idea behind this is once we run this delete from users where ID is this SQL query, there is going to be some rows, or there must be one row affected by this. So there are one of two possibilities. You could have you could have 0 that this is going to return. So if it returns 0, this result that rows affected, if it returns 0, this means no row had this user ID and the user, which basically means the user doesn't exist. But if this result that rows affected returns 1, exactly 1, this means exactly one row was deleted. So user existed, but is now gone, but no longer exists. So this is why we take a look at the result. So we can see, okay, how many rows were affected. This is going to give us something that's called rows affected, which is going to be effectively a number, and then the error. So if error is not null, now we need to be very specific what the issue was. Now you might be asking, okay, why do we need to have these many checks? Now imagine you have a front end for this API. When you have a front end for the API, like all these steps, little steps that we take in order to make sure that we know what went wrong at any stage of the operation, then that doesn't really make sense when it comes to all these little things. They do not make sense when it comes to a UI, because when you're not logged in, you do not have the capability or that button to click on and to delete. The only way that you can delete an account is to sign up, then log in, and then go to your dashboard or wherever the delete button is, and then click on it. If you're not logged in, you will not have access to that delete button. So all these, if you can have the ID, of course, if you're logged in, there is the ID, so there is nothing wrong there. There could be some connection problem that you could say, okay, we actually take a look at that, but under normal circumstances, you're not going to need all of these. They are important. Why? Because if someone bypasses your UI and they actually use Postman or some other software that bypasses the UI, and they just make calls to your backend directly. In that scenario, these are very important to actually prevent them from deleting the user. Again, when it comes to UI, you log in, this means the user exists, user has ID, then you delete that. But aside from UI, these are very, very important. So when I'm writing these like different stages, I don't have this in mind. Like I'm not paying attention to, okay, someday this might have a UI. No, I'm doing my job when it comes to like going through proper steps for securing a backend API. I don't care if this is going to have some kind of a UI or not, but you need to be very specific when it comes to backend. Okay, you can't do this. This is not possible. This is not possible. This is possible. Okay, so we do our job. We don't care about the front end. If you don't end up using them, it's okay, but they should be here. Okay, this is what I'm trying to say. Now, if we have some kind of an error, again, we return false for this operation. We do not allow this user to be deleted. And then we take a look at the error. We could send the error so the developer could know if, like it's the developer who's working with this API, they know, okay, what the problem is. Failed to confirm deletion, and then I'm going to provide a placeholder for the error. This means that we had errors with this result. Now, let's take a look at the rows and see if any rows were actually affected. So I'm going to say if rows affected is equal to 0, then what does this mean? It means we weren't able to remove this user. Either there was some problem with the ID, with finding this, or this user doesn't exist. So again, we return false for the operation and null for the error. But if after all of this, we were able in deleting the user, then we say return true. And then for the error, we're going to return null. Now, you might be asking, okay, here, okay, so here, if no rows is affected, I return null for the error, but then here I also return null. So what is the difference between these two? Now, the reason that we return null here is that it signals, this null signals to the resolver that we are about to get started creating. It signals to the resolver that the user was not found. Now, the resolver can then return its own error to the client. So we keep this separation clean. The repository reports facts like we found the user, we didn't find the user, like user found or not found, but then resolver decides what error message to show to the client. Okay? So there we go. This is the update. Sorry, this is the delete user. We are going to go into this mutation. And here is where we're going to write the delete user mutation. Now, why mutation? Because we're changing data on the backend. So for this one, let's come right here. There we go. This is the next one. So we're going to copy this. I'm going to put it there. But then before running this, we need to actually go ahead and comment this one out. So I'm going to put that here. We can already see the signature for this. It's very easy to understand. We have this R, which represents this mutation resolver. We have the delete. We get the context that we need in order to delete this user. Where is the ID? Okay. How do I know which user it is that I want to delete? Well, user ID is available on this context that we need to access from that get user ID that we used inside of the middleware. So it's here. Then we have the Boolean and then we have the error. Okay, let's move forward. This should be very, very simple for us to actually implement. Now, one thing I actually forgot to mention is that when you have this kind of an operation where you are trying to delete the user, there is a term that we use that when you delete user has some information attached to it. To avoid having those information become orphaned records inside of our database, what we do is we need to go ahead and establish something that's called a foreign key relationship. Now keep in mind, when we wrote the SQL, the database code right here, we said foreign keys relationship are allowed inside of our database. Okay, so when you delete that user, you want all of those records inside of the habits table to be deleted. Which records? The records that relate to this user. So user is the parent of those records. If you delete the parent, not delete the child records, then you end up with something that's called orphaned records. These are the terminologies. I haven't selected them. It seems like it sounds horrible, but we just talk about like data and like SQL. So I have to like go ahead and use this terminology. I know it doesn't sound good, but I have to like keep using them so you are familiar with these. Like once you get a job or you're actually working in a team, you hear this. So you know they just talk about database and tables, nothing serious, okay? So this is what we need to do. So you have this container, which is the user, then container has some items inside of it. If you remove the container, you have to remove the items as well. But that's something that we're going to implement later, but I just wanted to mention that, so we need to keep that in mind that something like that is going to come up. So let's move ahead and let's take a look at our middleware. This is the middleware. On the middleware, we have get user ID. I'm going to pass the context of this resolver to it. And based on this context, this is going to give me user ID. And remember, it's going to give me OK. So what do? We do the same thing that we did before. Right here. So these things, they are going to be universal when it comes, like they're going to be shared when it comes to different mutations. Okay, let me collapse this and let's put that here. So we say if it is not okay, then we return unauthorized, but then we cannot return nil for a Boolean value. Here we could just return false. Very good. Now that we have access to this user ID, let's pass this user ID to the repository operation. So this operation is the operation that's going to delete one user, one record from the users table, okay? But this needs to have this ID. We need to give it an ID so it can find that user and delete that user. Well, how do we give it an ID? Keep in mind, this is a function definition. Here we have defined the function, we have not called the function. So as long as the function is defined but not called, the function doesn't do anything. The function invocation is going to make that function actually get up and do something. Okay, so you have function call or function invocation. These are like synonyms. You can just keep using them interchangeably. How do I have access to that function so I can delete a user? That's available on our user repo dot delete user. Now see, it needs to have an ID that has a type of string. I'm going to pass in that user ID that we got from this get user ID middleware. So we have this. Now here is where I am calling that repository operation, the one that I created here. So I'm calling it here and I'm giving it user ID. So it knows now which user it is that we're trying to delete. So what is this going to return? This is going to return either deleted or error. There might have been some errors there. Now, if error is not nil, then what do? We say return false. We do not delete anything, and then we return the error. But what if error was true? Then we return true. But before doing that, I want to have like one more step here. And this refers to that last part that we did inside of here. So if we return false, from this operation, so if this deleted is false, that means that if this is false and the error is nil, which operation am I talking about? I'm talking about this one. So if no rows were affected by this deletion operation, what does this mean? So if I've reached this stage inside of the repository operation, one of the things that it means is that we have already deleted this user. because we moved from this point. That means we were able to delete the user. We moved from this point as well. We were able to confirm that deletion. And we came here, but we got stuck here. One of the reasons that we got stuck here is that we had a user. We received a request to delete that user, but then we received another request to delete that user again. So in the second time that we receive a request, the rows affected is going to be 0. And then we're going to return false and nil for the error. So I don't know what this error is. See? So for this condition, for this specific condition, I'm going to say if deleted is equal to false. See? So that deleted, this rows affected is equal to false. This deleted returns false. So if this deleted is false and error is nil, then I'm going to return false. And then I'm going to say, I couldn't find this specific user. User not found. Very cool, right? So we think of every different step in this process. This could be one situation. Okay, let's move forward. Now, what if none of these errors occur and we were able to delete the user completely? Then we say return true for this Boolean operation and we return nil for the error. Now, what do we have to do? Well, we have to jump inside of the schema resolvers, comment this part out, take a look at the server. Server is trying to build this. There we go. It built that. Now, we don't want to update. First off, let's go ahead and let's log in. So I'm going to click on login. Jane Smith, we could, I need to open up a Beekeeper Studio as well. So let's go ahead and let's delete this Bob's account. I'm going to select the email for Bob. I'm going to put it right here. The password is the same. I'm going to click on this so we were able to log in for this account. Then I'm going to select this token. I'm going to say, come on, buddy, authorization. Okay, then I'm going to pass in bearer and then the token. Very good, very good. So this is bearer and authorization. Authorization. What seems to be the problem? Everything is okay. Anyway, I'm going to change this. So what do we want to change this with? We want to actually run the delete user. And how do we run that? So let me just get rid of this. Why do we, authorization doesn't appear in any GraphQL query. Authorization. This is typed correctly. Anyway, let's come right here. Let's go to mutation and then we have this delete user. We are just going to go ahead and we're going to run this. So I'm going to get rid of all of these. I'm going to say delete user. That's it. Let's run unauthorized. Bearer hyphen. Oh, I put it in the wrong place. This should be inside of headers. So I'm going to put it inside of headers. So I'm going to first cut it, run this. You can see we are not able to delete this user. Now, I'm going to put this here, right? So let me open this up. Inside of the users table, we have Bob. This is the one that we want to delete. And Bob is right here as well. So as soon as I run this, it says delete user true. We were able to delete this user. Now, refresh this. There we go. Bob is gone. Run this line again. There we go. Bob is gone. You can see that? Bob is gone. Now, if I run this again, user not found. Because we used to have this. This has the correct structure of an ID, but we weren't able to find the user. That's why it's very, very important to actually think about every step of this. Now, where is that user not found is coming from? Here we don't have that. It says failed to delete user. Now here the errors, they are database related errors because this is the repository operation. If this operation which is carried out in the DB, has some issues, then we're going to show these errors. But if we have any other error, that's going to be here. Now take a look at this. It says user not found. That's very, very important for you to understand, okay, why we do this. Why we go like step by step and try to understand every bit of this. So we know that, okay, this user doesn't exist. What we can do next is we could actually take a look at a query. So we have this me query, right? Remember, which is going to give us information about this current user. I'm going to say me, and then I'm going to pass an ID, name, and email. Let's run it. User not found, and path is me. Very good. So this is working perfectly fine. It is protected. You cannot just go ahead and delete a user if you don't have access to it. No operation provided. Very good. So we were able to actually do a lot of things, a lot of very good things. Let me collapse these. So we implemented all of these. We were able to create user, get that user by email, by ID, update user, and delete user. When it comes to the updating of the user, we can update any part of the user information, and we check that, right? So this is the user repository. I'm going to close this. We're not going to need it for now. And this is the mutation. So we implemented these 4 mutations, and we implemented 1 query. I'm going to keep them open. I'm going to get rid of the SQL Go, and we're still going to have this. Now, the other part of this API, I'm not sure what to call it. The second part or third part, we talked about a lot of stuff. This part of the API is done when it comes to talking about users and how we can create a user, update user information, and get that information, and also delete the user information. So we were able to do all of this. You could hit the brakes here. You could say, okay, I learned a lot of things. I don't want to move forward, but I recommend you move forward so you can learn even more things, because there is just a ton of more that we need to actually implement and talk about. But now you're confident that you can follow this very, very well. So what is going to be the next thing that we're going to do? Well, the next thing that we are going to do is actually create habits. So see, we implemented all of these. The next step is to create a habit. Then we should be able to find out how many habits we have, find out one habit like individually or all of them. We should be able to update habits. We should be able to delete habits. So the way this application is divided is if you take a look at the migrations, take a look at this. This is the first category of migrations that we created, but we still have 2 more categories of migrations. The next category refers to habits, and the category after that is going to talk about check-ins for a specific habit. So once you have gone through with your promise, once you have implemented that habit, you carried it out, that's a check-in. You check in for that day. Okay, I did it this day, so I am recording that I implemented my habit this day, and now I'm relaxed. Okay, I did it. I went through with my promise. So for that, we need to have different tables, right? For these operations, for these 2. So the next thing that I want to do is to actually create these tables. Remember, when it came to users, the first thing that we did was we actually created tables for the user. Then we went ahead and we did all of the rest of the stuff. Now that you have experience when it comes to implementing migrations, these should be very simple. So the first step is create those tables. I am going to just copy paste their name. So I'm just going to copy that. I'm going to come right here. Where is that? New file, put the name there. So it is all of these zeros to create habits table.up.sql. Hit enter. Now, I don't have to explain what this means because we talked about this extensively when we created the users table and the up migration for the users table and the down migration. We talked about them. So in the up migration, we create that we create that table and we specify what each column is going to be. and what are going to be the constraints for that specific column, so like the rules that we define for that column. That's going to be inside of the up migration. Inside of the down migration, we just get rid of that table. That's it. We just get rid of it. So I'm going to paste this again, and instead of up, this is going to be down migration. So these are the first things that I want to implement here. And so let's get started with it. We have already talked about this. We want to create a table if this table doesn't exist already, if not exists. But what is the name of this table? Well, I'm just going to call it habits. Very simple. Now, I need to be very specific when it comes to the different fields that this table is going to have. So what I'm writing here inside of this pair of parentheses, each one of these statements is going to be one column inside of this table. So what is the first column? The first column is going to be ID. The type of this is going to be text. This is going to be primary key. Again, we have talked about this extensively. So primary key is going to be a UUID, Universal Unique Identifier, which is generated automatically by SQLite. Okay. And then we say default, since we want this to be generated automatically. Now, what do we do with this? Well, we need to have some things, some rules applied to this. First off, we convert this to random blob. Again, we talked about this extensively. And then we are going to convert this into hex. And then from hex, this is going to be lowercase. Very good. Lowercase. Or I'm just going to say lower. And then I'm going to get all of these and put them inside of parentheses. Provide a comma and move forward. Now, this next part is something that we haven't talked about, and this is that foreign key relationship that I talked about. So what relationship am I talking about? I'm talking about user and all of their habits. So if user deletes their account, all of their habits must be deleted. And in SQL, we have a specific command for that, which is called onDelete cascade. So we have this user underscore ID. This is going to have a type of text, not null. And what is this row? What is this row going to reference? This is going to say references. What is this reference? It references the users table, and inside of the users table, the ID column. So as I'm typing this, I'm explaining this. And what is the the nature of this reference? It's going to be on delete cascade. So we're deleting these in a cascading manner. That means from top to bottom, one after the other. We just get rid of them. But this happens so fast, you think, okay, all of them were deleted simultaneously. So let me go over this statement once more. When we say user ID, what this does is this is going to link this habit to its owner inside of where? Inside of the users table based on that ID. The reason that we write text is because user IDs are UUID strings. We say not null because every habit must have an owner. It must belong to a specific owner. So we avoid having orphaned habits with no owner that actually make no sense inside of our application. When we say references user ID, what this does is this creates a foreign key link that this user ID must match an existing ID inside of the users table. So this is like explaining it in more details, if you will. So what does onCascade specifically mean, technically mean? This technically means when the referenced user is deleted, automatically, so this means automatically delete all of their habits too. And this prevents orphaned habits from remaining after a user is deleted. Very good. So then what do we have for a specific habit? Now, these were like the general stuff that, like, not the ID is the general, the user ID is the very specific part, but these are some rules that we need to actually specify. But now let's talk about what kind of information do we want to accept from the user when it comes to one specific habit. So I want any habit to have a name. The type of name is going to be text, and it is going to be required. So it's going to be not null. Let me provide a comma there as well. Now, so I want to have these habits have names. What else? Let's give them description. So description. Did I type that correctly? Yes. So this is going to be of type text and not null. What else? What kind of other information do I want from this? Well, I want these habits to show me when they were created and when they were updated, if user wants to update them. So for that, I'm gonna actually open up this table just to show you that these are actually, they are the same thing. I'm gonna select these two. This is the users table, the created at and the updated at. I'm gonna copy that and I'm gonna put it here. So let's do this. Let me just fix this. Now, we want these two columns, the created at, the updated at, actually three columns, the ID, created at, and updated at. These three columns, we want them to be generated, or their data to be generated automatically by SQLite. Therefore, we provide this default. So created at, it has a type of date time, which means SQLite is going to store this as a text string in ISO format. It's going to be automatically created, and this is going to be set when we say current timestamp. This is going to be set to the to when a new row is actually inserted, and the updated at is when the data changes in any of that, like. The name and the description, and then if you have any of them change, we actually change this data. Now, there is one more thing that I want to do here that we did not actually do inside of the users table, is that I want to create an index on the user ID column. And why do I need this index? So the idea behind this is that we frequently query habits by user ID. For example, I'm saying, give me all habits for this specific user. So every time a logged in user opens the API, opens our app, we run something like select all habits from the habits table where we have this user ID. Okay. So based on a specific user ID, we select all of their habits. So without an index, SQLite is not going to have a shortcut. It's going to read every single row in the habits table from top to bottom, looking for the matches. Now, we have like a specific term for this in SQL. This is called a full table scan. So with 10 rows, it is instant, but imagine you have 1 million habits. Then your database is going to become slow. So whenever you hear this, okay, you need to implement indexing for your MongoDB database or your like SQL database. This is what we mean. The general idea behind database indexing is to make sure the database it functions faster. All right. So an index is a separate data structure that SQLite maintains along with the table. I am willing to give you another analogy, so you can think of it like the index at the back of a specific book. So instead of reading every page to find foreign keys, you jump straight to the page number listed in the index. And SQLite does the same thing. Instead of scanning all rows, it looks up user ID in the index and jumps directly to the matching rows. Okay, so it's a faster way of, like you could say it's a faster lookup. It's a faster way of finding data, and this is going to make more and more sense and become more and more necessary the more data you're going to have inside of your table. Now, of course, there are going to be some trade-offs. Again, this is a beginner level video. I do not want to jump like into too details, but the trade-off is that indexes, they speed up reads, but when you read the database, but they slightly slow down writes. In SQL, read is when you say, okay, like select, the select statement, the select word that you write in SQL, that's a read operation. But then you have write operations as well. The write operations are when you say insert, update, or delete. So it just like, that's a trade-off. It depends on, again, on your project, on a lot of different things. And then you are going to talk about this indexing. Okay, it's not like something for this very small project. I'm going to do this. Now, the reason that I'm doing this for this is not because this project needs it. It's because these real world practices, they must be taught at some point in some video. So if I started like a 200-hour video for like a big like project and then teach this there based on the context, it is going to be impossible for anyone to follow. So we have this small app API, which I'm going to show you. Okay, you can do this, but once you see it in a larger project, you're going to understand, okay, oh, this is indexing. This is why we have this. So let's go ahead and let's actually create this. We're going to say create index if not exists. Very good. So far, so clear. Then what we need to do is we need to provide a name for this index. So I'm going to say IDX. Now I'm following conventions, okay? IDX, index, habits, underscore, user, and then, well, habits, and then that specific column that I want to reference, which is user ID. And on what table do we want to create this index? So IDX, the reason that we say IDX, this prefix is going to tell us, or it's going to tell the database that it is an index. It's not a table, it's not a view, it's just an index. And on which table do we want to create it? It's going to be on the habits table. On which column? User underscore ID. And that's it. We created this. That's it. So let me move forward, provide a semicolon there, and there we go. So now you know what all of this means. Let's move forward and let's destroy this easily. It's very easy, again, to destroy something, right? And the first thing that we do here is we're going to drop the index. Now you might be saying, okay, if we drop the table, SQLite is going to drop the index automatically. Yes, it's going to do that. But we want to have like a clean way of writing this, a clean way of going about this. So we drop the index. This is like a more explicit approach that I'm taking here. And then I'm also trying to mirror the up migration that I created, that I wrote here. So in the up migration, we have this table, then we have this index. So I'm being explicit. I'm deleting the index that depends on the table, then I'm deleting the table. This makes more sense. It's not like confusing, you know, okay, what it is that we're trying to do. So we want to delete this index. And then after we drop the index, we're going to drop the table if exists, and that is the habits table. There we go. So we have implemented these. Now let's go ahead and let's actually run these migrations. So I'm going to kill this terminal that belongs to the database. And let me just bring this down. Okay, so we have these. Very good. Let's keep this open. I'm going to open up another terminal. Now we have that script, this script that is going to actually run these migrations, right? So we're going to say migration up. Let's run this. There we go. It created that table. It created the habits table. Now, there is something that you need to keep in mind. We have already created 2 users. It's John and Jane. Okay, we did 3. We deleted 1 user. Now, if I were to go ahead and show you the down migration, it's going to get rid of that users table as well. But doesn't matter. We're going to create that the users again. So I'm going to delete this. Now, the reason that it runs down migration for all of them is because that's how we have coded this migrate.ps1 file. If you want to be specific, be my guest, go to the GitHub. I showed you, okay, how the code is going to work. You can be specific to which migration you want to actually drop. So I'm going to do this, not applying all down migrations. Now let me try to connect to the database. So here, I'm going to say .tables. It still has all of these, not applying all down migrations. Let me get out of here, exit, clear this. I'm going to run the down migration. I'm going to provide 2. Oh, there we go. I think we have actually, it's been so long. We have actually modified this part. Let me just get rid of this. If I go to the scripts, tells migration scripts. Yeah, we need to be specific which steps do we want to drop. Very good. Close these. Now get rid of that. If I were to take a look at our tables, yep, we just have schema migrations. Now we need to exit or quit, clear this. Now run the up migration again, and this is going to create both of them. I just showed you that, okay, you can drop this as well. So now we can, whoops. There we go. Yeah, I know that was incorrect. So SQLite 3.tables. Now we have these tables. We can say select everything from users, nothing, of course, and select everything from habits, nothing. Very good. So if I just, there is no data, we don't have any data. Okay, so this part is also done. What should we do next? Let me close this. The next thing that we could do is actually, we need to have, so what did we do for the user? Now we created the migrations. Here we have the resolvers. We created this user.go. What we need to do is we need to actually create this model for this for this habit. So what we need to do is we create some kind of a model so we know exactly what type of data user is going to be able to provide when it comes to the creation of one specific habit. So this is going to be the next thing that we're going to do. And to get started with the habit model, the first thing that we need to do is we need to actually create its file. So right where we have this user.go, inside of the models package, I'm going to right click and I'm going to create another file that's going to be habit.go. Now, there is something that I want to direct your attention to. Take a look at this. You can see this is models with an S at the end. And this means this is the package in which we have this the habit.go file. Now, if I were to go to the schema resolvers, we're going to see that that's not the case. So this should tell us that we need to actually go ahead and regenerate all of these. So here we have this resolver that is create habit. It's a mutation resolver. We have talked about different parts of it. So we know what the context is, what the name is, what the description is. But take a look at what the function returns. This function returns model.habit and then error. So the problem is here. It says model. There is no S at the end. So by this convention that we have models with an S at the end, does this refer to the to this habit model that we're about to create? No. So what we need to do is we need to actually regenerate these. So this is no longer model.habit, it is models.habit plural. I just wanted to give you a heads up. So first off, let's go ahead and then let's actually get started with this model. So what is a model? We've already explained this in depth, but I'm gonna give you the shorter version of it. So when I say we need a model for a habit, that's actually a Go struct or a Go object that represents a single habit in our application. So it is the blueprint that our code uses when working with habit data, whether reading from the database, passing between functions, or returning the habit back to the GraphQL client. And we know that every layer of this API is going to have to deal with this habit in some way or another. So we're going to have repositories, resolvers, GraphQL server itself. They're going to use this same struct. So that's why if we define it here inside of this file, what we end up with is one single source of truth. That's a terminology that we use for what a habit is going to look like in our code. So we just know, okay, this is what it looks like. These are the fields that it is going to have. And all the other parts of the application, they're going to work with this. So how do we get started with this? Well, the first thing that I want to do is I want to import this package models. That's very important. And then this is a Go struct, right? So what is the name of this? This is going to be, now keep in mind, one individual habit is going to have this type. But then when you have like a slice of this, then it's like individual habits in like more than one individual habit. But their model, their blueprint is not going to change. And then we need to write struct just to say that this is a struct. Now inside of this, we are going to have two different kinds of fields. We're going to have fields that are called stored fields. So let me show it to you. So these fields that we had for the user, these are all stored fields because they accompany this DB tag. So they have their JSON tag, and then they have their database tag, which is going to map it to that specific column that is relevant or that is like related to this ID. So these are called stored fields. Actually, they're values that are saved as columns inside of the table. So we save these. But then we're going to have another set of fields for this habit specifically, which are called computed fields. I'm going to come back to this, but for now, let's just go ahead and let's come up with these. So the first one that we're going to have is, what do you think is going to be the first one? Well, of course, we need to differentiate between different habits. So that's going to be ID. It's going to have a type of string, and then we need to specify what the JSON tag is going to look like and what the DB tag is going to look like. So the JSON tag is going to serialize this as ID when we send JSON responses to the client. So how do we do that? We're going to say, okay, let me just click here. We're going to say, where are my JSON or JSON? And then what is going to be the JSON tag's name? That's going to be lowercase ID. I'm going to provide a space. Then we need to specify the DB tag. This DB tag is going to map this uppercase ID to a lowercase ID column in the database when we use the scan method. So DB is going to be ID as well. So if we want to send a response to the client, we need to know, okay, what is this field is going to represent? It's going to represent this lowercase ID. And then if we want to read this from the database, what is this field data going to come from? It's going to come from this column. So the column that we have inside of database is called ID. So that's why we have like this JSON tag and a DB tag. This is the normal convention when we have stored fields, because again, we store them, right? So the next one is every habit is gonna go to one specific user. That's going to be user ID. The type of this is gonna be string, and this is going to be stored inside of the DB. So it's gonna have a JSON tag. JSON tag is gonna be user underscore ID. The DB tag. Now we created this table, we created these columns. You can take a look at them. If you just come right here, you could go to your database, and in there, you can actually take a look at the schema for one specific table. First off, let's see how many tables we have. We have the habits, the schema migrations, and the users. So as soon as you do .schema, and then you need to specify which table you want to take a look at. So if you go with the habits, hit enter, there we go. So each of these fields that we have, each of these is going to be a column. See? Up until they updated that. So now we're talking about the second one. The second one, what is the column name? It's user_ID. So that's what I'm going to type there. I'm going to say user_ID. And we just make sure, okay, that the JSON tag is the same thing. So there is no actual confusion when it comes to that. So next up, we need to have the name. I could bring this down, keep it here so we can take a look at, okay, how this actually maps to its corresponding database column. Right, next up we have name. Name is going to have a type of string. Then we need to specify the JSON tag. That's going to be lowercase name. And then the DB tag is going to be uppercase name. Lowercase name. And once you get the hang of this, creating different models for different data structures or different parts of your API, when you just take a look at it, you're going to know, okay, I'm going to have these things for the habit. They are necessary. I could add more things if I wanted to, but these are this is the starting point. After this, we have description, which I'm going to uppercase. This is going to have a type of string. The same thing, we have JSON, description, and then we have DB, description. After this, we have the created at. This is going to be of type time.time. Let me save this. So we imported that, and the DB tag we need to specify, because we stored these values, we need to specify the JSON and DB tags for these as well. This is going to be created_at. And the DB tag for this is created_at. I'm going to copy paste this. This is going to be updated. Oh, I wanted to do Control D and then update it. And now this first one is going to be uppercase U. Very good. So I think we're done with this. And now you can see, okay, how each of these, they are going to be mapped to their specific columns. Now we're done with the fields that I call them stored fields, which are actually called stored fields. We're done with them. And you can see we have covered all of them here as well. Like all of these columns, they have been covered above. Now, what is remaining is things that are called computed fields. And the reason that I'm calling these computed fields is because their values are going to be computed at whenever we receive a request for them. So if we don't receive a request, we're not going to calculate anything. All right, so what do I mean by this? Now, let me take a look at some other files. I'm going to get rid of this terminal just to show you. So if I go to the schema.graphqls, I want to show you that we have already talked about this, and that is here. So we have this current streak, longest streak, and we have something else that is total completions when it comes to one specific habit. So we have already touched upon these shortly. We talked about the current streak. So what the current streak is, it has a type of integer, right? So it is a type of integer. And what it specifies is from today's date going backwards, like yesterday, the day before yesterday, the day before that, how many days in a row, starting from today's date, going backwards, how many days in a row have we checked in for one specific habit? So again, like if I want to go for a morning walk, I did it today, I did it yesterday, and I did it the day before yesterday. So how many days is that? That's 3 days. Since it starts from today and it goes backwards, that's the current streak. So that's how many days I've actually gone through with my promise. Okay, so that's the current streak. But let's say that I've been using this API for the past 6 months. Let's say that, and I have been going for a morning walk on and off. So sometimes I go for a morning walk like 10 days like in a row, or 10 consecutive days. Sometimes I go for a morning walk like 15 consecutive days. Then I don't go one day, so I break my habit. I break that streak. Whenever there is a gap between like these days that, like when there is a gap between the previous day and the next day, and in that gap you have not implemented that habit, then that's going to break the streak. So longest streak, now we talked about this current streak, okay? It's this day going backwards. So it has to be today's date. That's the calculation for the current streak. Once we actually write this code and you're going to see that, that's going to make a lot more sense. But first, again, let's just focus on the current streak. It's today, and then how many days before today I did this. Okay, so that's the current streak. The longest streak is the longest I have gone through with this habit without breaking it. So if I've been using this API for the past 6 months, the longest, like I've gone like to I've done this morning walk thing, like let's say it's 15 days in a row, every day for 15 days. And then one day I thought, okay, I'm not in the mood for it. Then I broke that habit. So I cut my streak. So what is the longest streak? It's 15 days. So the longest streak is not going to be calculated from today going backwards. It's going to be calculated for one specific habit and how many days that habit has been implemented consecutively or in a row. So it takes a look at the entire lifetime of a specific habit. So if I started this habit of morning walk 6 months ago, the lifetime of the habit is 6 months. How many days in a row have I implemented this habit over the course of the lifetime of this habit? 15 days. Even though there is like 6 months, but then I implemented this habit, I went for a morning walk on and off. So 1 week, and then like, let's say then 2 days, then I didn't go 1 day, then I went 10 days. Perhaps I have like 5-6 times where I've gotten close to 15 days, but then I've broken my habit. So that's the longest streak. Now you can see these contain a lot of calculations, right? And they depend on how lengthy or how the duration of the habit increases. So if I have created the habit 6 months ago, 6 months from this point onwards, that's going to be 1 year. So if I were to go ahead and store all of this data in the database, what am I going to do with that? After every day passes, I have to keep updating those database columns. So for now, let's say I went for morning walk today, yesterday, and the day before. That's 3 days. So I have this current, I'm going to capitalize this. So current streak, which is currently 3 days. So I go to morning walk tomorrow. What is going to be the value of this? 4. And then I go the day after tomorrow. What is the value of this? 5. So you can see if I store this inside of database, every time I check in or I log into that habit, I record that habit, that value must change inside of the database. And if there is like anything, if any problem arises when it comes to the database connection, that record is not going to be stored in the database. And we might end up with old or incorrect data. Imagine like if like 10,000 people use this API and you keep giving them outdated data. For example, like a social media app. They post something. As soon as they click on post, the post is not shown because like there was some problem with the database. So that's something that I just wanted to explain. I mean, like posting something on social media is not like the correct analogy, because that has to be stored on the database. But this current streak, this is just some calculations that we do. And we do this calculation when user wants this. If user doesn't want it, we don't do it. So this calculation has to be as in sync with the API as possible. And that's the reason that we don't store this in the database. If we store it in short, we need to keep changing it and changing it and changing it. And then that makes everything very, very high maintenance and difficult to actually maintain. So we have this current streak. The type of this is integer. Now, since we just send it to the client, we don't store it in the DB. This is just going to have a JSON string. This is going to be current or JSON tag, current streak. And we talked about what the current streak is. But again, once we come up with the calculations for this and you see we have like 2 users and we don't have any users at this point. When we have a user, they create a habit, they keep logging in for that habit, they keep checking in for that habit. You're going to see how this current streak increases. And then it's going to like make a lot of sense. But I'm sure you understood what the idea behind this is. So next up, after the current streak, we have the longest streak. This should be lowercase l. This is not going to be stored in the database because these are real-time calculations. It's difficult to just put them there, then like change him, update him, and then update him every single time. And then the final one is total completions. So you might be asking, okay, what is the difference between longest streak and total completions? I'm going to give you like a few seconds until I type this. You can pause the video and think about it. And I'm pretty sure you're going to see the difference between these two. So current streak and longest streak, we know what the difference between that is. It's the current day. The longest streak could contain the current day or not, but current streak must contain the current day. And these are really difficult for me to pronounce. I actually bit my tongue a little bit just pronouncing these. So you can just pause the video and think about the longest versus total completions. Let me add the S. And I'm going to explain that as well. Completions. Okay, so I hope you pause the video, you thought about this. So longest streak is the longest you have gone in order to go through with this habit in a row, like consecutive days in a row, right? Consecutive days are days in a row, so I shouldn't say that. But total completion says how many times you have checked in for the specific habit. So the lifetime of the habit is 6 months. Like let's say in the first month, I went 3 days, then I went 5 days, then I went 10 days. So that's 18 days out of 30 days. So let's say the month has 30 days. So how many days have I implemented this habit? How many days have I recorded this habit? 18 days. Okay. So let's say I recorded this habit 20 days in the next month, and then so on and so forth. So total completions is going to calculate every single time you have logged in. It doesn't care if it is the current streak, it's the longest streak, it doesn't care. It just every time you have checked in. So let's say the lifetime of the habit is 1 month. So I went 3 days in a row, then I broke my streak, I went 5 days in a row, and then I broke my streak, and the final time, the last time I went, let's say 12 days in a row. So the longest streak is 12, right? And the total completions is 20. So we have three records, then plus 5 records, then plus 12 records. The total completions are going to be 20. So these are like, I don't want to like waste too much of your time. I like to talk a lot. So sometimes these videos, they just turn into like therapy sessions for me. I just keep on talking and talking. So we have, now you know what the difference is. You have these stored fields and then you have these computed ones. Computed ones, we do not store them in the DB because they have to be in sync with the API, with the current, they have to be updated. So it's just easier to do them on the fly, even though storing them in the database is going to allow us to read them faster. But then again, we need to keep changing the database, and that's going to make it slow anyway. So it's better if we just go ahead and calculate them on the fly. So current streak, longest streak, and total completions. I think everything is okay. Let me just, yeah, very good. So let's close this user one. We have completed this one here. Now, the next thing that we need to do is, I'm going to delete this. I'm going to kill that terminal. We need to go ahead and actually regenerate the all of these resolvers for schema. So how do we do that? We say go run this link, GraphQLgen, and generate. Hit enter. We're going to wait for this to be completed, and then we're going to see, okay, what the difference is, what happened inside of these schema resolvers. It should pick up our undefined utils schema. So exit, we have GraphQL resolvers already declared at this. So let me just bring this down. Log in. It tried to implement all of these again here. Anyway, let me go to the top. Let's see. So we have the current streak. So it did implement this, right? And object, this is the current streak. Okay, we have the longest streak, the logs, the user created at. Now, this created at, this is, take a look at this. This is habit resolver, and it is on this models.habit. That's very good. We have this register, which I'm going to get rid of. We don't need that. We have the login. I'm going to get rid of it. We have the update user. Get rid of it. What else do we have? We have the delete user. Get rid of it. Save this. Let's see what else is the problem. We have this me. Now, these are the ones that we have implemented. That's why it's saying, okay, you have already implemented these. And it just brought everything back here. And we can see it's actually reading that models. Now, what I'm interested in is this create habit. So this is the one that I gave you as an example. It's a mutation resolver, right? Because it creates something on the database, context, and the name and the string. Sorry, the name and the description. And there we go. You can see it says models.habit. So it is correctly wired up to to select our specific what am I talking about? Specific model. User.go, created at and updated at. Now there is another problem. Since we have already implemented created at and updated at here, we no longer need them here. So there are two things that you need to keep in mind when it comes to these two resolvers. They have the same name, but they're actually different resolvers. So this is user resolver. This is also user. This is when a user was created, user account, and this is when their account was updated. These just track the time. And you can see it is models.user. It's both of them are the same thing. But we have already implemented these here. And you can see it's a copy of them. So I'm going to get rid of that. There we go. We have created at and updated at for the habits as well. But they refer to a different struct. It's models.habit. Cool. And they are available on these two, like habit resolvers. So that's the difference between these. Okay, so what is the first one? We're not going to talk about these for now, these current, longest, whatever. The first one that we want to implement, the first repository operation would be this create habit. We want to be able to actually create a specific habit. Then we're going to move like forward with different parts of that. So what is going to be a create habit? Is that going to be a query, or is that going to be a mutation? You can think about that. Well, creating a habit, that's actually a mutation. So let's go ahead and let's create this. Now, mutations are going to be written here inside of the mutation.go file. Inside of the query, we're going to write all of the queries. Now, when it comes to these two files, they are not, since they fulfill or implement one GraphQL specific operation, we're not going to distinguish between user, habit, login, whatever. All of the mutations that are going to come right here, all of the queries that are going to come right here. But when it comes to repository operations, we are going to differentiate. So we have this repository folder. Inside of here, I'm going to create a new file. Now, we already talked about the user underscore repository. This is going to be habit underscore repository.go. And what do we do here? Let's take a look at the user repository very quickly. So the first thing we did was we needed to specify we needed to connect to that database connection, the SQL.db. We know where this is coming from, right? So the first thing that we did inside of the user repository was connect to the DB pool or to the connection pool, and then create a sort of factory function so we could wire this up with the like main server file. We have talked about these two extensively, and this is the thing that we are going to have to do for the habit repository as well. So what are we going to do? Let's jump into the habit repository. The first thing that I want to do here is I want to specify that package repository. So all of the like imports, they work automatically. Now, first, I am going to create the habit repository struct. That's going to be habit repository. And this is a struct. What is this struct going to contain? This is going to contain the connection pool. Now, this must be the same connection pool that we used in user repository. It must be the same thing. So we have this, the type of which is SQL.db. There we go. So this is, again, the same connection pool that we used here, right here. It's the same one. Now that we're done with the connection pool, now you might be asking, okay, why do we have to connect to the same connection pool? The reason for this is, one of the reasons is that they share the same underlying database connection, and we must pass the same DB instance to both constructors inside of the main server file. So we have one connection pool. That was the idea behind a connection pool, remember? So we have one pool that is going to be shared across all repositories. Why? Because this is efficient, this is consistent, and we don't have to like keep connecting and disconnecting from our database. So we borrow a connection. Since this is a connection pool, a collection of connections, we borrow a connection, we do whatever we want with it, and then we return it. So that's one of the reasons that this is extremely efficient. Now let's talk about the constructor function. That's going to be func new. So we had, you can see the name for the previous one was new user repository. This could be new habit repository. We talked extensively about the naming convention for these, why we need them, what is the good idea behind this. Now, again, in the context of this simple API, this like factory function or this constructor function, it doesn't make any difference. But I have to show you these conventions that we use in Go, so you can like see it. When you see it in the context of such a small API, it's not overwhelming. It's not gonna like confuse you. So you can see, okay, how everything is connected, but then you can implement the same idea when you see like a medium to larger application. This is going to be the connection pool that we pass in. What is this going to return? This is going to return a pointer, and that is going to be habit repository. Now, returning a pointer means the caller holds the memory address of the struct. So everyone who uses this repository works with the same instance. They're not going to work with different copies. We do not make copies. We work with the same instance. This H should be capital. Let me just capitalize that H. And this should be capital as well. Very good. So what do we do here? Well, we create a new repository, a new habit repository struct. So that's going to be habit repository. And if I call this, what should I pass? I should pass the DB connection. That's going to be DB. And then this is something that we return from this function. Now, what we want to do is we want to return the memory address of this struct. So here I'm going to pass in the ampersand. And there we go. Now, after we're done with this, we could jump into the main file. So where is the main file? And actually wire this up, but I want to wire this up after we're done. So we're going to wire this up here, right? So we did this new user repository. We're going to do new habit repository because, again, you need to call this. And when you call this, you pass to it what? You pass to this function as an argument, you pass to it the connection pool, much like we did here. So where is this connection pool coming from? It's the exact connection pool that this database.initDB is going to create. We've already talked about that. We just share it. We now share the same connection pool with a different repository, a different interface that's going to talk to a different table inside of the same database. Okay, extremely simple stuff. So first off, let's actually go ahead and let's try to write the logic if we were to create a new habit. So if I want to create a new habit, I need to pass in the receiver. The type of this is going to be habit repository. Now, if I were to go to user repository, just open any of these, not open them, like here. You can see here we have user repository. We talked about the receiver and why this is important. Then we have the name of the function, what the function accepts, and then what the function produces or returns. So what is the name of the function? The name of the function is create habit. What is this going to accept? This function is going to accept user ID. So we need to be specific to which user or which user is trying to create this habit. Every habit must have a name. And every habit must have a description, the type of which is going to be of type string. And after this, we need to specify what this function is going to return. This is going to return models.habit. Now, again, we return a pointer type just to make sure. I get a couple of reasons. One is pointer types can be nil. The other one is that this is actually faster if we go about it like this. So we don't have to copy it. We just return the memory address of this. Very good. So what do I want to do here? I'm trying to create a new habit, right? So the first thing that I'm going to do is I'm going to calculate the current time. That's going to be time.now, which I just imported. And we need to know the ID of we need to have some kind of an ID for this habit as well. So I'm going to initialize the habit, the ID here. It's going to be very similar to this one. So we have time.now, we have the ID. We use the scan method. So this query row, this is going to return one ID for us. And you remember, right? ID is auto-generated by SQLite. So this returns one ID, and then we scan that ID. So when we say we scan, what does that mean? It means we put the value that this query row has given us or has returned to us. We select that and we put it inside of this variable, which is called ID. And then this ID is going to have some value returned by the DB itself. So that's what the scan method does. And we do the same thing here. So we need to actually target that specific database connection, and on there we have query row. The same, you can see it, we follow the same structure. I could even go ahead and copy paste this. So we select this column, right? I'm going to put it there. Select, get rid of that quote and get rid of that. And then what is this query row return? It returns one specific row, exactly one row. It's not going to return 2 rows. It's not going to return 10 rows, 1 row. And then we scan whatever that is into the ID. So that's going to be %ID. Now we have an ID, okay, but we need to know, okay, what this returns. If this process encountered any kind of error, aka if error is not nil, then we need to actually return some error message, right? So that's going to be return nil. See, since we are the first thing that this function returns is a pointer type, we could just return nil for it. And the second one is the error itself, for which we are going to return what the problem was. So we're going to say failed to do what? To generate ID, habit ID, and then we could provide like a placeholder for that specific message or error. There we go. So if we move forward from this if statement, this means we were successful in creating or generating an ID. Okay. And where is that? It's stored inside of the ID variable. Now, the next thing that we need to do is we need to actually insert data into the database. And that's one of the main things that we need to do. So we created the ID. Why do we need to insert data after the creation of the ID? Well, we need to have all of the information ready. Then we can put that information inside of database. Then we can actually create records. And how do we put something inside of database? Well, we could use a specific SQL statement or SQL query. But first we need to target that database connection. We're going to take a look at execute, which what it does is it is going to execute a specific statement that we give it. Now, every time one user sends us like a GraphQL mutation, which is called create habit, every time we're just going to create how many habits? One habit. And where do we put that habit? Well, we need to trace the information that we received from the habit to their respective columns. So I should put the ID of the habit in the ID column, the user ID of the user who's creating the habit inside of its specific column, the name, description, and the rest of them. So for this one, what I can do is I can say insert. This is what's going to insert entries into the database. Into what? Which table? It is called the habits table. And what do we want to insert? Well, we need to be very specific. I want to put into the ID column. I want to put into the ID column something. So here is what where I'm selecting the column names. These are inside of the pair of parentheses. I'm selecting the column names. So the column names that I want to have this record. The other one is going to be user ID. The third column is going to be called is already called name. The one after that is already called description. Then we have created _at, and then we have updated _at. So these are all the columns, but where are their values coming from? So their values are coming from here. One question mark. So how many columns do I have? I have 1, 2, 3, 4, 5, and 6. So how many question marks or placeholders do I need? I need 6 of them. So that's 1, 2, 3, 4, 5, and 6. Provide space. There we go. Why do we do this? Because again, to avoid SQL injection. The values are going to be passed separately, and the database is going to treat them as pure data, and database is never going to treat the values that we receive as SQL code. So if we receive a SQL code, we run it, it might do a lot of damage. Like, it might get rid of everything. It might destroy everything. So we just make sure that the values that we receive, they're just pure data. We're not going to run them. So that's why we do this. Now, I have 6 columns. For 6 columns, I have 6 placeholders, aka question marks. How many things do I need for these 6 question marks? I need 6 different fields. So what are they? The first one is the ID that I created above. The second one is the user ID that this repository has received. So keep in mind, now we are actually defining this repository. We're not calling it. We're going to call it inside of its respective or relevant resolver. And once we call that there, resolver is going to give it the user ID, the name, and the description. So that's 3 columns out of 6 columns. The rest of the 3, ID, we generated that here. There we go. And what about created at and updated at? Well, they're right here. That's going to be this now. That's why we created that here. So we have the user ID, then we're going to have the name, we're going to have the description. Then for the created at, it's going to be now, since this is the creation of the habit, at the stage of the creation of the habit, the created at and updated at, they're going to be the same time. But once user changes habit in some way, then updated at is going to be changed on it. So what is this going to return? The first thing it returns is SQL.result. We do not need this. We do not need to know the rows affected. So I'm just going to get rid of that, but I'm interested in the error if there are any errors. So I'm going to say, let me just go beneath it. I'm going to say if error is not equal to null, that means there is some kind of error. What am I going to do? I'm going to return null for that habit, aka habit was not created, and then I'm going to return the error. So error F, that's going to be failed to create this habit. And let's provide that there. And I'm going to pass in the error there. Very good. So what else do we want to do? If we pass over this, like if we jump over this if statement, this basically means we were able to create this record inside of our database. Now, the next step is to actually get it back from the database so we can give it to the resolver. Resolver is going to send it to the client. And I'm going to create a struct. The type of this is going to be models.habit, and we're going to store this inside of this struct. But now, if you want to select a record from the database, which method do you use? You want to select exactly one record from the database. You use query row, but then which method after that you use in order to populate this habit struct? You use the scan method. So r.db.query row. This is going to be, so which parts do you want to select? Which columns do you want to select? We could select ID, user. Now, when I say select, that's a SQL statement. So the columns or the things that I write after it, they must be exact column names. They shouldn't be anything else. So they must be column names because I'm writing a SQL statement. SQL statement refers to its own column names of its own table. So we have the ID, we have the user ID, the name, the description. After that, we have the created _at, updated _at. Where do we want to select this? We want to select it from the users table, right? No, we want to select it from the habits table. And what is the selection criteria? Or What is the condition? The condition is that the ID of the habit must match with the ID of the habit that we want to actually send back to the user, right? And again, that's going to be a question mark as a placeholder, and I'm going to pass an ID. What is this going to return? It's going to return it's going to return one database row or an error. So before actually talking about the error, we didn't use scan on this. So we need to actually scan these values back into that struct, that habit struct. So here I have habit, lowercase, habit dot ID. And then I have habit dot user ID. Where is user ID? It's right here. Then I have habit dot name, habit dot description, and created at as well as updated at. So dot created at dot updated at. Very good. That's it. So we selected, we returned a row from the database because you create one habit and you get one habit. That's why it's just exactly one row. It's not like you create one habit and you also get the hundreds, the 100 other habits you have already created. No, you create one habit and you're going to read the data of the exactly newly created habit. Okay, so here we're going to say error is not nil. We have already done this like 100 times. This is easy. Return nil and fmt.errorf. What am I going to do here? I'm going to say failed to retrieve. I always misspell retrieve. I think it's EI, but then it's IE. Retrieve. Failed to retrieve created habit. See? Created habit. I wasn't able to do it. Sorry. Try again later. And that's it. So that's going to, whoops. That's going to be the if statement. But if everything goes according to plan, what do we end up with? We end up with a habit. And we say return habit. So that's going to be for so the function returns two things. It returns a pointer type. That's why I passed in the ampersand. And it also returns error. But if we have reached this return statement, then it means the error is nil. So I'm just going to pass in nil for the error. And that's it. This is going to be the repository operation. Now, remember, we need to wire this up with the other parts of the application. The first part is we need to go into this resolver here. This is where we actually wired, because this is the root resolver. This is the main resolver of this API. We need to put its child resolvers inside of here. So we had this user repo. Now instead of user repo, we have the habit repo, which refers to, so if I do the dot, I have the habit repository. Very good. So this is, again, the wiring up stage of this new repository that we created. So we attached it to the root resolver. And the next thing we need to do is we need to actually attach it to our server. So it can get the data, it can access the same database connection. So here, beneath this user repo, I'm going to say habit repo. And this is going to be repository dot habit repository. So I'm calling that habit repository here. And I'm going to pass in, sorry, this is new habit repository because we're calling that constructor function. And to that constructor function, we pass in that connection pool, that database connection pool. And then we need to reference that here as well. This is going to be habit, I could have just typed it myself. So habit repo, habit repo, and this is going to be equal to habit repo. Let's save this. What seems to be, habit repo. Oh, should I provide a comma? Save this. Struct literal type, but does not have unexported habit repo. Unknown field habit repo instruct. Why is this unknown? This shouldn't be unknown. This should be known. So we have habit repo right there. Repository, new habit repository. Where I passed in this. It should be fine. I mean, like, it should be totally fine. Let me go to the resolver. Where is the resolver? So we have, this should be uppercase, sorry. This should be uppercase. Save this. And there we go. It was this. Okay, so we have this habit repo, which is coming from here, but I passed in this as lowercase. Just, you can see, this is extremely sensitive, so you need to pay close attention to this. And that's it. So the wiring part is also done. The next thing is I'm going to go ahead and close this user repository. We need to jump into the mutations because this is going to be, again, this is going to be a mutation because we're creating new data. And this should be pretty simple for us to implement as well. But before coming right here, there is something that I want to create. So we have already talked about this utils extensively. We have the email for checking or validating email. We have the JWT one for validation of JWT. So for validation, for creation, we have the name. For validation of name, we have the password where we validate password, generate hash, and I think we also compare the hash. Yeah, we compare password, we hash password, we also validate password. So 3 things. All of these utilities, they're inside of the password. Now the next utility that I want to create here, that's going to go for the description of this habit. So what we could do is, let me think about this. When we create, for the name of the habit, we could use the same validate name that we have for the user. Will that work? Let's take a look at it. I don't want to create one unnecessary util if possible. So for validate name, we trim the white space. I mean, this is, if I were to validate the name of the habit, I would do the same thing. So just to be clear, I am trying to decide if I can use the validate name utility that I used for the validation of the name of the user for the validation of the name of the habit as well. So I don't have to create another validate name. So if I'm trying to validate the name of the habit, I would want to trim the white space and then take a look at if there are no characters. I'm going to say name cannot be empty. So here you can see it's very general. It says name cannot be empty. It doesn't say username cannot be empty. So up until here, it's okay. The name of the habit must be at least 2 characters long. Okay. It should not exceed 100 characters. Yes. Because if you want to add more data to the habit, then just add it in the description. Why would you elongate the name of this habit? It's not necessary. Okay. Very good. Now we take a look at character by character. We say if it contains the period, the name, that's okay. If it contains spaces, that's okay. If it contains hyphens, that's okay. If it contains apostrophes, that's also okay. But if it contains anything aside from these specific punctuation marks that we determined, then we're going to say, okay, I forgot this one. And if it is like a Unicode letter, then we also say it's okay. But if it is none of these 5, yeah, there are 5, we're going to say name can only contain letters, periods, spaces, hyphens, and apostrophes. Yes, I think we can use this name utility for the validation of the name of the habit as well. I have decided that I'm going to do this, but we need to have something for the description of the habit, right? So what is going to be the criteria that how is user going to create the description of the habit? So for that, we should go ahead and create another utility. So here I'm going to create a new file that's going to be description.go, and inside of here, we're going to come up with a utility that is going to validate the description for one specific habit. And to get started with the description utility, the first thing we need to do is import package utils. So we want to create a function because we want to validate description. Now, since we have created a lot of other validations, it should be easy for us to implement this one as well. So this is going to be validate description. There we go. And now what is this function going to accept? Well, since it validates description, the only thing that it accepts is going to be description. What is the type of that? It's going to be string. If there are any errors, the function is just going to return those errors. Now, if these validations, they pass, what the function returns is going to be null, which basically means all checks passed and there are no errors. So aka the description is valid. Now, how do we get started with this? Well, when we did the validation for name, the first thing we did was we trimmed the white space. We could get started there. So we could say strings.trim. So we are going to select this method, which is going to be trim space, and I'm going to pass in description. Now, what this is going to do is this is going to get rid of the spaces at the start and at the end of the description. So when user, for example, may have typed or clicked on the space bar several times, and then there might be some spaces at the end. So we get rid of all the white spaces at the start and at the end. Now, after this operation is done, if the length of description is equal to 0, that means we didn't have anything to begin with. So this means we didn't have any kind of description. So we're going to send an error, and that's going to be errors.new. And what do we send? We are going to say description cannot be empty. Since this is required, you need to write at least something here. Very good. Now let's move forward. Now, what if we have description? Now, the next thing I want to do is I want to limit the number of characters when it comes to description. Now, description is simple. We're not going to fix the description by any specific language. So if user wants to write description in any of the languages, like whether languages that start from the, like writing from the left or from the right, that's okay. Like Arabic from the right, Persian from the right, and then you have English and German and like these languages from the left. That should be okay. So there is nothing that we want to do there. When it comes to what users can write in their description, it could be anything. They could just write a bunch of numbers. They could write like a description that contains paragraphs and numbers and characters, whatever. So it's not like email and password that we want to do validation. So users must follow a specific pattern. There is no pattern here. They can just write whatever they want. But what we need to have as safeguards is the number of characters users can write. For example, we need to specify, okay, you cannot give me less than, let's say, 15 characters. And you cannot give me, let's say, more than 500 characters or more than 100 characters. So I want the description of this habit to be very simple and to be very straightforward. So that makes you think, okay, like walking, why do I have to walk every day? Or reading, why do I have to read? Or like any other habit, spending time with family, why do I have to do that? So you just write one sentence or two sentences, or perhaps like a short paragraph, like consisting of a few sentences, and that's it. And we do not want to like allow users to write essays here. Just this is a habit, it's simple. We don't want to overcomplicate this process, right? We just want to create that habit. So here I'm going to say if length of the description. Now here is where you can select whatever number. You could say, okay, if the length of the description is less than 2, but then I thought about it and I said, okay, what could be 2? So like it's going to be very difficult. So I'm going to set it to 20 characters. Like you have to write at least 20 characters, or you could set it to 15 characters or 10 characters. Let's say you say walking is relaxing. So relaxing is 7 characters if I'm not mistaken. So I could set it to 7 characters or whatever. I don't want to like give like an upper border that is too big. So I'm just going to set it to 10. I changed my mind during this discussion. So my idea was that, okay, I'm going to set it to 20. But anyway, this is not important. Let's move forward. Now, what if users give us some kind of a description that is actually less than 10 characters? We're going to say description must be at least, for example, 10 characters. Again, this is extremely flexible. You can select the number yourself. And then I'm going to select this and I'm going to paste it here. And then I need to provide an upper limit. Let's say I'm going to say the description can contain only 250 characters. Description must not exceed 250 characters. That's it. And finally, if all of these are passed, we're going to return nil for this error. And that's it. So it's, again, since there is no pattern, it's very easy for us to just provide like some loose constraints here and there, and that's it. And let's just call it a day there. Now, what is the next step? Well, the next step for us is to actually go ahead and create the resolver, because we have created the repository that is going to talk to the database and put some data in the database, select some data from the database. Now, where is the data coming from that repository layer is going to put in the database? That's going to be this resolver, which fulfills what? One specific GraphQL operation, or I should say one specific GraphQL query. Now, before writing this, let's jump into schema.resolvers and let's take a look at what we have here. So we got rid of a lot of resolvers that we implemented. I didn't want to do that, but once we regenerated, it just compiled, it just wrote everything here again, and there was just a lot of errors, so that forced me to just get rid of all of them. Now, here we are. This is what we're looking for, and I'm just going to copy this mutation resolver, and I'm going to put it right here. Now this is, let's take a look at this. This is a function, and we know the type of the resolver or receiver is mutation. This is the name of the function. It accepts context, name. Now, for any kind of habit that you want to write, there are 2 important and necessary pieces of information that you must give me. One of them is name, that has a type of string. The other one is description. The rest of the information I can come up on my own. And then what this returns is either successful, upon successful completion, a habit, or an error. So how do you go about this? Well, the first thing we need to do is we need to distinguish who it is that wants to create a habit. So that's where we're going to jump into this get user ID. Now, if I want to select user ID, shouldn't I pass the current updated context? Yes. And that's why we have this context. So this CTX, in the context of this create habit, it contains a lot of things. One of the things is actually user ID. And this get user ID is specially built to extract that from the context and put it here. So we have this user ID variable as well as OK, just to make sure that everything is running smoothly. If OK is false, what does that mean? It means we were not able to actually get the user ID. There was something wrong. And what could be wrong here? If you can't select user ID from the token, what does that mean? It means it's unauthorized. So fmt.errorf, and I'm just going to pass in unauthorized. Very good. Now let's move forward. If I move forward, what does that mean? It means I have successfully selected the user ID. Now, if I've selected the user ID, I'm going to come back to that later, but for now, let's validate name and description. Now, we did create the description utility, but we did not actually invoke this function. So it's just like sitting here, it's doing nothing, it's idle. It does nothing unless I invoke it here. That's how these functions actually work. So we could go one of two ways. Let me just show you one of the other ways that we went. So take a look at this. I want to go over this because you are going to come across this thing that I'm about to explain, because that is also idiomatic Go code. Now here we have two statements, right? We have this declaration of a variable, and then you have the second one, which is this if statement. Now, these two are separate. You can see, even though they're next to one another, they're clearly separate. So we have this validate name, and if it contains any errors, we put it here inside of this error. And then in another statement, we check if error is not null, we return this part. So these two are separate. Now, what does this mean? It means error is actually available anywhere else inside of this register resolver. So this error, this could be accessed, you could access it here, you could access it here. So it is available because the context of this error is not fixed to this if statement. That's the reason for it. Now, this is one way of writing code, but if you worry about this very fact that errors could be accessed in any part of the resolver, there is actually another way of defining this. And that way is going to make sure, that error is not going to be available anywhere else. And I'm just going to go ahead and get started with writing this, and then it's going to make perfect sense. So first off, we select the utilities, and then since we want to validate the name, I'm going to select validate name. Now, this validate name utility, it accepts one thing, and that is name. I just passed it there. Now, the interesting part comes now. We say now, so in the previous way that we did this previously, we said that whatever this returns, whatever this operation returns, put it inside of the error. And then we check if error is not null, we return null for that auth payload, and then we return this specific error for this error. Okay, we talked about this a lot. But again, the thing with this is that this error that we're returning, it is available inside of this function, inside of this resolver, in the outer scope. So it is available anywhere inside of this function. So the scope is not tight. Now here, if I were to actually try to make sure that this error does not exist anywhere else inside of this create habit resolver, by fixing its scope or by restricting the scope of this error to the if statement only, this is how I would do it. So we're going to say, okay, so this is the operation on the left, right? On the right of this operation, we're going to have our condition, and that's going to be if error is not null. Now, I'm explaining this because you might come across this, right? So what does this mean? Of course, there are a couple of errors because we have not actually completed this. I'm going to pass in the if statement there as well. And now we can see there is just one error, and that's going to be undefined error. We need to actually go ahead and define it. And where do I define it? The definition is going to look like this. So we're going to define it before the utils, because this itself is still the thing that we just copy paste. So I could just copy paste this, right? So I'm just going to copy that, and I'm going to put it right here. There we go. And then we say if error is not null, then we jump inside of this if statement. So what did I do? I put those two statements into one statement, which is this if statement. And you can do this in Go. So this part is that definition of the error. We said validate the name. If it returns anything, put it inside of this variable, which is called error. And then we check if error is not null. And this is the condition part. If this condition is true, which means error is not null, then we jump inside of this if statement. We return, the rest is the same. We return null for the habit. We don't allow users to create habit if the validation of name fails. And then we need to be specific when it comes to the error. We're going to say error.fmt.errorf, and it's what could be wrong here. The problem is that this name did not pass the validation. So we're going to say invalid habit name. So there is something that I want to explain about this as well, which I might not have actually I might not have actually talked about it in depth. And that is this part before the colon. This is the general context of the error. So which department does the error belong to? This is what this specifies. So it belongs to the name validation department. Now, inside of that department or inside of that context, what specifically happened? What did exactly happen? That's going to be represented by this %W. Since this is a placeholder for the error, we need to put the error right after it. So whatever this error returns, we put it here, and then the error is going to be invalid habit name, which gives you the context of what the error is. Like, which category does this error belong to? And then this %W is going to tell you exactly what the error is. So how is this going to tell you exactly what the error is? Well, for that, you need to go to the name.go file, that utility. So inside of this name.go file, we can see there is a lot of things that we are returning. Perhaps the name was empty. So it's going to say, so this is how this error is going to work. The first thing user is going to see is going to be this part. They're going to see invalid habit name and then colon. And then after colon, the users are going to see this. User is going to see name cannot be empty. So invalid habit name, colon, name cannot be empty. So that's why we provide these placeholders for these. So this error, again, this error is the specific thing that went wrong, but this invalid habit name tells you generally which part of the habit went wrong or what happened generally. You first specify the location of the error, and then you dive into that location to take a look at that specific error that happened. But now with this approach, this error is not available outside of this if statement. So if I go ahead and if I type error here, this is not actually available. So if you hover on this, you can see it says undefined. But here it was available, like in the register, it was available. That's why the first time that we initialized error, we used this sign. This is short variable declaration. But the next time that we used error, we didn't use that short variable declaration. We just used this assignment operator, which means by this point in time, error exists. We just keep changing its value. So error was created here, and then we just kept using it. This is also idiomatic Go code. But I wanted to show you this because you're going to see this in code bases as well. And I wanted you to actually have experience with this. Okay, what is this? When you see this, okay, what are we doing here? It's very simple. You're declaring a variable in this part that I've highlighted. So whatever this validate name returns, you're going to put it in the error, and immediately you're going to see if error is not null. This is the conditional part. And this is if error is not null, then I'm going to do this. Doing this means I'm going to return null for the habit, aka user is not allowed to create that habit, And then I'm going to send this message to the front end for this error. Very simple, right? And now you can see this, the scope of this is coupled to this if statement. You cannot use this error outside of the if statement. So it's a little bit hard to read as opposed to this. So this is easier to read, but the good thing with this is, again, you cannot reuse error in any other part of this create habit. It doesn't exist. So this is the validation for the name. Now let's go together. How would we go about the validation for the description? Let's do it together. So first we're going to go into utilities. This is a very good practice for you to actually get used to this structure as well. I've used this in a couple of times before, like in the previous hours, I would say, but I did not dive into this much detail. I actually forgot to dive into this, but now I'm actually explaining, okay, how this works. So we want to validate description. We go to utilities and then we select this utility. What does this utility want? It wants description. So where am I going to pass in the description? So description is right here. And from here, I'm going to pass description here. What is this? This is the thing that user has written. So the thing that user has written, whatever that is, I'm going to pass it here to validate it. And there we go. So I'm going to provide a semicolon there. I'm going to come right here. Now, whatever this returns, I'm going to put it inside of this error. Now see, I do not use this equality sign because I'm not reassigning the error. I am creating a completely new variable. That's why we need to have the colon. Okay. Now, this is our statement. This is the variable declaration part. But we want to also check if error is not null. So I'm going to say if error is not null, where is the if itself? So if the if keyword is part of the syntax, you need to write that. And there we go. It's the same thing as here. But once you get used to it, it's just going to be easier to write it like this, right? So we are going to return null for the habit. Again, if name is invalid, we don't create a habit. And if description is invalid, we don't create a habit either. So this is going to be fmt.errorf. What is wrong here inside of this if statement? It's the description. That's the general thing that is wrong here. That's the general context of the error. But what is specifically wrong? That specific thing is going to come and it's going to replace this %w from the description.go file. So whatever is wrong here, so if any of these is actually true, for example, description is empty or this, these are going to come and they're going to replace this %w, and we're going to see invalid description. Description cannot be empty. Invalid description. Description must be at least 10 characters long or whatever. So now after passing these two steps or validations, we know that user was authenticated. User gave us a valid name. User also gave us a valid description. So all checks are passed. What should we do next? Well, we need to select all of this information and store it in the database. How do we do that? Well, we have access to the database using this mutation resolver. So you need to select your database or connection pool, and then which specific, you need to select that specific repository which has that connection pool. That's going to be habit repo. On the habit repo, we have this create habit. Now, what does create habit require? It requires the user ID of the user who is trying to create the habit. So John is not allowed to create a habit for Jane and vice versa. So where is this user ID? We selected this user ID up above. So it's right here. See, this user ID is this one. We got it from the context. We used this excavation method, or this excavator excavated the user ID from the context and it put it here. And then we select it from there and we just basically put it here. Why? Because every habit should go to its relevant user or relevant owner. Now, what is the name of the habit? Since we validated the name and everything is okay, we can pass it here. We're sure that is correct. And we pass in the description. Now, what is this going to return? This is going to return two things, the habit and error. Now, again, this error is different than the previous errors, so I need to actually declare this, like initialize it. Now, there could be some other issues with this storing of this or this creation of the habit as well. There could be like a slew of other issues like database connections, whatever, that we have not actually handled or written like code for it, but we need to actually catch those. So we are going to say if error is not nil, and it could be anything, we still do not create a habit and we return the error, whatever the error is. But if I have moved on, I've moved past this if statement, then it means everything is okay. Then we return the newly created habit. So once user what is the I'm looking for the word. What is the validation for the user or this confirmation? I'm looking for confirmation. So what's going to be a confirmation for the user that this process was successful? They actually created a habit as soon as they see it. So you post something on social media. The way you know that that post was successful is you see it immediately. So once you clicked on this post, it just goes to your profile and you see it immediately. And then that's a confirmation for you that this process was successful. Okay. Now we return the habit to give users this confirmation, and we return nil for the error. Very good, right? So now let's go ahead and let's comment out. We are going to actually get rid of these at some points. I'm just going to get rid of them here. Now, there are two more things that we need to actually write, which are these created at and updated at times for that habit. Since user doesn't give us these, we need to actually go ahead and create these. And they are similar, or I would say like identical to the ones that we created for the user themselves. So when user creates an account, there's going to be created at, and user updates their account, there's going to be an updated at. And initially, both of them are going to be the same, but once user changes something, they're going to change. We talked about that. But for now, what we want to do is we want to do the same thing, but this time we don't do it for the user. We do it for the habit. Take a look at this. This says models.habit, and this is the habit resolver. So for this, what are we going to do? We had this user.go file, which contained these two. We could create a habit.go file. Habit.go file. Very good. And I'm going to close that. So inside of this habit, and if you take a look at this habit file is actually this one is inside of resolvers, and resolvers inside of the graph, and then graph is inside of the internal. So this habit.go file, which is this one right here, which is inside of resolvers, it's a different thing than the habit.go file that is inside of the models. This is a model for one specific habit, but this one contains habit-related resolvers. So that's the difference. Now, if you're wondering about why these icons, just in case you're wondering why these look different, because recently I received a message. I used some sort of a library, some sort of an extension for icons. Let me just see if I can find it. It told me that that extension was deprecated. This one is right. Yeah, this extension is deprecated. And then you could actually install this one. And it has like a lot of downloads as well, and it is being maintained. But then I actually sifted through with these like icons, and I found this one. This is material icon theme. It has like 34 million downloads, so that's a lot. And I installed that, and once you install it, it's very simple. You just click on the set file icon, theme, and you just click on that and it's going to change everything. And that's why these look different. I tested a few of them, but this one caught my eye. So I'm actually changing this. You can see when the folder is open, it just shows it to you. Like this guides, you can see it's closed. Now when I click on it, it just open. It's like these little cute things that you see there. Okay, and now let's get started with this habit.go. I'm gonna come right here. So I could copy both of these, put them here. We're going to go to the top, and here I'm going to say package resolvers. Very good. Let's get rid of this panic, and let's get rid of this one as well. Now, what do we want to do here? We just want to format this time because we want to return a string. We have an object, we want to return a string. And how do we do that? We have already done that. We have return obj dot. On the obj, we have this created at. We format that using time dot, that was RFC 3339. Very good. Let's save that. And what do we return for the error? Now we know that this process is going to be successful. This is very simple. So we just return nil for the error. And we do the same thing for the updated at. There we go. That's it. So we just needed to do these two, and we're going to get rid of these, save this, and that's it. So next up, what should we do? We are going to go ahead, go and jump into the playground. So you can see there are no issues here. It's actually, it built that. So let me just refresh this. Sorry for the flash. There we go. We have the database. Now, if you remember, we actually got rid of everything, because we rolled back both migrations. You can see we don't have any users. Of course, we don't have any habits, but our users were gone as well. So if you open up the database, you're going to see these three. You have the habits, the schema migrations, and the users. I double clicked on the users and the habits, so just to have them side by side. And now let's go ahead and let's actually create a user first. So to create a user, what did we do? We used this register mutation. We need to pass a name. Name is going to be John Smith. And then we need to pass in an email. Email was jsmith@test.com. Let me provide this. Let me just hit enter. So they're on top of one another. Then what do we have? After this, we had password, which was pass@123. Right. What do we want to return from this? Let's just return token. There we go. Let's send this. And this is the token. We could take a look at the user as well. Let's say user. Let's select the ID, the name, and since I created this user, this is not going to work. We could use this for the other user, but if I click on it, you can see email already registered. We're going to create two users, so that's okay. Now I'm going to refresh this. There we go. So I just created this user. This is the time for it. And let's just bring this here. Very good. So we have this user, and we can check that inside of SQL here. We're going to say select everything from users, and there we go. So we created this user. Right now, let's go ahead and let's create Jane Smith. That was, I'm going to say Jane-Smith@test.com. And we're going to take a look at the ID, the name, and email. Or just name and email. That's enough. Send this. And there we go. Jane Smith @test.com. Refresh this. There we go. So very good. We have created these users. Now what we need to do in order to create a habit is to log in first. So I'm going to say log in. We're going to first create a habit for Jane Smith. So log in. We are just, we could keep the user here, just log in, select this token. If you don't pass in the token, you're not going to be able to create a habit. We are going to test that as well. So authorization. How did we go about this? We had bearer and then this. Now, how do we create a new habit? Well, you can take a look at that here. We have this. Where is that? Create habit. So you need to pass in the name of the habit and the description of the habit, and then you can select the information about the habit. So that is still a mutation. That's going to be create a habit. We no longer have these. Let me get rid of these as well. This should be uppercase. Create habit. There we go. We pass a name. What should be the name of the habit? I'm going to say read every day. And then we need to pass in a description for this habit as well. So description, this is going to say read for at least 30 minutes before bed. Right, like I'm going to do that. Anyway, what do we want to select from this habit? That's going to come right here. Let me get rid of one of these. Very good. And let's say we want to select the ID, the name. Let's hit enter, the name, description, then created at and updated at. Now let's send this. Invalid description must not exceed 250 characters. Did this exceed 250 characters? If you take a look at this error that we have gotten, this is a little bit zoomed out, but we can see all of the information. This is very good. The first thing that is wrong is, you can see here, it says invalid description. So we know which category of errors it is that we need to go into. And then we say, it says description must not exceed 250 characters. Let's take a look at it. What is wrong here? I'm going to come right here. It says if, okay, you can see. So it says if it is less than 250. This should be if it is greater than 250. So these two were in clash. So again, the reason that we see this is because it says, even though here I say there should be at least 10 characters. Now disregard what this message says. Disregard this. So I'm going to cut that. I'm going to cut this one as well. What does the if statement tell you? This if statement tells you that the description must be at least 10 characters. And then this if statement overrides the previous one, and it says the description must be at least 250 characters, which is incorrect. We want the description to be a maximum of 250 characters. So we need to, since I copy pasted that, I did not change this. Cool. So let's go back. Let's bring back the print, whatever we want to print there. But again, always look at what the condition says, not what you have written here, because this was incorrect that I did here. The condition was incorrect. That's why it said it cannot exceed, even though what it meant was description must be at least 250 characters long. Now we should be able to create one. So we can see the errors, they're working fine. And there we go. We created a habit. Congratulations, by the way. Now, we have this user, which is Jane Smith. The ID of this user ends at 44AF. If I go to the habit, refresh this, there we go. So let's take a look at what kind of information do we have. I'm going to zoom this out. How much? Let's see. So we have the ID, which belongs to the habit, the ID of the user to whom this habit belongs, the name of the habit, the description of the habit, when the habit was created, and when it will be updated. Very cool stuff, right? So let me zoom. Okay, good. Let me zoom this in. Now, the ID of the habit actually distinguishes two habits from one another. So that's why we have ID. The ID of the user distinguishes habits based on user. Now this habit belongs to Jane. We can see that the ID of Jane is right here, 44AF. So if you take a look at the habits table, no habit is going to tell you which habit belongs to which user by name rather by ID. Okay, that's what we created. And now what I can do is I can create one for John as well. Let's take a look at the table here. We could say select everything from habits, and then you're going to see that. So we have this read every day, read for at least 30 minutes before bed. This is the created date, and this is the updated date. This is the ID of this habit itself. This is the ID of the user to whom this habit belongs. You can see this ID and this are the same. So these two are the same. Sorry, that's the John, and they're not the same. So let me just select this again. So we have users, and then we have habits. There we go. Now it's the same. So this habit, this ID, and this ID is the same. This is how you trace which habits belong to which user. And if user deletes their account, all of their habits from the habits table will be deleted as well. Now, let's move on and let's try to create a habit without this authorization. So I'm going to select all of this. I'm going to cut this. I'm going to send this. It's going to say unauthorized. Why? Because it was not able to extract the user ID from the token. Why? Because there is no token. So it just returns unauthorized. Very good. Let's do some other tests. Let's say this is the description of the habit. Invalid description. Description must be at least 10 characters long. But let's say it has too long of a description. So let me just keep pasting these. Click invalid description. It cannot exceed 250 characters. It's very good, right? Before bed. I'm gonna cut it to here. What about the name of the habit? What if there is just one character there? Invalid habit name. Name must be at least 2 characters long. So the department of the error, that specific error that you see. Very good. So this is the habit that we created for Jane. Let's create one for John. How do we create a habit for John? Well, first we need to log in with the John's account. So instead of Jane Smith, we can just get rid of these. And this is, let me zoom this in. This is too zoomed out. This is going to be J Smith, which is John. And there we go. We got the authorization. I'm going to cut it, copy it. And inside of the headers, we're going to have authorization bearer, and then pass that there. So now that we have that, the only thing we need to do is actually create a habit. So this is going to be create habit. What does it need, this create habit? It needs a habit, habit name. So what should be the habit name? This could be, let me think about this. This could be walk. Daily walk. And the description for this is going to say walk for at least 30 minutes every day. Should I put them together or apart? I think they should be together. Okay, very good. Now that is done. Let's take a look at the habit. We can select the ID of the habit, the name of the habit, the description of the habit, and let's get rid of the ID. Just name and description are enough. So as soon as I click on this, there we go. We created this habit. This was successful. So again, the successfulness the success of this creation of the habit is shown by the fact that we actually return that habit. So if habit is not created, how do we return it? So this means that we actually return that. And this means that we actually created the habit as well. If I come right here, if I just refresh this, there is another entry. That is daily walk. You can see user ID ends at F4 to F. Come right here, John, F4, right here. F42F, the same user ID. You can check it inside of here as well. Select everything from habits, and let me just bring this down, and there we go. So we have this daily walk for at least 30 minutes every day, and this traces itself to the user ID of John Smith. This is very interesting, right? So we were able to create 2 habits. We were also able to validate these habits. Make sure that unless you have a token, you're not going to be able to create habits. So everything is working fine. What should we do next? So the next thing that I want to do is I want to load habits. So that's going to be when you want to take a look at how many habits one specific user has. So imagine if you have like a front end for this API, user logs into their account and user sees all of their habits. How do we do that? Well, we need to have a specific repository operation for it and a specific resolver for it, because that's a GraphQL query. It comes to the resolver and the resolver talks to the repository operation. That's what we are going to do next. And to get started with the implementation of this, the first thing that we need to do is we need to jump into the habit repository, because as usual, we get started with the repository layer first, and then we are going to write the resolver for it. So down here, I'm going to create the repository. This is going to be function. We know that the receiver, this is going to have a type of habit repository. What is going to be the name of the function? This is going to be get habits by, so we want to get habits for one specific user. And again, we distinguish between users based on their user ID. So this could be get habits by user. Let me just lowercase that. So we have user and then ID. What is this going to have? Now we're going to give this a user ID. And then what it does is it's going to return all the rows that have habits that belong to the specific user. So we give it a user ID, and then that is going to have a type of string. This is going to give us, now keep in mind, this is not going to give us just one habit, as in the case of when we create a habit. So here, if you take a look at this, you can see we have models.habit. So it's clear that we talk about one individual habit. Since you can create one habit at a time, you're going to get one habit at a time. But if you have more than one habit, how are you going to resolve that? Then we're going to end up with a slice of habits or a list of habits or an array of habits. And that's going to be models dot, let me just convert this to star, models dot habit. So there could be more than one habit. Most likely there is more than one habit, or error. So what do we want to do here? Well, we want to select some rows from the database, right? So let's go ahead and let's select it. We are going to select the R, which is habit repository, select our connection pool or database connection pool. Now, so far we have talked about this query row. Now, what this does is it returns one row of the database, but since we know that there is going to be more rows, there could be one row, but there is a possibility that there could be more rows. We actually use this method. So this query method, what it does is this is going to return multiple rows. So this query method does execute a select statement. So let me show it to you right here. So you can see here we have this query row. What it does is it implements a select statement that returns one row. Now query also implements a select statement of SQL, but it returns multiple rows. So this is going to be select. Now what do we want to select? We could say we select the ID column. Now this is what I'm writing inside of these quotes, that is SQL code. So we select the ID, the user underscore ID, the name of the habit. Now keep in mind, this is when we go into the habits table and select the habits, because in the habits table, we just have one habit that contain the we just have one habits table that contain all the habits for all the users. We sift through these habits just to select the ones that belong to this user. For example, the habits that belong to John. We select them based on their user ID. So we talked about user ID and I showed you, okay, that the user ID of the user is stored inside of the habits table, and that's why we do it. So we can know which habits belong to which user. We're going to select the description of the habit. We could select the created _at, and we could also select the updated _at. After the updated at, we need to specify which table it is that we are referencing. So I'm going to say from habits table. Now, where is the condition? So I said we're going to select these habits based on a condition. The condition is the user ID. So if user ID matches, then we select those habits, because at no point in time we want John to see habits of Jane. That would be awkward, right? We want in no point in time for Jane to see the habits of John. So they're only concerned with their own habits. So this is going to be very important. So we're going to say where user _ID. Now this user ID is going to be the distinguishing factor is this. Okay, we are going to pass in this question mark, and this is going to be replaced by the user ID using this SQL driver. But what I want to pass next is I also want to order these. So I'm going to order these in the manner that they were created. And what do I mean by that? So I'm going to order them in a descending manner. And what that means is we're going to see the newest ones first. So you could do this as well. You're going to say order by created _at, and I'm going to pass in DESC. There we go. Now let's pass in user ID here, and that's it. So now this query method, it has the ability to not only return 0 rows, 1 row, it can also return several rows. So this query, if user doesn't have any habits in the database, query is going to return nothing. So that's why we use this. But if user has one habit, query is going to return 1 row. If user has 1,000 habits, query is going to return 1,000 rows. So this is going to return rows and error. Let's go ahead and let's take a look at each of them individually. If error is not nil, then what does that mean? It means there was some problem with this process of fetching the habits from the database. So we return nil for the habits slice. We don't return any of the habits. There is nothing to return because we didn't fetch them, but then we return the error as well. That was, for example, you could say failed to fetch habits, and then we could provide a placeholder for the specific error that was happened. But failed to fetch habits, that's like the general context of the error. But then %w is going to tell us, okay, what is that specific error? Why did this happen? Now, since we are actually talking about a different method on the database, which is this query, there are 2 more things that I want to introduce to you, and there are things that we have not actually talked about before because we didn't actually return a slice of data so far. So the first thing is I am going to actually close the database here. So I'm going to say defer, and I'm going to explain to you why this is and why do we need this and why this is a good practice. That's going to be rows.close. So it goes like this. Whenever you call this query, this db.query, what it does is it is going to open a database connection. And it is going to keep it open while we read the rows. Now imagine if there are 10,000 rows. It is going to take some time until we read these rows. But if during this process at any point we forget to close that connection, the problem is that the connection is going to stay open permanently. And this is called a connection leak. So what we do with this defer rows.close is that we guarantee the rows are closed when the function returns. Which function? This function. So whenever the function returns, no matter if there was any errors with this function or there was no errors and we were successful in this operation of returning all of the slices, we are closing the connection. So that's why I'm putting this defer rows.close immediately after this error, failed to fetch habits. Because if we fail to do this, we need to close the database connection immediately. And this defer, what this actually means is that run this line when the surrounding function exits. So rows.close closes the database connection, but what is this defer? This defer basically means that we want to run this line. So by writing defer, we mean run this line when the surrounding function closes. So, or the surrounding function exits. Now, we don't care how the function exits. What am I saying? So we say defer, run this line when this function exits, or this function is done completing, or it's over. And it doesn't matter if it was successfully over or unsuccessfully over. We're just going to say, okay, you're done. We're going to close the database connection. Now that's point number one that we talked about this in the main server file, but I just wanted to show you that we do this here as well. There is something else about this query that is really interesting. So what this query method actually does is it actually returns something that we called it rows, but it is actually called this. So let me just write it above. It is SQL dot rows, but this has an asterisk at the start of it. Now, what this says, this thing is called a cursor in database. Now, this is database language, so whenever you hear this, you're going to be familiarized with this. SQL.rows is actually called a cursor. So what is a cursor? A cursor is a pointer. You can see the asterisk. It's a pointer that moves through a result set or a slice of result one row at a time. So what I just explained seems like this is some kind of a loop. And it is. And yes, it is some kind of a loop. So why do we need this? Why do I need to know that this returns a cursor? So what is a cursor again? It's a pointer that moves through a result set one row at a time. Why row? Because we are returning database rows. So imagine you have 10,000 database rows. You return them by this get habits by user ID. Now what do? You send them to the front end. But how do you send that? You need to package it. You need to package it inside of the slice and then send it to the front end. So what we do with this cursor is that we read one row at a time, and each time we read that row, we put that row inside of the slice. So we get the first habit, we read it, so this cursor is going to go through the result set. When it finds the first row, it's going to read it using the scan method. Scan method is going to put it inside of a newly created slice, then it's going to go to the next one. It's going to see, okay, there is another row as well. Let's say user has 10 habits. The cursor is going to iterate over the result set how many times? 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And each time it iterates, it's going to call the scan method. And why the scan method? Because we use scan method here. We used it several times, and we use it to populate the result struct that we sent to the resolver. So we populated this habit, we populated the user one. So we talked about the scan method a lot. But since we have, let's say, 10 habits, we need to repeat scan 10 times. So we need some kind of like a loop syntax, and that's where cursor comes into the picture. It does exactly what we wanted. So how does it do it? It's extremely simple. The first thing that I want to do is I want to create these habits. So I need to have a slice into which I can put habits. Now keep in mind, this must be a pointer type, because if user doesn't have any habits, in case user doesn't have any habits, we want to return an empty slice. We want to return an empty array. We don't want to return null, so this, okay, but null, I'm going to say, come on, buddy, not okay. Because this null value right here, this value is actually invalid for a non-null list field inside of GraphQL. But this is valid. This is in case user has created an account, but user doesn't have any habits. So because we want to return an empty slice that matches the GraphQL schema or the GraphQL type, we are going to use a pointer, because pointers can be null, which means pointer can be empty, but we do not want to return the actual null value. So if I return a slice, so think of it like this. If I return the slice, when the slice is empty, the way JSON is going to serialize an empty slice, it should be this. The way JSON is going to serialize an empty slice is it's going to replace it by this, an empty slice. But if we do not use an empty slice, if we do not use a pointer slice, it's going to serialize it as null. And null is not valid with this GraphQL field that we have used. So that's why I'm going to use the make method, and in here I'm going to pass in. So we want to create an empty slice. This is going to have a type of models dot habit. Now initially we're going to say there is 0 habits because this is an empty slice. And in case you're wondering about this GraphQL schema that we talked about, that was way before, that was towards the start of this video. If you go to the schema.graphqls, take a look at this habit. So this is one specific habit that we return. So for, let's say for this user, take a look at this. So if user doesn't have any habits, what do we return? We return an empty slice. So at no point in time, we return null. We return an empty slice. So if there is no habit here, how is that going to look like? It's going to look like that. But it is never going to be this, because this is not compatible with the way we have coded this. So, and that's easier to understand as well. Okay, empty slice means user doesn't have any habits. So now that we have created this, we are going to populate this empty slice incrementally. So we read one row from the database, then we put that inside of here. Then we read the next row from the database, and then we put it here. So for this kind of iterative operation, we're going to use a cursor. And cursor is returned by this query. This SQL.rows is a cursor that is returned by the query method. So we can actually leverage this. So I'm going to say for, take a look at this rows. We used this rows to close the database connection, and now we could use it to iterate over the data as well. And we're going to use the next method. Now this is very interesting. So rows.next is going to move the cursor to the next row, and it's going to return true if there is a row. So imagine you return 3 habits for a user, 3 habits. The first time you have rows.next, it's going to return true because you have a row in the first iteration. Then what you do is you call the scan method. Scan method is going to scan the information from that row and put it inside of the habits empty slice. Then you go to the next iteration. Since you have 3 rows, the second iteration, rows.next, is still going to return true. Scan method is going to do its thing. We go to the next iteration, which is the third one, and then this rows.next is going to return true for a 3rd time. And we're going to grab the data and put it inside of the habit slice. But if we go to the next iteration, which is the 4th one, does rows.next return true? No, because we don't have any rows anymore. So it returns false, and we break from this loop. We break from it. So this loop ends. That means we just had 3 results, 3 habits, and we populated this habits slice with those 3 habits, and that's it. We're done. So this is how we're going to go about this, right? Now I'm going to create here a variable that is going to be called one individual habit. All right. So this is going to be a habit. The type of this is going to be models.habit. And then I'm going to show you how you can put these individual habits inside of the habit slice as well. So we have this rows. On the rows, we could use the scan method. You can see scan method is available on the rows. Now, what do we want to scan? What kind of information did we return from this habit? So take a look at this. So for that, you need to go to where you implemented your SQL query or SQL statement. So here is where we implemented our SQL statement. We said we want to have ID of the habit, ID of the user, name of the habit, description of the habit, when the habit was created, and when the habit was updated. So in total, we want to have 1, 2, 3, 4, 5, 6. We selected 6 different columns from the habits table. Now, if we have 6 columns, that means there are 6 kinds of information for one specific habit. So how many fields do I have to have for this habit that I've created above? I need to have 6 fields, right? So that's going to be habit.id. That's the first one. See, we go one by one. Then what do we have as next? So it says select ID, then user ID. So let's select user ID. Very good. What do we have next? Let me just copy paste that. Then we have the name of the habit. So I'm going to say .name. Very good. Then we have the description of the habit. Very good. That's 4. How many are left? 2. Then we have the created time of the habit and the updated time of the habit. And there we go. That's it. So this is basically the main thing that we did. We iterated over this. Now, inside of something that you need to keep in mind, inside of this for loop, we talk about one habit. That's it. So inside of the for loop, the information that's inside, they do not know if another habit exists or not. Only rows.next knows that. Because if next rows exist, this is going to return true. For as long as this returns true, we run this line. We run what's inside of the for loop. But if for rows.next returns false, we do not run these lines again. So as far as the body of the for loop is concerned, they don't know if there is another habit. They just talk about one habit individually, and then we give them another habit and scan does its thing, and then another habit and scan does its thing. So scan method, let me just select my cursor. This could return an error, which I'm going to put it there. And then we need to actually talk about this error. So we're going to say if error is not null, that means what did happen? What kind of an error do we have here? Well, it was the problem is that we weren't able to scan these habits. So I'm going to return null for the habits, and I'm going to say fmt error f failed to scan. That's the general context of the habit failed to scan habit. That's the general context of the error, not the habit. And then we provide that specific thing that went wrong. Now, we're still inside of the for loop, right? We check this error for every iteration. Now, after this error here, this means the operation was successful. We were able to put one habit's information inside of this struct that I've highlighted. So this is a struct that I highlighted, and in each iteration, we put one habit's information right in here. What do we do after that? So we need to keep populating this habits list incrementally as well. So we don't have to create another for loop. So here I'm going to select this habits list. You can see I have this autocomplete. So we select the habit slice and we append to it more stuff. What do we append to it? Now, you need to understand how the syntax works. So I'm going to get rid of that part. We have this append method. Append method accepts a slice. This is the slice that we put in there. It's right here. And then it puts some data in there. Since all of these are pointers, we're going to put a pointer to a habit. It's easier, this is faster, and this is Go convention to go like this. Now, since we have added some stuff to the habits, to the empty slice that was habits, we are going to update the value of habits with that as well. So we basically reassign habits to all the habits that we have populated to it. So this is how we actually put all the habits inside of the slice. This thing is this thing is this thing. So these three are the same thing. So this, and this. Here, this thing is referenced here, so we can populate it with these habits, and then we reassign it to habits, so everything changes, right? So we have an updated slice that contains information. And that was simple. Now, what if this process actually encounters any kind of error? That means we had some errors during this iteration. We can take a look at that as well. So if rows, it returns an error. So I'm going to do both of these in one if statement, okay? We talked about that. That means error is not nil. Then what do? We're going to say, now where is this error coming from? It's right here. There we go. So what if error is not nil? Then what happens? So if rows.error returns an error and error is not nil, it might be like the error is nil. Then again, we do not give the users any habits. If there is any error at any stage, we do not give them anything because the process was not successful. fmt.errorf. Now, what is this error? This is going to be error iterating habits. A little bit of a technical error, but the website developer is going to know, okay, what is this error? Now, if we move away or move past from this if statement, we know for sure that we have habits and error is going to be nil. And that's it. So we talked about a lot of, like a couple of, or I should say 3 new things: query, cursor, and this closing of the database. And yeah, this belongs to the cursor, to the query again. But the rest of the stuff is something that we have already done several different times. Now, let's go ahead and let's create the, I'm going to close description. Let's go ahead and let's create the mutation or the query. Which one? Which one should we create? Now, since we are trying to load information, we don't have to, we must not go into mutation. This is not a mutation. We do not change data on the backend. Let me collapse that one. We go into query, and that's going to be just another one. So we could select the structure of the query from here. Let me see which one it is. So it could be this one, right? What is this going to return? Let's take a look at it. So this returns a slice that has a type of models.habit or an error. And you can see it says habits on the, it is also a query resolver. So yes, this is exactly what we are looking for. So I'm going to copy this, come into the query, put it there, get rid of this. This should be very simple for us to actually implement. So what do we want to do? The first thing that we want to do here is, again, find out which user ID it is. Now, if you take a look at this habits repository that we have created this, let me collapse this one as well. We have created this get habits by user ID. Now, we created this, but we have not invoked this function. So the way this works is you invoke the function, you give it a specific user ID, and based on that user ID, we select some records, if existing, from the habits table. So where is user ID coming from? We know user ID is available on the context. We just need some kind of a shovel to extract it from there. And what is our shovel? That is the middleware dot get user ID. And then as soon as you pass in CTX, It's going to give you that user ID that we need. So it's going to be user ID and then OK for this operation. We are going to say if OK is, if it's not OK, then there could be just one possibility, right? If we cannot extract user ID from the context, aka from token, there is just one problem. User is not authorized. So we're going to say unauthorized. There we go. Authorized. Very good. But if I move past this, that means we were able to select user ID. So now I have a user ID. I'm going to call that get habits by user ID. I'm going to give it the user ID. And what is that repository operation going to give me? So I'm going to give it a user ID. It's going to give me a list of habits, if habits exist. If not, it's going to give me an empty list. And that's it. So very simple. I'm going to say R habit repo. And on the habit repo, we have get habits by user ID. And in here, I'm just going to pass in user ID. If there are habits, it's going to give me habits. If there is an error, it's going to give me the error. So I know what is actually happening here. So first things first, I'm going to say if error is not nil, return the error. Tell me what, return nil for the habits, but also return the error as well. But if everything was fine, just return all the habits and nil for the error. And that's it. So what do we need to do next? Let's delete this. That's it. Let's take a look at the server first. This is our database. Servers are also running. Let's come right here. So if I go into the DB, we can see we have just one habit for Jane, one habit for John. Oh, sorry. Here, these were actually users. So here we can see we have two habits, and since their user ID is different, we know that one habit belongs to Jane and one to John. So let's fetch them. This is going to be a query. Now, the first thing that we need to do is we need to actually log in with information. Okay. So I am going to come right here, click on this. This is John's account. So I logged in. Why? Because we need to have token. Token contains that user ID, remember? Let's go into the headers. And in here, I'm going to say authorization. And then we pass in bearer, pass in the token. Very good. Now let's get rid of this. That was a query. And what was the structure of the query? Well, we just want to fetch some habits. We could take a look at that here as well. So I'm going to go to query. This is the one. So I'm going to click on it, or I could just go back. You can see we just need to specify what kind of information. The first thing we need to do is we need to write habits. Then we need to specify what kind of information do we want to select from those habits. So let's do that. First we write habits, then we specify what information do we want. So I could select the ID of the habits, name, description. Remember 6 different fields. I could select the created at, updated at, and right after the ID, I could select the user ID. What does this return? So can't we select user ID? So user for this. If I hover on this, field user of type user must be selection of subfields. Okay, so you could select the ID here. Okay, very good. You can see how flexible this is. I can select user ID like this. So I'm going to click on this, failed to fetch habits. Very good. So failed to fetch habits, SQL logic error, near from syntax error. So there is some kind of a syntax error. First, we're going to take a look at this. Failed to fetch habits. That's where the context of the error lies. So if I come right here, go there, failed to fetch habits. So there is a problem with this one. It says there is a syntax error. We actually did a syntax error. So we have select ID, user ID, and the name description, created at, updated at, from habits table where user ID is this, order by created at DSC. I don't see the error. Let me take a look at it again. Near from. From. Let's get rid of this comma. I don't think there needs to be a comma. Let's run this. Failed to fetch. Let me take a look at this. It doesn't show anything here. Let me close the server. So clear this, run error again. If this shows the error, that's going to be better. Let's go to the playground again. I am going to cut everything from there, put it here. Even though we have like all the information, I'm going to click on this internal system error. Let me get rid of this. Just select the habits, and there we go. And now we have our habits. The problem was with that user that we specified there. Let me take a look at this. Where is the error start? No implemented user. Oh, we were selecting. Okay, I know what the problem is. We were selecting user, but we have not implemented that resolver. So that was the problem with it. Anyway, let's bring it down. I want to take a look at something. So we put the user ID inside of this habit, right? And that's something that we return as well. Let me go to schema.resolvers, ID, name, description, logs, user. So we can select a user like this, but we have not implemented this user. This is what's allowed, right? So there we go. We have this. We could go ahead and create another habit. So let's go ahead and do that. For this user, let's say I want to create meditation. Do meditation at least 30 minutes a day. Let me click on this expired token. Do we need to log in? Really? So let me go ahead. I think that's a different account. Anyway, if I go to the mutation, log in, select this information, copy it, go to the creation of the habit, and then put all of that information here. Click on this meditation. Very good. Now let's come to this table, reload this, and this habit belongs to John. That's F42F. Take a look at this, John, F42F. So we're working with his account for now. If I go and if I select this query, where is the query that with which we actually select all of the habits? And there we go. We have two habits. This is one habit struct. This is another habit struct. And it doesn't matter if you have two, you have 1,000, this is going to work. And this habit is actually a slice. So if we were to create an account for someone who doesn't have any habits, for example, remember Bob Smith, this is going to be B-Smith. Let's create an account for this user. And then we need to log in as well. So log in, and I'm going to get rid of this name. Click on it. This is log in. I'm going to select, copy this token, and let's fetch, come on, buddy, habits for this user. We need to actually see an empty slice being returned. I'm going to put that there, send this, and there we go. So as soon as front-end developer sees this, they know they're just going to replace this with a message, you don't have any habits. So click create habit to start creating your very first habit. So it's going to look like this. Now, if I sift through the code, we need to take a look at the unauthorized error. So I'm going to get rid of this. unauthorized, that works. What else do we have? We have this habit repository. So we saw this fetch works. The rest of these, it's almost impossible for me to simulate them. They should be like happening on their own. But like this one, this happened on its own. These two are going to be like that as well. But we know that this unauthorized works, and that's the main one. All right. So I'm going to collapse this. Let's jump into the habit repository, and let's talk about the next repository method that we're going to create. And the next repository method, or technically repository operation, is going to refer to loading one habit. But before doing that, we need to actually check to whom does this habit belong. So we need to keep that in mind. So what we want to do is we want to load habits whenever we have already implemented the user check. So if this habit that user wants to load belongs to this user, then we're going to load it. So what I mean is, not only we do not want for John to see all the habits that belong to Jane, we also do not want John to see one habit that belongs to Jane. So these are like two different operations that we need to actually implement. And what this also allows us to do is, if we try to pass in the ID of a habit, it's going to tell us like whom does this habit belong to. So let's go ahead and let's code this. This is going to be function. So what is this going to accept? This is very simple. The first thing is going to be repository. This is going to be habit repository. What should be the name of this? This is going to be get. Now we're going to say get habit, and I'm going to say with, so W capital, with user check. So we get one habit. Now keep in mind, get habit with user check. So we get one habit and we check that habit belongs to that specific user. So what do we pass? We need to have the ID of the habit passed in. That is going to have a type of string. And then we need to have the ID of the user passed in as type of string as well. Now, what does this function produce? We know that it produces one single habit or error. Let's move forward. Implementing this should be easy. Now, we do not need to talk about that query method that we used here, because this actually returns something that we call the cursor, which is iterating over this result set one step at a time or one row at a time. Now, here we just talk about one habit. One habit always corresponds to one row in the database. And what kind of a method do we use in order to get one row and exactly one row from the database? We know we use query row, but before doing that, I'm going to create a struct which is going to be called habit, and the type of this is going to be models.habit. Now, we are selecting one row from the database, so I'm going to say r.db connection pool, remember? And then we're going to say query row, which returns that row, and then we use the scan method to scan the information from that row into this struct, into this habit struct. Now, inside of the query row, we know that we need to pass in the SQL statement or query that actually does something on the database. So we select the ID. Now here, we just select one row. Remember, one habit, one row. So that's what this is going to return. We select the user ID, the name. These are all columns inside of the habits table. So we select the ID, the user ID, the name, the description. And then what do we have after that? We could select the created at as well as the updated _ at. And then from where? We're going to say from the habits table. Then we need to have like a specifying condition. And that condition is going to specify which record belongs to whom. So which record are we selecting? We're going to say where the ID of the habit is equal to the ID that we received with the GraphQL query from the front end, and And you can see I'm continuing. So I said where ID of the habit is equal to whatever we received from the front end, and so I'm chaining on to this condition. I'm saying and user underscore ID, where am I? So I'm going to say and user underscore ID is equal to the user ID of the user that I received from the front end. So there we go. Should I zoom this in? Let's zoom this in or zoom this out. I don't think that's readable enough, so let's zoom this in. Now we can see it is actually working fine. So we say we select ID, user ID, name, description, created at and updated at. So these are all column names. So we select these 6 columns from where? From the habits table, but under 2 conditions. The ID of the habit must match the ID that we received with the GraphQL query, and the ID of the user must match the ID that we received from the GraphQL query. So unless these 2 match, we're not going to return anything. These 2 must match, both of them. Now, we have 2 placeholders. We need to fill these placeholders. So provide a comma and space, then we have the habit. So for these positions are very important. So the first placeholder is the first question mark for the ID of the habit. That's why I'm going to pass in habit ID. The second question mark is for user ID. I'm going to pass in user ID. Now, what is this? What does this return, this query row? All of this. This returns exactly one database row. And then we use the scan method to scan this information into this habit struct. So what kind of information have we received from the database? 6 columns. So we need to scan this 6 into 6 different fields inside of that struct. So we have the ID. Then we have the name. There we go. Then we have the description, created at, updated at, and I know one is missing, and that is the ID of the user. So this should be user ID. And remove that space. There we go. So if this process is successful, then that's okay. But what if this process is not successful? Then that's going to be an error. Now I'm going to go ahead and I'm going to zoom this out. There we go. This is readable enough, I'm pretty sure. We're going to say if, let me just put it right underneath it, if error is not null, that means this process of like grabbing the habit and putting it into the struct, it was not successful. But keep in mind, what we are doing is we're actually trying to return a habit, aka find a habit. So we say we did not find any habit, so the habit is going to be null. And for the error, I'm going to say error if habit not found. I couldn't find it. That's going to be the error. And well, let me think about this. So habit not found, this is going to be the error for when the database row doesn't return anything. Okay. But once we cannot find, so if it doesn't return anything, that's going to be habit not found. We didn't find this habit with this ID and this user ID. So this actually belongs into another category that is called if errors dot is. And what is that error? The error is, let me just pass it here. It's SQL dot no error, no rows. There we go, that one. If we didn't return any rows, we are still going to return null for the habit. So we return null, and this null is going to belong to this. So for this habit, we return null, and this habit not found is for this error. That's the message. But what if there is some other issue here? Any other issue would mean that we were still not able to find the habit, but then we're going to say, I'm going to say failed to fetch habit. Failed to fetch habit. Now, what is that specific thing that has happened? I'm going to provide a placeholder for it. There we go. So this is, we need to, the reason that I did this is because we need to actually account for if we didn't receive a row from the database, as opposed to any other issue with the database, like database connection, whatever the problem with the database was. So if everything was fine, but this habit did not exist, we're going to return this. But if there is any other issue with the database, we're going to say, okay, we were unable to actually get this habit, and there you go. This is the problem with the, this is the actual problem. So what do we return? If everything goes well, we return the habit and we return nil for the error. Now that this habit repository is done, it's time for us to jump into the query. We need to actually write a resolver for this. Now, do we have to write a mutation resolver or a query resolver? Well, we don't change anything on the database. We just select some information from the database. So this is going to be a query. And let's see if we have this inside of here. So we're looking for one individual habit, and there you go. Where is it? Right here. This is the one. So take a look at it. It is a query resolver. Very good. The name of it is habit. It has the context and also the ID of the habit. And you might be asking, okay, but the habit repository needs the habit ID and the user ID. Where is the habit ID and where is the user ID? So on this resolver, the user ID is inside of the context, and this ID is the habit ID. So technically we have both of them. We extract using that shovel. Remember, we extract user ID from this context, and this is the habit ID. So we could use this. Let's just copy it, come into the query, paste it here, get rid of this. Now, what does this return? This returns just one habit or error. And you can see that the query resolver, the receiver, actually has the correct type. Now, what is the first thing that we do? We do exactly what we did here. So I can just copy that and I can put it here. So what did we do? We selected this get user ID from the middleware. We passed to it the context, which we have already explained several times. And what this returns is user ID and OK. OK basically means, was this successful? If this was not successful, we do not return the habit and we say unauthorized. Why? Because if we were not able to select the user ID from the context, there is just one explanation for it. User is unauthorized. That's the explanation. But what if the token was misconfigured? Then we have other errors for it. But if everything is fine, but we cannot get the user ID, that means this habit does not belong to this user. And we want to stop them right there. So that's why we say unauthorized. Okay, now let's move forward. What do we want to do next? Well, we do what we used to do. We select this get habit with user check repository. Now remember, here we have actually created this repository operation, but up until this point in time, it doesn't do anything. So we need to actually reference this, invoke this here. So where is that? That's available on habit repo dot get habit with user check. And what does this accept? It needs to have the habit ID, for which I'm going to pass an ID, and then the user ID, which I've extracted from the context. Now, here is where this get habit with user check actually does something, because we invoked it here. What is this going to return? Now remember, this repository operation returns two things. It either returns habit or error. So you could say it returns both things, but since error is nil, you could say, okay, it doesn't return anything for an error, so it just returns habit. But technically speaking, it returns two things, habit and nil. So what does this return? It returns the first thing, which is the habit, the second thing, which is the error. So the first thing, see, habit, the second thing, which is the error. And there you go. Two things. It returns, so this part returns two things, the habit and the error, in which the error could be nil. So I'm going to say if error for some reason is not nil, which it should be, we do not return the habit because the habit doesn't belong to this person, or there was some other issue. We don't care. We do not show someone else's habit. So, and we return the error. So we need to know what that is. But if everything is going well, we show, so it's John who wants to see John's John's habit, then we show them their habit. And so I keep saying sorry a lot. Let's backtrack a little. I'm not going to cut this. So if everything is going well and it's John who's accessing John's habit, we return their habit and I return nil for the error. And now the next thing should be to get rid of this, save this, and we should be good to go. So let's jump into here. I'm going to log in, mutation login. So this is Bob. This is J Smith. This is John. Very good. Login. And we got the token. Just copy it. And in here, I'm going to say authorization. Let's pass bearer. We're going to check that without token 2. And then how do we select the habits? Well, for that, you could take a look at the documentation for query. Now you have this habits that you can just call. Now this one, you need to differentiate between these two. So this one is the one that we have already created. This selects all of the habits. But this is the one that's going to give us individual habits. But see, what does it need? It needs to have the habit ID. So what I can do is I can first of all get all of the habits, get their ID and their name. This is actually a query, not mutation. And prettify this. It gets rid of the query keyword, which I do not like. Let's just run this. So we can see we have 2 habits for John. Okay. Now in this, I have no idea to whom, now that I'm looking at this, I don't know to whom these habits belong. I need to remember which token this was, right? So I want to select one habit's ID, and I should be able to find out to whom does this habit belong, and also find out the extra information around this habit, right? So what am I going to do? I'm going to get rid of this. We have habit. I'm going to open up parentheses, and in here, I'm going to say ID, and then I'm going to pass in the habit ID. And at the end, let's get the ID. We could get the ID again, or let's get the name of the habit, the description for the habit, the created at, as well as the updated at. Run this. There we go. Do meditation at least 30 minutes every day. So this is if you pass in the ID of that specific habit. If this habit belongs to John, you're going to see this information. But what if this habit doesn't belong? What if the token is incorrect? So let's send this. You can see invalid authorization header format because I got rid of that bearer. Now I'm going to get rid of the entire token. I'm going to send this unauthorized. It doesn't belong to you. Unauthorized. You need to be authorized in order for you to actually be able to access this. Now, I'm putting back the token. I am messing up this ID of this habit, aka this habit with this ID doesn't exist on the database. So as soon as I send this, it says habit not found. It doesn't say anything else. It just says, okay, John, you're trying to access this habit, but this habit does not exist. So that's the idea behind this actual specific habit, specific resolver that I wanted to show you. So you can create a resolver that has access, or that can access all of the habits for a specific user. Or if you want to take a look at individual habits, you can do that as well. But under no circumstance can you access someone else's habits. So we could actually test this. So if I go to the database, if I go to habits, what do you see here? So this is user ID right here. This is the user ID column, right? We can see that 2 of these habits have the same user ID. One is not the same. This is different. So this third one is different. This means these two belong to one person, this one belongs to another one. And we know that this token belongs to John. And if I go to the Beekeeper Studio here, what does this end? It ends with 44AF. I know, since we're testing this, I know that this is the user ID of Jane. So if I go to users, take a look at this, 44AF, that is Jane Smith. Now imagine what would happen if I try to select the ID of a habit that belongs to a user, right, who is not John. So I'm trying to select this this habit ID that belongs to Jane, but with the token that I created for John. So that should not work, right? So I'm going to copy this. That's easy to copy. I'm going to come right here and I'm going to pass that here. I'm going to send this habit not found. Habit not found. Because again, this habit doesn't exist on the database that belongs on the rows that belong to John, because this token belongs to John, this ID. So as far as John is concerned, this habit doesn't exist, because this is something that belongs to Jane. It doesn't belong to John. But we could select any of the habits for John. I could just copy this habit ID, and I could come right here and just provide a little bit more space. And I could paste it here, send this, there we go. Daily walk this and this and this. So this is very cool, right? So it's actually taking shape. Now I want to move forward with this, and I want to actually jump into our habit repository to talk about the next method, the next repository operation that we are going to create. And the next repository operation in the habits category belongs to updating a habit. Now, before jumping here and talking about the updating of a specific habit, I want you to actually open up the part where we talked about the repository, that user repository, where we talked about update user, because there are going to be some parallels here that I do not want to dive too deep into, because we have already talked about them deeply. So I'm going to zoom this out one level, because there is nothing new here. I just want to just direct your attention to this. So when we talked about update user, what did we say? What did we try to accomplish? We said that the first thing that we do is we check if this user is the authenticated user who wants to update their own information. That's the first thing that we did using this user ID. And then we said, it's up to the user when they want to update their information, whether they just want to update their name, their email, or their password, or they just want to update name and email, or email and password, or name and password. So it's up to them. We want it to be flexible. Any combination should work. And we do not want to do the following, which is we do not want to force users when they update their name, we do not want to force them to update their email and password as well. Imagine if that was the case. We don't want to do that. So if user just wants to update the name individually or just the email or just the password, they should be able to do that. Now for that flexibility, we had some trade-offs. We had some complexity in the code in order for the implementation of the simplicity, or I shouldn't say simplicity. So for the implementation of the flexibility, we introduced some complexity into our code. I just wanted to sound poetic. So what was the complexity? We had to create a dynamic SQL query that is going to update based on whatever information it has received. So if it has received name, it would do this. Remember, we talked about all of these. This, and then this was for email. This is for password, and this could be for any combination you can think of. Now, when you update a record inside of a table in SQL, the code is the same. The query is the same. The update is the same. We're going to use the same update. The table is going to change, of course. That's a different table. But the syntax of SQL is going to be the same. So when the syntax is the same, what else is the same? The SQL fragment and the SQL data is going to be the same too. So what if we want to provide users with the flexibility to just update the name of their habit, or to just update the description of the habit and not update the name, so this flexibility, you can update one without having to update the other, then we need to come up with some kind of dynamic SQL. Because depending on what we received, we need to adapt to it. And that's why we used this dynamic SQL. So when it comes to the updating of a habit, user could update just the name of the habit or just the description, or you could say user could update both of them. So there are three possibilities. So when something has more than one possibility, it's not static, it's dynamic, right? So that's why we need to come up with some kind of a dynamic SQL query, which we're going to run at the end, and that's going to determine what we have received. So what did we do? We said we have clauses, set clauses, where set clauses contains that specific fragment that user wants to update. And then we have args that contains the data with which user wants to update that fragment. So we talked about these extensively, right? Then depending on which part user wants to update, we had different conditions. But the important part here was they are not chained. They are separate. They're independent from one another, because they should be, we should not force on user to update one, and they must update the other ones as well. So we wanted to give users flexibility. That's why these are separate. Now, this was the case. Let's move forward. Then we said if user tries to invoke this method or this function, but user doesn't give us anything to update, we're going to say you didn't give me anything to update, so please specify what do you want to update. Then we said, okay, we want to find out the current time because we need to change the updated at time as well. If user does something other than creation of data or deletion, so if user does something to the already created data, which is not deletion, that means that's update. So we need to update the updated at time. That's the function of the updated at time. Then we combined all three of them together into a string. So this join method not only puts them into one string, it also gets rid of their syntax, their slice syntax, those square brackets. It gets rid of those as well. Then we created that dynamic SQL right here. So this part is common. We say update table set. So a table could be users or habits set. Then we provided the clause. So that clause was dynamic. Depending on what user wants to update, we are going to put it here. And what was the condition? The condition is the ID of the user. So if it is the correct authenticated user, then we're going to update their information. And then we had some generic errors, and if everything was right, we returned that specific user. So this is everything that we have already talked about. Now, the reason that I went on this rant is because we're going to do almost the same thing here. So I'm going to speed this up so we don't have to talk about this a lot. I don't want this to be I am trying to not make this redundant, not make the explanations redundant as much as possible. So we have update habit, not updated at, update habit. This is the name of the repository. Now, if I want to update the habit, I need to know which habit it is user wants to update, aka habit ID. So how do you know which one? You distinguish between them using the habit ID. So ID is going to be unique to each habit. So if I have an ID, I know which habit this is. Then I need to know if this is the correct user who wants to update this. Then it comes, so these two are fixed. There is no compromise here. with the habit ID and the user ID, because this is authentication, there is no compromise in authentication. But when it comes to the updating of information, we could return a pointer type for name, because this is optional. When you invoke or when you call update habit, it's optional for you to either update name or update description or update both of them. So that's why we pass that. Then we have description, because pointers can be null, but strings is going to be an empty string, and we cannot really distinguish, did we receive an empty string from the front end, or that was the process of the result of some other process. So that's difficult. But once we return nil for this pointer type, we know user just wanted to update their name, and for description we received nil. That's easier to understand. So that's why we pass in these pointer types. We have models dot habit, but at any point in time we just return one habit. User can update one habit at one time. You cannot update two habits at the same time. No, just one habit. That's why this habit is singular. Or it could return an error. And now what do we do inside of this repository operation? The first thing that we need to do is actually check if this habit belongs to this user who wants to update it. And how do we do this? Well, we already have this get habit with user check. That is going to accept the ID of the habit, and the ID of the user is just above. And it's going to tell us whether or not this is actually correct. So I am trying to reference get habit with user check. Where is that available? That's available on the habit repository. Remember, all of these repository operations are available on the habit repository, which is R. So as soon as I do R dot, see, create habit, get habit with user check, get habits by user ID, update habit. Which one do I need? I need, since I'm returning one habit to the front end, that's the habit user wants to update. The correct one is which one? Should I get habits by user ID, plural, or singular? Get habit with user check. Singular, because we return just one. So what is this going to accept? This is going to need to have the habit ID as well as the user ID. And these two things are the things that this repository operation is going to receive whenever we invoke this inside of its relevant resolver. What is this going to return? Now this is going to return either a habit. Now remember, what does this return? It's right here. So this get habit with user check, it either returns a habit or it returns this error. Now at this point in time, we do not care about the habit, but we just care about the error, because we want to check if this is correct. If by this I mean if this habit belongs to this user. So this is just a check. So if error is not null, that means there was something wrong. Perhaps the thing that was wrong is that this habit does not belong to this user, or this habit doesn't exist in the database. So it could be any of these errors. So we return null for the updating of the habit or for the updated habit, and we return that specific error. Now, if I move past this, what do we have? We need to actually come up with that dynamic SQL. So how did we come up with it? It's very simple. The first thing we did was we said we need to have SQL fragment and then the data for those SQL fragments. So I could just very well copy them, paste them right here. So you can see it's the same thing. So we come up with this structure with this method of writing our code, and then we could just copy that and use it in other places of the code. So it's understandable, these steps. I do this, and then I can do this, and do this. All right, so we have already talked about these two extensively. And then we have two conditions. Now for the specific habit, we don't have email and password, but we do have name for it. So I could just copy if user has given the name of the habit in order to update that habit. we need to do this. So what we're doing is we're constructing that set clauses list dynamically. If user has given us name, aka name is not nil, then we put name inside of the set clauses, but then keep in mind, inside of the args, we need to put the value. Since the value is a pointer type, we need to dereference it. That's the terminology we use. So this asterisk right here, it doesn't say it's a pointer type. It says, well, it does say that it's a pointer type that we want to dereference, aka dereferencing basically means that we get the actual value. That's what dereferencing means. So this is for name. We need to have one for what? Email, password, description. Just for description, because we're talking about habit. Habit has name and description. So this is going to be description. If description is not nil, then we put description equal to question mark in the set clauses, and then we select the value of description from the resolver in which we're going to invoke this specific repository operation. So what did we do after this? We checked. If you want to update the habit, you don't give me the name, you don't give me the description. So are you like playing with me? You don't give me any information. I'm going to say no fields provided to update. So if you want to update, you need to tell me what do you want to update. So then we say that. But after this, we construct basically we try to change the value of updated at. And we did this. So we calculated the current time and we put that. So these three are actually belong to one category. So there shouldn't be any space there. We calculated the time. We set clauses. Now keep in mind, we put updated at the end because that's the further column. If user has given us name, we put the name. If in conjunction with name, user has given us description, we put that after the name, but then right after the name, we put the updated at because we need to update this column as well because some data has just changed. So we need to do that. What did we do next? Well, after this, we have a slice. So we know that set clauses is actually a slice. We need to convert it into a string. So we can put it right here because this is a string. It doesn't accept a slice. So how do we convert that? Well, we used, we used this join method. And we joined all of the clauses into a single string clause. So I'm just going to copy that, come right here, put it right here, and let's move forward. What did we do next? Well, after that, we need to basically construct that specific SQL string or statement or query. And we used this sprintf just because we just want to have one string that has a placeholder inside of it. All right. So I'm going to get this. I'm going to put this here. Now you can see how similar they are. Because if you want to update something using SQL, the code is going to be similar. It's just we referenced a different table. So this users here doesn't make sense. I need to change it with habits. And finally, this is going to be the string that we are going to run, but where is the data for this is going to come from? Its data is actually inside of this query. Sorry, inside of the args. I shouldn't say query. Inside of the args. Put it there. But do we have this ID? So do we want to update the information of the user or information of the habit? We want to update information of the habit. This ID doesn't exist. We either have habit ID or user ID. So we pass in habit ID because at the end of the day, we want to update habit information. So now we have the statement, we have its data, it's time to execute this. So writing this statement, like formulating the statement doesn't run it. We need to have a method that is going to run it. And that method is available on RDB. I'm going to write this. Execute method is going to run this. It's going to execute this. So execute method is going to accept the query, and then we need to pass in the data. But data is in a slice. How do we pass it there? We spread that slice. So we get rid of the syntax. We put all the information of the slice individually here. What is this going to return? Well, this is going to return a SQL result, which we don't care, but we care about the error. If error is not null, what do we do? Well, let's take a look at what we did here. If error is not null, well, here it says, since we had an email, we had this unique constraint failed, but in the habit department, we don't have that email. So we don't have that specific error. We could just say failed to update habit. So I'm going to put that right here. I'm going to say return null for the updated habit, null, no habit is updated. And I'm going to say failed to update instead of user. I'm going to say habit. Very similar, right? So this is what makes it actually very good and very unique. So what should we do next? Well, at this point in time, what we did was we went through all of the processes, and once we are at line 149, that means there is something that a user wants to update about one of their habits. There is something about it. We don't care what it is. It could be name, description. It could be any of the hundreds or thousands of habits that they have. We don't care about that. But we know there is something that's going to change in the habits table. But we know for a fact that there is one thing that's going to change at one time. So how do we do that? Do we go ahead? So let me just ask you this. Should we run all of this again? So do we grab that from the database, run the scan method on it, that specific row which belongs to that specific habit that user wants to update? Should we select it from the database, then run the scan method on it, and then populate the struct with it? Or we could just use one of these repository operations that already does that and not write all of that repetitive code here. You could go both ways. What you could do is, inside of this repository operation, which is called getHabit with user check, you could copy all of this there inside of the update habit, or you could just reference this, invoke it, and this is going to, so what is this does? It gives you one habit. And what does update habit does? It gives you one updated habit. It gives you one habit nonetheless. So we could just select this get habit with user check and run it. And we don't have to write all of that redundant code again. How do we do this? Well, we say return. Where is that available? Remember, on the habit repository, which we reference using R. And there we go, get habit with user check. Now, why don't I use create habit? Because that's going to create habit. We don't want to create habit. We want to update an already created habit. Why don't we use get habits by user ID? Because it clearly says get habits. It returns a slice. It doesn't return one individual habit. And why do we use get habit with user check? Because it returns exactly what we want, one habit. But since we are inside of the update habit, it's going to return one updated habit. So I'm going to call that. What is this going to need? It's going to need the habit ID as well as the user ID. So by the end of this repository operation, you can see that we can actually reference previous repository operations and we can use them. We did the same thing here. Perhaps I didn't explain it like this. I don't remember. That was like a while ago. For me, it could have been like a few days ago to like a week ago. So I don't remember how I explained this, but that's why we used it. So we already have created this get user by ID. That's get user by ID right here. We already have this function or this repository operation. We're just going to reference it and that's it. We don't have to repeat the code again. So this is saving us time and code, and the number of lines of code, even though these days it's more important to have more lines of code than for code to actually make sense. But anyway, there are a lot of other YouTubers who talk about this stuff. That's why I don't focus on this AI stuff, because I've seen that there are I could say tens of other very, very popular and prominent developers and instructors who used to teach. Now, because they get more views with AI content, they talk about basically every aspect of it. So I don't see the need for me to actually go ahead and jump in there, because realistically, there is not going to be anything new that I can give about AI that's not already covered by some other greater developer than myself. So what I try to focus is on the fundamentals. It doesn't matter if you use AI or not. You need to know these fundamentals. Even if you work with AI, you still need to understand your code. So that's my preference, and that's the way I go about this. And I can see that teaching these fundamentals, it's going to get rarer and rarer, and there's going to be a scarcity to this. And I want to fulfill basically that scarcity when it comes to these kind of information. That's why I provide all of this for free, so you can have that access to free education if you want to. Or maybe you want to support me in this endeavor, which is going to be, that's something that I want to do in the future, which is, I'm not sure when, launch my own platform and then put a new content there. But for now, I just want to focus on this, because there is just a lot going on with the job, with the family, everything. So I just want to focus on these tutorials for now. So we're done with this. What should we do next? We should have a resolver to update these information. But do we create a mutation resolver or a query resolver? We create a mutation one because we change data on the backend. And let's get the signature of this resolver. We want to have update habit. There we go. So you can see it's a mutation resolver. The name of it is update. It has that CTX from which we can select the user ID. We have the habit ID, the name of the habit, and the description of the habit, which user can select whichever one to update. Also, what this resolver returns is models.habit, aka just one habit, exactly in line with the repository operation that we have created. So I'm going to come right down here, save that, just get rid of this. And now what do we want to do here? Well, the first thing that we want to do is we need to check if this habit belongs to this user. So we need to actually check for the authenticity of the user ID. Now, that's something that we can do using getUserID. Now I'm copying stuff from the update user because these are similar. I'm copying stuff from the update user and putting them inside of the update habit. Let me see. So these are two different kinds of mutations, but you know what, the convention is to put all mutations inside of the mutation.go. So it doesn't matter if these are different concerns, we're going to put them inside of one file, because the file itself concerns itself with all the mutations. So how do we go about this? First, we check this user ID. If this is correct, then we need to find out if user has given us their name, the name of the habit that they want to update. So if we have the name of the habit, we need to validate that name. If the new name for the updated habit, for the habit user wants to update, does not pass validation, we throw these errors, right? So I'm going to copy that. That part is actually similar. So I'm going to put that there. And then I could just copy this for the description. So this is going to be description. And we don't have this validate description. We have validate description with a capital D. So these parts are also done. We're chaining error. I shouldn't say chaining. We're limiting the scope of error to this if statement, so it's not available outside of the if statement. Now, if user has given us either name or description, we're going to move forward. But if user doesn't give us anything, we're not going to be able to move forward. So if I'm at line 176, that means there is something that user wants to update about the habit. What is that? It depends on what user has given me. But how can I implement this? So I need to jump into the habit repo. From there, select the update habit repository operation, which accepts as the first argument. Since we're invoking the function, when you invoke the function, you pass in arguments. That's the ID of the habit. The second argument that it accepts is the user ID of the user who wants to update. Then if, now we are flexible. If user wants to update their name, we just pass in name. If user wants to update the description, we pass in the description. I shouldn't say their name, it's the name of the habit. You get what I mean. So sometimes I misspeak. What is this going to return? This is either going to return one updated habit or error. If error is not null, we know what we do. It's this thing right here. So here you can see in the update user, this update user, it returned user and error. If error is not null, we do this. But here, it returns habit or error and or error. But what if we move past this? Then we know that user has updated one thing about, at least one thing about the habit. Let's pass in null for the error and get rid of this resolver stub or function stub from here. And this is actually looking good. So we're completing this. Very good. Now, what should we do next? Well, we need to actually jump into this playground to check, to actually be able to do something, actually update the habit that we want to update. So how do we do this? We can go to Mutation, and here we have update habit. So in order to update the habit, see what do we have? Let's take a look at this. So ID is required. You can see that exclamation mark. But for name and description, none of them are required, but we need to pass at least one. So if I'm trying to update a habit, I need to be specific which part do I want to update. Now this token belongs to John, right? Yeah, that belongs, or daily walk. Let me just take a look at the database. Yeah, that belongs to John. Very good. So I'm going to get rid of these, get rid of all of this. That's a mutation. And we say update habit. Now we have that. The first thing is that we need to pass in what? The ID of the habit that we want to update. So let me put that on another line. And what is the ID of the habit? Let's select it. So let's say this meditation, you can see there is one extra space inside of the description. Let's say I want to get rid of that space. I'm going to copy the ID of now you need to pass in the ID of the habit, not the ID of the user. Why? Because the ID of the user is already included inside of the token. We need the ID of the habit. So that's the ID of the habit. I want to change its description to what? To the following thing. So I'm going to copy this. I just want to get rid of that space. You can see there is two spaces. I just got rid of one. And meditation 4, I'm going to pass in 4 as well. Do meditation for at least 30 minutes every day. Now, this requires us to return something. We could return the ID of the habit, the name of the habit, the description of the habit, the created at time, and the updated at time. Since the updated at time is going to change. Let's run this, and there we go. Take a look at this. So we got rid of that one extra space and we added this 4. And we can verify this because I'm recording both of these on the same day, but the time is different. So the day is the same, 4th of June, but the time is different. So I created this on like at 12:18 a.m. and or p.m., right? This is p.m. or AM? I always confuse these. Anyway, so it's now, I updated this at 21:34. So a lot of difference, right? So almost like 10 hours, 9 hours, 9 hours, yeah, not 10 hours. So it doesn't, that's not the point. The point is we have updated the update at that time. We were able to update the description, and you can update any part of this if you want to. For example, you're going to say name. I just want to update the name to Meditation. So all caps, you could do that. Get rid of the description, and there we go. You can see we just updated that. And it is going to change in the database because it's the database that gives us that information. And there we go. Meditation, yeah. And if you don't pass in anything, it says no fields provided to update. What are you doing? If you get rid of the token, it's going to tell you unauthorized. It's not going to tell you no fields, rather unauthorized. So this part is also done. What do you think we should implement as the next step? Of course, we need to come up with a repository operation and a resolver that is going to that is going to help users delete a habit if they want to. And it is very easy for us to implement this. So let's go ahead and let's write the definition for the repository operation. This is going to have R, that's going to have a type of habit repository. The name of this repository operation is going to be habit ID. Sorry, delete habit. I was thinking of like this is going to accept habit ID. That's why I said that. So when we want to delete a habit, what kind of information do we want to have in order to make sure that it's the currently authenticated user who wants to delete the habit, and it is their specific habit that they want to delete? So there are two checks. First, we need to know it is the authenticated user, and then if user, let's say, wants to delete habit A, they should just delete habit A, not habit B. Cool. So these checks, we need to actually implement them. So this is going to be for the habit ID. So we know exactly which habit user wants to delete, and user ID to know exactly if this user is authenticated or not. If this is the owner of this habit who wants to delete the habit. This is either going to return bool or error, because sometimes we are not able to find the actual habit, so we're going to return false in that case. Sometimes we cannot fact check the user, so we're going to return false in that case. But returning false, so the issue with this is, we have already discussed this when we deleted a habit, when we deleted a user. The issue with this is, if we return false, that means there was something wrong. But that is not going to contain what the reason was, what went specifically wrong. That's going to be the job of the error. So that's why we first provide a flag. Okay, was this successful or not? If not, then why? So here, let's go ahead and let's find out if it is the currently authenticated user. We can select this one since we want to know if one habit belongs to the user. We can just select get habit with user check. To this, we're going to pass in habit ID, which this repository operation is going to receive from the resolver. And then we're going to pass in user ID, which we get it from that shovel, from that get user ID. So what is this going to return? This is going to return. So what does this return? It returns either habit, one habit, or error. I don't care about the habit that it returns because I'm just checking if it is the user, authenticated user, then we just take a look at the error. So we're going to say if error is not equal to nil, that means there was some problem with this operation. And what is that problem? The problem is that, well, there could be because we're running this get habit with user check, there could be some errors that we have actually specified inside of that specific repository operation, or the problem could be that this user does not own this habit. So what do we return for the Boolean? We return false, but then what specifically went wrong. That's going to be the job of error. So that's why we differentiate between these two. And after this check, we know that this habit belongs to this user. What do? We run a specific SQL query or statement that is going to delete one record from one table inside of the database. How do we do that? We select the DB, and on the DB, we have execute. Since execute is going to run that, and it's just going to return result, which we are going to come back to it. For now, we just want to run this. So how do we delete one record? It is the same thing that we did for user. So we say delete from where? From habits table. And what is the condition? If this condition does not meet, we're not going to delete it. The condition is where ID of the habit is equal to this ID. And I need to pass an habit ID. So SQL driver knows how to put these two together without compromising anything. This is going to return a SQL result, or it is going to, I shouldn't say just or, it returns an error alongside with the result. Sometimes error is nil. So that's why we say if error is not nil, because at any point in time when you say result and error, it returns both of them. So if error is not nil, that means there is something inside of error. We return false for the Boolean, and we return that specific error that went wrong. So what could go wrong here? Here, the problem is that we were not able to delete the habit. Failed to delete habit. And then I'm going to pass in that specific part of the issue. And this is going to be the error. Now, let's come back to this result that we have not used. Why are we interested in result? Because there is something that we call rows affected, which is a method that is available on this result. So as soon as I do result and I do dot, you can see I have this rows affected. So the idea behind rows affected is to know how many rows were actually affected by this specific SQL query or this delete statement. How many rows were affected by this one? So there are going to be two expected values. What we expect from this rows affected to return is 1. If it returns 1, the number 1, that means we deleted exactly one habit row. So we deleted one row from the habits table. And we know that in the habits table, every row is dedicated to one single habit. So that's what we expect. But it could give us a result that is unexpected, which is 0. That means habit was deleted between ownership check and delete. And let's actually see this in action. So here, what this returns is something that's called rows. I should call it rows affected and error. So what are we interested? The first thing that I want to do is I want to take a look at the error. So if error is not nil, that means there was something wrong there. And what do we return? Well, for the Boolean, we return false. For the error, we're going to return error F. That's going to be failed to confirm. I could say failed to confirm deletion. And then I'm going to pass in that specific error in there. Very good. But if there is no error, then there could be something else wrong. So there is a possibility that you have a valid ID for a habit. We already encountered this when we deleted a user. So you have a habit ID that used to belong to a habit and that used to exist in our database. You clicked on delete habit, you deleted that habit, but you still have that ID since we work in the playground. If you click on it again, what is going to happen? Well, the first time you deleted that. The second time, no rows are going to be affected by that. So that's why we say rows affected. If rows affected is equal to 0, which basically means delete statement of SQL ran successfully, but found no matching row. But this should not happen after a successful owner check, but we handle it like defensively. We write this anyway, because there could be like a lot of concurrent requests. I don't want to like dive too deep into why we use this. Just, okay, what the idea of this is. If deletion was successful, there was no error, but we like found no matching record or no matching habit inside of the habits table, then we are still going to return false. We're trying to handle this gracefully, and we're going to return nil for the error. And finally, if everything goes according to plan and we delete a habit, for the deletion we return true, and for the error we return nil. Very good. So this is the habits repository on its own. It doesn't do anything. We need to jump into mutations, and we need to actually go ahead and write a resolver for it that is going to handle that deletion, the deletion for us. So we could select the signature or function step from here. I'm going to copy that. So this one, delete habit, come into the mutation, put it right here, and I'm going to get rid of it from here. So let's take a look at it. We can see that this is a mutation resolver. And since this is a mutation resolver, we are inside of the mutation file. That's good. The name checks out. We have CTX context. So we have this context. And then this ID belongs to the ID of the habit. This is the ID of the habit. But that repository operation requires user ID as well. User ID is inside of the CTX, which we are going to get our shovel. So how do we get our shovel? Well, we have already done that. We don't need to type it out. There we go. This is going to give us that specific user ID from the context. But you can clearly see it returns nil here, but we need to return Boolean. So for this one, we are going to say return false. That's it. That's very simple to implement. Now, after this user check, after we have found out what the user ID is, let's call that habit repository method or operation which we just created, which is called delete habit, and pass in two things. The first thing is the ID of the habit. The second thing is the ID of the user. What is this going to give us? This is going to give us a deleted and error, and or error. What do? We first check the error. If error is not nil, then it means something went wrong. And what could go wrong? Well, it depends. So I'm going to return false, and I'm going to return the error. So whatever went wrong, we're just going to put it there. But then we need to also take a look at this deleted. So if deleted is true, everything is okay. Everything is fine. But if deleted is false, that means we were not able to actually delete this habit, because this habit, either it doesn't exist or it was already deleted. So for that, we are still going to return false, but we are going to provide a better message. We're going to say habit not found. We know for sure. If deleted is false, now keep in mind, why this? Because we handle this here. You can see this resolver says deleted is false, but there is no error. And that's exactly what we did here. So even though like we send this error string, by error what I mean is we do not cause this error is not going to cause the breakdown of our API. So we handle that gracefully. There we go. So that's why we pass it there. And in here, we're going to say return true. We're going to check this. Don't worry about it. And we're going to say nil for the error if we were able to successfully delete that habit. And now let's get rid of the function stub. There is just a handful of them remaining, and we're going to finish all of them one by one. Now that this is done, it's time for us to actually jump into the to the playground, and let's find out a habit to delete. Let's say I want to delete this meditation, which I know belongs to John. And let's go ahead and let's log in. Mutation, So there we go. I'm going to log in with the John's account. That's a big one. Let's copy that, come into the headers. That's going to be authorization. And I'm going to pass in bearer. I'm passing the token. Very good. So now that we are authorized, let's go ahead and let's actually delete this habit. And how do we delete this? Well, that is still going to be a mutation. So let me get rid of all of this. This is going to be delete habit. And what does delete habit require? See, it just requires one thing, and that's the ID of the habit. So let's take a look at the database. Let's say I want to delete this. Now keep in mind, we need to provide the ID of the habit, not the ID of the user, because ID of the user is included inside of the token that we provided as the authorization header. But we need to specify what the ID of the habit is that we want to delete. So this one, just right click, click copy, and then we're going to go to the playground and I'm going to paste it there. I'm going to click on this. There we go. True. That means habit was deleted. So if I come right here, refresh this, bottom right corner, refresh this. There we go. That specific habit is gone. Now keep in mind, I cannot delete a different habit because these IDs are unique to every habit. Now let's see if we can delete the habit that does not belong to John. So someone else's habit. Let's paste that there, send this, habit not found. If I get rid of the token, let me just cut it, send it unauthorized. So you can see every part of this is actually working. Now, as far as this delete habit is concerned, if you pass in the ID of a habit that doesn't belong to this user, or if you just pass in something gibberish, whatever, like this, it doesn't matter. Both of them are going to be treated similarly, because as far as this user is concerned, this thing doesn't exist as a habit. It doesn't exist. So let me just delete a few of these. So if I send this, you can see it says habit not found. And which path? It is the delete habit. So this doesn't exist for this user. Very good. Now let's, we actually got rid of that. Can I go back? There we go. So this is the habit that we just deleted. Let's run this again. Habit not found. And we know exactly where that error is coming from, right? So this is the deletion of a habit. I wanted to test something else because I didn't test that. I just remembered. Let's create a couple of habits for John, or for, I want to keep, you know what? I'm going to get rid of John and I'm going to keep Bob. So we have John that has only just one habit. Let's create another habit for John. So that's going to be create habit. When we create habit, we need to pass a name. That's going to be habit 2. I'm just going to say habit 2. Description, habit 2 DSC, description, lowercase d. Yeah, that's going to work. And then that's going to be create habit. And then we could return the name as well as the description. All right. So let's create this. Can only contain letters, periods, spaces. Oh, right. I can provide numbers. So if I get rid of this, if I say habit 2, but we should be able to pass in, that's because this name is the one, let me take a look at it. We're actually reusing this. So you can see everything, like anything could come up at any stage in which you're actually writing this program. Now, how can we actually do this? We need to actually sift through this because that was like a very long time ago that we wrote this together. So let's see. We have this first check that is for the length, again, length, again, length. Then let's go down. We have this if statement. So the error came from here. This is the error. It means there was something wrong with these that we threw this. So let's see. In the first one, we allow users to provide letters. We allow users to provide dots or periods, as well as empty spaces, as well as hyphens, as well as apostrophes. Here is the apostrophe. So if user provides any of these, we say continue, which basically means it is allowed. But if user doesn't provide any of these, we do not say continue, and then that is not going to be allowed, and then we're going to throw this error. So what we need to do is we need to actually create another if statement for number. So I think on this, so if I do Unicode dot, since it's digits, we're not talking about symbols, we're just talking about digits, right? About integers. So there should be a method among these. If you do dot, it says dash, so I'm just going to write digit. There we go. So here is the method. So if I select this, it says isDigit reports whether the rune is a decimal digit. And that's exactly. So we talked about how we actually convert these into runes and why we do that. I believe so we discussed that. But anyway, that's a different topic. You can jump into it. It's actually a data structure in Go. You can go ahead and read more about it and know why we convert to and from it. So now these two look the same almost. They're both available on this Unicode package. We have this is letter and then we have is a digit. So if there is a digit, we should continue. Now you can see so far we have made 2 adjustments to this. And that's the reality of writing code. There's always going to be adjustments. So this is the reason why it's important to know your code inside out. If you know, okay, I saw that even though this is a small code base, it's extremely small, it's extremely tiny, but still I have like authority over this. I know, okay, where I have written that error or where I've written something. So when something breaks, I know exactly to where to reference in order to fix that broken thing. So here, since I've added number after the letter, I could say name can only contain letters, numbers. I should have thought of this because someone could be like John the Second or whatever. I'm not sure if John the Second is written like in digit or 2 and then in D, whatever. But we should allow users to have like, if we're using this utility, especially for habits, they should be able to write habit 1, habit 2, habit 3. I mean, it's their free will, so they can write whatever they want as long as they're not attacking our database. Then they can write whatever they want. Okay, so now we have created this. Let's change this to habit 3 and let's test it. Is the server running? Yeah. Come right here. This is going to be habit 3 description. Run this and there we go. It is allowed. Now in description, we know that it was allowed because we didn't actually do anything in the description, anything crazy. We said, just some length stuff. Yeah, just some length stuff. And that's it. Not less than 10, not more than 250. We want to keep everything like concise. So here, there we go. We have 2 more habits. We have habit 2 and habit 3. All 3 of them belong to the same user. You can see they have the same user ID. Now, what we want to do next is we want to call the deletion of this user. And we want to see if once we delete this user, all of their habits are going to be deleted because remember, we have that pragma, foreign keys enabled. We used indexing, so we connected these 2 together. Let's go ahead and let's see. We have delete user. Now, I might have forgotten what then the structure of this mutation is. So I could just come right here, delete user. I don't have to pass anything. I just have to go ahead and just call this. So let me just get rid of that, get rid of this. I think this is it, right? We have the token. Let's click on it. True. So user was deleted. Now, first things first, I'm going to go to this. We shouldn't see John anymore. John is gone. He's no longer with us. So let's just click on this and there we go. John is gone. And now for the moment of truth. I hope it works. Let's refresh this. And there we go. Congratulations. All of these are gone. So to whom does this belong? 44AF. Is this Jane? 44. Oh, like for a moment, I thought, okay, 44AF was John. How is one of his habits remaining here? So, but no, lo and behold, it works. We don't have anything else. This belongs to Jane, 44AF. So BEBCE 44AF. BEBCE 44AF, Jane. There we go. We got rid of John. And now we can take a look at that inside of here as well. I don't have this. And we could say select everything from users. We just have Jane and Bob. And then we could say select everything from habits, which is just going to be traced to Jane. We know that this is Jane. Very good. So that that foreign key relationship also works. So when you're using this API, if you delete your user account, all of your data is going to be deleted automatically. That's good. That's very good. I really wanted to make sure that that actually has been implemented correctly. And now that these parts are done, we are effectively done with the second, I don't know, like with the next part of this API. So if you say that all of the setup that we did, that's part one, then you say what we did for user, everything we did, all the repositories, the mutations, the queries, the middleware, whatever, everything that we did there, that's part two. Then this is part three, because this belongs, all of these, they belong to the habit. We have the habit repository. We created, so let me get rid of these, get rid of this as well. We created these mutations for the habit. We also created, let me collapse this one. We created queries for the habit. So the third part, effectively, third part is also done. And now we are in the last part of this API, which is habit logs. So the idea behind these habit logs is that when you enter a habit into the database right here, we are going to create a new table. Like a new table is going to come right here. And that table is going to contain, as the main thing, it's going to contain the ID of the habit. And then it's also going to contain how many times have we implemented that habit. So for example, if my habit is to read every day, and the description says read for at least 30 minutes before bed. So this is my habit. This is something that I want to do. So how many days have I done this habit? How many days have I completed this habit? And then what were those days? So did I complete that on the 1st of June, 2nd of June, 3rd of June, 4th of June, and 5th of June? So you can see 5 days. I need to know how many days, and I need to know which days. So that's what's called habit logs. They're not user logs. They don't belong to user. They belong to habits. We need to be specific. How many times have we gone through with that promise that, okay, I'm doing this, and I'm sticking with this. I'm walking every day 30 minutes at least. I am reading every day 30 minutes at least. I am meditating every day 30 minutes at least. So like some ideas. You could write whatever you want, of course, as I said previously. So how many days have I done this? Now, in the first or 2 weeks, that's not like going to make that much of a difference. You can just tick mark a table or write it on a whiteboard. But after a year, I'm not saying it's not important. Those first 2 weeks are the most important days of any new habit. They're the most important days. They're going to determine whether or not you're going to go through with that habit for the lifetime of that habit. Okay, so they're very important. But keeping track of those first 2 weeks is easy. You can just write it on a piece of paper. But imagine after 1 year, you have like 12 habits or 15 new habits that you want to do, like these micro habits that you want to have. but then you want to keep track of these. Even if you have like 3 habits, after 1 year, that piece of paper is not going to be maintainable. So you can use this API. You can just write everything. You're going to get a neat table. Also, you're going to get calculations. So you don't have to calculate anything. You're going to see, okay, how many times have you gone through with that habit? What was the longest that you went and you implemented that habit without breaking your habit? So all these things is the job of this API. And the last part of this API is those logs. When did you implement that habit? How many days consecutively have you implemented that habit? So in 365 days, how many days have you actually went for a walk? Let's say 250 days. So what did you do for another 100 days or 115 days? So whatever. So this is what you can see. This is your own personal information. You can see, okay, where I can provide improvements. So that's what I'm basically trying to do, is I'm selling you on this habit logs, why we need this. Without this, you could use this API, but you can just, this could be like a to-do API where you just write your habits and delete your habits, but there is no accountability. But when you have logs, you're going to see them and you're going to have like a sense of, you could say pride or a sense of fulfillment. I shouldn't say pride. It's a sense of fulfillment that I've went through with this habit. I did it for these many days. I'm happy about it. I'm happy about myself. So this logs is, in my opinion, the most important part of this. This habit logs gives this API identity. It gives it something that actually makes sense. But up until this point, this is just a to-do API. It looks exactly like the one I did for the REST API inside of this playlist. So if you take a look at that, that was a to-do REST API. You just add something, delete something, update something, and read something. But we want to have this some sense of accomplishment. So that's why the next step for us would be to jump in and actually create migrations, which are tables for the habit logs. We need to create the model. So the structure is the same, the number of steps. Create the migration, create the model, create the repository, and resolver, repository, resolver, repository, resolver. And in between, we're going to add some calculations and then we're done. And now let's get started with the migrations. So the first thing that I want to do when it comes to habit logs is create 2 files. Where is our migrations folder? So it's right here. We could just make this a little bit larger. And we have here the migrations. I'm going to create a new file that's going to be all these zeros 3. The name of this is create habit logs table. And then what kind of a migration this is, whether up or down. There we go. And that has basically created that. And we just opened it. And I'm going to create the down migration for this one as well. Now for this specific migration, I do not want to implement or run the down migration. That's going to get rid of all of the users and the habits that we have created, but you're very welcome to actually go ahead and run that. Now, what do we do inside of the up migration? Again, the idea is the same. Inside of the up migration, we want to create a table for habit logs. And in short, what are habit logs? A log individual, a habit log refers to the date that the habit was completed. That's it. So what kind of information do we want for this specific table? Now, when we talk about the table, that means we are actually talking about the table name, also the table columns. So we want to create, so whatever I write inside of this, since the extension is SQL, this code is going to be SQL. We're going to say create table, if not exists. There we go. What should be the name of this? We could say habit underscore logs. Very good. So this is the table. Now, what kind of columns is this table going to have? The first one is, of course, it's going to be the ID of that specific log. Now, when I'm inside of the habit logs table, the ID refers to one entry inside of this table. And the entry inside of this logs table, one entry is one habit log. So that's going to be why we actually, that's why we actually provide the ID, so we can distinguish between different logs. It's the same concept for user ID, the same concept for habit ID, and now we have log ID or habit log ID. This is going to be primary. We have already talked about this, primary key. We want this to be automatically generated by SQL. That's why we pass in default. Then we need to do some conversion. So we did random, this was random blob 16. We converted that to hexadecimal. So that was hex. And then we lowercase this entire thing. So let me surround, surround this with lower. And then I'm going to select everything and I'm going to put it in parentheses. That's it. So this is the first column. And these are the conditions that we want this column to have. The second column is going to refer to which habit does this log belong to. Now, the relationship that the habits table had with the users table is the same relationship that this habits logs table is going to have with the habits table. What do I mean by that? So one habit was traced to one user. So these are two different tables. Habits table contains one record that is traced to exactly one user. Okay, now habit log is going to have one record that is going to be traced to its habit. So you can think of like, okay, user is the parent, habit is its child, but then the child of the habit is habit log. So you have these kind of relationships among these three tables. Very good. So what is going to be the next column? The next column is habit ID. Now inside of the habits table, so if you take a look at this, create habits table up, if you take a look at this, what was the second column? So the second column is the user ID because habit is an extension of user. The same way, habit log is an extension of the habit. So we just go one level deeper. Very good. This is going to have a type of text and this is going to be not null. We must have this. Now, this is going to reference, now keep in mind, this must reference something in another table. What is this habit ID? Where is this coming from? And this reference is going to connect this or link this to the parent table, which is the habits table. So we say references what? The habits table. Now, inside of the habits table, which column does it reference? It references the ID column inside of the habits table. And now, if I delete one habit, it's the same discussion that we had when we said if we delete the user, if the user deletes their account, we do not want to end up with orphaned records inside of the DB. We want to get rid of all of those records as well. We just want to delete them. The same conversation we could have here. So if we delete a habit, do we want all of its logs, all of its completed dates to be available inside of the database, which at that point in time, they would become orphaned records? Do we want them to be there? No. We want when the parent goes, so do the children. So when the parent is the habit that is deleted, in response to that, we are going to get rid of all of the records that belong to that habit in the table, which is called habit logs. As I said before, it sounds like horrible. It doesn't sound good. I know that, but these are like the terminology that we use here. So it's like easy to understand what we mean. So this is a term. We have orphaned records. If I get rid of the habit, but don't get rid of the logs for that deleted habit, I'm going to end up with orphaned records that belong to no one. So they're going to throw errors. That's going to make our database more difficult, way more difficult to maintain. Now imagine you delete your social media account, but you have had that, let's say, for 15 years, and you have just kept posting and posting and posting. Perhaps you have hundreds or thousands of posts there. Imagine 100,000 people delete their social media accounts, but on the database of, let's say, Facebook, you still keep all of their data. What is going to happen to that? So that's extra cost for database administration, that's extra overhead, that's extra maintenance. Now, the reason that it doesn't really matter if we keep them or not inside of this API is because this is a small one. But we always learn these concepts in the context of these small APIs, but then we apply them to larger and larger and larger applications or larger companies. So it's the same idea. We don't want to have them. Okay, we might give them 30 days for them to download their information, but eventually we're going to get rid of all of their information. So if user doesn't exist, the habits should not exist. And when habits do not exist, their habit logs must not exist. That's just extra cost, extra headache, extra errors. And imagine if there is terabytes and terabytes and terabytes of data that belong to no one, users do not exist, and you still keep them. Why would you keep that? No company does that, by the way. So what we do is we get rid of all of that, but I'm showing you how you can do that in the context of the small API. So when you see that in a team, like in a little bit bigger of an API or a larger API, you're going to know the concept is the same thing. It's just the application is larger. The application area, where we apply these, that's the context is bigger. But here it's smaller, but the idea is the same. So here we say on delete, and what was the keyword? It was cascade, which basically means if I get rid of one habit, since that habit has records or logs inside of another table, which is called habit logs, I'm going to get rid of those records as well. That's basically what on delete cascade means. And now you can see, whenever you see on delete cascade, you're going to know what this means. It meant the same thing when we created the habits table, and it means the same thing when we're creating the habit logs table. And it is going to mean the same thing no matter what kind of an API you're working on. It doesn't matter. The idea is the same thing. It's just the implementation is going to be a little bit different. Cool. Let's move forward. Now, these are some general things that we add to this table. The column, there should be a column for ID. We should have that foreign key relationship. But what else? Now we dive into this, the more specific parts of this habit logs. What kind of columns do you want this table to have? Well, it depends. What kind of data do you want to accept from the user? So if user enters logs, which are when the habit was completed or when they went through with their habit, so what kind of information do you want from them? Well, you want a completed date. When did they complete that habit? So we're going to say completed date. This is going to have a type, of course, it says date, so this is going to have a type of date. But do we want this date to be auto-generated by SQL? No, this is something that user is going to give us. User is going to tell us, I completed this on the, let's say, 1st of May or 2nd of May or whatever. So this is not some date that we are going to create on our own. This is something that user has to give us. We don't know when user completed their habit. Now, after this, I'm going to add, and that's the only thing, by the way, that user is going to give us. User is going to give us the ID of the habit. Perhaps we could formulate the resolver like this. And then user also going to give us the completed date for that habit, and then we log that or we register that inside of the table. So we have this completed date for when the habit was completed, but I'm going to add another date, and that's going to be for when we entered this record into the database, and that's going to be created at. Now, I'm going to emphasize on this that created at has a type of date type. This is going to be default. That means SQL is going to generate this automatically. And this is going to be current _ time stamp. Now you might be asking, okay, what is the difference between these two? So let's go over them. Completed date is the date that the habit was completed. For example, today is 6th of June. For example, one of my habits is that I want to go for a walk. I've been doing it for the past 3 days, and I did it today as well. I went for a walk for at least 30 minutes. So today I completed this new habit. That's the completed date, right? That's the completed date. But I have forgotten to register today's date. I have forgotten to register when I completed that date. So remember, the date of completion is the 6th of June. It's today. So I'm going to say June 6th. That's when I completed this habit. But let's say I get lazy and I do not write this in my notebook. That on Saturday, 6th of June, I completed this habit. I write that inside of my register 2 days later, June 8th. What is the difference between these two? Now, no matter when I write that when I completed the habit, it doesn't matter when I write it, after 2 days, after 1 week, after 6 months, the completed date of the habit is not going to change. It's that when I actually pick up my pen and write it in the notebook, that's going to be the date that it changes. All right, so I hope I was able to explain that. So when you create the record inside of the database, it could be on the same day. So I went for a walk, and as soon as I came back, I took a shower and I just cracked open this API and I just entered that into the database. So in that scenario, the day that I completed my habit is the same day that I entered the completion of the habit into my database. But if they're not the same day, then it means maybe I got lazy, I did that the next day or 2 days later. So that's why we need to have 2 days. Created at refers to when user gave us that query, when user entered their record into the database. But completed date has nothing to do with the created date. Completed date is when the habit was completed. For example, I remember writing that in my notebook that for the first 10 days of the month of May, I went for a walk. But then I didn't go for a walk. Maybe I went for 20 minutes or 25 minutes, but I didn't go for a walk for 30 minutes, okay? So I remember that because I've written that on my notebook, and then I want to enter that into the database. But a month has passed. So the completed date of my habits is going to be May 1st to May 10th. But the created at dates inside of the database, that's going to be June 6th or June 7th or 8th or whatever. So that's why I try to explain that in a couple of different ways. I'm pretty sure you understood that. Completed date, when the habit was completed. Created at date, when we receive that query from the front end that user wants to enter their data into the database. So that's the difference between these two. Now there is something else that I want to add here, and that's going to be a constraint. So this is actually called a unique constraint because for one specific day, we are not going to allow users to provide 2 logs for the same habit. So in one day, I am only expecting users to implement their habit once. If they do it more than that, that's up to them. So going for a walk for 30 minutes a day, if I enter that into my database for today, I'm not going to be able to do it again. I'm not going to be able to, I could go for a walk again, but I'm not going to have a duplicate record for the same habit, for the same date. Okay, so going for a walk, on the 6th of June, I entered that into my database in the habits log table. I cannot enter that for the same day. And when tomorrow I go for a walk, then I can enter that again. So one habit is going to have 1 log per day, not 2 logs per day, because we want to limit this. So if we have 10 different times, then it's going to be very difficult for us to calculate this, and it doesn't really make sense. We just want users to go through with their promises for that day. If they just do it once, that's enough. But if they do it more, It doesn't matter when it comes to our database. Okay, we just enter that once. So that's going to be the habit ID. That's going to be the differentiating factor. So for one habit, for one day, you can just have one record. And for one day is inside of the completed date. And this is actually called a composite unique constraint. The reason that we do not provide these constraints individually is because the same habit ID could appear for different dates, 4th of June, 5th of June, 6th of June. And the same completed date could appear for different habits. So if you have 5 habits, you complete them, all 5 of them in one day, even though they are different habits, their completed date is going to be the same thing. So that's why we put these two constraints together. We make a composite unique constraint. And this is the only way that this is going to work. Only the combination of the same habit on the same date is forbidden. We're not going to allow users to do this. All right? And this composite unique constraint is going to enforce exactly what we want. It is going to reject a row when both habit ID and completed date match an existing row. So if we have a row for, let's say, habit ID, which is 10, on the 6th of June, we're not going to have this row repeated again. That means if we would have that, that would mean that user wants to create a log for the same habit for the same day twice. That's not something that we're going to allow. You can just do it once inside of the database. You could go for a walk 10 times a day, but you can record that, write it inside of the DB just once. We're not going to have duplicate ones. Now, there is a couple of indexes that I want to create. We have already talked about this. The first index is going to be on habit ID for fast lookups of all logs belonging to a habit. And the second index is going to be for completed date for fast date-based sorting and filtering. So we have already talked about why we actually go ahead and we create indices, what this indexing actually means, the idea behind this when we created the habits table. And in short, it is just when we want to find out what are the logs for one specific habit, it's easier, it's going to work faster if we have like this indexing. That's going to be, so every time we would go from the top of the table to the bottom of the table if we do not have this index, but if we have this index, that's not going to happen. The way it works is that, so if you don't have this indexing, we're going to scan the table, this habits log table from top to bottom. But if you have created this index, what SQL does is it's going to jump directly to the matching rows because you have actually created this relationship. So that's why we actually go ahead and make these indexes. So this is going to be create index if not exists. There we go. Now, what is going to be the name of the index? There is some convention that we need to provide IDX. That's going to be habit underscore logs underscore. So this is inside of the habit logs table. It's going to be referred to the habit ID. Now, what is this index going to be created on? It's going to be created on the habit ID. So inside of the habit logs table, we have a column that's called habit ID. So this is the first index, and the second one is for the completed date. So if you want to take a look at the completed dates for one specific habit, you should be able to do that fast as well. So I'm just going to copy that. We have create index if not exists, IDX habit logs. That's not going to be habit ID. This is going to be completed underscore date. And that's going to be habit logs on the completed date. And we need this completed date for the streak calculations as well that we are going to do in this last part of the API. But we are going to come back to these. Now, we are basically done with all of this. Let me provide a semicolon there as well. So this table is done. Let's go ahead and let's destroy everything we have created. So the first thing that we do is we first drop the indices, then we drop the table. Okay, we just want to be thorough and go step by step. So I'm going to say drop index if exists. I think create index if not exists. Yeah, that's correct. So drop index if exists. And what is the name of the index? I could just copy it from here. This was, we created this index last, so we are going to drop it first. That's going to be there. I'm going to copy this. We are going to go to the next one, index habit ID, and provide some space. And finally, we're going to say drop table if exists, and the table name is habit logs. And there we go. So what should we do next? We need to run these migrations. So I'm going to go to the terminal. Let me kill that one, kill this one. I'm going to create a new one. I'm going to zoom this out, clear all of this. I'm going to say migrate. Okay, we need to go to scripts. So scripts migrate PS1 up. I'm going to run this. This should create the habit logs table. There we go. 3U basically means migration number 3 ran up the file. And it just took 9 seconds. Quite fast. So we have SQLite. Let's go databases. We say .tables. So there we go. We have habit logs, habits, schema migrations, and users. Let me open up Beekeeper Studio. We should have the same information there. But until that is opened, you can take a look at the schema structure for any of the tables. So if you just type habit underscore logs and hit enter, there we go. So you have an ID column, habit ID, completed date, created at, and unique. And you have your constraints as well. Let me just click on that. Now, if I just open this, there you go. You have habit logs, which I'm going to open up there. Here are the columns, the ID, the habit ID, completed. So there is no typo, right? Completed date and created at. Very good, very good. But we don't have anything. So one record, so the records of this habit logs, they're going to be traced to habits, and the records of habits are going to be traced to users. So if you delete a user, it's going to delete all of their habits, and all of the habits that have habit logs, the logs are going to be deleted as well. So this is like this. So this table is connected to this, and this table is connected to this using foreign key relationship. Very good. We could take a look at the pragma foreign keys as well. I'm going to show you how you can do that. You're going to write pragma, and then you have foreign underscore key underscore list, and then you pass in habit underscore logs and terminate this, run this, and there we go. So you have the table, which is habits. There we go. From habit ID to ID, and so it basically says on delete cascade. So you can take a look at what this actually means. On delete cascade says what happens when we actually delete this. So this is fine. This is very good. Now the next thing that we need to actually go ahead and do is create the habit log model. And how to create the model? Well, let me first close these two. Let's jump. Where do we have the other models? There we go. So here is the models that we have created. And we have already talked about what the idea behind these is. Every model in Go, it is going to represent, this model is going to represent how our data is going to look like on the DB. So we need to know what we received from the front end. That's going to be the JSON tag. We need to know how we can trace it to that specific column into the database. So this is where we connect these two together. We had one for users. We have talked about that extensively. We had one for habit, and now we have one for the habit log. So let me just go, where is it? Right here. So I'm going to right click on this models, create new file. That's going to be habit_log.go. Since we are already inside of the models folder, this is going to be a model, and this is going to be the simplest of all of them. So a habit log is going to represent a single check-in. So when I say, first let me just import the package. When I say check-in, I do not mean chicken, the bird, right? So check-in, chicken, that's why I'm pausing there after saying check-in, which I shouldn't pause. I should just say check-in. But these two are like different. This is the bird, chicken, and then we have chicken. Perhaps I'm pronouncing them in the same way, but they're two different things. One is a name, the other one is a verb. Check-in is a verb. So for every habit, we are gonna have check-ins. The reason that I wrote this is because this check-in is going to be the literal name of our repository operations and our resolvers. So that's very important to keep in mind. For now, I'm going to close this habit repository. I don't think we're going to need this. If we needed that, we're going to open that up. So a single habit log, again, it represents a single check-in record one day that the user has completed a specific habit. So each row in the habit logs table is going to map to one habit log instance. All right. I want you to keep that in mind. And something else is that if a habit log is created, it's going to be immutable. You're not going to be able to change that. So you can change then your username, your email, your password. That's user information. You can change habit information, the name of the habit, the description of the habit, but you cannot change any field inside of here. So once you have entered that record, it's going to stay there. All right. So that's something that these are some things that I wanted to point to. So we have habit log. This is going to be a struct because struct is like the most efficient data structure for these kind of things. So the first thing is going to be the ID of that specific log. So I am trying to say user, habit, and then log. So when I say log, that means I'm saying habit log. So I'm referring to a single check-in for one specific habit. Instead of saying habit log, I'm just going to say log. So this is the ID of the log. We need to provide the strings. So the JSON string is going to be ID, but what about the DB string? Which column does this capital ID map to inside of the database? That's the ID column. Then we have the habit ID. Remember, that was the second field. And the type of that is string. And I could just copy this, put it right here. So the JSON string, what was the JSON string? It was habit underscore ID. And then we have the DB tag was also habit underscore ID. Let's go to the completed. First off, I'm going to change these two. This is completed. What did we call this? Complete or completed? We called it completed. And this is going to say, we're going to capitalize this. So completed date. Very good. And finally, we did talk about that created at, right? When the log was created, as opposed to completed, when the log was completed or the habit was completed. So these two, Control D, this is going to be created underscore at. That's the DB and the JSON tags for both of them. That's it. So log was the simplest of all of them because it's immutable. We don't have any information that we can change. It's just we are trying to log one record, and that is the main one is this completed date for when the habit was completed. So that's why it's simple. Now, we have created this model, but what we need to do is we need to actually go ahead and run that GraphQL server again, the generation of the server again. And the reason for this is because of that auto bind setting that we have in gqlgen.yaml file. We have talked about that extensively. We want the YAML file of the GraphQL gen to find this habit log struct. And we wanted to use it instead of generating its own model.habit-log. So if I come right here, I could show that to you, of course. So let's take a look at this log. Which one? Create, check-in. Yeah, there we go. So this check-in habit. That's the day. That's going to be the mutation resolver that we're going. You can see it's a mutation resolver that we're going to use to enter one record inside of the habit logs table for when the habit was completed. It's called check-in habits or check-in habit. But what is the return type of this function? It's model. Model.habit-log. But our model is not inside of this folder. See, it says model, it's singular. Our folder is models. Models, then habit-log. So it's not using the model that we have created inside of the models. It's not using this model. We wanted to use that one. So for that reason, we need to run that generate command again. And we know what's going to happen. It's going to populate this entire file, and then we need to remove all of the already implemented resolvers. We know that, right? We already did it. So let's do it again. That's going to be go, run, and there we go. This is the command. This is the command. And if I'm not mistaken, I've provided you with this command inside of the habit streak tracker setup guide. That should be inside of here. So the easiest way is just do Control F, generate, and we have 19 times we have that generate. So you can just click on this. Let me see if we have that specific command here. It says, what do we have before it? So let me go there. GQL. You could select this entire thing, or it's GQL. So you could do this as well. GQL gen hyphen. And then you have like 6 different types. There we go. It's inside of this habit streak tracker setup guide. There we go. This is the command that you run. 99 designs. It's the same command. So I use Control F when I'm looking through like specific like .md. I work with markdown files a lot. So when I'm like working with these and they're like too big, I just use Control F. That's easier. And you can use that inside of any code that you want, any file. So we're going to run this, and it's going to take some time until it runs, and it's going to create all of those function stubs again. And it's going to make sure that it uses the models dot whatever it was, like the habit log. So now you can see we have all of these issues because we have already implemented these, right? So wherever we have these duplicate ones, we're going to get rid of them. Take a look at this register. See, it's our implementation, which you just copy pasted here. So we need to get rid of these. I'm going to collapse them, and I'm going to get rid of them in one strike. There we go. How many are there? So now let's select all of them. Let's go up until register, backspace. Very good. We have the me. So these are, when you see these are all the resolvers that we have already implemented. All of them. And let's save this, and there we go. So how many resolvers are left? We have the current streak, longest streak, logs, user, habit, check-in habit, delete habit log, habit logs. That's going to load. You can see we are differentiating among them with types. And this is the user resolver for all of the habits. We have created that, and we have the updated at. Model.user, user resolver. We have already implemented these, haven't we? Yeah, we have, right? So if I go to here, where am I? User.go, we have these two, right? So I need to get rid of them. And just save this. What else have we implemented? So the ones that say not implemented, we have not implemented them. But the ones that do not say that, we have already implemented. So these are all the ones that we have not implemented. We're going to implement them one by one. So this is like a much bigger API than the first API that I created in this series of Go, gqlgen, and then whatever the database that we use in this Go series, getting good at Go. Now, what do you think is going to be the next step? Well, the next step is going to be the first repository operation that we use. So the first one, the first repository operation is going to be for the duplicate ones. So before we are able to enter any logs into the habit logs table, we are going to actually try to check if this log has already been entered or not. Because we have created a unique constraint, remember, we created that composite unique constraint on the habit ID and completed date in the database. So if a duplicate is inserted, the database will reject it with a constraint violation error. And you might be asking, okay, we have not entered anything. Why should we check for duplication? Well, there are two main reasons for it. Reason one, it's going to allow us to write our error messages better. And reason two is separation of concerns. So duplicate log is going to be something that is just a pure read operation. But creating habit logs, they are pure write operations. So if I'm working on a pure write operation, like something I'm writing inside of the database, it has no concern checking for duplicates or having that code inside of it. So we first have that duplicate. So when user enters something in the database, we are checking that even if it is the first record. So now that we know this, this is just a something that the way that I'm going to go about this. Of course, you can change this. You can create the check-in habit first and then create this. But this is how I'm going to go about this. So we have the resolvers here. We have the repository operations. These repository operations are responsible for communicating directly to the database. Now we're going to create the third and the last one. That's going to be habit underscore log underscore repository dot go. So we had the user repository, which contained all of the repository operations that talked or communicated with the database in regard to user. The same went for habits, right? We talked about them. And now we have habit log repository. Very good. So what is the first one? First off, we need to import this repository. The first one is going to be, before doing all of this, remember, if I go to the habit, what did we do? We first have to reference that. We first have to create the repository struct itself, put it inside of this resolver.go. So connect it to the main resolver. Now, this main resolver type, it has three children. It has the user repository, the habit repository, as well as the habit log repository. So we need to connect that there. Then we need to connect it to the main server using that factory function that we are going to create. So we're basically going the same way. I could even just copy this code. We have talked about this extensively. This is not going to be habit repository. This is going to be habit log repository. Very good. Save that. We are referencing that database pool, that connection pool. Very good. This is no longer going to be new habit repository. This is going to be new habit log repository. And now you can see how these names are really important. Okay. And they have the same structure. So here, what we need to do is this function is going to reference that. So I'm going to pass it there and I'm going to pass that here as well. And that's it. So this is that struct that talks to that connection pool. This is the factory function. So we just need to change and invoke factory function whenever we use this. And after this, we can come up with the very first repository operation, right? So after the creation of the repository operation, then we are gonna add it to this habit to this resolver and to the main function, to the main server, right? Which is a function. So what is going to be the first repository operation? First off, we need to know what this references. This references the habit. Does it reference the habit repository or habit log repository? Well, habit log repository. Then the name of the repository function, that's going to be check duplicate log. We check duplicate log. Very good. If I want to check duplicate log, remember that constraint? What kind of information did we pass there? We passed in the habit ID, that is going to have a type of string, and the completed date. So the constraint was on this. The type of this is time.time. What is this going to return? This is going to return bool, because we check, okay, did we find duplicate or not? True or false? And another reason for working with Boolean values and returning them as function return types is because they are very, very normal expected business outcome. They're not like unexpected failures. For example, in this function, when we say bool, it has only two values, aka two outcomes, either true or false. So if we return true from this repository operation, that means a log already exists, aka duplicate. But if we return false from this repository operation, that means the log is unique. It is not duplicate. So in either of these conditions, true or false, we do not want to return some kind of an error indicating, okay, that the server broke or the database broke. We want to return a friendly error. So if record exists, we just return a friendly error. If we end up with a duplicate record, our API should not break. We should be able to handle that. So that's another reason for why we use Booleans. And now you know if Boolean is true, what we are going to return. If Boolean is false, what we are going to return. So the first thing that I want to do is I want to actually give this completed date a very specific format. And the reason behind this is it's going to have something to do with the way SQL reads times. So what we want to do is we want to format this completed date to a date string before querying. And you might be asking, okay, why don't we just pass in this time.time directly to the SQL query? Well, the problem with this is, let me just give you an example so you can really understand what I'm talking about. SQLite date column actually stores the data like this. So it's going to be like, let's say 2026-06-06, and then it's going to have like a T in there, and then you have the hour, let's say the minute, whatever the minute is, and then the second, which is going to be like that, and then you have the Z, and that is going to be capital. So this is the way SQLite's date column is going to look like. But the stored date that we want to accept from users is going to have, so the stored date is going to have this kind of format. So let me just put it beneath it for the same date, 2026-06-06. These two are different. So that's why we need to come up with like a universal code, with a universal kind of date, right? So that's why I'm going to format this, and I'm going to explain this further as well. So I'm going to have completed date, and on this I'm going to call format, and I'm going to pass in a specific format. The specific format is going to be this, 2006-01-02. And I'm going to store this inside of a date stir variable. 2006 basically means that it's a reference year for Go. It's a reference year for Go. It means it has 4 digits. 01 is a reference month for Go. For this, like for Go, by Go, I mean Golang, right? It's a 2-digit month, and we have a 2-digit day. So effectively what we are saying is, let me just write that there. What we are saying is this. We want this to be converted into this. That's it. That's what we want that's what we want to happen. So it's readable enough for us. Okay? So that's why I'm doing this. I didn't jump into too much details. You can always jump into like further details about these date types. And now that we have formatted this completed date, what are we doing inside of this check duplicate lock? We are looking for if a record already exists for duplicate records. And we have two common approaches for checking if a row exists. We could use count and we could use exists. Now I'm going to go with count because that's the simpler and more readable syntax. And since this video is for beginners, it's going to be very easy for, especially if you have like no prior knowledge of SQL, that's going to be, count is going to be easier to understand. And we have worked with exists a lot, and I want to show you some other way of working with the database as well. Another reason for that is because of the composite unique constraint that we have implemented. Count can only return 0 or 1 for this query that we are about to write. All right. So the syntax is going to be something that we have not actually talked about before, but I'm going to go ahead and I'm going to explain what that syntax actually means. So the first thing is I'm going to create a variable that's going to be count. The type of this is going to be integer. So this is going to have initially the value of this is going to be 0. So this could be 0 or this could be 1. Now, let's go ahead and let's write that query or that SQL statement that is going to check if one row exists more than one time. So how do we do that? We say r.db.queryRow. We're going to work with query row. And inside of here, so this is the statement for SQL. We're going to say select, and then I'm going to pass in count, which is going to count, which basically means this is going to return exactly one row, the count value. All right. Now we use query row, not query, because we always get back exactly one result. And since we want this count to count all of the rows, I'm going to pass in the asterisk. Now this asterisk has nothing to do with Go code. This is SQL code. So whatever we write inside of these quotes, that's SQL. Okay, I just wanted to emphasize on this point. Now, we want to count all rows from where? From the habit logs table. So I'm going to say from habit underscore logs table. Now, what is the counting criteria? What is the matching criteria? Well, remember, we have two conditions. We have two matches or two criteria or two constraints that we want to look at. The first one is, so we need to write where. The first one is the habit underscore ID, which is going to be this question mark. We have already talked about this. And the next one, which is completed underscore date. Now, we say habit underscore ID because, again, this is SQL. SQL talks to the database, and the column name inside of the table is habit ID. The same goes for completed date. And here is the completed date. Now we need to pass in the habit ID from the function parameters, as well as the, now do I pass in the completed date? No, I pass in the date string that we have created together. And now what do we do next? Well, the next thing for us is to actually go ahead and scan this, whatever the count returned, which is a number, which is an integer, into the count variable. So we just use scan method, and we put that, the reference of it, into the count variable. So that's going to be $count. Now, this is going to return an error, and I'm going to store, if it returns an error, I'm going to store that there. What is going to be the error? So if error is not null, then this means we are going to return false for that, for this function, and we're going to return the error. That's going to be error F. What was the error? We can say failed to check duplicate lock. And then that specific thing that went wrong. We pass that here. And okay, so, oh, this is E uppercase, this should be lowercase. Very good. So now if everything went well according to plan, count contains some kind of a number. It's either 0 or if it is greater than 0. If it is greater than 0, that means we found a duplicate, right? So we can say if count is greater than 0, if count is greater than 0, if this condition holds true, then we are going to return true from this duplicate log repository operation, and that means this record was duplicate. But we still do not throw any errors, right? That's the job of the resolver in that scenario. There we go. But if this count greater than 0, it returns false. That means this record is not duplicate. And still the error is going to be nil. Okay, so that's it. I explained this a little bit more because we talked about something that we have not talked about before, the format of the completed date, this count. But the idea behind this is return true, this record exists, return false, this record does not exist. Now that we have created the first repository operation, it's time for us to actually put this habit log repo inside of here as well. So what is this going to be? This is going to be habit log repo. That's available on repository.habitlog repository. There we go. Now we need to connect it to the main server file. Let's go there, main, and how did we do the other two? We could just copy paste that. So this is habit log repo, and this is available on the repository habit log, new habit log repository. We need to pass in the connection pool there, and we need to reference that here. So this is habit log, and this is habit log repo. Save this. There we go. So we were able to wire this up. And now let's jump into the next step that we are going to actually complete here. So we have this repository operation. We created that so we could check duplicate ones. Now the next thing that I want to do is actually be able to create a habit log. I mean, we should be able to do that, right? So that's going to be the next thing that I want to do. And that is going to be a repository operation as well. And this habit log record insertion into the DB, that should be very easy for us to implement. We have already implemented like all of this in some capacity, some way or another. So there isn't like much new code that we want to enter here. So let's get started. The first thing that I want to do is I'm going to have this as type habit log repository. What is the name of this? We're going to say create habit log. What kind of information do we need? We need to have the habit ID. The habit ID that is going to have a type of string. Now, what information is user going to give us? That's habit ID as well as the completed date. The type of this is time.time. What is this repository operation going to return? It's going to return one habit log. That's going to be models.habit log and or error. So what do we do here? First, let's go ahead and let's calculate the current time, because we want to be able to actually go ahead and whenever you enter a record into the table, we need to know when that record was created. Aside from the idea of when the habit was completed, we need to know when the record was inserted into the DB. That's going to be time.now. Now, before moving forward, I want to explain one thing here, and that comes, we have already did something here that was the completed date.format. The reason that we did this was because the SQL column is going to contain this. When we say completed date has a type of time.time, this is time.time. But what we want to store as data is going to be this. We want to get rid of this time component that's inside of this. And we just want to get this date, the day, the month, and the year. That's what we are interested. So one way is to do this, and this is this works in most of the cases, but if time zone is different, this could throw some issues. So for us to be able to do this properly is for us to actually do something that's called truncate time. So how do we do that? I'm going to explain this to you, and then we're going to go ahead and we are going to do that for the check duplicate log as well. So I just noticed this, and I wanted to, I thought about this, and I wanted to actually show you, okay, that's the better approach. You could do this, but this is the better approach that we can go about this. So we have this completed date. We know what this is. We know how this looks like. It looks like this. That's the completed date, but this is not the date that I want to store inside of the DB. I just want to have the day, the month, and the year. That's it. So the first thing that we do is we normalize all times that we get, we convert them into UTC. That's like we first convert all time zones that we receive into a general one, which is this UTC time zone, to ensure consistency in the time zones. After this, we get rid of the time part by truncating that. So how do you get rid of the time part? You need to, as this truncate function says, we need to pass in a duration. Duration is that hour, minute, second of the day. So if you do 24 times time.hour, this is going to give you all of the milliseconds inside of one day. And we truncate all the milliseconds from one day, and what we effectively end up with is, it would seem like this. We just delete that part, and we end up with this date. So this is like a programmatic way, more intentional way of going about this conversion of this time.time into just a time string that contains month, day, month, and year. So we have effectively, let me just copy this, we have effectively converted that above into the below. And I'm gonna, well, in here, we just get that truncated part. In the next one, in the next step, we will have actually been able to do this. So this is, I could call this truncated. And then I'm going to say date string or date string is equal to truncated dot format is this. So I'm going to pass in 2006-01-02. And I do encourage you to go ahead and read about this 2/1/2006, because this is the reference that you must pass. It must be exactly this. You can go ahead and read about this. That has a very interesting history behind it, but I'm not going to dive into that. Let's just move forward. And since we are trying to create a habit log, we need to have an ID for it as well. Much like user, much like habit. So I can say var ID that has a type of string. And how do we create an ID for this? We are going to say r.db.queryRow. Where is the ID? Well, the ID is inside of the DB, right? So how do we select that? We select, what were the conditions? Lower. And then inside of the lower, we had hex. Inside of the hex, we had random blob 16. So this is going to be scanned into, so scan into the ID. Where is the ampersand? There we go. This could return an error, and we are going to take a look at that. So that's going to be error. If error is not nil, what does that mean? It means we were not able to generate the ID. So I could say fm error f, fmt, I'm going to say failed to generate log ID. And then that specific thing that went wrong. And here is the error. And if this process was successful, what do we do next? Well, if we have generated the ID, what do we do next? The next thing that we do is we actually try to execute a command on the DB. And how do we do that? We have r.db.execute. And to this, we need to pass in that command, right? We are going to say, now, what do? We want to insert something into the DB. So I'm going to say insert into which table? Habit underscore logs. What do I want to insert? Well, I want to insert the ID, the habit underscore ID. Now keep in mind, I'm selecting the column names. What do we have next? We have the completed underscore date. So it's the same thing that we did for habit and for user. We have the created underscore at, and then these are going to have their values. So we have 1, 2, 3, 4. So we need to have one question mark, the second one, the third one, and the fourth one. So 4 values for 4 different columns. Now, we need to actually provide these values as well. The question marks are placeholders. This is the ID. Now, these should be in perfect order. ID of the log for the ID column, habit ID for the habit underscore ID column. We have for the completed date, remember, we created this date string for that. And finally, we have the created at. That's now. The reason that we do not truncate this is because this is just referring to when this record was created on the DB. So if we could take a look at an example of that. So if I come right here, if I go to the habit to the habits, so this habit was created on this date. Now, you cannot do anything to this habits table that is going to change this date. You cannot do anything. This date is always going to remain. But if you change some information about the habit, the updated add date is going to change. But this created is going to stay here. It's immutable. You could delete this, of course, but you cannot change this. That's when we created the habit inside of the habits table. But then you update the habit, this date changes. So when you create a record inside of the habit logs table, that's when this created at is going to store that date. And that's why this is independent of the completed date for the habit itself. All right. One refers to when the habit was inserted into the DB. One refers to when I actually went out and I went for a walk. So that's what we do here. So whenever you enter a record into the DB, that time is going to be this current time, that exact specific time that you enter. That's why it says time.now. And we don't care if it has like minutes, seconds, whatever. We actually want it to have that. So this returns a SQL result, which we don't care, but it also returns error if there are any. Now for this error, we have already done this before. We say if error is not nil, that means there could be a possibility that that unique constraint is actually violated. So we have if strings dot contains, and what does it contain? Error dot error. And what is the error? It's unique. So it's unique constraint failed. Very good. So unique constraint failed. What else do I have here? If unique constraint fails, we return nil. That means we do not create the log. And then I'm going to say, if unique constraint fails, what does that mean? It means you're trying to create a duplicate log. So I'm going to say you have already checked in for this habit today. Very good, right? So let me take a look at this. Should we say you have already checked in for this habit today? Because let's imagine May 1st. So that was like a month ago. Depending on when you're watching this, that's a date in the past, May 1st. So if I've already checked in for that habit on that day, and after a month, I try to check in for the same habit on May 1st, and I receive this. You have already checked in for this habit today. Even though it's a month later or 6 months later, it's not today. It's for this day. Sometimes it could be today. Sometimes if it is in the future, it's not today. So this, we could come back to this string when we try to duplicate this. But then, I don't know, it doesn't seem okay. I should, today, you have already checked in for this habit today on this date. You know what? I'm not going to read too much into it. I'm just going to leave it there. You could always change that. But if there is any other error aside from the constraints, then we are still going to return nil. And we are going to give users a general context error. That's going to say failed to create, habit. Well, we couldn't create the habit. And there we go. Here is the error. What specifically went wrong? Oh, the reason that we have this error is because why do we have this error? What is wrong here? No new variable on the left side of this error. Oh yeah, this is not a new variable. Very good. So it told us. Now, what if we don't have any errors? We actually were able to create a habit log on the DB. Now remember, the way users know for sure that they were able to create a log is if we show them that log again. So they create a log on the DB and they get back that same log. So here we created that log on the DB, then we need to read that immediately and show it to the user. Again, it's the same example. So you create a post, you click post, the post goes into the database, it is stored there, and you immediately see it back. So these are like two different operations. One is a write operation. This is a write operation. And once you see that post again on your profile, that's a read operation. So these two are completely different operations. For the read operations, since we just want to show users one row, that's going to be query row. And select is a read operation. Insert is a write operation. What do we show? We show the habit, the ID of the log, the ID of the habit to whom or to which this, no, I shouldn't say whom, to which this log belongs, the completed date. So I hope you got that. We do two things. We put it in the database and we show it to the user at the same time. It takes like a few milliseconds. So we first put the log in the database and then we immediately get it from there and show it to the user. So user knows, okay, I was successful in writing this post or posting this picture. And ID, habit ID, completed date, as well as created at. So we select all columns from habit logs table, where ID is this question mark. So ID is the determining factor, the ID of the log. So if you give me the ID of the log, I'm going to know, okay, which log it is you're talking about. Then we have this scan method. Now I didn't create the variable or the struct that is going to contain that log. So you can see, as you see this, you know we did the same thing for user, we did the same thing for habit, and now we do it for log. And if we had any other part for this API, any other part of the API, we would do the same thing. So we create this log that has a type of model.habit log. Then we populate this. This is models.habit log. And how do you put data inside of it? We use the scan method, remember. So we select, we reference the log and we put the ID there. Now, since here, this habit log, if you hover on it, what does it contain? It contains the capital ID, capital habit ID. completed date. Now we used, as I told you, like this is where we connect the DB with the JSON. DB is on the backend, JSON is something we send to the user. There you go. Using this struct, using this model that we have created. That's why it's very important. But inside of the model, we don't have lowercase id, we have uppercase id. And then I have habit ID, see, I have autocomplete. Then I have completed date, and finally I have created date. There we go. So we scanned it into this, but this process could return an error. This could have some kind of an error. So the error is going to be right here, double R. What happens if error is not nil? Well, what is it that we're trying to do? We're trying to get data from the DB. We're trying to receive or retrieve data from the database. So I'm going to say return nil for that log, and fmt.errorf failed. We weren't able to receive data or get data from the database because query row just gets data from the database and it gives it to scan. Scan puts it into the log struct, and we send log struct to the front end. But if this process is not successful, we could say failed to retrieve. Again, this retrieve, I always forget how to, whether it's IE or EI, created log. There we go, %W. And then we need to pass in the error. So that's if this process was not successful. But what if we get that log? Then we send the log to the resolver. And that's a pointer because the resolver is going to expect that. We send the memory address of it. Okay, so let's save this. That's it. That's for the repository operation. That is going to create a new habit. A new habit log. That's going to create a new log for us. And now what we need to do is we need to actually go ahead and create the resolver for this. So if I take a look at these resolvers, you can see we have this. We need to have to, let me see. Current streak, longest streak, logs, user habit, check-in habit. Okay, we don't have them here, but we need to actually create inside of the resolvers. I'm going to create a new file that's going to be habit_log.go. That's going to contain what we implemented here. So this is the habit. We did created that and updated that for the habit. But for the habit log, we have the completed date as well as the created at date. So we need to actually do that here. So this is going to be package resolvers. That's going to be extremely simple for us to do. That's func. Maybe I've gotten rid of it during this process anyway. That's going to be, so this is the habit log resolver. Habit log, there we go, habit log resolver. We have the completed date. Completed date must contain the context dot where is my context? Context, very good. And then the object that is going to have a type of models dot habit log. What is this function going to return? Here we're basically, what we're doing is we're converting the time into a string. So we have already done this twice. Object dot obj dot completed date dot format. What formatting criteria did we use? We said time dot RFC 3339. And then we know that this process is highly likely to be successful. That's why we're just going to return nil for the error. What say you? Undefined. Object dot completed date dot format time.rfc. It is defined. Format. Let me take a look at this again. Dot completed date. Why don't I have this? This should be available here. Let me pass that again. Maybe something was wrong with this GQL generation of this. At this point in time, I'm not sure, but let's first move forward with this. This is going to be created at. We don't have that defined there too. Object.completedDate.format undefined type string has no field or method format. Is this type string? Completed date type string. Let me jump into the habit one. This is time.time. Created at. This is also time.time. So if it is time.time, why do I have to actually convert this into string? We don't have to. Created at time.time. Here it says it's type of string. Let's take a look at the model, habit and log. So here you can see it's created at and updated at. It has types of time.time and habit log. These should not be strings. These should be time.time. Time.time. Yeah, that's a mistake on my part. Save this. Both of these should be time.time. That's perhaps the reason GraphQL has not created them. So that should give you like a hint. If the stub doesn't exist, there might have been some issue with that. So now if I just close these, this is habit.go, close that. Habit.go, close this one as well. Now you can see it has time.time. It should be okay. We shouldn't worry about this. It should be okay. Once we write that mutation, then we are going to know, okay, if this thing has worked and if we were successful in this. And yeah, everything is fine. So I'm going to close this. We have this habit log repository where we created two repositories. Let's go to the mutation. The next mutation is going to be to create one single habit. So it's going to be this check-in habit, which has a type of mutation resolver. Copy it, put it right here. And then we need to actually go ahead and create this. This is going to be extremely simple. The first thing that we do is we extract the user ID. So I'm just going to copy it, put it right here. We know user ID is inside of this context, but instead of returning false, this function needs to return. Now, again, just to slow down, what we are doing is we're creating the mutation resolver for check-in habit. The name of the mutation resolver is different than its repository operation. It is create habit log. Here it is check-in habit. Now the next step for us to do is to actually take a look at this completed time. We need to determine this because we need to pass in this completed date, this date that user passes for a habit that they've fulfilled on that day or they've completed on that day. We pass this to its respective repository operation. And if we go back to this repository operation, it's this create habit log. What does it accept? It needs to have the ID of the habit as well as when the habit was completed. So we talked a lot about this, that we truncate this. Basically, we get rid of this time part. We just take a look at the habit and we need to provide this specific format for date. So what we can do is we can actually take a look at this date. Because this date is not going to be in the format that we want to store it inside of database, we need to actually do some things about this. So what I'm going to do first is I'm going to create a variable. I'm going to call this completed. I could just call this completed date. The type of this is going to be time.time. Now, there are going to be two possibilities when user wants to check in for a specific habit. The first possibility is if date is equal to nil. What does this mean? It means user wants to check for a specific habit, but user has not given us that specific date. When do you want to check for that date? So if you take a look at this, you can see we have this asterisk. And this asterisk, what it means is this is a pointer type. This means this can be nil. So this is optional. You can check in for a habit and not provide a date. Just provide the habit ID, and we are going to take a look at that once we move to the playground. So what happens in that scenario? If user wants to check in for a habit and doesn't provide a date, we're going to default to when? To today. So completed date, see, I'm selecting that variable. Completed date is going to be today. So it's going to be time.now.UTC. I'm converting it to UTC. And we talked about this UTC that we convert to this to just ensure consistency regardless of what the user's time zone is. So a server running UTC plus 5 and one that is, let's say, UTC minus 5 or -5 should both record today as the same date for the same user. So it's just some uniformity that we need to bring here. But you can see the type of this completed date is time.time. Should we truncate this? No, we don't have to do it, because this is going to be something that we pass in to this repository operation, which we are eventually going to call inside of this resolver. And repository operation already truncates that. We don't have to do that again. So here I can just say completed date is today's date. That's the completed date. But what if user gives us something? Then what we need to do is we need to actually take a look at what that is and make sure it follows the correct format. We need to parse it correctly. So if user gives us something, the first thing I'm going to do is I'm going to create this error that is going to have a type of error, because there is going to be a method that we're going to use that's called time.parse. And what is the date that we pass to this? 2006-1-01-02. Now, what does this do, this parse? The parse method, what it does is it actually converts a formatted string to time.time. Because unless we convert this, we make this conversion, it's not going to be able to have the same type as the completed at. And what is the date that we pass in here? Now keep in mind, date is actually of type pointer. It has a pointer type. So we need to pass it in the same manner. So when I say, so here, let's distinguish between these two asterisks. When I pass one here, when I pass the star here, this suggests this date has a type of pointer or is a pointer type, which can be null, which can be empty, and our server is not going to crash. That's this star. But this star, what it actually means is the date is a pointer type, but we do not want to copy this. We do not want to do anything. We want to go to that specific part in memory or address in memory and take a look at the actual value that is carried inside of date. So this is called dereferencing. That's what's called that's what you mean by dereferencing. You go to that memory address and you actually take a look at the actual value that is inside of that pointer type. Or I shouldn't say inside of the pointer type, the value is inside of memory. Pointer type just points to that address, and the address holds that specific value. Now this operation, this is going to be either completed date, and I shouldn't say either, this is going to be completed date and error. And you can see, because completed date has a type of, if you hover on this, time.time, that's why we need to actually convert this date into that specific time. All right? So if I were just to pass this here, this is not going to work. So let's take a look at this, and there you go. So if I hover on this, it says two variables, but with one value. Okay, let's get rid of the error. But now it's still not going to match. It says cannot use date as time.time value inside of an assignment, because these two have essentially different types. So what we do is we make sure that this date has the same type as completed date. And we want it to have that type because inside of the repository operation, we already handled this. So what this accepts is this completed date. Take a look at this. The repository operations completed date expects us to pass time.time. So that's why we do this conversion again. Now, what happens if there is an error? So if error is not nil, this should be a quality sign. What is going to be the issue? Well, the issue is that there is just one issue here, and that is we first do not let users to create a log for a specific habit or to create when that habit was fulfilled or completed if the date is not correct. So the error is actually going to say that the date is not correct because that's the only problem here. We're going to say invalid date format. And what does that mean? It means, well, you enter date in an incorrect format. And I'm going to tell users you need to write this. So 4 digits for year, then you have 2 digits for month and 2 digits for day. This is the only valid format that you can give me in order to create a log for a habit. So when I say create a log for a habit, or when I say check in for a habit, both of them are the same thing. So when you check in for a habit, let's say today I went for the morning walk, or last night I did that reading before bed. So I need to actually tick mark, right? Like check it, I did this habit today. Now I'm happy with myself. So that is the check-in habit. Check-in habit creates a log for that habit. And log basically says when the habit was completed. So today, morning walk was completed. So I'm just going to create a log for it so I can keep track of my dedication to this habit. Okay, so that's the thing. Now that we have taken care of this entire completed date, issue, or I shouldn't say issue, this entire completed date thing, let's move on. So the first thing after this that I want to do is I want to verify that the habit actually exists. That's number one, and actually belongs to this user before we go ahead and we check duplicates. So that's something that I want to do. Now, how can I do that? We have already created methods for these. So if I want to make sure that this habit belongs to this user, where should I go? Should I go to user repository, habit repository, or habit log repository? Since I'm looking for the duplication of the habits, I'm going to go into habit repository because that repository operation is available there. And then here we have the specific repo operation where it's going to select the habit ID and the user ID, and it's going to tell us if this habit belongs to this user. So we have get habit with user check, and this is going to return just one habit, exactly what we want. So what should we pass to this? Again, we should pass to this habit ID and user ID. We already have both of them. What is this going to return? So if you hover on this, you're going to see it returns a habit and error. Now, do we care about the habit? No, we don't. We just care if this was successfully verified. So if error is not nil, that means we did not end up with this successful verification of the ownership of the habit. Then I'm not sure what the issue is. So for that, we are going to say return nil. We do not create a log, and then we return the error as well. Now the error could be like a one-off, like a lot of errors, like one among many things, but then that's the job of this repository operation that we have created to tell us what that specific issue is. That's why I'm not assuming anything. I'm just saying return nil and error. And we have already talked about this get habit with user check a lot. You can see I've already created that. So it could be habit not found. It could be failed to fetch habit. It could be like one of like a series of errors that could like come up. Now that we have done this, if we move past the if statement, that means this habit belongs to this specific user. Now what do? We want to create a log for this habit for today. Let's say for today or for yesterday. Now we want to create a log, right? So we need to go into habit log repo and we need to create a habit log. But before creating this, shouldn't we check if this log for this habit has been created for today? So what do I mean by this? If I've gone to the morning walk today and I've recorded that once, should I be able to record that again for today? No. So you can create a log for one habit for one day just once. You cannot do it a second time. So that's what we want to do. So we go into check duplicate habit. What does this need? It needs to have the habit ID, which I'm just going to pass. And the second thing is the completed date. There we go. So we pass in the completed date. And we have talked about this check duplicate. There is something else that I want to dive into this because I want you to like really understand what is happening here. And you might have already had this question, so I want to address this. But right after I create the error handling for this. So what is this going to return? If you hover on this, even though it accepts habit ID and completed date, what it returns is a Boolean as well as error. So Boolean is going to tell us if this habit is already duplicated. So we can store that here. The Boolean I'm going to store inside of duplicate. Now remember, this function, this repository operation returns true or false as well as the error. Now there is something that you need to keep in mind here. There are two kinds of error handling that I'm about to do, and I'm going to explain both of them. So one of the kinds of error handling is if this process fails. If this process fails. So if we are not able to actually check for duplicates, then that's this error. So for any reason that this process fails, that's this error. But what if we find a duplicate? That's this error. So there are two kinds of things that we want to do here, and we're going to go one by one. So let's see. So if error is not nil, that means we were not able to actually do this duplicate check. So what was the issue? I don't know. There could be some real database error that I've not been able to do this. So we return nil and we return the error, whatever the error is. But what if this process was successful? Now keep in mind, the process of this check duplicate log repository operation being successful doesn't have anything to do with us finding a duplicate or not. So finding a duplicate or not, it actually depends on this process being successful. But if the process is successful, doesn't mean we found a duplicate or we didn't find a duplicate, okay? So I need to be very specific here. This error, it refers to this process that we do, to this check that we do. If there is a database error or the database is down, that's going to be caught here. But what if the database is not down, database is operational, and we found a duplicate or we couldn't find a duplicate? What happens in that scenario? Well, for that, we need to have another if statement. So if its duplicate is true, that means we found a duplicate. So check duplicate log repository operation ran successfully and it found a duplicate. And then we are going to catch it here. That's one scenario. The other scenario is check duplicate log ran successfully, but it couldn't find a duplicate. That's going to be checked by this if statement as well. So if we found a duplicate, remember, check duplicate log is going to return true because it returns a Boolean. It's going to return true. So if it returns true, that means we found a duplicate. But for that true to be returned, this check duplicate log repository operation has to run successfully. So that's why I'm iterating this several times. Because of the fact that this function returns a Boolean and an error. Because like the other functions, like this one, like this repository operation, we didn't have this discussion because we know what it returns. It returns a habit and error. But if it returns a Boolean, Boolean has nothing to do with the failing of this operation. That's why we need to talk about that. So if it returns a Boolean, whatever the value may be, that means check duplicate log ran successfully. Okay, so it has to run successfully to return a Boolean value. And then we take a look at the Boolean value. If the Boolean value is true, we return null for the log and we return the error. What is going to be the error? Now, this returned the Boolean value of true. That means you have already checked in for this habit today. So this is a message that I want to talk about as well. So if Boolean is true, that means we found a duplicate log. But this message, it needs some work. So I'm not like really finalized on this message. Let's just imagine like you went for the morning walk today, you recorded that in the database, okay, once. And in the evening, you want to record that again. Perhaps you have forgotten right after your morning walk, you just came home and you recorded that on the DB. Okay, perfect. But then like right before bed, you forgot that you have entered that record and you try to do it again. So what you're going to end up with is this message. You have already checked in for this habit today. And then you're going to say, oh, I entered this log this morning. I don't have to do it again. But imagine like you went for a walk like yesterday and you're not sure if you have entered that into the database. Even though yesterday morning, right after the walk, you did that. But today, which is like the next day, you just remembered and you're like in doubt, perhaps I haven't entered that, but I'm sure I went for a walk. So let's just try it. And you have went for a walk this morning as well. So you try to enter that into the database, even though the date is yesterday. What is it gonna tell you? It says you have already checked in for this habit today, and it's like confusing. The habit was yesterday. The message is saying today. So what is happening? So that's why I'm not finalized on the text for this error. We could say you have already checked in for this habit today, or on this date, but this is like too long. So this is up to you if you want to like go ahead and polish this, because if you want to check in for a habit that was a week ago, today doesn't apply to that, right? So you see that message today, but you're saying, well, I didn't go for a walk today, or I went for a walk and I recorded that. What is this? I'm getting confused. So we could say, you have already checked in for this habit today or on this date. Okay, so you can just fix this however you want to. So I just wanted to talk about that as well. And let's now move forward. So what do we do next? Well, we did all of these checks. Everything is fine. We passed through with flying colors. Well, the next step is to actually put this log inside of the DB, which is the important one. So we take a look at the habit log repo. And we have this create habit log. It needs to have the habit ID. That's the good thing about this, this pop-up. We need to pass in the completed date. We know it's going to do its thing, and that's it. So what is this going to return? This is going to return log for that specific date as well as error. Again, we say if error is not nil, that means there was some kind of an issue. What kind of an issue? I'm not sure. I'm just going to pass in the placeholder and we're going to take a look at that. But if everything goes according to the plan, this resolver is going to return a log and the error is going to be nil. There we go. So we were able to do this. There is something that I just remembered, which I actually forgot to mention, to actually come back to. I talked about this specific thing, this check duplicate, and I wanted to talk about this, but then I was like hesitant, okay, should I talk about it or not? Even though like I know this video is already too long, so why not? Let's just go ahead and talk about it. So for me to actually explain what I mean is, let's go to the habit log repository.go, the repository file that we're currently working with. Let's go there. So if you go there, if you start from the top, let's just zoom this out a little bit. If you go from the top, you can see here we have package repository, we have our imports, we have this like initialization of the struct repository, we have our factory function. But then what we have is this check duplicate log as well as create habit log. So how many repository operations do we have? 2. Check duplicate and create habit log. But for these 2, we just have one resolver. That's not the thing that I want to talk about. The thing that I want to talk about is this word duplicate. So what I wanted to talk about is if you open up this create habit log, and if you take a look at this, what is this? What are these lines doing? So in this line, on this line, what we do is we insert a one row of data into this table, which is called habit logs, into the columns ID, habit ID, completed date, and created at. Where do these values or this data is coming from? That's coming from the resolver, where we actually call this create habit log. So we pass all of this information into the DB, right? We execute this SQL command, which is going to create one row inside of this table. That's fine. If there is any error, we're going to take a look at that. There are 2 different kinds of error. One error is here, the other one is here. So if you take a look at this first one, what does it say? It says unique constraint failed. What does that mean? It means this log for this habit, for this date, so these 3 conditions must match. The log for the specific habit, for the specific date already exists. And what do we say? We say you have already checked in for this habit today. So that discussion that I had with you about this string, this was familiar. We had already have this. We've already had this. I like it went the other way around. We have already had this inside of the repository. Take a look at that. So this, you might have this question. If I'm taking a look at duplicates inside of the create habit log, why do I have to create a different repository operation to do the same thing? Why do I have to do that? I'm taking a look at, I am basically creating this if statement that is going to take a look at if any log is duplicate, then why should I overcomplicate my code with this? What is the idea behind this? So this is something that I wanted to actually talk about, and this is really, really important, and I wanted to actually take some time and explain this. So yes, you can, the first thing that I want to answer is yes, you can get rid of this check duplicate log and the code is still going to work fine. You're still going to be able to check for duplicate records inside of the table, which is called habit logs on the DB. You're actually able to do this. But the idea behind this is not to just check for duplicates once we hit the DB. So you need to be able to distinguish between these positions. If I go inside of the resolver, which one of these methods comes first? Sorry, which one of these repository operations comes first? Which one? This one. Check duplicate log. So before this log that we want to create, before a log hitting the DB, we check if it is duplicate or not. So that's one difference between these two. See, so if it is duplicate, we're going to throw this error and we're going to return nil. So that means create habit log is not going to run. That means if check duplicate is going to run, if this returns true, create habit log is not going to run. So what we do is we do not pass that duplicate record into the DB just to have the DB reject that. We don't let it go that far. So that's point number one. Again, just to drive this home. Point number one is if a log is duplicate, the reason that we use check duplicate log repository operation is to stop that log before going and hitting our database. If a log is duplicate, we're not going to let this insert command run. That's point number one. That's the first advantage that we have this check duplicate log. Now, the second advantage is for this check duplicate log is actually a disadvantage for the database. What do I mean by that? So if we do not have this check duplicate log, what we do is we are letting every duplicate attempt hit the database, and what happens after that? What happens after that is this insert statement of SQL, this is going to fail. What happens after that? Then what we need to do is we need to actually go ahead and catch that error here. Now, you might be saying, okay, so what's the big deal? The big deal is that this is not clean. Why is this not a good approach to get rid of this check duplicate log? Because what we do is, if this error runs, what happens? If this if statement returns true, what does that mean? It means a database error. Now, if we have a duplicate log, do we have a database error or do we have a business logic error? Which one? We have a business logic error. We don't have a database error. So just because I got lazy, I didn't create this duplicate log, I am returning to the users a database error as opposed to something that has nothing to do with the database. This error is not on the side of the database. This is not because of the database. Okay, this is because of a duplicate date that user gave us. So database errors should be the kind of errors that show something went wrong with the DB. But in the case that we receive a duplicate log, what went wrong with the DB? Nothing. We received a duplicate. So for every duplicate, let's say this is like a big app. Let's say there are like 10 million, 100 million users. And what happens if 1,000 of those users or 10,000 of those users submit duplicate logs every day? What happens to that DB? Every time the DB is going to return an error. And how is that error going to be masked? How is that error going to be dressed? It's going to be dressed as business logic, which is not correct. So that's why I didn't want to jump into this like too much. I actually thought about this, but I thought, okay, you might have this question. Why do we have a separate repository operation to check for duplicate logs if we already check that here? So in these repository I know we haven't done this throughout this API throughout this video before. So what I try to do is I try to even though this is a beginner level video, I try to spice things up a little bit so you are familiarized more and more with how real world code changes, how scalable code is going to behave. So I want you to actually imagine what is going to happen every single time this insert statement fails. And now imagine if it fails 1 million times in a day. Then imagine the cost of that, imagine the scalability of that, imagine the maintenance of that. Okay, so that's why before letting this hit the DB, what we do is we actually take care of it inside of this check duplicate log. So what do we have this for? Well, this is a final check. perhaps that didn't execute fine, but we still need to have a last line of defense. And that is our last line of defense. This is not the first line of defense. The first line of defense against duplicates is this repository operation, which is fast, and it doesn't care because it doesn't talk to the DB. Now keep in mind, when of course it talks to the DB. What I mean is that select statements, read operations are generally faster than write operations. This is a select statement. Take a look at this. This is a select statement. This is a read operation. Insert is a write operation. And we have used indexing for our DBs. So that could be another reason why we need to have check duplicate lock. When you use database indexing, writes for the DB, they're going to be very slow. Reads are going to be fast. Writes are going to be very slow. And we have already talked about why reads are faster than writes. One of the side effects, I should say, or trade-offs, I shouldn't call it an issue, I shouldn't call it a side effect. It is just a trade-off of using indexes or database indexing, is that when we read the DB, it's going to be very fast. We can very quickly find records that belong to one user, for example, their habits, or find records that belong to a specific habit. For example, it's their logs. But write operations are going to be slower. So insert, update, delete, these are write operations. Why are they generally slower? Because they take some time to actually store them inside of DB. Because they're actually changing something on the DB. They either enter a record, create a new record, they update an existing record, or they delete an existing record. So that's one of the reasons. Now, the second reason is because we use database indexing. Now, imagine if you want to create a new log for a new habit. Like you have completed one habit in 100 days consecutively. So you are at the day 100. What happens is you log for this day 100. Now what should the DB do? The DB not only should insert that log into the DB, but it also must update that index that we created. So that's two things that the DB is going to do, and that's extra work. Extra work means what? It means extra time. So that's why not only write operations on their own are generally slower, I'm speaking generally slower than read operations, but if you add database indexing, read operations are going to be way more faster now with that same trade-off of, so their quickness or their like speed is at the cost of the slowness of the write operations. So imagine if your DB is hit with 10 million different write operations, of which several 100,000 are duplicate. Your DB is hit with that. That's going to be very costly, and most likely the DB is going to fall. It's going to just say, okay, I cannot handle this. These many connections, I cannot do this. So isn't it better for us to go ahead and take a look at those several 100,000 duplicates inside of a different repository operation that leverages this read operation, which is select, which is fast. So it doesn't care. It just like sifts through that database. Okay, it exists. There we go. That's it. So these are the couple of things that are really like technical when it comes to the databases, and I was hesitant again in talking about them because you can see it just took a long time. But then I said, okay, I decided, okay, let's just go ahead and talk about these, because we have already spent a long time talking about like this API and like all the aspects of it. So why not just talk about this one as well? Now, we could change this message for this last line of defense. So I'm going to collapse this check duplicate log and take a look at this message. You have already checked in for this habit today. We can make sure that both of them have the same string. There we go. And let's save this. So I'm going to collapse this one as well. This is neat and tidy. Very good. I'm not sure what is happening to my English today. So we created a couple of repository operations. We created the resolver responsible for them. But this resolver is actually very good. It's a very powerful resolver. It not only selects the repository operation that is inside of a different file, like this this habit repository operation, it also talks to two. So it talks to two log repository operations. So in total, there are 3 operations, 1, 2, and 3, which is right here. So this is a quite powerful resolver that we have written. Now let's get rid of all of that. I do not have the server on. Let's go ahead and kill these terminals and have the server build this so we can take a look at this inside of the playground. And there we go. So I'm going to just click on this. I'm going to bring you the playground. There we go. So this is the last thing that we did. We deleted a user. Let me take a look at the DB. So DB is open here. How many users do we have? We have B Smith, which is Bob Smith, and then we have Jane Smith. How many habits do we have? I believe this belongs to Jane, 44AF. So haven't recorded a video in the past, I should say 5 days, 4 or 5 days, like just very busy, been very busy, and I've actually lost track of what I did last. So Jane has 1 habit. Let's try to create logs for this specific habit. So I created this habit on the 3rd of June. Today is actually, let me take a look at the date. It's actually the 13th of June. Oh, I thought it was 12. So it's 13th of June. That was 10 days ago. So that's sometimes how busy I get with everything. So let's come in here. Let's log in. We don't have this account anymore, right? So I am going to actually create this account. If I log in, invalid email or password, we can see all of these work. We're going to pass a name. That's going to be John Smith. This is going to be, what was the name of this? Register. Very good. So do this. We got this, and we can take a look at this inside DB. I would like to have all 3 accounts available. So that's this. Let's convert this to, should I log in for this or should I log in for Jane? We could log in for Jane as well, but I just wanted to create this one. So log in. What is the email? Jane Smith. Okay. The same password for all of them. Very good. Just copy all of that, come into the headers. What were we going to write here? What are we going to write here? That's authorization and then bearer. Put that there. So what is it that we want to do? That's a mutation, and that is check-in habit. So we need to provide the ID of the habit, which is required, and then the date of the habit. As you can see, it is not required, but we are going to provide it. We're going to see this. We're going to check this several times. So the ID of the habit is here. Now, this is the ID of the habit. This is the ID of the user to whom this habit belongs, or the owner of the habit. Okay, so this is check. Just bring this here. Check in habit. Very good. It needs to have habit ID, which I'm going to pass there. What it returns is none of these. So what does it return? Check-in habit, habit log. So if I take a look at the habit log, we can say, give me the ID of the habit, the habit, let me say completed date, as well as the created at. Very good. Now let's go ahead and let's run this. Unexpected type time. The time should be string. message type from middleware directive chain should be string. So take a look at this. We can see that it says check-in habit, completed date, and check-in habit created at. Now I'm going to go here. The issue is that I don't see this here, so I'm not really sure where this error is coming from. Unexpected type, middleware directive chain should be string. Path, check-in habit, completed date, check-in habit, created at. So let's come right here. Here we have return null, so it's not this. I didn't provide today's date, right? I didn't provide a date, so it should have defaulted to today's date. Get habit with user check, duplicate, create habit lock. So this should be where the error is coming from because it's not about the other two. Now let's go there. Failed to generate ID. Let me take a look at the DB. It created that. So that's the thing. It created that. It gave it that date. It is the today's date. So the truncate, first let's talk about the truncate, and then we're going to come back to that other part of the issue. So you can see this is the date. This is today's date. I didn't provide a date, so this is today's date. And this is when it was created. So accidentally, these two are the same, right? But if I log in or if I check in for a habit for yesterday, they're not going to be the same. So if I run this again, you can see it says you have already checked in for this habit today or on this date. Path, check habit, check-in habit. If I take a look at this, let's go ahead and so let me provide a date. That should be, let's say it is 2026-06 yesterday. So it's like the 12th. The server is not running, of course, that's why we see that issue. Let me make sure that it builds this. Let's run this, unexpected. We still don't see any issues inside of the server. How can I trace this? It should be string. Let me take a look at this. So this truncated has a type of time.time. This has a type of time.time as well. Now, failed to create this. I need to take a look at this. So we see that this completed date, it has a type of time.time. Okay. And we had another habit log here that accepted this created at, it has this type, and completed at also has that type. Do we have to generate these function stubs again? I don't see the created at. We did discuss that it didn't create those times. Check with users check. Okay, so it's not inside of the mutation. This is okay. Otherwise, it would have thrown an error like before. So you can just skip forward. But I'm trying to find out, because all of these errors, they actually have some text with them. But this one, it says unexpected type from middleware directive chain. Should be string. Now the path is check-in habit. That's the resolver. It's talking about the completed date. But it is going to that check-in habit, the same resolver created that date. So when we go to the check-in habit, we can see that here it has a type of time.time. Oh, this has a type of string. package time.time UTC. So all of these are time.time. Time now. The type of this should match. And there is no issue with this because I checked in for yesterday and yesterday is not today. So actually this part ran. So if date is nil, we just stick to today. That's the if statement. So, okay, so we parse the date and we put it inside of the completed date. This has a type of string. The reason that it has a type of string is because users, they pass in strings. So that's fine. We check this, it belongs to this user. If it doesn't belong to this user, let's just get rid of the if at the end. It says habit not found. We know that. You have already checked in path, check in habit. You have already checked in for this habit. So if I just pass in 1, 2, 3 here, we know that this is going to come from here. Failed to fetch. Let me run this again. You have already, there we go, date 1, 2, 3. So it should be here, and that should be the error. Create habit. But it created the log and then it returned that error. Because if this if statement runs, it's not going to create the log. It's just going to do this. So it was able to surpass that. ID, let me take a look at these. String, time.time, time.time. I need to go ahead and run that generate again. Let's wait for this to get completed. Then we need to actually like tidy up the schema resolvers. Okay, perfect. Habit resolver. So this created, I'm looking for the created at for the habit log resolver. There we go. Now you can see it actually created this because the type of this is correct. So we need to actually delete all of these ones that have squiggly under them because those ones, they mean that we have implemented them already. So delete user, create habit, update habit, delete habit, check in habit. We don't have that. So let's delete these. We have the me, the habits, and the habit individual. Let's delete all of them. So now all of the stubs, they were generated correctly. Let's clear this. If now, method created at already available at schema resolvers failed, we fixed that. Okay, so here is the user resolver. Okay, let's get rid of these. Where is that user resolver? It's this one. So we have these two here, right? So we need to get rid of these. And very good. So it's building that again. See, error is running, and now we don't have any issues here. I'm going to open up Playground again, and let's run this. You have already checked in for this habit. If we take a look at the DB, it is the same habit ID. See, 32BF, but two different dates. So the good thing with this is now this is actually storing, but with that error, which it should have been gone, it should have gone away. So let's just cross our fingers, and there we go. So as I said, there was that issue. I suspected that was the issue, because let us backtrack so we can understand what the issue is and we can learn from it. So the issue was that inside of the models, when I created this habitlog.go file, when I created this, let's zoom this in, by mistake, I added a type of string for this completed date and created that date. So instead of writing time.time and time.time, I wrote string and string, and then I hit generate. So GraphQL generated all of the function stubs and the internal wiring based on that string. So even though I troubleshooted them inside of the habit_log file, and I changed these, I didn't run the GraphQL generate again, that server generation again, so that old version actually stuck. So that's why, even though it was creating the logs, it was throwing that legacy error. The error didn't exist in any part of the API. It was just something that the server, the GraphQL server or gqlgen had it in its memory. So now you can see we created a log for 3 days, and we could create another log for 10th of June, and now we don't see that issue again. We don't see it. And if I run this, there we go. So based on these, if you take a look at these, what is going to be the current streak? Now the current streak starts from today and it goes backwards. So today is 13, that's 1. Then it goes backward to 12. You can see there are no interruptions. So that's 2. It goes to 11 sequentially, that's 3. It goes to 10, that's 4. So the current streak is 4. What is the maximum streak? Or sorry, what is the longest streak? That's still 4. What is total completions? Total completions refers to how many times we have logged in for one specific habit. So total completions is also 4. But if I were to record this, to write this record at 5th of June, let's just add 5. This shouldn't work. We need to have that 0 there. And now for your front end, you can just replace this with that calendar, for example, inside of React, and that's going to be working fine. You just have to tweak some strings like date-time strings here and there, but like I've given you like a standard version of date, and you can just work with this, and that's it. So now we have 5. Now take a look at this. There is one interruption. So the current streak is still 4. The longest streak is again 4, but the total completions is 5. So this is how these are actually different. So it could be 5, 6, and then 7. Take a look at this. 8. I just want to give you an example, right? Oh, I shouldn't have created the one for 9. I didn't want to create that. I wanted to be 9 to be the exception. But anyway, we have all of these. So anyway, let's move forward from this discussion. Let's talk about the next repository operation that we are going to go ahead and we're going to create. And the next repository operation is going to help us get all of the habit logs for one specific habit. So that's going to be then the thing that we're going to do next. And the implementation of this repository operation is going to resemble a lot something that we have already implemented. So if I go into the habit repository, let's take a look at get habits by user ID. So it is similar in a sense that we're trying to select several records from the DB. It doesn't matter what those records are. In the case of habit repository, those records are habits, but in the case of logs, they are habit logs. So here, if you just click on this and you open this up, we've already talked about this, right? We talked about this extensively. We said that this is query instead of returning just query row, which returns one record. What we do is, because there are chances you have like 10 records or 1,000 records, so there is a possibility of more than one, we use this query. And what this returns is something that's called a cursor, which is actually something that is going to return a result set, and you can basically go ahead and iterate over that using this method rows.next. We also talked about rows.close, this defer. What is the idea behind this? So the implementation is going to go hand in hand, or it's going to be very similar to that repository operation. So let's go ahead and let's actually type this out. We have a func. This is going to have a type of habit log repository. What is going to be the name of this repository operation? Now the names of these, except for the names that are auto-generated inside of the schema resolvers. And again, you have basically command over these as well. You can change these as well. But here you're like really free without having to generate gqlgen again, without having to run that again. So here you can be flexible. We're going to say get. This is going to be, so let me think about this. We want to get habit logs by habit ID. So this is going to be get habit logs by habit ID. So if you give me a habit ID, I'm going to give you all the logs or all the records or all the dates in which that habit was completed. So the only thing that I need from you is going to be habit ID, the type of which is going to be string. Now keep in mind, user has to give us this for us to be able to show them what the logs are. What is this going to return? This is going to return a slice because there is a possibility, of course, that there is going to be more than one habit log or more than one log, and the type of that is going to be log. This is also going to return error. So how do we start writing this? It's going to be the same thing that we had here. So I could very well select all of this and just paste it here, and we're going to go over this code. And now let's go over this code. This is going to be r.db.query. We talked about why we use query, because we expect that there are more than one row that are going to be returned. Select statement is going to read this from the DB. So what are the column names? We're going to have the ID. Instead of user ID, we're going to have the, now we are referencing the habit logs table. So let me just open this up. Then we have the ID, we have the habit ID, we don't have name, description, anything else. Instead of these, we have completed underscore date and then hyphen. And after completed date, we have created that. And finally, we don't have anything else. That's the last column. So we just have, we select the ID, habit ID. ID here, this refers to the ID of the log. This is the ID of the habit. This is when the habit was completed. This is when that completed record was entered into the database. So that's the difference between here. We select all of these from habit underscore logs table. So what is the condition? We don't have user ID. Instead of user ID, we say where habit underscore ID is equal to this. And order, we can order by created at, or I'm going to order by completed date, because we're going to show when that habit was completed. So the newest date is going to come first. That's what it means when we say, okay, DESC. So the newest completions for one specific habit, they're going to be shown first. And now what is this? The placeholder for this is not user ID. I copy pasted this. That's why there is just a lot of things that we need to change. Now here, if the error is not nil, we're not going to say fail to fetch habits. We are going to say fail to fetch habit logs. So now that we are done with this, again, we need to actually go ahead and try to schedule cleanup regardless of how this function exits. So if we find some kind of an issue and the function basically unexpectedly exits, we need to close the database connection, because like sifting through all these hundreds and thousands of rows is going to take some time. So we need to make sure that we don't have any connection leakage or database leakage. So that's why we're going to say close. Now this is going to only close the DB once we exit from the surrounding function, which is this repository operation. Now let's move away from this. What we want to do is we want to create a slice Because let's say query returns 100 logs for one specific habit. So let's say you started you created a habit 6 months ago, or let's say 6 months ago, and then you have implemented that habit, or you have fulfilled that promise for 100 days in those 6 months, or 150 days. So what we need to do is we need to create a slice to put all of those records, all of those completed dates, one by one inside of there. So we basically put all of the rows, so it's not just going to be completed date, even though completed date is going to be like the most important part of it. But so each row is going to have 4 columns: ID, habit ID, completed date, and created at. So we need to create a slice that is going to accept some kind of a struct, and that struct is going to have 4 fields: ID, habit ID, completed date, and created at. So first let's go ahead and let's create the slice. And now what is this log? We could go one of 2 ways. We could do this. So we could say the type of this is models.habit log. We could do this, but the problem with this is if user doesn't have any logs for one specific habit, but they still send us a query, okay, they want to check, okay, so I know I created this like morning walk, but I'm not sure if I have actually gone through with that promise or with that habit. Let me take a look at it. If I've implemented that any day, they don't see anything, right? Because they have not entered anything into the database for that. So the problem with this is, what this is going to return is, this is going to actually return nil. But in this scenario, nil is going to be serialized by JSON into null. Now, null is not something that the field that we have used, that we have created inside schema.graphql is going to accept. It's not going to accept this. So this is bad. What we want to do is we want to return this. So we want to return, if user doesn't have any kind of logs for one specific habit, we want JSON to serialize it to this, as opposed to null, because this empty slice is something that we have already coded. So we are going to surround this by the make function, and I'm going to pass in 0. So initially the length of this is 0, and now you can see the errors are gone. So how do we keep populating this? Because this query returns a cursor that jumps over or iterates over a result set, we can leverage that inside of a for loop, or in conjunction with a for loop, to keep populating this one record at a time. So let me just open up this DB because I don't want to take a look at it. This just shows yellow and it's too distracting. So what we want to do is we want to keep populating this, but the important thing is we populate this one record at a time. We're not going to throw like 10,000 records just directly. No, we select one row. If the next row exists, then we go to the next row. So in every iteration of the loop, we're going to take a look at if that the next row exists. So how do you do that? Now see, rows is something that is returned by the query method. And on this, we have this next function. Now this next method, what it does is, if there is something next, this is going to return true. So we move forward to next basically iteration of the loop. Now this is not if, this is for, but nonetheless, this part has to return true for this for loop to continue. So if you want the for loop to continue, this next part has to return true. But if you go to next and there is no record in the next iteration, this returns false and the loop ends. But much like with any loops, what you have inside of the loop body, inside of the for loop body, is you just have one record. You always talk about individually inside of the for loop body. And then the outside syntax of that for loop, what it does is it repeats that singular thing or that singular operation for a number of times. The number of times that you want to repeat that singular operation depends on rows.next. So again, within the for loop, how many rows do we talk about? just one singular row. And then we keep repeating that. And again, next row and the next row for as many rows as there are. If for one habit you have 1,000, let's say 1,000 records or 1,000 logs, you are going to do this iterative process 1,000 times. That's how for loops work. So instead of like doing it manually, you just use for loop. So what do we put inside of this slice, which is called logs? We put individual structs. Why do we put structs? Why don't we just put the data, like we just throw it there? Because what we want to put in there, it has several properties on it. And the best data structure to determine or to represent something that has several properties on it is a struct, aka an object. So one individual thing inside of the logs is called log, individual, singular. The type of that is models.habitLog. So I have created this empty struct. I've given it a type. And now if you take a look at this, there we go, here it is. But we have not actually used it. Now, how many fields are there inside of this log? There are going to be 4 fields inside of there. We know that. That's what this log slice also accepts for one individual item. How do we populate that? Well, we have this scan method, remember? Scan method selects something that is returned by a database method and it puts it inside of a struct. Then we select that struct and we send it to the resolver. Resolver fulfills the GraphQL operation with that struct, aka it sends it to the front end. And that's it. So we have the scan method. What should we reference? We should reference log dot, what is the first column? The first column is ID. Very good. That's the ID of the log. The second thing, the second column is the ID of the habit to which this log belongs. The third one is when the habit was completed, at what date. And the fourth one is when that record was entered into the DB. So sometimes these could be the same date. If you implement a habit and on the same day you enter it into the DB, this is going to be the same thing, these two dates. But if you implement habit, if you have implemented it yesterday and you enter it today, then the completed date and the created date, they're going to be different. What is this operation going to return? This could return error, right? Well, this returns error. We take a look at if error is not null. Then what do we do with it if error is not null? Well, what are we trying to do? What does this error refer to? Well, the error refers to selecting or basically scanning stuff. What are stuff? Habit logs. So I can very well say, if I come right here, I'm going to say return nil. I'm going to return nil, which means I'm not going to put any logs inside of the logs slice, nothing, because I encountered an error. Then I'm going to say error F, failed to scan what? To scan habit. Now here, this is very important. Should I say failed to scan habit log, individual, singular, or should I say logs, plural? We are inside of the for loop. Inside of the for loop, you just talk about one log. So that's going to be singular. This was just another test for you. So this actually, I'm trying to explain it somehow so you really see what happens behind the scenes of these for loops. So if you see it, it doesn't matter, like in the most gigantic code base, it's going to basically do the same thing. So it takes away from that fear, especially if you're like new to these, from that fear of seeing thousands of lines of code in one file. You can just break it down to different basically things or parts of the code, and then you are going to see, okay, how all of them work. Now, if we move past this if statement, that means this process of selecting data from the records that are returned by the query and scanning them into the log struct, that process was successful. So what do we do next? Now we need to select these individual logs and we need to put them inside of the logs slice. But we do this one log at a time. So I'm going to say append. What am I going to pass? First, I need to reference, or I need to select the slice that I want to populate. It's that slice. Then we need to dereference these logs, which basically means this is a pointer. And then we select the initial logs, a slice, and we basically change its value every time this for loop runs. And that's it. So there is, we talked about this error right here, error iterating habits. If there is any kind of error that we encounter during the iteration, that was not, keep in mind, that was not caught by the scan method, then we need to actually go ahead and get it right here. We need to actually catch it here. So I can just copy this, and I'm gonna go outside of the for loop, and I'm gonna put it there. I'm gonna say error iterating, not habits. I'm gonna say habit logs. It's the same thing, right? So we declare this variable, and we create the if statement in one line. In this way, this error variable, it doesn't exist outside the scope of this if statement. It doesn't exist anywhere else. So if you were to just write error here and hover on this error, because we have implemented that here, so if I were to just get rid of that from there and take a look at it, you can see it says undefined. What are you talking about? You have not defined this. Because we defined it above, that's why it is showing it here. So we already covered this before, and I just wanted to remind you of this. And finally, if everything goes according to plan, what do we return? We return the logs slice, and we basically say, okay, there was no error, or the error is nil. Now let's move ahead or move on, and let's talk about the repository, the resolver. I kind of forgot the name. The resolver that is going to invoke this repository operation. I'm going to close the habit repository. Now, let me ask you this. We are trying to load one log or more than one log. We're trying to load logs for one specific habit. Is this a mutation resolver or a query resolver? You can pause the video and think about it. Well, this is a query resolver because we are trying to load information. We're not trying to change anything on the DB. We're just trying to load information. So let's go to schema resolvers. And here we have the current streak, longest, logs. I believe it's this one. So logs is the resolver for the logs field. Let's take a look at what it accepts. It accepts the context, and then object models.habit. Models.habit. No, we are looking for something that accepts the habit ID. So let's come down, habit logs. Let's take a look at this one. You need to be very, very careful with these. So this is a query resolver. Okay, we know that it is query habit logs. It accepts context from which we are going to extract the user ID. Very good. For authentication purposes, then we have the habit ID that this resolver accepts from the GraphQL query. Okay, so this is exactly what we're looking for, because this habit ID is something that we're going to pass to the newly created repository operation. What it returns is, it seems like a slice that has a type of habit log, exactly what we're looking for. So I'm going to copy this, just copy it, come into the query, and I'm going to paste it here. Now, what are we going to do as the first step? We need to select the user ID. So I'm going to copy all of that, put it here. We have talked extensively about this. Now, what should we do as the next step? Well, the next step that I want to do is I want to check whether or not this habit actually belongs to this user. Then user is going to be able to take a look at logs for that specific habit. First, user has to prove if this habit belongs to this user. And also in this process, we actually take a look at if even this habit exists. Now, in the case of a front-end UI, this check, you could get away with not actually providing this because If the habit doesn't exist, user in the front end or on the front end, they're not going to be copy pasting the IDs of the habits. So they give us the ID of the habit like this resolver expects. And then we're going to show them the logs for that habit ID. No, that's not how front end works. So front end is UI. And if habit exists, they're going to see some kind of a card for it, or like some kind of a section in the website. And then when they click on it, or they want to click on the part where it says, okay, get logs, or take a look at the logs for this habit, then from that click, we extract the token, we extract the ID of the user, and we basically show them all of the logs. But if habit doesn't exist, user is not going to see anything to click in the first place. So again, you could get away with not checking if this habit exists and belongs to this user. But what if someone is trying to attack your website without using like a front end, like Postman, or like this GraphQL Playground, or any other third-party software that is going to bypass front end? So you need to have these checks on the back end, because you not only are thinking about this API having someday this might have a front end, you also must think about, okay, what if this just stays an API? Okay, so you need to have all of these checks present. So I'm just going to pass that there. What this is going to do is this is going to need to have the get habit with user check. We need to pass in the user ID, which is this needs as the first thing the habit ID, and as the second thing the user ID. So this first one is going to be habit ID. Very good. And if this habit exists and belongs to this user, what do we do next? Well, from this operation, I do not want to have I do not want to select a habit. So I'm going to pass in this blank identifier. I don't care about that. I just care if this error happens or not. And as the last step, so we checked that this user is authorized. We checked that this habit exists and belongs to this user. What should we do next? Well, we need to select all of the logs and give it to this user. So we say r.habit log repo dot get habit logs by habit ID. What does it accept? It accepts a habit ID. What does it return? Two things. It returns a slice of logs and error. Let's take a look at the error. If I think I'm just gonna copy paste that here. So if error is not nil, we're going to return nil for the slice of habit logs, and then we're going to return the error, what the error was. Otherwise, if everything goes according to the plan, we're going to return all of the logs, and we're going to return nil for the error. And that's it. That's basically it. So we need to go ahead and delete this. This is another function step that we have completed. There's just a handful of them remaining, which we are going to, again, complete one by one. So what should we do next? The next thing is we need to actually run air and wait for it until it is done building. So there we go. This is our playground, and very well. So first off, we need to log in for once. Let me take a look at these that I have. So here I have the ID of the habit. As I can see, all of these IDs are the same. That means all of these logs belong to one specific habit that ends with 32BF. And well, there I just have one habit here, and that is 32BF that I believe belongs to Jane. So the user ID is 44AF. If I come right here, there we go. So this is Jane. Very good. So I need to sign in with Jane's account. Do I have that? Yeah, there we go. So sign in. And I'm going to select this token. We have done this several times. We need to put it here. Authorization. Bearer. And then pass it there. So we said that that is actually a query. So let me get rid of this entire thing. This is query. The name of the query is what was it? Habit logs? Yeah, there we go. I kind of forgot that. So what does habit log require? You can see it requires a habit ID that we need to actually pass to this. So let's come right here. We could select a habit ID. You could select a habit ID from the habits table, or you could select it from the habit logs table. I'm going to select it from the habits table. I'm just going to copy this. You can see it says ID, and I'm going to pass it there. Very good. Let's just bring this back. Now, what should we select from this? We could select the ID of the logs, the completed date, and the created at. Let's run this. We should get a slice, and there we go. This is very good, right? So there is just a lot of information. Let's get rid of the ID of the log. Let's run this again. So now for every individual log for this specific habit, now keep in mind, all of these logs, they're referred to one habit, and this is the habit. So let me just put it on the next line. And just put it there. There we go. So all of these logs, they refer to the dates in which this habit was actually completed. So that's what these refer to, completed date. Now there is something that I just paid attention, that I just noticed. It's this, the completed date has that truncated part attached to it. So the part that we gotten rid of it. So even though we stored it into the DB like this, when we select it back from the DB, it is just as though we didn't do anything. So I just paid attention to this. So let's see. This is mutation. This is the query. Let's go into the repository. You can see the type of this is time.time. And this is not going to be easy because what this log requires is habit log. You can see it needs to have that time.time. That's going to be something that it is going to require. Now, it's not going to be easy to actually change this from here because, as I said, it's going to be this habit log. We are selecting a type that was already created. Inside of query, we have stubs, right? We had stubs, but then we changed it with these. Okay, so oh yeah, so if you take a look at this RFC 3339, now I just remember, so we have this habit log resolver where we actually implement this completed date, which has a type of time.time, and we format it and we return a string. So we convert that into a string. But the formatting criteria that we passed with, or standard, is this RFC 3339. And what it does is it returns this. You can see that 2/1/2006 there. So even though I did not store this inside of the DB, take a look at it. So inside of the DB, I just have these dates here. But because we truncated the time, it sets the time to that like 000000. So if you take a look at that here, there we go. So 000000, basically midnight. It is midnight. So it sets it to that. But now you could hit the pause here, hit the brakes here, and you're going to say, okay, if this API makes it to a front-end app, a developer is going to know how to get rid of this part and just select this date from it. Or you could say, I'm not satisfied with this RFC 3339, and I want to change it. So the only thing for us to do is going to be just to pass in that 2006. So I'm just going to move back here. So if you hover on this, you can see this 2006-01-02, copy that, and I'm going to put that instead of that here. This should be in quotes. There we go. You can see there are no errors. So fingers crossed. There we go. Perfect. Yeah, that's good. That's good. It just put a smile on my face. So we have 13, 12, again, newest first, right? That descending keyword. So we have 13, we have 12, 11, 10, 9, 8, 7, whatever. But you don't have that time component in there. We truncated that, we sliced that away, and we just ended up with this figure, with this time, with this date. I keep saying time. I keep saying time, not I keep seeing time. So we show to the user exactly what we have inside of the DB. Again, you have control over this. If you say, no, I don't want to do that, then you just return, again, time.rfc3339. But I want this to be consistent. So what I see in the DB, it should be what I show in the front end as well. And we worked on this, right? We spent time on this to get rid of that time component, just to show the date. We don't care when you completed that habit throughout the day. We just care that you did that. So that's the thing that we're interested in. And I think this is very good. So let's move forward. What is the next thing that we want to do? Well, the next thing is that we should be able to delete habit logs as well. So that's something that we should be able to do. So we should be able to delete habit logs. But before doing that, I just thought of something. So let's go ahead and let's check something. So if I delete a habit, does it delete the logs of it as well? Or even better, if I delete the user, does it delete their habits? And do the habits delete their habit logs in return? So we could just check all of that in one go. So I'm going to say delete user, right? Just delete user. And that's going to be delete. Oh, this is a mutation, not a query. That's why I don't get that autocomplete. Delete user. So which user it is? We know that's Jane. Jane has several, like 9 records inside of the habit logs table, 1 record inside of the habits, and 1 record inside of this users table. Let's see if this foreign key relationship actually works. So I'm going to run this. We got true. We know that user and habit, they're going to be deleted. The question is the logs. So if I refresh this, Jane is gone from here. Let's come right here. If I refresh this, the habit is also gone. Now here is the moment of truth. I hope this works. And there we go. I am so happy with this. So we can see when you delete the user, their habits go away. When the habits are deleted, the habit logs go away. And that's it. So now what we can do is we can say login. Login. Oh, whoops. This should be mutation. What am I doing? I'm so happy that this works. Login. This is email. Which email do we... You know what? Instead of typing all of this, I could just click on this login. Let's log in with the account for John. There we go. Now I'm going to create a habit for John, right? That's going to be authorization bearer this. And okay, let me just get rid of this part. This is going to be create habit. What do we pass? We pass in a name for the habit. Let's say habit 1, habit test 1, habit test habit 1. Why do I overthink this too much? Then we have the description to be deleted. -1. What do we return? We could return the name. That's enough. So I created this, and now if I come here, we have this 023 for John. Refresh this. Yeah, 023, test habit 1. Let's create a log for it. Now I want to delete the habit and see if that works, if that also works. So check in habit. For check in habit, I'm not going to pass in a date. I'm just going to pass in the habit ID. Copy it. Come right here. That's going to be, so what does it, is it require, does it, oh, it requires habit ID. I thought it would just require the ID. And then completed date and created at. Let's run this, there we go. And you can see it works here as well. So completed date is this and created is this. Now it has a log. Now what I want to do is I want to delete this habit. So delete habit, and then I'm going to pass in the ID of the habit. So I'm going to delete this. True, that means the deletion of the habit was successful. So let's come right here, refresh this, the habit is gone. Now when the habit goes away, so should or so must, there are logs. There we go, the log is gone. So I just wanted to make sure, even though it worked before, just wanted to make sure that it actually works fine. So now let's close this. Here we are inside of this repository. Let's talk about the next one. And the next one is, if we take a look at the stubs, what do we have to do? We have to implement this delete habit log, where you can delete like habit logs as well. But to be able to delete them, you need to get the ID of the habit log. Then let me think about this. So what we want to do, we need to have the ID of the log that user wants to delete. And so that could be one repository operation, much like this duplicate where we separated that into a separate repository operation. We could get the ID of the log inside and put it inside of a separate repository operation. Then we could write a repository operation that actually implements the deletion, that talks to the DB and implements the deletion. And we have just one resolver for that as well. So that's how I'm going to go about this. And to get started with this repository operation, the first thing that I'm going to do is create its function signature. So this is going to be our habit log repository. There we go. And what should we call this? Well, since this repository operation's job is to select only one log based on its ID, we can just call it get habit log singular by ID. So we don't pass in the ID of the habit, we just pass in the ID of the log, and then we get that log. So that's going to be ID, the type of which is going to be string. This is required, so if you want this repository operation to work, you need to pass in that. What is this going to return? We know that this is going to return models.habit log. That's the type, as well as error. Very good. So how do we go about this? Well, we want to select one thing from the DB. How do we do that? We can use the query row method, right? So I'm going to say r.db.queryRow, since it just selects one row from the database. And now since we select something from the database, that is going to be a read operation. So we are going to write the select statement of SQL. This is going to be ID. Now we need to target which columns do we want to select data from. So we specified ID. The next column is going to be habit underscore ID. Then we have completed underscore date, as well as created underscore at. Which table are we referencing? That is going to be habit logs table. Now there should be a condition, right? So we are not selecting all of the rows. We just select one row based on the ID of that row. So we're going to say where ID is equal to this placeholder. And now we need to pass in that placeholder. So This is going to return a row from the DB. What do we do next? We scan that into a specific struct. So we haven't created the struct. Let's go ahead and create it. That's going to be var log. Since it just returns one log, the type of this is going to be models.habitLog. How do we populate this log struct? We're going to select it and we're going to pass in the ID as the ID, habit ID. There we go, as the habit ID. What do I have next? We have the completed date as well as created at date. Now, what is this throwing here? So if I just do this, oh, there we go. The H is capital. There are chances that the error is not going to be null. So we are going to say this is going to return error. And what if error is not null? Well, we have already talked about this. There could be two possibilities. There could be that we couldn't find any rows. So let's first just write this. If the error is null, the first thing that we do is we take a look at if errors contains the specific error. And what is that? That is SQL.error no rows. So what is the idea behind this? Well, this error no rows is going to check if the error is specifically that we couldn't find any rows. And what does this mean? This means the log ID does not exist in the DB. So what happens if we hit this error? We are going to return null for the habit log, and we are also going to return null for the error. Now, why do we return null? Because if you could not find this ID for this log inside of the DB, is that a problem with the database? I'm asking you this. So do you think if you cannot find some kind of a record on the DB, does that mean that the database threw an error or the database actually broke? No, it doesn't mean that. It just means this record that you're looking for doesn't exist. So that's why we just return null for the error as well. So returning null also allows the caller, which is the resolver, to control the error message. So what kind of error message do you want to show? Null here basically means not found. This log was not found. That doesn't mean that our database is like there's something wrong with it. No, it just means that we were not able to find it. So here, if there is any kind of error aside from this rows, then we're going to return null and we're going to say fmt.errorf and we're going to say failed. So whatever error comes up, that's basically going to be, okay, this is something that is a real unexpected database failure. So in the case of any kind of failure when it comes to the DB, we are going to be unable to fetch habit log, but not inside of the if errors.as, SQL no errors, error no rows. So not that, because that basically states, okay, we couldn't find this on the DB, but that doesn't mean that the database is like broken. But here we say fail to fetch because even though this row existed, there was some issue that we were not able to actually select this record. So that's why these error messages, they change. But what if you have this log? What do you do then? Well, you return it. So we're going to say log and we return null for the error. So this is the repository operation that just talks about getting one single log from the DB. And what should we do next? Well, next up, what we need to do is we need to create another repository operation that's going to delete this log that is returned by this get habit by ID, get habit log by ID. So we need to create this, just selects it, this get habit log by ID. Now we're creating another repository operation that is going to delete the selected one. So this is going to be habit log repository. What should be the name of this? I can say delete habit log. Very good. What should we pass to this in order to be able to delete a specific log from the database? We need to know what the ID of the log is, right? What is this going to return? Well, after the deletion, what is left to return? Nothing. So much like the previous ways, like the previous repository operations that talked about delete, this is just going to return Boolean. If true, that means first, we found the lock. Second, we were able to delete the lock. And then it also returns error. But what if it returns false? False means we couldn't find the lock. But whether that is true or that is false, it doesn't contain any kind of information when it comes to what went wrong with this. So for example, if it is false, we don't know, because Boolean doesn't contain that. We don't know what specifically happened that we weren't able to delete this record from the DB. So what do we do here? We want to run a statement on our database that is going to change the database in some way. So we're no longer working with a read operation, we're working with a write operation. And we want something to execute something, like some kind of a method to execute some kind of a statement on the DB. So we're going to use execute. There we go. And what am I going to pass? What kind of an operation do we want to carry? That's going to be delete. It's a write operation. From where? That's going to be the habit underscore logs table. Now, which row do I want to delete from this table? Now, I'm not deleting the table. That's something that the down migration is going to do. I'm just deleting one record if this record exists, right? If it exists, then I want to delete it. So which record is it? What is the distinguishing factor? That is the ID. So we are going to basically sift through this table by ID. And I'm going to pass in the ID there. Now, what is this going to give us? We know that this is going to give us result and error, which we're going to store both of them. So let's go to the next line. We're going to say if error is not nil, then what does that mean? It means so what are we doing? Then we can decide, okay, what does the error mean? So I'm trying to delete something on the DB. I wasn't able to do it. That means what? That means we were not able to delete this lock. So we're going to return false for the Boolean because we weren't able to do it, right? And then for the message, we're going to say fmt.errorf failed to delete habit lock. Now, what went specifically wrong, or what specifically went wrong, is going to be replaced, or I should say is going to replace this %w. So this failed to delete habit lock is the general context of the error, but then what the specific error is going to come right here from this error. Very good. But if I move past this, what does that mean? It means we were able to actually delete this, right? We were able to delete this, but then we need to take a look at if any rows are actually affected by this. And what are the possible outcomes? So it's going to be 0 or 1. 0 means no row was affected, meaning we didn't find a row that contained this ID. 1 means exactly one row was deleted. So the log existed and is now gone. So we need to actually take a look at that as well. So that's why we select this result. On this, we have rows affected. What is this going to return? This is going to return rows affected as well as error. There we go. So let's move forward. I'm going to say if error is not nil, what does that mean? It means we were not actually able to, this deletion process was not successful. So there was something wrong with this. And that thing could be like something unexpected. So nonetheless, we're going to return false for the Boolean, and for the error, we could just print something. We could say failed to confirm deletion. We weren't able to do it. There we go. And I'm going to pass in the error there. Let's save this. But what if we were able to do this, but then something else came up. So the SQL command, this delete, it actually ran successfully, but it didn't find any rows. So what happens in that scenario? That's when rows affected is actually equal to 0. So that means there was no issue with the database. We were able to find this ID. We deleted that, but if you click on it at a second time, it doesn't exist. So even though there are no database errors, that row doesn't exist. So rows affected is going to be equal to 0. So in that scenario, even in that scenario, we're going to return null and we're false for the Boolean and null for the error. We're going to let caller decide what the actual error is going to be for that. Now, I want to clarify that this happens in one of the situations in which this could happen is that if you receive a concurrent request. So if you receive a lot of requests, you just deleted this from the DB and you just received that request again, even though it was just in the database, but it doesn't exist maybe in less than 1 millisecond later, or in 1 millisecond or a few milliseconds later. So you receive several concurrent requests, a request that you receive simultaneously at the same time. So that could be one of the issues. That could be one of the things that is actually wrong in here. So what we do is we return false to signal that we didn't delete anything, right? Nothing was deleted, but it doesn't mean that it is an error. So we allow resolver to go ahead and then return its own error, the error that we're about to write inside of the resolver. And then that error could be okay, we were not able to find this habit log inside of the DB, some kind of a message like that. But if we move further than this, if we move down, what does that mean? It means there was no database issues. Some rows, one row was actually affected. So we return true for the Boolean and return null for the error. This means one log was successfully deleted. So what should we do next? Well, the next step is going to revolve around creating some kind of a resolver for this. What kind of a resolver do we need for this? Do we need a query one? Then we collapse this one, collapse this one. Is this going to be a query resolver, or is this going to be a mutation resolver? You can pause the video and think about this until I just go ahead and collapse these. What kind of a resolver is going to be? This is going to be a mutation one because we changed something on the DB. So let's go ahead and let's write it. But before that, let's come here. We have this delete habit log. What else do I have? So we have current streak, longest logs, user, habit. It should be this one, delete habit log. Copy that. Come into here, put it there, and now we're going to take a look at it. So we can see this is a mutation resolver. The name of it clearly indicates that we are trying to delete a habit log. It accepts the context for authorization, and then we pass in the ID of the log. It gives us Boolean as well as error. So this is the correct function stop that we want to actually use in order to delete this log. And we're going to go step by step here so you can really understand all of that. The first thing that we do is we actually get this user ID. So I'm just going to copy it from there, put it right here. So that's the first thing. Now, this is the the check that we do in order to get the user ID and make sure that this actually works fine. And we're going to return false here if it is not okay. But let's move forward. So in the first step, we're going to fetch the log entry. And why do we do this? Well, we need to confirm that this actually exists. So step one, I could just say fetch the log entry to confirm it exists. Okay, so this is the first step that we do. First, we fetch the log entry. And how do we do that? Well, we can select r.habit log repo dot. How do we select that log entry? How do we select it? That is get habit log by ID. What does it need? It needs the ID of the log, and the ID of the log is the function parameter, which I'm just going to pass in there. Now, what this returns is going to be actually is going to contain two different kinds of errors, and we're going to talk about both of them. So it could return log, but if error is not nil, there could be some kind of an issue here. So let's first take a look at it. Now, if we move back to the repository, we said that there are two kinds of errors, right? There is one kind of error that basically says that there was something wrong with the database. There was something wrong with the database. But then there is some kind of an error, like this one, that says there was nothing wrong with the DB. What happened is that we got a concurrent request or several concurrent requests. We deleted this and we receive a request again. Even though this doesn't exist, we just return nil. So we return false because we didn't delete anything again. So this right here doesn't mean that something went wrong with the DB. So we need to actually distinguish between these two. If error is not nil, this means a real database error occurred and we return it immediately. So we return false and we're going to return the actual error. But what if the log is nil? Remember, the log doesn't exist inside of the database. We return false, which means nothing was deleted, and then we actually show a message that, okay, this habit log was not found. This is the part where I said, okay, no rows are affected. So, okay, so we're going to say log is equal to nil. What does this mean? It means we're going to return false. That means we didn't delete anything, but the error message is going to be very interesting. It is going to be error F. This is going to be habit log not found. Very good, right? So one is a database error. One is the kind of error that we show that is going to basically signify that we weren't able to find this on the DB. Now let's move forward. That was step number one. Let's go to step number two. In step number two, we fetch the habit to which or to whom this log belongs. We basically fetch the parent habit. We basically fetch the parent habit, yeah. And then we're going to talk about how we do this. So how do we fetch the parent habit? Remember, inside of the repository operations that belong to habit repo, r.habit repo, not habit log, we have a repository operation that has get habit with user check, create habit. We have this get habit with user check. We could take a look at this. Let me just see. So let me open that up. Where is our resolver? Habits repository is right here. Get habits by user ID. No, I'm not talking about this. So we want to find out if this parent habit exists for that log to be deleted in the first place. So if that parent habit doesn't exist, how can we actually delete that log? And we can clearly see that we have this repository operation that we created for this kind of use case. So we have this get habit with user check, but this is, you can see this is get habit with user check. We have the user ID available inside of this mutation. It's right here. We have that available. We haven't passed it anywhere. And this is going to return the habit or nil if we run this query row, which is going to talk to the, so I'm basically taking a look at this. So select ID, user ID, and then the name, the description, created at and updated at. From the habits table where ID is this and user ID is this. So we actually check the ownership of this as well. Yeah, we could use this repository operation. Yep, that's going to serve our purpose very well. So here, I'm going to do dot again. This is going to be get user check, get habit with user check. So I'm going to pass in the habit. Now I don't have access to the habit ID. That's the issue that I have here. I don't have access to the habit ID. How do I select the habit ID? How do I select that? So we could make a compromise. So take a look at this log. This log that is returned by this get habit log by ID. Now, what do I want? I want the ID of the habit. If I take a look at my database and if I go into the logs table, we can see the second column here is the ID of the habit. So if I hover on this, we have this type, habit log, and we know that contains that habit ID. So if I do log dot, there we go, gotcha, log dot habit ID. So this resolver does not accept the habit ID. We were able to extract it from this log. And at this point, at this point here, we know that this log exists because we were able to move further away from these two if statements. So that exists. That's the first thing. The second thing that it needs is user ID, which we got it above. So user ID, let's pass it there. What is this going to return for us? We know that this is either going to return, this is going to return error as well as habit. So let's go ahead and let's write the messages for this. The first one is going to be if something was wrong with the DB, right? So it's going to be exactly like this. So I'm going to copy that. I'm going to put it right here. That's if something was wrong with the DB. But what if everything was okay with the DB, but the actual habit doesn't exist? So what could be the issue? Like now that I'm thinking about this, perhaps I should change these two positions, because if log exists, what are the chances that the habit doesn't exist? Because any habit has a log. I mean, there could be there could be a possibility, right? That the habit doesn't exist and for some reason we just have like an orphaned log inside of the DB. So I could just get rid of this entirely, get rid of this parent check, because if log exists, let me see. I don't want to write like repetitive code. So this is the get habit log by ID. Here we are selecting this. If no rows, we return nil, nil. Failed to fetch habits log. So get habit log by ID. Habit log not found. I said that this if statement refers to, I actually said that refers to this kind of an error, but it is actually this one. So I need to backtrack on this. And I am sorry for explaining it like in a different place, but that's basically the same idea. It's just this error that I showed you here, this one, habit log not found. This actually comes from our very first step in which we talk to this get habit log by ID. And this message is going to appear where we here where we say nil. So this function, this repository operation. But instead, by mistake, I explained it here. It's almost the same idea, but the actual position for that is here. And I am sorry for that once again. So I didn't pay like close attention to it. But now that I'm looking at it, why do we need to actually check that this habit exists or not? We know that this habit, if log is not there, if habit is not there, there is no way that log is going to exist. Create habit log. So here is where we create that. Okay. Select. So this is get habit log by ID. Now, the problem that I'm actually wrestling with right now is that This get habit with user check, this is supposed to be a parent. This is supposed to be the parent of the log. But yet somehow this parent, basically it is dependent on the child for the parent to be true. So if this log doesn't exist, where do I get this habit ID? So you can see I am trying to, so this is like some kind of, you could say like a circular check that we're trying to do. We're trying to check with the help of the parent if the child, which is log, exists. But we're using the child itself to check if the child exists. So if log exists, then what is the purpose of this check? But then what is the purpose of this check if we do not pass in log there? So you can see log, because we don't have access to the habit ID like inside of this resolver. We don't have access to it. We just have access to the user ID, which we got from the token. And we do not expect the habit ID to be passed by the user. So this is like a circular check. I'm using parent with the help of child to check if child exists. So this parent check should be independent of this log for us to really know that this log exists or not. But the parent itself relies on the child to check if that child exists. So this is like, you hear this term like circular financing, circular this. You could call this, I'm not saying that's the correct terminology, you could call this like circular like verification that we're trying to do here. So I'm just going to move fast from this. Step 2, and basically we're just going to go ahead and we're going to delete this. So I'm not going to write this step. I'm just going to go ahead and I'm going to delete this. And if we go to the playground and there is some issues, we are definitely going to fix that. So here is where I call this repository operation. This is going to give me like this deleted flag, which is a Boolean flag. This should be colon. Now, if error is not nil, it's going to be the same thing. There was some issue that we were not able to delete this log. But if deleted is false, I'm just going to copy that and I'm going to fix this. So if deleted is false, come on, buddy. There we go. Then we return false from this resolver and we say habit log not found. And this specific error is exactly the error that we're going to show for this rows affected. That's the one, because that actually talks to the delete habit log. Very good. Now, if we don't see any issues, what happens next is we say return true and return null for the error. So there was no issue there. We didn't use this user ID. So how am I going to say that user is not authorized? If I don't use this, what can we do here? What can we do? So this user ID, it has to be if okay. So let me just pass in an underscore for that user ID. What am I doing? An underscore for the user ID. We don't use it. But if this process is not okay, then we return unauthorized. So I should remember to check the deletion of a log without the token so we can see if that actually works. So let's save this. Let's go to the table. We don't see any logs here. So the first thing is we need to actually create these logs. So there we go. This is delete habit. I'm going to log in. So it doesn't really matter which account it is. You log in. We are going to select this token from here, copy it. And here I'm going to say authorization and bearer. There we go. So let's come to the habits table. We don't see anything. I'm logged in with John's account and I'm going to create a habit for John. So We have all of this. The creation of the habit is actually a mutation. Create habit. And I'm going to pass a name. That's going to be habit 1. And I'm going to, I actually hit enter, so that's why it ran it, even though I just wanted to move to the next line. So habit 1, description. Very good. What do we select? We could select the name. Name of the habit is enough. Send this habit 1. So we created one habit, and that's enough. That's enough for now. Let's go ahead and let's create the log. So create habit, or sorry, that is check-in habit. Yep. We need to pass in the habit ID. Copy. And that was habit ID. I'm going to pass it there. If I do not provide any kind of date, let's say completed date, the completed date is going to default to today. Let's just bring it down and bring this down. Run this. There we go, 16:6. Very good. So we have a log here. And let's actually create another log. So that's going to be, what was that? The query, that was date, right? So date is 2026/06 14. That's another one. Let's do 13. Another one, 12. Oh, that should be 12, 11, 10. Let's refresh this. There we go. So we have several logs. Let's say I want to get rid of the one that has this one, the 10th one, or the 14th one, this one right here. So let's say I want to get rid of this log. How can I get rid of this? First off, we need to actually run delete habit log. What is this going to require? This is going to require the ID of the log that we are trying to delete. So here I'm going to pass in the ID of the log. So this is the one. I just copied that and I'm going to paste. Oh, it just copied the entire thing. So let's just click away, click here, copy it. This is the one that I want to delete. Put it here and I'm going to send this. It says true. It says true. So now refresh the DB, 14 is gone. Now let's say we want to delete 13, right before that. But for that, let's first run this again. You can see it says habit log not found. Okay, very good, very good. And now let's get rid of the token. And I'm going to select the ID of this habit, copy it, and I'm going to put it right here. And I'm going to send this unauthorized. Very good. See, so this works fine. I'm just going to Control Z there. And if I just run it again, it says true. So without the token, that's not going to work. Refresh the page, refresh the DB. You can see 2 records are gone. Now let's say I want to get rid of this 12th one. But before doing that, I am going to log in with the Bob's account. I'm going to create a habit for Bob, and then we're going to see, or basically, you know what? Let's log in with Bob's account and see if Bob can delete a habit log that belongs to John. So B-Smith, very good. B-Smith, I'm going to log in, copy. I should come right here, delete habit log, very good. And which one is this? Delete, oh, there we go. That one has the authorization. I'm just going to change this, get rid of all of it, and I'm going to paste this one, the one that ends with M0M. So let's select. First, let's select the ID of the habit that belongs to John, and now it's Bob who wants to delete it. Yeah, first let's pass that. So that's going to be delete habit. that is going to require ID, and I'm going to pass the ID. As soon as I run this, habit not found, because this habit actually belongs to John, and now Bob is trying to delete that. So that didn't pass. What about the habit lock? So this 12th one, I'm going to select the ID. See, I'm selecting the ID of the lock, not the ID of the habit. So I'll just copy it, come right here, and get rid of this, paste that, 77. Run this, habit not found. Oh, sorry, this is delete habit. This should be delete habit lock, because the message should change. Delete habit lock. We don't do the ownership check, right? See, we don't do the ownership check. Oh boy. So Bob can delete logs that belong to John because we don't do the ownership check. Let's see that again. So I'm selecting the habit. Bob was not able to delete, but the logs Bob can delete, and that's a very big vulnerability, extremely difficult. So there we go. That's a big security issue. Whoopsie. Bob can do that. Now, how do we fix it? Well, again, we need to bring back this because we need to actually do this user check. So I am going to bring this back, even though this seems like it is like circular kind of circular verification. But even though it looks like that, we still need this for this ownership check. We need it. So to this, I'm going to add actually another thing. So if this habit is nil, so the habit doesn't exist, I'm still going to return false, and I'm going to say fmt.errorf. It's a very good thing that we did that check. Parent habit not found. And now, how do we do this ownership check? We have, the way that we can do that is take a look at this habit. So the habit itself, it has this user ID column. So we say if this ID that is inside of this user ID column is the same ID that is here that we got from the token, if these two match, that means it's the same user. But the ID that I get from the token, it belongs to Bob, right? Currently, the way that this security vulnerability is working is the ID that we select from this token belongs to Bob. But the ID of the habit belongs to John. So these two are two different IDs. We didn't do this check. So we're going to do that check, and we say if these two IDs do not match, then that means it's not the same user. So we're going to say if habit, so on the habit, if I do dot, you can see I have a user ID. So this is the one that's inside of the database. This is the correct one, right? Again, this habit.user ID is the one that's inside of DB because we get it from this habit that we received from this get habit with user check. That's the one, right? So we say if this is not equal to the user ID, now this user ID is the one that we received above. So if I just go a little bit out, they just disappear. So I should zoom this out. So there you go. So see this user ID? It is the same one that we have here. So this user ID is right here that we get from this get user ID from the context. See the context, which means this is the token user ID. This user ID is this one. So this is the token. In this current situation, token belongs to Bob. But this user ID on the habit, it belongs to John. So what happens? Let's actually take a look at that inside of the DB. See, this user ID that belongs to John, this is 023. It ends with that. But here, take a look at this. 023, this is John. 84FA is Bob. So the one that is inside of the table, that's the correct one. This is the correct one. This is the ID of John. But the one that we receive with the token, that is not the correct one. So we need to actually do this check. And if this check fails, what do we say? We say return false, do not delete records. You're not allowed to delete someone else's records or someone else's posts. You're not allowed to do that. So we need to make sure that that is not allowed. And for this, the only message that you say is you're not authorized to do this. So it's unauthorized. Let's save this. Let's try this again. Try this again. John unfortunately lost like 2 of the records because of that security vulnerability. And now let's see if he has to suffer another loss. I selected the one that is this 10th one. And now I'm going to go to the playground. We did that check, remember? And I'm going to pass that there, and there we go. Habit not found. Delete habit log. The error is habit not found. If habit is, if habit is null, then we say parent habit not found. We pass in the error. The error is coming from here. So if I go to the playground, delete habit log. So it's clear. It is this one, delete habit log, habit not found. Habit log not found. So this, like the log that you're trying to delete, the habit for it, we didn't find that habit. If error is not null. So if here, if I do fmt.errorf, habit log not found 1, 2, 3, just like that. Or I should say just testing. Save this. Failed to fetch npm GraphQL. Let's run this. There we go. Just testing. See? So we could change it with this instead of saying, so when you're running this mutation inside of the habit log, why should I say habit not found, right? Because habit was found because we're throwing this, we're not throwing this. So habit exists. It's not like habit is nil. So we are here. Here, habit exists, but there was something else that was wrong with the DB. So instead of returning that, and then that repository operation is going to say, because repository operation just belongs to habit, this one, this is just involved with habit, it just says habit not found. And you see, okay, I'm not looking for the habit, I'm looking to delete the log. Why is it saying habit not found? It should say habit log not found. So I think this is like a better message. Not only you cannot do it, so if I come right here, refresh this, see 10, this date is right here. Not only you cannot do it, you're also going to see habit log not found. So this log that actually exists on the DB doesn't belong to you. It belongs to John. So I'm just going to say habit log not found. And now I'm going to get rid of this testing. If you wanted to, you could provide like a placeholder for that. And now let's see what the error message is going to be. First one, this, of course, and now let's run it again. Habit log not found, habit not found. So it's actually up to you if you want to do this, but I think just habit log not found is enough. And now, yeah, that's it. So you're not authorized to do that. Habit log not found. It doesn't even pass this. It doesn't even get here. So even if I like get rid of these two and now save this and try to run it again, internal system error. Run this again. You cannot, I don't think you should be able to delete it. Yeah, there we go. You can see it actually stays there. But let's bring these back. So we have all these checks, and then again we check the habit, the user ID of the user who wants to delete this. Let me bring this to the top of this, put it there. Let's see what happens now. Internal system error. This is not a delete habit log. So it's the same thing, but you know what? Let's just put it down. And now let's run it again. Habit log not found. It doesn't matter how many times you click on it. Habit log not found. And there we go. You cannot delete this. So that's very good. So with this, I think we're actually done with the log part as well. We were able to, now what can you do? You can sign up, you can change your information like name, email, and password, all three of them. That's very good, right? You can create habits, you can update, delete, so all operations on the habits. And then we have those foreign key resolvers implemented as well. Now, so everything, like you can create logs, you can delete logs, and all of the checks that are going to be there. All of the checks are actually implemented. Let me collapse this one. Now I'm thinking, as I'm explaining this, I'm thinking about what the next step should be. So we know that there is like a few calculations that we need to do. Collapse this. And what are those calculations? Those ones are inside of the schema.graphqls. I could just show it to you. So we have this current streak, longest streak. So these are two of them. We need to also have something for total completions. We need to do that as well. But then I want to show you some more resolvers that you can use in order to actually just get overall information when it comes to your habits. And I'm actually thinking about these, that how many of these should I actually go ahead and show it to you. And these are actually called field resolvers. They are a little bit different than the resolvers that we have actually created so far. And I want to talk about them. And I am going to show you 4 resolvers. So you're going to have, so when you call, remember we had, if I go to the, so here we are, this is our query. So remember this me query where it actually shows who is the authenticated user. What we can do is we can have this show all of the habits of the user. So when you like go ahead and call this me query, not only you're going to see your information, but you're also going to see all of your habits, your habit logs. So these field resolvers are going to be in this context. So we're going to create one for user habits. We're going to, and if you remember correctly, like a while back, we checked something that didn't work. So inside of the query, so inside of the, we selected the habits, but then I passed in user here. So it didn't work. So you can select a habit and immediately you can take a look at the information of the user who owns that habit. So these are like some extra resolvers that I want to show you that how they work. But you can, of course, just hit the pause here. But that API, in this way, if you just pause here, the API is not going to be complete because this is like a way bigger API than the previous one that I built for Go, that REST API. I want to actually show you something aside from like just like a to-do API, like add something, delete something, update something, and get something. But I actually want to show you like something that is useful. So that's the idea behind like these field resolvers. But before going ahead and explaining and defining what a field resolver is and how it is different from the query resolvers, query mutation resolvers that we have created so far, I need to actually show it to you what I mean by this and what is the reason behind this. So let's say, first off, let's open up the schema.graphql files. So this is our schema.graphql file, and the idea, this was like one of the first things that we created. The idea behind this is, again, that this shows what is allowed by this API for users to send us queries and what is allowed for us to send them responses. So all of the capabilities of the API is right here. We have the user type, we have the habit type, habit log. We saw the auth payload, the query. Then we had these mutations, which we implemented all of them. We implemented all of the queries. But there is just a couple of things. There's just a few things that we have not implemented. So let's start with those. The first thing is this one. So you can see I am within something that's called a user struct. And in here, I can see this. So technically, I should be able to handle a request that user wants to see their own information along with their habits. But we haven't written anything for this, right? We cannot resolve this. Our API cannot resolve this right now. And then it also goes in reverse. So we have the person to whom the habits belong, and then you have the habits that belong to a specific person. So you can see we go in two different directions, right? So we go from user to habit, and we also go from habit to user. And this is something called bidirectional traversal. And this is actually a power that GraphQL API has over REST API. You cannot do this with a REST API in a single endpoint, but we can do this in a single endpoint with GraphQL. And we can go as nested as we want. And I'm going to show you that you can actually go nested 1 level, 2 level, 3 levels, 4 levels, 5 levels. Technically and theoretically, you can go infinity level nested, but you can't do that with a REST API. But I'm going to get to that. But for now, what I want to do is I want to be able to show one user all of their habits if they send me that kind of a query. And then if I receive a query for habit, I should be able to show who is the owner of that habit. So these are two different field resolvers. I'm going to come back to the definition of a field resolver in just a moment, but there is something else that I want to show you as well. So the relationship that user has with the habit, as in user is the owner of the habit, it's the same relationship that habit has to the habit log. Habit is the owner of the habit log. So we should be able to find out what are the logs, what are all of the logs for one specific habit, as with we should be able to find what are the habits, all the habits for one specific user. So all habits, one specific user, all logs, one specific habit. I hope I'm not explaining this. So I'm like hearing myself and I'm like thinking, okay, am I saying this correctly? So I'm just going to repeat myself just for surety. So one user, several habits or all of their habits, and then one habit, all of the habit logs, right? And then this goes in the other direction as well. So we end up with sort of up until now with like 4 field resolvers. Now this was the theory. Let's see this in action. So I'm going to go to the query and we are going to implement the me one first, this user one. So I should be able to call this is a query resolver, right? Now it has been some time, so I'm gonna need to log in first. This is Bob. So this is 023. That's John Smith, J Smith. So I'm going to log in with John Smith account information. That's J Smith. Log in. We need that token. We need to have the token. So I'm going to copy that and delete all of this. We're going to go to header and I'm going to pass that authorization. First, we need to see the limitation of the API. I need to show you what the problem is. then I'm going to show you the solution, because I don't like showing you the solution and then we don't even know what the problem is to which we need this solution. Why can't I select this? Yeah, let's get it up until, I think I selected all of that anyway. So we have this query. Remember, so if I say me, I can select the ID, the name. Do we need the ID? No, let's get rid of it. Doesn't make sense anyway. We can select the email, right? So if you just select this, this is the user, ID, name, email, right? And then I'm gonna do habits, right? Habits, and then create that. Already you can see there is a squiggly, and then there is the updated at. You can already see that there is a squiggly because this is a resolver that we have not actually implemented. Now, if I run this, internal system error, I don't know what this is, and it just completed this on its own. So if I get rid of this, run this, we get John Smith, J Smith, whatever. We get the information, but we clearly see that we have habits. So imagine I want to see all of my habits. I want to see my information and all of the habits that I own. How can I do that? Now, this is where a field resolver comes into the picture. Now, a field resolver is something that you run, that not you, it is something that GraphQL or gqlgen is going to run automatically. Now, why does it do it? Because when gqlgen hits a field or gets a field, for example, for the client, for this me query, and it sees a field that doesn't exist on the struct that we have created, right? Now you need to keep in mind, it also takes a look at the model that we have here. It also takes a look at this. You can see we don't have habit here, even though we have it inside of Schema GraphQLs, because Schema GraphQLs talks about the request that we can receive, the response that we can send, but this is the model for the user that we can basically communicate throughout this API. But user is not exposed to this. User is exposed, the end user is exposed, or our client is exposed to what we have inside of the GraphQLs, inside of this GraphQLs file. So what we do is, we need to actually go ahead and resolve this inside of a field resolver. And the field resolver's job is just one thing. Go get that missing data and return it. So in this example, that we cannot select the habits on this me query, what is the field resolver going to do? So GraphQLgen is going to need to call some kind of a field resolver to go fetch this information from the database. Do we have this information on the DB? Yes, we do. We can see we have a user that's called John, and John has a habit. So we can clearly see we have these and they're connected inside of the DB. So the only thing that we need to do is we need to actually tell GraphQL to actually connect these two. GraphQLgen is not going to be able to automatically do this like magically. We need to tell it, okay, if you receive something, for example, you receive a query that needs to have habits, run this resolver. And this is going to give you the habits. This is going to resolve that. So that's the entire difference between these two kinds of resolvers. So we have only talked about higher level. You can call them entry point level or higher level or top level resolvers. And what are those? They are mutation in this file that we talked about, and they're also query in this file that we talked about. But now we're going to create a field resolver. Now, you need to also distinguish that when you receive a request with a GraphQL API, through a GraphQL API, the field resolver is never going to run first. So it's going to be either the mutation or query resolver that's going to run first. Then after they are resolved, you need to keep this in mind. After they're resolved, then the field resolver is going to fill the gaps only. And that's it. And that is only going to run if those gaps, if those fields are requested, but they're not existent so far. Much like this habit that doesn't, even though we said we have this ability for user to select all, to take a look at all of their habits, since we have not implemented this in a field resolver, it's not possible for them to do this. So that's why we need this field resolver. So it's going to run automatically, and it is going to just fill in the gaps. Just fill in the gaps. It's not going to do anything else. All right. So what is the gap? The gap is we should be able to take a look at all of our habits. That is something we should be able to do this without facing an internal system error. So how do we do this? Now we have talked about a lot of things, and doing this is extremely simple. So what I'm going to do is inside of this, now we say we are looking for resolvers, right? So inside of this graph folder, GraphQL folder, where we have created all of our resolvers, see, here I have the mutation and the query resolver. Inside of this resolvers folder, I have this user.go. And you're familiar with this, right? Here we implemented the created at and the updated at. This is where we implemented those. Now, before writing anything here, let's think about this. This is a resolver that I know it's a field resolver, but at the end of the day, it's a resolver that resolves a GraphQL query. What does it mean? It needs to have, it needs to create a response to a request. So when something creates a response to a request in GraphQL language, that's a resolver. So it resolves that request. Cool. So now that we are on the same page, we know that this is a resolver. And we also know that we generated function stubs for all of the resolvers. So technically speaking, we must have this field resolver already created as a function stub inside of the schema that resolvers. So remember, we copy pasted all of the resolvers, whether they were query resolver or mutation resolver, whatever. We copy pasted them from here. If it didn't exist here, like the ones that we created for habit log, we generated them again, remember? Because the date was incorrect, the inside of the model, it was string, it had to be time.time. So if the stub doesn't exist for the resolver and you create the resolver, that means gqlgen was not able to generate that automatically because we need these to be bound together inside of that YAML file, right? So that's why it's important. So the field resolver that I'm looking for, even though it's a field resolver, at the end of the day, it is a resolver whose function stub must exist. So let's go through this. So which one it is that we're actually trying to look for? So we are trying to get habits and put them inside of that user or that me query. So are we looking for the current streak? No. Longest streak? No. Logs? No. User? We're going to get to this, but for now, no. Which one is it that we're looking for? Are we looking for a single habit? No, user might have 100 habits. Are we looking for this one? Yes. And you can see it is a user resolver, the type of this. And if you take a look at this, well, it seems like this is just a normal resolver. And yes, it is. But technically, it's called a field resolver because we're not going to run this directly. It is just going to be run inside of another top-level query, whether that's a query or a mutation. So this is the one that we're actually looking for. So what am I going to do? I'm just going to copy this. Where should I put this? Should I put it inside of mutation? No, because it doesn't change data. Should I put it inside of query? No, because this is not a query resolver. Now, where am I going to put it? I can't put it inside of the models. This is the model for database and JSON responses. I can't put it there. But I do have this user.go file, which is available inside of the resolvers folder, remember? Which is then in graph, which is then in internal, in which I already have two resolvers for created at and updated at time. What do these times refer to? To what part of the API? They refer to the user, see? So when you created a user, this is the created at time. When you updated the user information, name, email, password, this is the updated at time. So right beneath this, I'm just going to put that here. I could copy the comment of it as well, just so, because these two have comments. I'm going to put that, I'm going to put the comment there as well. Now, let's get rid of this. We're not actually done with this, even though this is going to contain very, very little code. There is one more part that I want to explain in depth, because I want you to actually like really see this. And when you see this and understand it, it should be easy for you to, like, it doesn't matter what the context or the project is or how big it is, you should be able to actually see these patterns and understand them and leverage them. So first off, let's take a look at the function signature. It's the function, it's a user resolver. As I said, it resembles any other query or mutation resolver. This is habits, cool. We get our CTX, that's very important, even though we might not use it or we might use it, let's see. But the reason that we have it, so every one of these stubs, they must have the same kind of structure, this context. Then we have this object. Now the object, even though I did not want to talk about it, you can see the type of it is user. So object is what? It's user. Object is the query for which we are trying to resolve something. What is the query? Let's take a look at it. The query is me. Isn't me user? It is user, right? So object basically refers to the user. Now, I'm going to come back to this object because this is in just a moment, because this is very, very important. So far, we talked about what a field resolver is, how it is run automatically by gqlgen. What is the function of this field resolver? It just fills the gaps inside of an already resolved query or an already resolved mutation, right? So it's most of the times, like for majority of the times, it's just going to be you load information and you just need more information. So it's like highly likely that it's going to be always a query resolver. So it just fulfills the gaps inside of a query and it just fetches the missing information from the DB. But it only does it if the query is already resolved. If the query is already resolved and there is just this piece of information that's missing, then we just resolve that using this field resolver. That's what a field resolver means. That's what it does. So we talked about all of these, right? And now let's talk about how we can actually find this out. Where can we get all of the habits? Where should I go? To which repository operation should I go? Now keep in mind, resolver doesn't talk to the DB directly. Resolver talks to another function, and then that function talks to the DB directly. Which function does talk to the DB directly? It's repository operations, right? That's why they're called repository operations. So which one should I open? I'm looking for habits. Which one should I open? Which repository file? So see here, I have this repository. That's why these are separated. I have this repository. Should I open up the log, the habit, or the user? What am I looking for? You need to like see what you're looking for. You need to imagine that. I'm looking for habits. So should I look for habits here? Or should I look for them here? Or should I look for them here? Even though I'm trying to resolve a user query, but I'm not looking for user information. I'm looking for habit information. So I should go here, right? So now let's crack it open. Let's take a look at it. Let's see which of these repository operations is going to give us all of the habits that belong to one user. So this is create habit, the first one. Does it give us habits? No, it just creates them. This is get habits by user ID. So you can see clearly this returns a slice that has a habit type, and it gives us all of the habits by user ID. So this is what we're looking for. It seems like this is the repository operation that we're going to go to, and then this is going to talk to the DB and get all the information. But what about the next one? This is get habit with user check. So this is going to give me a singular habit. That's not what I want. User might have like 100 habits. So this is not it. And this clearly says update habit. I'm not looking to update something, and I'm clearly not looking to delete something. So the highly likely, like the higher, how can I put this? So the repository operation that's the most suitable for our purpose is this, get habits by user ID. Very good. But this user ID is something that we need to actually talk about, and that's what this object actually refers to. Okay, so let's go ahead and call this. So how do I call that repository operation? How do I call it? We know that that's available on this R, on this receiver. So I do R dot, which repo do I select? Habit log, habit, or user. I'm going to select the habit. And because that repository operation is available here. There we go. Get habit here. This is the one. Get habits, plural, by user ID. Very good. Now, the question is, what should I do here? Now here is, I truly want you to go ahead and pause the video and think about this, to really understand this. What does this get habits by user ID need from us? If you hover on this, it needs to have the user ID. What should I do? Should I extract the user ID from the context, or should I extract it from this object? What should I do? Please pause the video and think about this. This is very, very important. I hope you paused the video and you thought about this. So whatever your answer is, I'm just going to go ahead and I'm going to explain this to you. We have two possibilities. One possibility is to select this from the CTX. We already have a shovel that does this for us, right? We talked about that shovel repeatedly, and it is this get user ID. We could do that, but that's not the expected way for us to go about this. So when we talk about this, there is a term that we actually use, that is, we want to make sure that the user ID is the correct user ID by design, rather than by coincidence. So in the context of this API, I need to be very clear. In the context of this small API, it doesn't matter if I select the user ID from CTX. Let me just remove that, use this. It doesn't matter if I select it from this CTX, the user ID, because this needs that user ID so we can know what the habits are that belong to this user. It doesn't matter. Or if I select it from this object. But now keep in mind, these are like very small things, small concepts that we talk about them, that you should be able to implement them in larger scale applications as well. But imagine, this is a big API. This is a very, very big API. And then there is an admin dashboard. There is actually a person who is taking a look at different accounts. And there comes a day where you face an issue with, for example, something that refers to your habits. Perhaps you cannot create a log for a habit. Perhaps streak calculations are wrong. So what you do, you call customer service, right? For this API. Perhaps you have already done this kind of a thing, whether that pertains to social media or to Amazon or to your bank account, your like account transactions. There is some issue. You call customer service. Now, customer service has to log into your account, right? So when customer service logs into your account, what happens? The customer service agent is going to get a token. That token is right here. That's what they get. But in that scenario, the token that they got Is that the token that you got when you logged in? No. So in that big application, for example, you have an issue with your bank account, some transactions, that's like a common one. So you go to the bank and they have to log into your account. If we were to use this context, if we were to code this, the customer service agent is just going to see their own transactions, their own habits, because they're not going to be able to log into your account because you said the user ID is this user ID, the one that we got from the token, the one that is logged in, the person who is logged in. So they are going to log into your account, but through the admin dashboard of that bank or whatever the account is, or the Amazon agent or customer service. They're going to log into your account, but the way that they're going to come into your account is through their own account. So they have an account and then they're going to take a look at your account. But the token is issued to their account. So again, in the context of the small API, it doesn't matter because we don't have an admin. The one who is logged in is the one for whom we are trying to resolve this query. It doesn't matter. But in the context of a larger application, that actually matters. So if you want, as the developer, for that bank agent or customer service to see your transactions and to see what the issue is, you should take a look at the object, because the object contains the user information for whom we're trying to resolve this query. We're not looking for who is logged in. We're looking for whom we're trying to resolve these transactions or these habits or this issue or these orders that we have on Amazon, whatever that is, whatever website that is. So that's why we select the ID of the user from the object. Object always refers to the person or to the thing for which we're trying to resolve, aka we're trying to create a response. Am I creating a response for the customer service agent? No. I'm trying to create a response for the user. Where is the ID of the user? The ID of the user is here. In the context of a small API, the ID of the user is also inside of the context. But in a larger application, this context will hold the ID of the admin. It's not going to hold the ID of the user. So if admin doesn't have the information of the user, how are they going to be able to solve your issue? I know you might be saying, okay, habits, they're private. They're my habits. So are bank transactions. Bank transactions are also private. But the bank or the customer agent or customer service agent at the bank, they can see your information. They can see all of your transactions, even though bank transactions are highly confidential. They're private. They show your routine. They show what you did, where you went, to which city you traveled, what you bought, how much money you spent on that, where the money came in, where the money went out. So I would argue that bank transactions are more private and more important than habits, right? But you gave them your information because there is an issue and they are authorized to do this. You're not going to give it to someone on the street. You're going to give it to people who are authorized. So as the developer, you should be able to actually code this and understand the difference. If someone is trying to log into your account who is authorized, the token is going to belong to them. But you are trying to resolve this issue for yourself. How can you do that? Well, you need to pass in your own ID so they can access your account. So I just went on this rant and I hope you really understood this. And that's why as soon as I do object and dot, you can see I have the ID. So this object.id belongs to the person or to the thing for whom or for which we're trying to resolve this query, or for whom and for which we're trying to create a response. This is that person, not who is logged in, because it could be admin that is logged in. But who is the one that needs to have the response? It's the client. So this ID belongs to the client. Context is not going to always belong to the client. So this is something that's called, we're doing it by design rather by coincidence. So I hope you really understood this, right? So these are like, again, in small APIs, they don't make a lot of difference. They make a lot of sense, but not a lot of difference. But then again, these like industry level standards, you need to learn them somewhere. So in the context of these small APIs, it's very easy for me to explain all of this so you can like really see what is happening here, right? So you can implement it in larger contexts. Now, what does this return? If you hover on this, it returns a slice of habits and then also error. So let's see that. We are going to get habits and error. Very good. First, what do? We take a look at the error. So we're going to say if error is not null, what do? We return null for the habits. We don't return the habits because there was an error. And then we take a look at the error. The error could be whatever that we have already talked about extensively inside of the get habits by user ID. But if we don't have any errors, what do? We return all of the habits. If we do not have any kind of errors, we return all of the habits and we return null for the error. So now we have this habits, which is duplicate, which is right here. Let's get rid of it from there. Now we should be able to actually go ahead and call all of the habits on this. And now if I just write habit, you can see I have these. So I'm just going to open this up. I'm going to pass an ID, a name, and description. I even have autocomplete. So let's prettify this. Let's pass in query, run this, and there we go. We weren't able to do this before. So even if I just pass that again here, like comment this part out, save this. Now run this again. You can see we get an issue. Run it again, internal system error. And now bring this back, save it, get rid of this, save it. I just wanted to make sure that this actually works. There we go. We get the habit. But what if this user has more than one habit? Well, we can do that as well. So I'm going to cut this. I'm going to create a mutation. That is create habit. Name is going to be, I'm not going to even try. I'm just going to say habit 2. Whoops. Again, enter. I do control enter. That's like a habit from VS Code. That's going to be habit 2 DASC dot. Okay, here we could have the name of the habits. Yeah, so we created this. And now I'm going to go and I'm going to create habit 3. Let's create 3 habits or 5 habits. And then I have habit 4. 5 habits is good, right? This user has 5 habits. Let's check that inside of the DB. There we go. We have all of that. And now I'm just going to paste this, run this. And now this, you can take a look at all of the habits for one specific user. And the way these habits are arranged, that's what we already specified inside of this repository operation. We said, so now you can see, you know everything about this code base, right? We talked about this. You can see this is a cursor. And we said order by DSC. So order descending, which means created at is descending, which means newest first. There we go. Or last first. You can say that as well. You can get rid of the ID, get rid of the description. This is not something that REST API gives you, but this is something that GraphQL gives you. Habit 5, 4, 3, 2, 1. So these could be your habits. You can get rid of these. And there we go. Now, you could go ahead and actually nest this, but that's not something that we have implemented. So on the habit, if you take a look at the habits, click on this, you can see you have all of these things. You can also take a look at the user again. So that's nesting. So far we have this level 1, which is me. So this is level 1. Let me just, I use shortcuts so they actually interfere. Level 1, this is the top level. This is 1 level deep. This is another level deep, so that's 2 levels deep. You can also do user, and then you can take a look at the name of the user. Even though it shows there, but you have this ability. If I run this, why do I get internal system error? Because I don't have a field resolver for this part. Isn't this the same error that we got for habits? We implemented a field resolver for it, right? And now we don't get that for habits, but we still get the other way around error. So remember I talked about this a while, just like 30 minutes ago or so, inside of the GraphQL. So we said inside of the user, we should see all of the habits. That's one way, that's top to bottom. But inside of the habit, we should see the owner. That's bottom to top. So top to bottom, one direction, bottom to top, the other direction. That's bidirectional traversal. So we go owner to habits, and then we go habits to owner. And you can just nest this as deep as you want. Why doesn't it work? Because we have coded one of these directions, which is owner to habit, but the reverse of it, which is habit to owner, we have not created a field resolver for that. That's the next field resolver that we are going to create. So we need to jump. Now I want to create a field resolver for habit. I don't want to create it for user, right? So for user, I created this because you can see this belongs to user resolver, again, user resolver, again, user resolver, and user.go. So these must be in their correct places, right? And now what we want to do is we want to actually create a user inside of the habit. We created habit inside of the user. Now create user inside of the habit. Which one? This one? No. This one? No. This one? No. This one? Perhaps. So this is a habit resolver. First, let's open that file up. So we selected this user, right? And inside of the same resolvers folder, we also have habit.go. I'm going to close that repository. So if I take a look at these, you can see the common resolver is this habit resolver. So habit resolver inside of the habit.go. So I'm looking for something that is habit resolver that shows information about the user. And now the object is reverse. See? And the user one, it was models.user, but because we are trying to find out user for a habit, it just returns the habit. So where is the habit ID? It's inside of here. So this is the correct one. I'm going to copy that, come right here. I'm going to put it there. What do? We get rid of this. First, we take a look at the signature for this, right? So this is a function. And it has this resolver, habit resolver, which is the same as the previous two. Now this created that and this updated that, they refer to the habit. They created that time for the habit and they updated that time for the habit. We have this context again, which has the user ID, but the habit ID is inside of here. What does it return? Now we want to take a look at owner inside of the habit. So it returns the owner. In the previous one, we took a look at habit inside the owner, but now it's reverse, right? It's in the reverse direction. How do we go about this? Well, this is extremely simple. Where do we get the owner of a habit? Where do I get that? Should I go inside of the habit repository or habit log or user? Where do I get the owner for a specific habit? Well, we should go inside of the, much like to find out the habit, we went inside of the habit repository. To find out the user, we need to go inside of the user repository. Now, which one? This creates the user. This gets the user by email. This is one candidate for us. So this gets the user, but we need to pass in the email address. This gets the user, but by ID. So both of these actually get. But we need to come back to them which one we need. This updates the user, this deletes the user. We don't need these two. So which of these two? What do you think? Should I select this one or should I select this one? Now let's come back to this. It is this habit. So on the object that is a habit, what do we have? So we can take a look at this obj. If I do the dot, you can see I have created that, current streak, description, ID, longest streak, name, total completions, updated that, and user ID. So let's go into the schema.graphqls. Do I have, so I'm talking about this, right? I'm trying to fulfill this. This is missing this field. We're going to come back to these two later. These are going to be the last things that we're going to do. For now, we're trying to implement this. We already implemented this, so it didn't have this habits. We implemented the field resolver for it, and now we're trying to implement this habit. Do we have the email of the user anywhere in here? No, we don't. We just have the ID of the user. So which one of these should I use? I'm going to select the ID. So that's why we have two. You can select user by email and you can select user by ID. Which one do we use? See, if I do the dot, I have the user ID. I don't have the user email. Where is user email? I just have the user ID. So which of these repository operations selects or accepts user ID? It's this one. So I can just copy that, come right here, surround this with parentheses, put that there. And where is this available? This is our user repo. Dot. What is this going to return? This is going to return. Now, we need owner inside of habit. So this returns owner and error. Initialize that. What about the error? We know what about the error. The error is exactly this. So I'm just going to copy it from there, put it there. It's very general. But what if this operation is successful? If this operation is successful, well, I'm going to do one more check. What if this user doesn't exist? And somehow this habit is still inside of the DB. Well, this is just a check. So you don't have to do this, but I need to be thorough. I want to be thorough. I'm going to say return nil. So return nil for the user. And I'm going to say fmt.errorf user not found. Perhaps this user doesn't exist. Perhaps something was messed up inside of the DB. I still need to have a check there, right? But if everything goes according to the plan, we get the owner and we give it to the habit. So again, in here, we had owner to habit. In habit, we have habit to owner, the reverse of it. So we created this. We implemented this, right, inside of the habit. What should I do next? Well, I need to get rid of it from here. Save this. Well, I'm going to keep this. I'm going to comment this one out. We're going to run this to get that error. And then I'm going to basically bring this back so we can actually see, okay, this is not going to work the other way around. So how is that going to work? That's going to be a query, of course. So we want to take a look at a specific habits information or owner, right? So owner inside of the habit. Let's pass in the habit ID. Which one should I select? All of them have the same owner. So I could just select this first one, come right here, pass it there. So that's the habit for which we're trying to find out who the owner is. So I'm going to select the name of the habit, the description of the habit, and then I'm going to pass in user. So for user, description, user, I could pass in, give me the name of the owner, right? I could, again, I just hit enter, so that's why it's doing that. And also give me the email of the owner. If I run this, internal system error, you can see, I just keep clicking and it doesn't work. Internal system error because it doesn't exist. This field, there is no field resolver to fulfill or to fill this gap inside of the query. There is no one. So as soon as we define it, that gap is going to be filled. So I'm just going to bring this back, save this, get rid of this, save this, and now run it. Wait for it. There we go. So I have this habit, the name, the description, and I also have the user. to whom this habit belongs. And now that we have this ability to call the owner inside of the habit, this missing information is now fulfilled, or we have found it, and we can now give it to any query that is asking for it. So let's see. We also have the ability to fetch all the habits for a specific user. So in that scenario, I'm just going to get rid of all of this and I'm going to type this out. So this is the habits. We can take a look at the name of the habits, right? That's shorter for us, better. But then inside of here, I can also say user. But then again, I can do this as long as we have that schema inside of the GraphQL's file. We have that schema, then we can do this. And then I'm going to take a look at the name and take a look at the email. So if I run this, this is going to show all of the habits, but it is also going to show their owner, right? So now you can see, not only we can do that for the singular habit, we can do that for the plural habit. It's of course the same owner, but it is something that you can do. You can also do now, you can do this now as well. So we had this me. In here, I'm going to select the name, email. Then I have habits. So I'm going to go. So the first level was name and email. The second level is habits. I can select the name of the habits. But then the third level is going to be user itself. So see, that's third level. That's going to be the name of the user and the email of the user. But then I am inside of the user. Let's see if I can select habits again. I'm going to select the name of the habit. So that's 4 levels deep, right? And then since I'm again inside of the habits, I can select user. You might be saying, okay, this is redundant. This doesn't make any sense. I agree. It doesn't make any sense. But this is a functionality. And this is also a problem in GraphQL. I'm going to come back to why this is a problem, right? And here I can select the name again. So if I run this, you can see I can go as many levels deep as I want. And I have all of these. Now the issue with this is actually something that's called a circular. This is called circular queries or infinite nesting. The problem with this is that this could be something that someone who is trying to attack your database, a malicious client, they could send a deeply nested query that basically is going to like kick your database. It's going to hammer the database hundreds of times and it might bring the server down. So this is something else that I wanted to talk about, but very briefly. Of course, it doesn't make sense in this API, but in larger APIs, you should be aware of this, that something like this is actually possible. So many levels deep, and you can go deeper. The more field resolvers you add, the deeper you can go into this. That's why it's also called infinite nesting. So circular queries or infinite nesting. You can call it both ways. So in production APIs, this is solved by actually a technique that's called query depth limit, in which we basically fix how many levels you can go deep. For example, some APIs do not allow you to go more than 5 levels deep. Some APIs say you cannot go more than 7 levels deep. So it depends. Now, the way you implement this is there are some extensions that gqlgen actually has that is going to handle them. Am I going to show it to you? No, because this is a beginner level GraphQL API. I'm just talking about this so you know, okay, there is just so much more that you can jump into and you can talk about. But I just want you to be familiar with this. Whenever you see this, it shouldn't scare you. This is possible in GraphQL. I can go like 100 levels deep and repeat the same thing. But keep in mind, if there is just a ton of information and you have like thousands of concurrent requests, this is going to be problematic for the database, especially for the server, for the database. So this is something that I wanted to talk about. And now that we have implemented these, the next things that we are going to actually go ahead and implement, I'm going to close these 3 files and I'm going to come right here. They are going to belong to the habit log. So as I said, the relationship that user has to habit is the same ownership relationship that habits has to habit lock. Now we implemented habits inside of user and then user inside of habits. Now the next thing is, or the next two resolvers, field resolvers should be one, we implement logs inside of their owner, which is habit, and then we implement owner inside of their habit lock. So these are going to be the next field resolvers that we need to actually go ahead and code. But before actually getting started with the coding of these two new resolvers, what we need to actually do is actually go ahead and see that whether or not we actually have this functionality already available. So I have logged in recently with this John's account. I'm going to create a query. Now remember, we had a query. So let's go back. If you take a look at the queries here, for habits, we have two queries. We have one that returns one single habit, but then we have one that returns a slice of habits. So if I take a look at this, what is this going to return? This is going to return a single habit. And inside of this, I should be able to call this logs. So this should actually return something if we had those field resolvers. We have already resolved this user using a field resolver. And now let's take a look at the logs. So I'm going to select habit, and this is going to need an ID. I'm going to pass the ID here. Come right here. So here we have the habit logs table. We can see there is just one habit that has two logs. I'm going to select the ID of the habit. Very good. I'm going to pass that there, and let's get rid of the sidebar. What kind of information can we select from this habit? So if I just run this, we can see the name of the habit. If I just go down, and if we take a look at this list, we can see we have the ID, name, description. Of course, current streak and longest streak, they don't work, logs, and then we have user, created that and updated that. So these three at the bottom, they also work. Let's take a look at the log. We can already see there is that squiggly, but let's run this. And we get the same kind of error that we got when we try to access habit within its owner, which is user, and also user within its habit. We got the same error because this is not actually resolved for. So the field resolver actually belongs to this. So again, the relationship the user has with habit is the same relationship that habit has with habit log. So now what we want to do is we want to be able to actually take a look at the logs within the owner, which is the habit. And that's what we are trying to go ahead and code here. So for this, what we are going to do is first, I'm going to jump into the schema because these are field resolvers and technically we should have the function stubs already available for them. Now let's take a look at them. We have the current streak. That's not something that we use. Longest, not for this one. We have logs and then we have habit. So if I take a look at the logs, you can see it's a habit resolver. It accepts one habit, but it generates or it gives us a slice of logs. And this is exactly what we're looking for. We want to be able to pass in the ID of the habit to get all of the logs that belong to that habit. And this is the perfect candidate for us. So I'm going to cut this. Now, where should I put this before cutting it? We should put it inside of the habit resolver. So I could just for now copy this, come right here. Where are all of our resolvers? They're right here. I'm going to double click on the habit one. And there we go. This is where we have the habit. I'm going to put that right beneath it. And now based on the signature for all of these resolvers, they all look the same. So let me get rid of that. Just get rid of this part, collapse this one, and collapse this one. So if you take a look at this, habit resolver, resolver. All four of them are the same. Now, what do we want to write here? Well, the code is going to look a lot like this, the way that we coded this. What we want to do is we want to select all of the logs for one specific habit. So if I were to open up the habit log repository, now why do I open this up? Because I'm looking for logs for one specific habit. Which of these is going to be the repository operation that we're going to use? Duplicate? No. Create? No. Get habit logs by habit ID? Perhaps. Now here we have two methods. We have two operations that get information. We have get habit logs, plural, and you can see what it produces is a slice of logs, but this one is singular. This just produces one log. You can see there is no slice. So which one do we want? Of course, we want the one that produces a slice. So this is going to be the repository operation that we need to reference. How do we reference that? We're going to say r dot, where should I go? Habit log repo. And from there, I'm going to say get habit logs by habit ID. So I'm going to give you the ID of the habit, and then you're going to give me all of the logs that specify on which days this habit was actually completed. Now, the only thing that this requires is the ID of the habit. How do I select the ID of the habit? Well, we have already talked about this. It's this object, because this object is the object for which we're trying to create a response. We're trying to resolve that GraphQL query. So as soon as I do obj, if I do dot, you can see we have description. What is this description for? This is the description of the habit. What is this ID? This is the ID of the habit. What is the name? This is the name of the habit. And what is the user ID? It's the user ID of the owner of the habit. So I'm just going to select the ID. What is this going to return? Well, this could return a slice of logs and error. So let's just initialize that. What if we have any error? So it's just the code is going to be the same. If error is not nil, we're going to return nil and we're going to return error. But what if we don't have any errors? Well, the next thing that we do is we just return that slice of logs, and for error, we're going to just pass in nil. Now we need to actually get rid of this, and you can see we're just left with 3 resolvers, and that's it. So now if I just come right here and if I try to run this again, there we go, it works. So we can select all of the logs inside of one specific habit. We can select all of its logs. And now, since we were able to actually resolve this for one single habit, we are going to be able to resolve this for all of the habits. So imagine if John had another habit. So for now, John has 5 habits, but only one of those habits has logs. So if we were to create more logs, that would be mutation, that would be create or check in habit, right? And for this one, we need to pass in the ID of the habit. If I just take a look at this, we have 31B. So which habit is that? So we just have logs for the first habit. Let's try to create logs for the second habit as well. So this is the habit ID. Remember, we pass in the habit ID for the habit that we want to create logs for. Let me put this on the next line and put this there. And now what can we select from this? Well, this is check-in habit. We can select the completed date. If I don't pass in any completed dates, it's just going to default to today's date. So now we have one log for this habit. I'm going to do one more, and that's habit number 3. And I'm going to put that ID right here. And this is going to have a date. That'll be 06 or 06, 6th of June. Completed date, there we go. So if I go to the habit logs, now we have 2 new entries here. One is for the second habit, one is for the third habit. Now, if you query all of the habits, so query, you just say habits, and then from habits, just give me the names of the habit, or also just the name of the habit is enough. So you can see we have 5 habits in reverse order, newest first. But now inside of here, we should go one level deep. We should call logs as well, and we should take a look at the completed date for all of these. And if I click on this, there we go. Now, this is really, really beautiful to see, and this is also very powerful, because for the habits that we do not have any logs, we return an empty array. So this syntax is very, very well understandable by a front-end developer. They know what this says. This habit doesn't have any locks. See, this habit doesn't have any locks. But habit number 3, it actually has some locks. How many locks? There we go. We just have 1. So you can see not only we were able to resolve logs for one single habit, we can also resolve it for if we were to select all of the habits for a slice of habits, we can do that as well. That's because this is actually available inside of this field. Now, if this log was not available here, we wouldn't be able to do it. But now we can also go one level deep. So here, if I were to write, so if before doing that, let's just take a look at it if we can do that. Now here we have habit log. So for one specific habit log, we should be able to take a look at the habit. So I should be able to see which log belongs to which habit. And now here, I need to know the name of this. But as soon as I run this, we're going to see we have internal system error. Why? Because we just coded a field resolver, the job of which was to resolve logs within their owner. So within the habits, but we cannot resolve habits within their logs. For that, we need a different, for this, we need a different field resolver. And that's exactly what I'm going to do next. So we can already see here that this is going to be the field resolver. And since it says habit log resolver, we need to actually go ahead and get it and put it inside of the habit log. First, let's take a look at the structure. This is habit log resolver, even though it says habit. Why does it say habit and then it says habit log? So if it is habit, what is it doing inside of habit log resolver? Because inside of the habit log resolver, we want to find out to which habit these logs belong. That's the functionality that we're missing. So if you take a look at this closely, again, it's just come on, if I do this, yeah, I still get that. It's just some shortcuts, they interfere. So if you take a look at this, the upper layer or the upper query or the parent query is habits. The child query that we resolve for is logs. But then this logs is the parent query for this habit. So what we are trying to do is we're trying to resolve habit inside of logs. That is the other way around. So this makes it a two-direction, right? So a bi-directional traversal. We did the same thing for habit and user. So you were able to specify user within habit and habit within user. And now we were able to specify logs within habit. And now we want to provide habit within log as well. So like the other way around it. And this is going to be the field resolver for it because we are trying to return one habit. But for that habit to return, we need to know what the log is. So that's why we go into the habit log resolver. But what this returns is going to be a habit. Very good. So I'm going to copy this entire thing. This is habit log repository. Let's close this. We have here habit. We also have habit log. Now these two, remember this completed date where we changed it from time.rfc3339 because we just wanted to take a look at the date component, not the time component of that. So I'm just going to put this here and I'm going to get rid of this. And now you can see the signature is the same. Habit log, habit log, habit log, because we're inside of the habit log. Now, how do we go about this? Well, this is going to be very simple as well. This is much like what we did before. So what is it that we are trying to do? We want to find out one habit to which a specific log belongs. One habit. So you know that when it comes to this query, you say, okay, for one individual log, which habit is responsible? Which habit is the parent? So this is how we go about this. And this is going to be available on habit repo. And on there, we have create habit, no, delete habit, no. This is get habit with user check. Do we want to do that? No. This is get habits by user get habit by user ID. Which one? Let me go into the repository for this. I don't want to create another. So we want to select the habit. I do not want to create a new repository operation. Get habits by user ID, get habit with user check. This is going to need from us this user ID. So this just returns, I don't even have to go in there. This just returns one habit. This returns a slice of habits. What do we want? We want to return just one habit. So I have no choice but to choose this one. But for this one to work, we need to have this user check. Let's go ahead and let's try this. Let's see if we can get this to work. This is going to be get habit. So we want to take a look at one individual habit. It needs to have the habit ID. The habit ID, if I do obg dot, we can see we have the habit ID. Now that I've passed the habit ID, if I do obg dot, you can see we don't have access to the user ID. So this repository operation does not actually work. We could come up with some way of manipulating this, but I don't want to do that, just so I can have this field, this sub field resolver, the sub resolver, just to make it work. I do not want to ruin the code, because these repository operations, they resolve main queries. They help resolvers resolve or create responses for main queries. But for just one tiny field resolver, if I just change the code, that doesn't make any sense. So what I can do is I can actually go into this habit repository and actually create another one. That's going to be very simple. We have already done this. And the code is going to be basically identical to this get habit with user check. But the idea is that we do not want to have this user check. So this is going to be habit repository. This could be get habit by ID. That's it. And what do I need to pass to this? The only thing I need to pass to this is going to be the ID of the habit. What is this going to return? This is going to have the same thing, models.habit as well as error. How is this going to look like? It's going to look exactly like this. So I can just, even though I know it's repetitive code, we need to actually manipulate this in some way so we can actually find out this habit without user check, but I don't want to do that manipulation. I don't want to change the code that already works. So I'm just going to create this for that field resolver. Now you can see it doesn't accept this user ID. It just accepts ID, which is the ID of the habit. Now, let's see, we select ID, user ID, name, description, created at, updated at from habits table where ID is this and user ID. So we no longer have need for this user ID. Let me get rid of that. There we go. Let's save this. So what this produces is going to be one habit, much like this one. Okay, let me collapse this. What else do I need to change? So we have ID, username, everything is fine. We have error SQL habit not found. I could keep this. I could return nil for the error, or I could just keep it as this. And finally, we return the habit. Yeah, very good. So now this is another repository operation. We just created that so we can select one habit. Now if I do dot on this, we have get habit by ID. And the only thing that it needs is obg dot habit ID. What is this going to return for me? What this returns is one single habit as well as error. The rest should be very, very simple for us. If we have any errors, well, the structure of the error is like this. I'm just going to copy that, put it there. I'm also going to take a look at if we do not have this inside of the repository. So what I can do is, because I want to give this control to the resolver, Here I'm going to return nil for the error, but then resolver is going to take a look at that error. So if habit is nil, then that's the better way of going about this. If resolver determines the error, so this is if habit is nil, we are going to return nil, and then I'm going to say fmt dot error f, and I'm going to pass in habit not found. But if everything goes according to the plan, we just return one habit and we're going to return nil for the error. There we go. Save this. I'm going to get rid of this. So what am I going to do here? We have coded this. Let's go ahead, and now we should just click on this and there we go. It runs. So what it does is if a habit has logs, this one doesn't, but this one has. So if a habit has logs, it's going to show the log, but then it's also going to go in the other direction. It's also going to show habits inside of the logs. So we could take a look at this in the other way. That is, if I just go ahead and take a look at, what was the name? So I forgot what the name of that resolver is. So I'm going to go to the query. That was habit logs. So I'm just going to pass in habit logs. I'm going to open this up. What is this going to accept? This needs to have a habit ID. And to this habit ID, I could select any of this from here. I could select this habit ID, since this habit ID has two logs associated with it. Very good. And now outside of there, I could just take a look at their completed dates. And I'm going to run this, and there we go. So both of these completed dates, they belong to one habit. So this habit with this ID, it was completed on this date, and it was completed on this date. So we were actually able to do this before, but here, even though, so what is the functionality that we implemented? The functionality was to take a look at the habit to which these logs belong. So we could do that as well. So I'm going to say habit, and I'm just going to say, give me the name of the habit, and I'm going to run this, and there we go. So both of these logs belong to habit number 1, habit 1. This is not something that we could do before, but now we can do this. So we created 4 field resolvers in total. We created 2 for habit. Did we create 4 in total? So I created 2 here. We created 1 here. That's 3. Let me get rid of that. Where is the user? I think we just created 1 for user. Yep. So in total, we created 4 field resolvers up until now. We're going to create more field resolvers as well, of course, but we just created 4. So owner, user to habit, habit to user, that's 2. And then habit to logs, logs to habit, that's 2. 2 plus 2, that's 4. Now, what else do we need to actually create? Why do we need to create even more resolvers, field resolvers? Well, we need to have 1 for this current streak. We need to have 1 for the longest streak. So far, if you take a look at the habit, we don't even have these calculations. And we said we want to calculate these, as we talked about them extensively. We want to calculate them on the fly. So we need to have at least 2 more field resolvers. And there you go. You can see we have 2 more field resolvers here. One is going to calculate the current streak. One is going to calculate the longest streak. And now let me ask you this. Should we get started with the current streak, or should we get started with the longest streak? Now that, so we talked about that these are the only 2 field resolvers that we need to actually go ahead and create. But I think there is something missing. Remember we talked about, let me take a look at here. We talked about something that was called total completions. So current streak is today, and then how many days you go back without having any interruptions. Longest streak is the longest you have gone with that habit, and you completed that habit without breaking it. It doesn't have to be the current streak. That's during the entire lifetime of the habit. But then, if you remember, if I remember too, we had something that was called total completions. That was basically seeing, okay, if we did habit for 150 days out of 180 days, like for 6 months, we did the habit for like here and there. So like we did it 10 days and then I made a pause there. So I didn't do the habit for a couple of days. Then I did it for 15 days. So it doesn't matter what the streak is, how many times have I entered logs for one specific habit inside of the habit logs table. That was the total completions. But the problem with this is now that I'm looking at this, there is nowhere here inside of this habit where we actually talk about total completions. So the thing is with this is that there is something wrong here. So what we need to do is we need to actually go ahead and create these. Again, we need to run generation again because we don't have this inside of our schema GraphQL. So what I'm going to do is the first thing I'm going to do is I'm going to add it here. So that was total completions. This is something that's on me. I have not added this initially. When we created the schema GraphQLs, I should have added this, but I haven't. And I am sorry for that, but I'm adding it right now. So I'm going to save this. Now what I need to do is I'm going to close the server, clear this, and I'm going to say, so what we want to run is going to be this go run this generate script. And we are specifically looking for that field resolver, which is called total completions, to be also present here. So I'm going to run this. And now we're going to wait for this for a few seconds to get completed. There we go. Everything is there. We can see there is just a ton of other stuff, and it basically has generated all of the field resolvers that we have already implemented. It has put all of them here. So, but the most important ones are these three. We have already seen the current and the longest, and now there we go. This is the total completions. So again, total completions refers to how many days you have gone through with that habit. So let's say walking like for at least 30 minutes in the morning. If I've done it, so I have had this habit for the past month and I have entered 20 logs for this habit into my DB over the course of past month. So how many total, what is the number of total completions? That's 20. So total completions is regardless of the current streak or the longest streak. So total completions just tells you what you have achieved, but current streak and longest streak, they give you like some kind of like encouragement. Okay, my streak is 10. Well, let's make it 15 so I don't have to make any pauses here and there. But then, okay, the last time I started implementing this habit, I went 15 days in a row. So 15 consecutive days. Let's go 20 consecutive days this time. So it's some kind of like this thing that gives you encouragement when it comes to current streak and longest streak, but the actual total number of days that you have implemented a habit over the course of its lifetime, that's total completions. And now you can see everything else here, it has to go. Everything else, we have implemented all of that. So I could just start from the bottom so I don't delete anything. So I'm just going to start from here. You can see these are the dates. User resolver created that and updated that. We have implemented these as well. So I'm going to start from here, go to the top, and I'm just going to come right down here and I'm going to delete all of this. I'm going to save this and let's get rid of this FMT. It's still like working on this. There we go. So it shouldn't take long before it actually processes all of this. Saving schema.resolvers.go, running code actions and formatters. So there we go. All of them are gone. And now there we go. We have our total completions. So when it comes to the current streak and the longest streak, I'm going to have to create some utilities in order to calculate those. Okay, so because current streak and longest streak, they're not like that straightforward. But when it comes to total completions, I don't have to code any kind of utilities because I can just trace one habit to all of its logs inside of, so one habit in the habits table should be traced to all of its log into the habit logs table. So one entry in one table is traced into one or more entries into another table. And that's it. So we're not differentiating between which entries from the habit logs table are we interested in. We're not differentiating that because we just want to take a look at total completions. But when it comes to the current streak, we just take a look at, okay, today or yesterday, and then we go back as many days as there are no interruptions, for as long as there are no interruptions. But current streak does not contain the total number of logs for one habit. So we need to actually calculate this longest streak. So if I have entered that habit 200 times, so there are 200 different logs for one habit, how many logs are consecutive? So the number of the total consecutive logs in a row. What is the biggest number in there? For example, in 200, I've gone, let's say 50 days without breaking my habit. So the longest streak is no longer, it's not 200. 200 is total completions. Longest streak is 50. So I need to be able to systematically and programmatically subtract 50 or select 50 from the range of 200. So this needs calculations. That's why we need to have utility for current streak and longest streak, because they are calculations. But selecting the records without any kind of distinguishing factor, that's easy. We can just write a SQL statement for it. And that's exactly what I'm going to do. So what we're going to do is, because we're trying to select all of the logs from one specific table, what we can do is we can actually go ahead and create a repository operation for this. Now, which of these files should I open? We know it's not user because we're not talking about user. So it's either habit or the habit log repository. Which one? So if I select habit, I know that this file talks to the DB, but it talks to the habits table directly. So I am interested in the habit log table and how many entries there are. So I'm just going to click on this. I'm going to keep this open. So let's see if there are any things here that we can actually reuse that are going to give us exactly what we're looking for. So what we're looking for is the total number, or basically how many logs there are for one specific habit. Are we looking for duplicate? No. Are we trying to create a new log? No. Are we trying to load logs by habit ID? Yes, that's what we do. So this is a candidate for us. Let's move forward. Are we trying to select one log by its log? So get habit log by ID. So are we trying to select one log by its ID? No. That habit could have like several logs, one or more. Are we trying to delete? No. So this is the candidate. Let's actually open this up, take a look at it, and see if this is exactly what we're looking for. So what is this going to do for us? Now, let's first think about what it is that we want to select from this. We want to have one number. A number is going to be total completions. We don't want to know anything else about the logs because we have already coded all of these repository operations. What are we looking for? We're looking for total number of completions. And what is its type? The type of this is integer. So tell me, how many times have I entered logs for one specific habit? 10, 20, 100, 50, 500, whatever. So just give me a number. Now keep that in mind. We are looking for just one number, but this function, this repository operation, it says get habit logs by habit ID, but it selects habit logs. That's why you can see here, it returns a models.habit log. So it returns what? It returns a struct for us. Are we interested in a struct? No, we're not. So if you take a look at this, you can see this has a type of habit log here. So what it returns is ID. I'm not interested in the ID of the log. I'm not interested in the habit ID. I'm not interested in the completed date or created at. I just want to trace logs into to their habit, to just one habit. So 100 logs could have just one habit. They could just share one habit, and that would mean that that habit was implemented for 100 days. But I'm not trying to return logs. I'm not trying to do this. I'm just looking for one number. So this is not going to work either. Even though it looked like it would work, but what it returns is struct. We're not looking for a struct. What we're looking for is actually a number. How many times we have actually implemented that? You could say, okay, what this returns is this. We could do like some kind of a length on this. So however many structs there are, those basically indicate how many logs there are, and logs, that's exactly what we're looking for. But then that would require us to manipulate our code. I don't want to do that. I want to create a different repository operation just for this purpose, just so I'm compartmentalizing all of these and I know, okay, which one belongs to what. So even if I have to do that, even if I have to do this, I have to create some other kind of a function that is going to manipulate that and give me the actual number. But you know what? I am thinking about this. So that could be done, even though like in my notes, I have this other repository function that basically runs one SQL statement. Let me take a look at something before writing this, even though it doesn't matter if I just write it or not, but it is very important to not write redundant code. So when it comes to this, we are doing all of the checks. That's something that I'm sure about. We're passing a habit ID. We're getting all the logs that refer to that specific habit. Okay, we are making sure all of the error handling, they're in place and everything is okay and fine. So what did I change? Let me save this. Where do we call this? Now I have my server up. This is inside of the habitlog.go. Oh, not here, sorry. So this is something that loads information. Sorry, I need to go into the query. So here, this is where we called it. It returns all of the logs. Very good. Let me think about this. And so we can put it, now you can see we actually take a look at the logs after. So let me just highlight it for you. So here is where we actually take a look at the logs that we have here. Here, we just select this is get habit with user check. You can see we do all of these checks. And here I have, this is that user ID. So what I can do is, since we're calling this here, well, I can just write fmt.print print line. And inside of here, let's add a comment. I'm going to say number of logs. So here I'm going to select the length and I'm going to pass in logs. Save this and we're going to go to the terminal. It's going to start building all of this again. And you can see that line that I wrote, it is not running. So we are here. This is the last thing. We need to actually jump here, habit logs. We need to take a look at, so this is a good thing. We have this, but we don't have anything inside of the headers. Now what I'm trying to say is we need to actually run that query that talks to that resolver. So we need to run, we need to actually send some kind of a query that wakes that resolver up. So first off, I'm gonna log in. This is the JSmith account. Let's copy all of this. I'm gonna come right here and here, let's close this. We need to actually change this. Paste that there. Very good. So now this is, let me open this up. We need to take a look at which habit this is and whether or not this actually has logs associated with it. I could have run it directly, but I still want to make sure. So this ends with 31B, and that's the ID of the habit. So have user ID 31B. Okay, and if I come right here, we have two logs for this 31B. So we have 16, you can see these two logs, they belong to the habit ID 31B. So we should get to, number 2, a number that's 2 here. So I'm going to send this, there we go. So we got one log for this. This is one habit, but it was implemented on the 10th of June and on the 16th of June. So there we go. We can see it gives us the number of logs, and there are 2 logs, and it doesn't matter whether that's the current streak or the longest streak. Now you can see we could use this. We could very well use this, but imagine there is a problem with this operation. There is a problem inside of this repository operation, and what are you going to see as the issue? It says fail to fetch habit logs, or fail to scan habit log, error iterating habit logs, but it doesn't say that there was a specific issue with counting completions. So because this repository operation's job is not to actually count total completions, it gives us a slice of how many logs there are. What we did was we actually added this length on it, and it gave us the length. But if anything goes wrong with this operation, we will have no information on this. So if anything goes wrong with total completions, the messages that we're going to get, they're going to be confusing. It's going to say error iterating this, or doing that, or this, but they're not specific to number of completions. So you have 2 ways, and it's actually up to you which way you go. You saw that it works, and we could use that. But what I want to do is I want to actually put that inside of its own repository operation, just so it has its own place, and if something goes wrong with it, I know that. Okay, this is that thing that went wrong with this. Total completions. And since this is a read operation, it's not going to be that heavy on the DB anyway, because we're just trying to read. And if I take a look at this, so even though this is also a read operation, but this is like a little bit heavier than the one that we are about to write here. So what are we going to do? We're just going to pass in the habit ID that has a type of string. Now this is required, but then we just get a number. We don't get a slice, so we then do a length on that slice. We just get a number and error. So what do we do? I'm going to create a variable, and I'm going to call it count. Now I need to go ahead and run a SQL statement that is going to count how many rows there are for one specific distinguishing factor. And what is that? That's the habit ID. So I'm going to say r.db. What am I going to do? I'm going to say query row, and the SQL statement is going to be select. What are we going to use? We're going to say count. I'm going to pass in the star in there. Now we have already talked about all of the syntax. What this count does is it's going to return a number. This is never going to be null. So if we don't have any completions, it's just going to tell us 0. So where do we want to select this? We want to select it from habit_logs table, where now here is where we pass in that distinguishing factor, where that's going to be habit ID. So we want to sift through the logs by habit ID, and I'm going to pass in habit ID right here. Then I'm going to call the scan method on it. Since this is going to return a number, I'm going to put that number, or I'm going to scan that number inside of this variable, that count variable. Now, this operation could return an error, or the error could be null. So I'm going to say if error is not null. Now here is what I meant. So this is going to be return 0, but then the error itself is going to say error F failed to count completions. Now, if this process fails, you know where to look for it. But I'm also going to pass in a placeholder for what specifically went wrong, and I'm going to pass in the error there. But if nothing went wrong, what do we want to return? We just want to return count, and I want to return nil for the error. That's it. So this is the repository operation that we created. Next up, we need to actually jump in and write the resolver for this. So we already have this resolver. You can see it's a habit resolver. So where should we go ahead and put this? We need to go inside of the habit.go, where we have this, where we put this user and this logs. And I'm going to copy this total completions, come right here, put it right there. Now you can see the signature for all of these is the same. Habit resolver, resolver, habit, sorry. So habit resolver, habit resolver, habit resolver, habit resolver, habit resolver. So all of them are the same. Now let's try to complete this. This should be very, very simple for us to do. So we jump into the habit log repo and we call this count total completions. To this, what should we pass? We should pass in the ID of the habit. So if I do dot, this is the ID of the habit. Now keep in mind, when I'm selecting this OBG, I'm actually selecting the habit. So if I select the habit, what are the different things that are available on the habit? What are the different fields? On the habit, we have the ID, we have the user ID, the name, the description, and the created at, as well as the thing on the other end of the screen, which is the complete, which is the updated at. So we just select the ID, so obg.id. And let's take a look at that again. So we're on the same page. So if I do, you can see description, ID, name, user ID. No. We want to take a look at the ID because that's what count total completions is going to require. So this is going to return count and error. What if error is not null? So if error is not null, what do? We return 0 and we return 0 for the count, and then we return the actual error. But if there are no errors, then we just return the count. Now here is something that I'm going to do. I'm going to convert this count into a 32-bit signed integer. The reason for this is gqlgen generated this resolver to return int 32 because GraphQL's int 32 type is it's the integer type inside of GraphQL is actually a 32-bit signed integer. And the other reason for this is because what repository returns for us is a 64-bit, so that's why we need to convert it. And if you're like worried about the range of this actually return, this can hold up to 2.1 billion. So a habit's total completion count is going to represent close to 1,000 years. So you're safe, you're good to go. Don't worry about this. We just do some conversion. And there we go. That part is also done. Let's close, let's delete that, and let's go ahead and actually take a look at the total completions. Now, we don't need to actually print that inside of the terminal. I have this, I'm going to get rid of this habit inside of the habit logs. We know that that works. And now for completed date, I could also take a look at total. Total. We should have, so we have the, oh, this is not available on habit logs. This is available on habit. So if I go to the query, so if you take a look at the habits on habit logs, we don't have anything that's called total completions, but we have this on habits. So if I click on habits, there we go, you have total completions. So I'm actually running this the wrong way. So if I say habit, and then I could be very specific on the ID of the habit. So I could just change this with habit. This just needs an ID. And now I could select the name of the habit, the description of the habit, and click away. And then total completions, there we go. So let me collapse that, let's run it. There we go. So this is the name of the habit, this is the description, and this is the total completions. And you can see total completions doesn't come, like, it's not stored directly inside of the DB. It's just something that we calculate on the fly. So we have this, and let me take a look at something else. Habit logs. Let's go ahead and create a couple more logs for this. That was the check-in habit. I keep forgetting that. So I'm going to cut all of this. Just keep it there. That was mutation. Check-in habit. And we need to pass in the, let me just, come on, buddy. Habit ID. I'm going to come to the habit. Or if I copy paste that, that's going to get rid of everything. So I'm going to copy the habit ID, put that there, and I'm going to cut this again. So check-in habit. Now, what do I want to do? I need to specify a date for this. Let's go. That's going to be date 2026. We know for this habit, we have 10 and 16. So let's add 9. And then that's going to be completed date. So we recorded 9. Let's record 8, 7, 6, 5, 4, 3, right? 3, 2, 1. And then I'm going to say, I'm going to get rid of this date. And I'm going to run this. So we have recorded a lot of dates. There we go. So you can see for just one habit, for like a couple of habits, a few habits that we have here, you can already see it just gets out of control. Taking a look at this, this is just, now imagine if there are like thousands of them or hundreds and thousands of them. That's just going to get out of control very easily. So then I'm going to add the date again. I'm going to say 2026, 06, 22, 21. Then we have 20. So what is the, you've already checked in for this habit. Okay, very good. So let's do 19. So now we have a lot of records, right? I'm going to get rid of this entire thing. I'm going to put that here. So for this, I want to know the name, the description, and the total completions. We have 16 total completions for this specific habit. Now keep in mind, it doesn't say how many days are consecutive days. What is this longest streak? It just says how many logs we entered for this habit inside of the DB. And you can actually count that in there. So you can see there is just all of these, they belong to this specific habit. So this, very good, right? So what else do I want to do? Well, the next step for us is actually to go ahead and talk about the current streak and the longest streak. And as I mentioned, we need to come up with some utilities in order to calculate these. And I'm going to try to explain all the parts for these utilities and how these utilities actually work. And so first off, let's go ahead and let's create that. We're going to have two things. We have current streak and longest streak. We could create two different utility files, or we could just create one. We're going to call it streak.go, which is going to contain two functions. One of the function is going to refer to let me close this. It's going to refer to the current streak. The other one is going to refer to the longest streak. And now, how do you want to go about this? So I know that this video is already pretty long. It's so I haven't actually finished recording this. I'm pretty sure it's going to be above 20 hours, and I haven't actually completed the editing of this as well. But from the looks of it, it's above 20 hours, maybe above 22 hours. But I do not want to get lazy when I'm like towards the end, like very near to the end of this video. I want to actually take time to explain how this streak works, even though this calculation, these two functions that we're about to write, they don't have anything to do like directly with the GraphQL API. It's just a couple of extra abilities that we want to give to this API. And their logic, the way that we calculate these, they're just more like problem-solving kind of skills rather than API design and API best practices, okay? So keeping that in mind, I'm going to move forward. Now, the first thing that I want to do here is I want to calculate. So calculate. I want to first calculate the current streak. And we need to understand what the current streak is before we can actually calculate this. So the current streak refers to the logs that start from today or from yesterday, and then they go back in time. Because you should not be able to create a log for a habit in the future. Well, how do you know if you're going to go ahead and actually fulfill that habit? You don't know if like in a week you're going to be able to do that habit, or you're going to even have interest in doing that. So what we're looking for is today or yesterday, because you might have done the habit for the previous 5 days, but including yesterday, but you have not implemented the habit today. You're about to do it now. So we leave some wiggle room, as you will. So it's going to be either today or it's going to be yesterday. And then we move backwards. So today is June 23rd, right? You saw that. I just added the date for the log. I did the habit today, habit 1, June 23rd. I did it on June 22nd. June 22nd, yeah. I did it on June 21st. I did it on June 20th, and I did it on June 19th. But I didn't do it again. I didn't do it on June 18, 17, but then I did it on 16. So you see, there are 2 days of interruptions. So when there is even 1 day of not doing the habit, that breaks the streak, okay? So now we are on the same page. So I did it on 23rd, 22nd, 21st, 20th, and 19th. Those are exactly 5 days. So what is my current streak? It's 5 days. Why isn't it more? We have 16 total completions for one specific habit inside of our DB. So if I were to show it to you, we talked about this. We fetched that. We have 16 total completions for one specific habit. Now let's take a look at that. There we go. So you can see it's the same habit. It comes and it is implemented up until here. So it's, I have June 22nd for a different habit as well. But nonetheless, for 31B, the habit with the ID 31B, we have 1, 2, 3, 4, and 5 completions, which are the current streak. But why don't we count 16 and then 10 and then 9 and then 8? Because there is interruption. Where is 17 and where is 18? I didn't do the habit in these 2 days. So the current streak actually breaks down. Now, what is it that we require when we're trying to do these calculations? We need to know what today is. That's thing number 1. Thing number 2, we need to know what yesterday is. Because if you have a log for today, or if you have a log for yesterday, that's either of these is going to be the start of your streak. Okay. Now, because I have a log for today, that's the start of my streak. So this is 1. That's today. I go back 1 day and I add that count to the streak. So at the end of the day, streak is just going to be one number. It's going to be like total completions, even though there is a lot of calculation into it that goes into it. But what do we select from this function? Just one number. Just tell me what my current streak is. My current streak is 5. How did you calculate it? We're about to do it. So 22nd. Now, we talked about we needed 2 things. We need to know what today is. We need to know what yesterday is, because we need to know what the start of the counting of the streak is, the current streak. Okay, so today, yesterday, that's two things. Then we need to be able to go back in time 1 day at a time. That's the third thing that we actually need here. And every time we go back in time, we need to add 1 to that streak count. So if I find today, streak count is 1. If I find yesterday, streak count is 2. If I find the day before yesterday, it's 3. And then before that, it's 4. And then before that, it's 5. So I need to keep counting 1 day at a time, and I need to go backwards. But if I get to a point where, for example, for this 19, if I go back in time and there is just 2 days missing, the streak is broken. So these are all the things that we actually need in order to create this function. So now what we need to do is we need to actually go ahead and code this. But before coding this, I need to import that package at the start. And you see, it doesn't have anything to do with GraphQL. It's just some problem solving that we do here. We want to be able to actually count how many days we did this habit consecutively starting from today or yesterday, because we're talking about the current streak. So we are trying to look at logs. The type of this, we need to specify what type this has. This is models.habitLog. What is this function going to return? Remember, it's just going to return one number, and that's going to be what is the current streak of ours. First off, we are going to get started directly with our checks. If the length of logs is equal to 0, that means I have created a habit, but I have not started implementing it. Then I'm going to return 0, aka there are no logs for this habit on the DB, on the habit logs table. So that's the first check out of the way. Remember, I talked about two things. I said today, we need to know what today is, and we need to know what yesterday is. Why? Because that's when the start of the streak is going to be. So let's find out what today is. It could be any day, literally any day. And that's going to be time.now. But then let's take a look at it, what the problem is. It says, okay, I need to pass on that here. And I'm going to save this, so it just imports that. But the issue with this is we need to be very specific when it comes to this. And we need to normalize and make sure that this time is actually uniform. So what did we do? We actually converted this to UTC. Now, we want every day that is recorded, that is basically logged into the DB, it has to be set to the midnight. So I'm going to truncate the time part away from it. And how did we do that? This is just some defensive programming that we do, even though we have already done this, but I just want to make sure that there are no issues that are going to arise from this calculation. That's going to be time.hour. So this is going to give me today. What is yesterday? Again, yesterday is 1 day before today, and it is highly variable. If today is June 23rd, yesterday is June 22nd. But if today is February 15th, yesterday is February 14th. So whatever today is, yesterday is going to be 1 day before today. So it's going to be today minus 1. That's going to be yesterday. So that's why I specified today first, because yesterday depends on today. So that's going to be today. How do we go 1 day before today? Well, we actually have a method for it, and that's add date. So I'm going to pass in 0 for year, 0 for months, and as soon as I do minus 1, this is going to be, so whatever the current day is, whatever today is, minus 1 is going to be 1 day before that. Very good. This is very good, right? So now that we have found out what today is and what yesterday is, we need to know if today or yesterday they're part of their logs that user has entered into the DB. So if I have logs for June 23rd, which is today, and if I have a log for June 22nd, that's the start of the streak. But imagine if I don't have logs for them, then current streak is nothing, because current streak depends on today or yesterday. If I don't have a log for this habit for today or for yesterday, then there is no current streak. We could talk about longest streak, but current streak is going to be 0. So how do we find out? We need to know what the first entry into this logs slice is, or into the logs table is for one specific habit. And you remember, right? We actually ordered these based on descending, and that actually gave us the newest entries first. So the latest entries first and the oldest entries last. So if the latest entry is today or yesterday, then we can calculate streak. Otherwise, there is no current streak to calculate. So what should I do? I need to know what the last log inside of the table is. So let's take a look at it. We could just call it here total completions, habit name. We could just, I'm going to keep the total completions. Here we have logs, completed date. This is the good thing about those field resolvers, right? I'm going to run this. Is this server running? What is failed to fetch? Declare not use. Oh, it's because of these. Let me just save this. Missing return. It's talking about this function. So let me just comment this one out. Just comment everything out. So there are no issues here. There we go. It's running fine. So I'm going to call this. There we go. So you can see this logs is actually a slice that returns one thing, a struct that for now has one field inside of it because we specified completed date. And you can see it shows us the first thing, the first item inside of the logs slice is the newest date. It's the last date in which this habit was completed. If the last date that the habit was completed is not today or yesterday, then again, there is no current streak. Current streak is 0. But we can see that the first entry or the latest entry inside of this log slice is today. So we do have a current streak. So let's calculate that. I'm going to go back so we can actually see that. So first off, what do? We select the first entry from the logs slice. Why the first entry? Because we ordered these in a descending manner. So the first entry inside of the logs slice is actually the newest date for that habit which was completed. Why do we do this? Because we need to know if the completed date is the same thing as today or yesterday. If it is neither of them, we don't have a current streak. So we have this completed date, right? And we take a look at the completed date. We take a look at when the habit was completed, not when the habit log was recorded inside of the DB. That's a different thing. We had like a big discussion about that. So this is going to be first log date. That's why I'm explaining this, because again, this is like the part of our API where we're trying to solve something. We're trying to add more functionality, not specifically GraphQL related. You could do this anywhere, like in any kind of Go code or any other programming language. So we are trying to train that problem solving like aspect of this entire process. Okay. So this is also very important. I would argue this is like really, really important. Now we have this first log date. We need to compare this. Is this first log date today or yesterday? Is it? I need to compare these. If first log date is not today and it is not yesterday, well, there is no point in current streak because the streak is already broken. So first log date dot. So what is going to be the method that's going to compare if first log date is either today is equal to today or yesterday? We have this equal method that is going to basically compare two different times. I'm going to pass in today. Now we're looking if they're not equal. If they're equal, we're going to move forward with this function. But inside of this if statement, I'm going to flip this, and I'm going to say if they're not equal, then we return from this if statement. So I'm going to say also if first log date dot equal is not equal to yesterday either. So it's not equal to today. The first log date, the first entry inside of the logs table, it's not today, it's not yesterday. We don't have any current streak. Current streak depends on either today or yesterday. It's not the day before yesterday. That's too old for current streak. That's longer. You could count it into longest streak, but that's not current streak. So from this, we're just going to return 0. So up until this point, we have actually done a lot of the things that are very important. So we laid a good foundation for this. Now I need to keep moving forward. Here we have this first log date. And you can see we actually talked about this. So if I move forward from this if statement, that means the first entry inside of this logs is actually going to count towards our streak. So streak's value is going to go to 1. The reason that I'm setting it to 1 initially is because we moved away from this if statement, we moved past it. That means first log date is either today or yesterday. If it is neither, we're going to return from this function. But if we do not return from this function, that means we found either today or yesterday. No matter today or yesterday, streak value is going to go to 1. So streak value is going to start at 1. And then we need to keep adding previous days to it. We don't care if the start of the streak is today or yesterday, as long as it's either today or yesterday, and then we keep moving backwards in time, and that's 1 day at a time. So how do we do that? Well, the first thing that I want to do is I want to keep track of which days I've actually counted. So here I'm going to create another variable, and I'm going to call this previous date. This is going to be equal to the first log date. So the first log date, I have found it, I put it inside of the streak, I know it. So I'm not going to count it again. Keep that in mind. That's why I called it previous date, because I've already counted that and I put it inside of the streak. Streak was 0. Now streak is 1 because we moved past this if statement. This returns 0. So streak is 1. Now first log date is actually previous date. What is the day before previous date? Now, since we are going incrementally, 1 day at a time, we need to have some sort of like a syntax to be able to do this. So we need to go through a loop. I'm going to start the loop by 1. Why don't I start from 0? It's because we have already counted 0. There we go. 0 is already counted. So 0, if you are familiar like with the slices and arrays, 0, they are the index of slices are 0 based. So as soon as you say 0, 0 is going to select the first item inside of the slice. As soon as you say 1, 1 is going to be the second item inside of the slice. So why do we start from the second item inside of the slice? Because we already counted the first one, that's above. And we added it to the streak, so it's better for us to start from the second item. We're going to go for as long as 1 less than the length of these slices. And because indices start from 0, the last index is going to be 1 less than the length of the items inside of those slice. So inside of the slice of logs, you remember that total completions is 16, right? But so there are 16 items. What is the index of the last item? What is the index of the item number 16? What is its index? It's 15. It's one less than that. Indices are one less than length because indices start from 0, lengths start from 1. That's the difference. So that's why in these loops, we always say one less than the length. Because if you say index 16, that would indicate that the slice has 17 members. But does it have 17 members? No, it has 16 members. So 16 members means the last index is 15 because indices start from 0. So the first index is 0, the first item is 1. The second index is 1. So it's always one less than that. Again, that's why we do that inside of for loops. We always say one less than the length. And then after we hit that, we hit one iteration, we need to go to the next. And that's why we say I++. So if I hit the second item inside of this logs slice that has an index of 1, I say I++. I++ means 2. So then which item has an index of 2? It's the third item. Always. Index is one less than the length. So the third item has an index of what? 3 minus 1, 2. It has an index of 2. It's always one less than that. It's the same thing in other programming languages as well, like the ones that I've experienced with JavaScript, TypeScript, and these kind of things. So let's move forward with this. The next thing that I want to do is we want to loop through all of the remaining items. Keep in mind, we got the first item, and it didn't matter if it was today or yesterday, we got it. Now we need to take a look at how many other items there are. So I need to iterate through the logs slice programmatically. That's why I'm not going to say 1, I'm not going to say 2, I'm going to say I. In the first iteration, I is going to be 1. So if I say logs slice 1, that means give me the second item. We take a look at the completed date of the second item. And then if that completed date is exactly 1 day before the previous date, then it means we have a current streak. So I'm going to call this log date. I am sorry for these naming conventions. It's just, I could not think of a better name. I'm just going to zoom this in so you can really see what's happening. So we take a look at the items inside of the log slice, one item at a time. In the first iteration of this for loop, I is 1. So this is going to be logs 1. Logs 1 is going to get me the second item inside of the slice. And then I take a look at the completed date. If the second item's completed date is exactly 1 less than this first log date, then it means it's a consecutive day. And we're looking for consecutive days because they are going to count toward the current streak. So how do you do this? Well, we could go 1 day back, right? We could say previous date minus add date, and I'm going to pass in 0 for year, 0 for month. Now I just want to go 1 day back. That's going to be -1. And I'm going to store this inside of another variable. That's the expected date. Why expected date? So, given our current example, today is June 23rd. I raised the streak to 1 for June 23rd. What do I expect the previous date to be from June 23rd? I expect it to be June 22nd. So that's why it's called expected date. So if that expected date is June 22nd, I'm going to increase streak to what? To 2. 1 for today, 1 for yesterday. So that's why, again, it's called expected date. Now, how do we find out if it is exactly 1 day behind it? We need to take a look at it. So here is, we're going to say, again, another if statement, and we're going to use the equal. So I'm going to say if log date, now imagine, log date is the second item, because I is 1, it's the second item inside of the logs slice. What is that? So we handle this first item. Remember, this one is done. Finish. What is the second item? It's June 22nd. Is June 22nd minus 1 day of June 23rd? Is it? If yes, then we're going to increase the streak. So Where is June 22nd? Well, June 22nd is right here. And where is 1 day minus June 23rd? It's right here. So this log date, what does it contain? It contains the second entry inside of the logs slice. What is that entry? That's June 22nd. Is June 22nd minus 1 day from June 23rd? We need to do this programmatically. Where is minus 1 day from June 23rd? It's right here. So what this gives me is this expected date is whatever, see, previous date is right here. Whatever previous date is minus 1. So previous date was 23rd, minus 1 is 22. So I know that these two are the same thing. I know that. So I'm going to say if log date dot equal, if log date is equal to the expected, to the date that I'm expecting, then I'm going to select streak. How am I going to increase it? How am I going to do that? I could just do plus plus and that's it. Now, since I did plus plus, shouldn't I keep updating this previous date? Because currently, at this point in time, previous date is the first log date. The first log date is June 23rd. I said minus 1, so previous date is going to be June 22nd in the next iteration. So in the next iteration, I is going to be 2. This is I0, this is I1, this is I2. I2 is that iteration inside of the for loop. That's what? June 21st. So June 21st is going to be log date. Now, should I subtract 1 day from June 23rd? Should I do that again? Or should I subtract 1 day from June 22nd? Because remember, June 23rd was counted inside of the streak. June 22nd was also counted inside of this if statement. What is the next one? What is 1 day before that? That's June 21st. So I need to update this. So whatever the log date is, the current log date, that's going to be the previous date. I'm going to update this. And that's why I'm just going to use an equality sign. I'm going to say log date, and I'm going to tell you why. So in this, now you need to remember something. When we talk about the inner of a for loop, it doesn't matter how many times the for loop is repeated. Inside of the for loop, we always talk about one individual item. That's how for loops work. So for this individual item, in the first iteration, I is 1. First iteration, log date creates June 22nd. We know that. Expected date is also June 22nd. Because we got previous date, we said minus 1, and that gave us June 22nd. And we can see log date dot equal to expected date, it is going to hold true, so we are going to increase the streak by 1. So now streak is 1 plus 1, that's 2. Very good. What was the date of log? What was this date in the first iteration? June 22nd. So what I'm going to do is I'm going to say June 22nd is the new value for previous date. Why did I do this? I did it for the next iteration. So let's say here the for loop ends, even though we're going to add something else here. But let's say here the first iteration of this for loop ends. We still have so many more logs here, right? See, we need to keep iterating through these. We go to the next iteration. The next iteration is I1. No, we said I++. I is 2. So this is going to be 2. What is logs 2.completed date? This is going to be June 21st. What is previous date here? I said previous date is equal to the log date. Previous date was equal to June 22nd. Remember, I did this in the first iteration. So the second iteration starts from top. Log date is 21. Expected date is 22 minus 1. What is that? That's 21. So log date is equal to the expected date. We increase the streak. Streak is not broken. So streak goes up to 3. Now, what is previous date? It's equal to the current value of the log date, and that's 21. We go to the next iteration. This is 20, because I is now equal to 3. When I is equal to 3, I'm selecting this item. So it's June 20th. What is the value of previous date? It's no longer 22 because I didn't hard-code it. It's actually dynamic. It's now 21. 21 minus 1 yields 20. So log date is actually equal to the expected date. I increased the streak. A streak is now 4. But then I changed the value of previous date to the log date. So now previous date is 20. Let's go to next iteration, which is in which I is actually equal to, so I was 3, now I is actually equal to 4. So yeah, so 0, 1, 2, 3. And now I is equal to 4. And when I is 4, what do we get? We get June 19. So log date is 19. Remember here, previous date, we set it to 20. So here, this is going to change to 20. 20 minus 1, that's going to give us 19. So log date, log date and expected date are the same. We increase the streak. So streak is now 5. What is the value of the previous date? It's 19 because see, previous date is equal to the log date. Now we go to next iteration. I is now 5. 0, 1, 2, 3, 4, 5. And now there comes the problem. I is 5. 5 yields 16 for the log date. But here, previous date is 19. So 19 minus 1. What do I expect the previous date or yesterday of 19 to be? Yesterday of 19 is 18. Now, this yields 18. Is log date equal to the expected date? No. Log date is 16. Expected date is 18 because I just counted 19. Before 19 there is 18. You can see the streak is broken. There is no entry for 18. So this if statement is not going to hold true. Where are we going to go? We're going to go to the else clause. Inside of the else clause, I'm just going to break out of this loop. That's it. The streak is broken. And once I broke out of the streak, I return from this function. There is nothing else that I want to do here. And that's going to be a return streak. So this is how this works. Now we need to put back the dynamic code and remove these numbers, right? So this was logs. And now you visualized how that actually worked. Dot completed date, and this is previous date dot date 0, 0 minus 1, and now here we actually say log date, and that's it. That's everything. Oh, streak it should be 1. Very good. So now you understood every part of it. And you can like rewind if there was anything like, I'm pretty sure you understood every part of this. So this is it for the calculate current streak. And now it is time for us to get started with writing the function to calculate the longest streak. Before moving ahead and doing that, I need to tell you that I am going to reference this calculate current streak. I'm just going to call this current streak, because there are going to be some concepts, like a lot of concepts that are going to be shared between these two functions. And that's one reason. The second reason is for coming back to this current streak function is so you can understand, like really see how different current streak is from the longest streak. Why do we even have, if we have a current streak, why do we need to have a longest streak function as well? So that's why I'm going to go back and forth, and we're going to talk about both of these, and we're going to see what differences there are going to be when it comes to these calculations. And I want to reiterate this again, that this has nothing to do with how GraphQL API is coded and how we architect this API. It is just some calculation that I'm adding to this just to make sure this API is a little bit more real world oriented as opposed to just another to-do API. So it's just I'm giving this API a little bit more functionality. So let's get started with this. The name of the function is going to be calculate. Now instead of current streak, I'm going to say calculate longest streak. Now there is going to be a lot of theory. As I said, I'm not gonna like fall short of explaining this just because these are like the last things that we're gonna do in this API. I don't care about that. I want everything to be explained from start to the end. I'm not gonna say, okay, now I'm close. I'm just gonna say, okay, anyway, so let's just write this, and okay, this is how this works. Anyway, this has nothing to do with our API. Let's just copy paste the code. No, that's not my attitude. That's not how I go about this. You can always go ahead and increase the playback speed. That's something that I usually suggest. You can set it to 1.5, and then if you're like a native English speaker, then that's going to be like a lot easier. But for anyone who's not native, like myself, I think speed of 1 is just enough. So let's get started with this. What do we want to do inside of this calculate longest streak? Now for this one, because this is going to contain more complex like ideas and concepts that have actually need to be written in code form, we need to have some kind of a reference or a standard that we can keep going back to in order to understand how this function works. Now, let's first see, where do we call these two functions? So we have one current and then the other one is longest. We're going to call them inside of these two resolvers, but they're going to be called not directly, not immediately, I should say, inside of these field resolvers. We are going to need to select all of the logs from the database. Then they are going to be called on the logs or on the slice of logs selected from the database. So then we're gonna know, okay, how they work. So if you go to this habitlog repository.go file, here we have several repository operations, duplicate. This is not producing, you can see this produces Boolean. So this doesn't give us a slice of all of the logs for one specific habit. This creates one individual one. This seems to be the one that we're looking for. And this is models.habitlog. So it clearly gives us a slice of all of the logs for one specific habit. That's exactly what we're looking for. This is going to give us one log. That's not something that we want. A habit could have like 200 logs, 200 days in which the habit was actually implemented. This is deletion, not at all. And this is just counting total completions. This just gives us an integer. We don't know how many interruptions there were. We don't know when the date was. We have no idea. We just know, okay, this gives us an integer. And the reason that I'm talking about this is because this tells us when we need to imagine which repository operation are we talking about, in the context of which we're going to use this calculate longest streak, so we can understand this function that we're about to write better. Now we're going to talk about it in the context of this repository operation. Why? Because this repository operation clearly selects one habit ID and it produces one specific slice. The slice could have one of two modes, or one of two ways, or one of two kinds. It's either going to be an empty slice because we have the habit, but we have not actually implemented the habit, or it's going to have some things inside of it. Those things are going to be dates. That's it. They're going to be dates. They're going to be habit logs, right? But what we select from those is going to be dates. We already called this somewhere inside of some kind of a query. We already called that. So we have one of two ways. We either use this function for our streaks as well, because for current streak and longest streak, we need to know what that slice is, because we are performing some operations on a slice of logs. Now let's go to the DB. And here inside of the DB, what it is that we're trying to do. So for current streaks, starting from today or yesterday, going back as many days as there are no interruptions. We count those days, and that's the current streak. But which column do we count? We just count the completed column. We don't care about the ID of the log. We don't care about the ID of the habit. Inside of the streak calculation functions, we don't care about these two. We don't care about when the records were created. We just care about the completed date, right? And that's why here we just selected the completed date. And again here, that's the only thing that matters. Completed date states when the habit was implemented. When did I go for a walk? That's the completed date. And then we see if completed date starts from today or yesterday, and then it goes back 5 days, and then there is 1 day that I didn't do the habit, aka an interruption, then the current streak is what? It is 5 days, or it's 6 days or 7 days, as long as there are no interruptions in the consecutive days. But we start from today or yesterday, and then we go back. Now, this thing that we did, starting from today and going back, that's exactly the kind of data that this repository operation gives us. It gives us data in a descending manner, see? So here it says descending. Descending means newest first. So when we talk about newest date, do we have a newer date aside from newest? No. Newest date means today or yesterday. Now, do we have a day that's newer than today? No, that's tomorrow. Tomorrow is not here. So we just talk about today or yesterday. Now, we could go about this function, this longest one, by selecting the same slice, not changing its order, and starting from newest first, which is descending, and then going back in time to the first date or the first log that this habit was implemented. So that's one way of going about this. The second way of going about this is to select this and change descending to ascending somehow and start from the very first day the log was implemented, the habit was implemented. And what is that? That's the oldest date. So this function gives us, what does this function give us? It gives us habit logs it gives us one slice. If slice is not empty, that means there are habit logs, however many days one habit was implemented. So it selects it from this table, right? And then we have an option. So I need to like tie these up. We have an option. Do we select this repository operation, or do we create another one that basically does the same thing and we just change its name? For example, we could create one that says get something like get streak calculation data by habit ID, but it would do the same thing. So what I suggest is to use the same repository operation, the one that we have already created, to avoid redundant code. So that's something that I suggest. Now, moving forward from this, the next thing is, do we select data in a descending manner, that's newest first, like we did that for the current streak, or do we change this order and we select data oldest first? Now, what is the difference between these two? That's what I said when I talked about we need to have some kind of standard. Now, aside from what is actually written inside of the DB, we're going to take a look at a simpler example. Now, we're going to take a look at a potential slice that could be returned by this specific repository operation. And I'm going to cut that. I'm going to put it above the current streak. So a potential slice could be like for a specific habit. So let's say this is whatever, this is the habit ID. So let me just, let's just remove these first. So let's say this is one habit. This is the ID of the habit. We could say this is morning walk. So that's the morning walk habit ID. I want to know how many days have I implemented this habit, starting from today or yesterday, right? So I'm gonna say, let's say today is June 20th. Let's just say that. Even though it's June 25th, let's say it's June 25th, all right? So I'm gonna write this here. I'm gonna say it's June 25. That's today. Did I go for a walk today? Yes. So that's June 25. Then let me just copy all of this. I'm gonna put it, did I go for a walk yesterday? Yes, I did. Did I go for a walk the day before that? Yes. And the day before that? No. That's June 21st. Now, what does this mean? It means I have 3 consecutive days. Whoops. So I have 25, 24, and 23. Do I have 22 here in the middle? No. So what is the current streak? It's 3 days. It's today, yesterday, and the day before that. Why is this not there? Why is this not included inside of the current streak? Because there is an interruption. I didn't go for a walk on June 22nd. But we're not done yet. Let's go ahead and let's enter some other days in which I've actually gone for a morning walk. Let's say I went for a morning walk on June 20th. Then I went for a morning walk on June 19th. And then I went for that walk on June 18th. It should be 18. Now, let me take a look at this. So we successfully calculated the current streak. It's these 3 days. So this integer that this calculate current streak function produces or returns, what is its number? It's 3 because it's today, 25, 24, and 23. Why is 21 not included? Because there is a gap. So current streak is done. Now let's talk about the longest streak. But I'm still going to go ahead and I'm going to keep implementing this. But I need to add a lot of days. So if I keep adding June, that's going to be very long. This is going to go eventually on 2 lines. So I'm just going to get rid of UNE hyphen. I'm going to say J25, J24. That means June 25. All right. Just one letter and then a number. Very good. You can see it's just shorter. We have J25, J24, J23. That's the current streak, which is 3. Then we have this. So we have 21, 20, 19, 18. Let's add 17. And then let's see. I have 15. So there is another interruption, right? So there is one interruption here, which is J16. And then there is one interruption here, which is here, which is J22. Now, we said we calculated the current streak, but what is the longest streak? I'm going to keep adding these until I actually get to the point where I want to stop. So what I have in mind is I'm going to add 3 days, then I'm going to add a pause, then I'm going to add okay, so we have 5 days. Then I added an interruption. Next time I'm going to add 7 days. Then I'm going to add an interruption. So you can really see what the difference is. Now this is J, so 15. This is 14. Then I have J13, J12, J11. So that's 1, 2, 3, 4, 5. Let's add 2 more. J10, as well as J9, or I'm going to say just keep it 2 digits, J09. Now let me save this. Let's take a look at this. I'm going to zoom this in so you can really see what is happening. We have one set. Now I'm going to basically change these into batches. We find a batch of logs in which the habit was implemented. So one batch contains an interruption. So when there is an interruption, you have the first batch. So here, whenever we see an interruption, that's going to constitute the first batch. 25, 24, 23, 21. Okay, there we go. There is an interruption. There is no 22. So that's batch number 1. That's the first batch. That's the newest batch because that's what the slice returns. It returns descending, so newest. So that's the newest batch. Then let's go start the next one, the second batch. So 21, 20, 19, 18, 17, 16. Oh, we don't have 16. So this is the second batch, right? So in this batch, we have 5 items. We have 5 days, 17 to 21. Let's move to the oldest batch. So this is the newest batch. This is the one in the middle, but this is the oldest. It records the first day that I started implementing this habit. So I created this habit on, let's say, on June 9th, and on the same day I went for a walk. So that's the first day, aka the oldest day inside of these. So if I ask you what is the oldest, it's June 9th. What is the newest? It's June 25. I'm going to come back to these, why this is important and why do we need this, why we need this for longest streak. So when we saw that this batch actually is broken, we had 5. So this is the second batch. And now let's find if we can find another batch too. So 15, 14, 13, 12, 11, 10, 9. Oh, there are no interruptions. And this batch contains 7 entries. So we have 3 batches. And we find out which batch has the highest number of, let's say, members. And that's going to constitute the longest run. It's that simple. So how many batches do I have? Batches are characterized by interruptions. When you get an interruption, aka a day in which I did not go for a walk, then that constitutes a batch. How many batches did we talk about? We talked about 3. So 1, 2, and then 3. Which of these batches of dates contains more members or more dates or more logs? It's this one. This has 7. This has, okay, it starts from here. This has 5 and this has 3. So what is the name of the function? Longest streak, right? Which one is the longest? It's this one. So what does that actually mean in simple language? It means that when I started this habit, I went 7 days consecutively. So 9, 10, 11, 12, 13, 14, 15. That's 7 days in a row. No interruptions. But then on the 16th of June, there is an interruption. I didn't go for a walk. I wasn't feeling well or I had a headache or whatever. So that streak broke. I broke the streak. But that's the highest number of days that I've gone without breaking. That's 7. So that's the longest streak, right? So this is what we are trying to do. Now I'm going to copy this, both of these, and I'm going to put that here. Calculating the current streak is, I would say, easier because we talk about today or yesterday and then we go back in time. We go back in time until we find an interruption. And once we found an interruption, we calculate how many days there were before that interruption, and that's the current. But to be able to understand what the longest streak is, you need to take a look at the entire lifetime of the habit. The habit started on June 9th. Now, for calculating the current streak, I didn't go as far as June 9th. I didn't go that far. I just went to 21st. So I went 25, 24, 23rd, and then as soon as I reached 21st, I stopped. So take a look at this. I reached this and I stopped. And I did not count all these days. Take a look at this. I did not count all these days because it was interrupted. My run or my streak was interrupted here. But for longest run, I need to take a look at all of the dates, all of the interruptions. And then I need to find out which one contains more members. And that's the longest streak. So the way that we, now these slices, again, these are the ones that this repository operation gives us. Now I'm simplifying this. They give us habit log. I'm just saying, okay, they're going to give us completed date because that's what we are going to select from them. Now, here we have 2 ways of going about this. As you can see, this slice clearly is newest to oldest. And that's exactly how we calculated the current streak. Now, what we could do is we could start newest to oldest and do the same thing inside of the longest streak as well. Or we could reverse this. And in reversing this, what is it that we're going to get? So I'm going to write here, this is original slice from DB. Let me just copy both. This is going to be reversed slice. How would this look like? So all the items, this is too big. I'm just going to have to go one by one. J09, then we have J10, we have J11. The AI is very good in this, but I'm not going to type it. I'm not going to give it to AI. So we have 9, 10, 11. I have 12. And then comma space, J13, comma space, J14, comma space, J15. This is how much I care that you really understand. I'm just going to go writing this manually, and I'm too slow in this. J17, this should be 18. I turned off the numpad, so this is J18. So it's 17, 18, 19, 20, 21. Okay, J19, J20, and then J21. Then we have an interruption, then we go with J23rd, we go with J24th, and finally J25. Let's save this. Now we could go one of these two ways. We could select this one, and this is, I'm just going to call it original slice, DSC. DSC, that's in a descending order, and that's newest to oldest, or newest first. This one, we could change this to ASCD or ASC. What is the, I think it's ASC, right? If I'm not mistaken. And this could be oldest to newest. Why do we say newest to oldest and oldest to newest? Because we take a look at the initial or the first member of this. So the first member of newest to oldest is June 25. Isn't that the newest date? Do we have June 26th up until when I'm recording this? No, it's tomorrow. So this is June 25. That's why it says newest to oldest. But why do we say oldest to newest? Because the oldest date that we received inside of this slice is June 9th. Do we have June 8th? No. So June 9th is the oldest date. We could go either of these two ways in order to actually calculate the longest streak. Now we have already done this with the current streak, and I'm sure you can guess which way I'm about to go, the one that I actually spent time writing by hand, and it is this. So I want to show you a different way of going about this. I want to show you a technique in which you can actually reverse two slices in place. You can reverse this slice, I shouldn't say two slices, you can reverse this slice in place. So what we're going to do is we're going to go oldest to newest. Oldest means the first date the habit was implemented. And now let's get started with coding this. What is this function going to accept? It's going to accept a slice of logs. What is the type of that? It's models dot auth payload habit log user input habit log. What is this going to produce? All of this just for one number. Just for one number. Now, if the logs are empty, we're not going to bother with anything. So that's what these two functions share, one of the things. But what if logs are not empty? What if the slice of logs is not empty? Then what we're going to do is we're going to basically make sure that this newest to oldest is oldest to newest. Now keep in mind, again, this original slice is something that we pass to this calculate streak. That's what we pass. So inside of this calculate longest streak, we need to reverse this. Reverting these dates from newest to oldest to newest, it has to actually happen inside of this function. That's why I'm explaining this. So how do we do this? Well, there is a technique that we can go ahead and actually use in this kind of situation, and the technique is called a two-pointer technique. Why do we call it two-pointer? Because there are actually literally two pointers. One of the pointers is I, the other pointer is J. So one pointer starts, now keep in mind, we're talking about this original slice. we want to convert this into this reversed slice. So when we talk about two-pointer technique, we talk about this original. If it is already oldest to newest, we don't need this technique. We need it in order to make sure this is no longer newest to oldest, rather oldest to newest. We want to make sure June 9th is the first item of the slice. So how do we do this? Well, we create, in simple language, we create two things, two agents, as I would like to. For for loops, what I would like to do is whatever the for loops variable is, whatever it does, I just call it the loop agent. The thing that actually does all the works inside of the loop. So we have two loop agents. Now, why do we have two loop agents? Because one of them is going to start from the front, the other one is going to start from the back. And they're going to swap their items. So in the first iteration of the loop, and I is going to start from the front, J is going to start from the back. We're going to swap these two places. We're going to say 9, this is the first item that J contains. So J contains 9, June 9, and then J is going to tell J is going to tell I that, okay, I have this date 9. Give me 25 and I'm going to give you 9. So in the first iteration of this loop, what happens is this. This is going to be June 25. This is going to be June 9. That's the first iteration of this loop. That's what's going to happen inside of the loop. So first, I could say 1 is T iteration. You can see we swap two places. Let's go one by one so you can really understand what two-pointer technique is. Then we go to the second iteration. In the second iteration, now J, because inside of the for loop, we are incrementing the value of I and we are decrementing the value of J. So if I increment the value of I is going to move forward. So incrementing the value of I means I is going to move forward through the slice, and decrementing the value of J means J is going to move backward through the slice. So that's also something that you need to keep in mind. So J is now going to select this state. J is going to say, I have 10, give me 24. I give me 24, and I'm going to give you 10. And I is going to agree. So 10 is going to come right here. 24 is going to come right here. So that's the second iteration. Let's move on to a third iteration. So what I could do is I could get rid of these just to make this process a little bit faster. So in the next iteration, we're going to take 11 and we're going to swap it with 23. So 23 is going to be 11. And here, 11 is going to be 23. Now, we don't care if we get interruptions or not. That's not the point. The point is, for I and J, this is just a normal slice that you want to reverse. That's using a two-pointer technique. This is just a normal slice. So we reverse 3 items by now. Now we are we are at the 12, and here we are at 21. So here I'm going to write 12, and for 12, let me just come right here. Here I'm going to write 21. Whoops, that should be the next iteration. There we go, right? So we go one by one. 25, 24, 23, and now this should be 21. J21, and this is going to be J12. In the next iteration, what do we do? Please just bear with me. We're barely done, and then the code is going to be extremely simple to understand. So we put 13 right here. There we go. And then what did we have there? We had 20. So I'm going to put 20 here. Let's move forward. So now you can see we have 25. So I have 25, 24, 23, 21, and then 20, and then here should be 19. This is 19, and then 19 is 14. Let's go next iteration. We have 18 and 15, right? So this is going to be 15, and 15 is going to be 18. What do we do with the item in the middle? Now, if the number of items or members inside of the slice, they're odd, you don't do anything with this medal. It doesn't make any sense if you change this. So you can see here we have 2, 4, 6, 7 items here, 7 items here, and then we have 3 and then 4, 7 items there. So we have 7 plus 7, that's 14. But the total number of items inside of the slice is 15. So the middle item is going to stay in its place because you're trying to reverse this, right? And there is no other element to reverse this with. Very good. So I can see that everything is working fine. So how many iterations did it take? 1, 2, 3, 4, 5, 6, 7. It took 7 iterations to change newest to first into oldest, newest to oldest. So 7 iterations to change newest to oldest into oldest to newest. How many iterations? It just took 7 iterations. Now, how do we code this? This is extremely simple. We actually have like specific syntax for this. So since we are trying to create 2 loop variables or 2 loop agents, that's going to be I, j. Now, you need to provide their initial values. Where do they start? Now, we talked about that I is going to start from the front. The front is going to have an index of 0. So the first item inside of any slice, so this J25, I is going to start here. What is the index of that? Index of it is 0. That's how indices work. Now, I need to provide a comma. You're going to say, what is the value for J? Where is that? So this 0 is the value for I. You can see the order is very important. So I has the value that I specified as the first thing, and J is going to have a value that I'm going to specify as the next thing. And how do I separate these? Well, how did I separate I and J? I separated I and J using commas, and I'm going to separate their values using commas as well. Now, J is going to start from the back. That means J needs to have the index of the last item. A technique or a hack that we do in programming is, I'm sure you are familiar with this, we select the length of the array or slice, and as soon as we do -1, that's going to give us the last item inside of this array. And why does this work? Why does this work? So what is the length of this? Let's break this down. Length of logs, it's 15. But what is the index of the last item? What is the index of the last item? We know indices are 1 less than the length, right? Because indices start from 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I have 15 as the length. And if I do -1, I'm going to get 14. 14 is the index of the last item. Why don't I just write 14 is because the length of the logs slice is going to be variable. If you have 100 items, it means the length is 100. It means the index of the last item is 99. But if you have like 50 items, then the index of the last item is 49. So every time this logs is going to be different. That's why we write it programmatically. We don't hardcode these values. We want them to change when the logs change, because this API could be used by millions. They're going to have hundreds and thousands and like millions upon millions of habits. So should this be manual? No, it has to be flexible, programmatic. Now, so we have the initial value. We need to have the condition. What is the condition? So we say for as long as the condition is true, the for loop is going to run. Well, I'm going to say for as long as I is less than J, the for loop is going to run. And with this slice, this is going to be a little bit difficult for me to actually show you how this is going to look. But anyway, it's going to take a little bit of time. So in the first iteration, I is 0. J is, what is the index of the last item? It's 14, right? We say for as long as I is less than J. What does that mean? Is 0 less than 14? Yes. So the condition is true. We go to next iteration. In next iteration, I is 1 and j is 13. 13. So let me take a look at this. Yeah, so in the next iteration, I is 1, j is 13. Because j is moving backwards, we're going to reduce one number from it so it can move backward. And then what do we have? We have 1 and 13. Is the condition true? Yes. So we go to next iteration. In this, j is going to be 12, I is going to be 2. I'm not sure if this is going to work, but anyway, I'm going to keep moving forward with this. So far we can see I is less than j. Let's move to the next iteration. In this iteration, I is 3, right? And j is 11. So 3 is less than 11. And let me move forward so I can see that this is going to work or not. So this is going to be 10. This is going to be 4. This is, I feel like I'm making a mistake somewhere. This doesn't look good to me. But anyway, let's move forward. So in next iteration, this is going to be 5. This is going to be 9. This is going to be 9. And the next one, this is going to be 8. And this is going to be 5. This is going to be 8. And this is going to be 6. So 4. Sorry, this is 5. And this is 6. So 6 is less than 8. 14, 13, 12, 11, 10, 9, 8. 0, 1, 2, 3, 4, 5, 6. So we got 7 iterations. And it took 7 iterations. We say for as long as we're going to swap for as long as, maybe I made a mistake here somewhere. And so if I were to go to the next iteration, even though we don't have any other item to swap, let me just copy. I think this is okay. I think I just jumped the gun. Where am I typing? Come down, buddy. So this, in the next iteration, aka the 8th iteration, I is going to be equal to 7. J is also going to be equal to 7. Is 7 less than 7? No, here is where we're going to stop. So we're going to check the condition. We're going to check this condition. It doesn't hold true. This is wrong. Then we stop. We don't run the loop an 8th time. So the loop runs for 7 times. Very good. So I was right. First iteration. So this is the first. This is the second, third, fourth, fifth, sixth, and 7th. So in the 7th iteration, we know I is going to be 7 because that's 6 plus 1, right? We add that. And then we want j to move backwards. J is going to be 8 minus 1. That's going to be 7. Is 7 less than 7? No, that's why we stop. So now we want I to move through the slice from beginning to the end. That's why it's going to be j. Let me add it like this. So it's going to be I comma j. And then I is going to be I plus 1, but j, so whatever the value of I is, we're going to add 1 to it, but whatever the value of j is, we're going to subtract 1 from it. And the reason behind this is because we want j to move from the end towards the start, so that's subtracting the indices until you get to the start. And we want I to move from start to the end, that's adding indices so you can get to the end. And now the only thing remaining here is actually to swap these two values. So I'm going to say whatever value I has, I'm going to swap it with whatever value, as I said, we talked about that, right? Whatever value j has. Now, I swapped I with j. So What does that mean? It means what J has. So initially J has, what did J have initially in the first iteration? In the first iteration, J had 9th and I had 25. That's the first iteration. So I is now in the first iteration, I is 9, but J is not 25. Because if you take a look at this, we're assigning the value of J to I, but we're not assigning anything back to the J. So J is still 9th. We need to assign whatever I has to the J as well. So that's how we swap. I gives value to J and J gives value to I. Now here, J gives value to I, but I has to also give value to J. And how do we do that? Well, that's going to be inside of the same statement. Here I'm going to say logs. Now, I want I to give values to J. So that's why I'm going to do this. Now, this order is very important. There we go. So in the first iteration, J has 9. I is 25. We change the value of I from 25 to 9. In the same iteration, iteration 1, I, remember the initial value of I was 25, J was 9. So we change the value of J with 25. That is inside of I. So initially or essentially or conclusively, I at the end of the first iteration, remember at the start I was 25, at the end of the iteration, at the end of just one iteration, I is now 9. At the start of the same first iteration, J was 9. Now at the end of the same one iteration, J is now 25. And that's it. This is called the two-pointer technique. So that's why I actually took more time to explain this. Now, let's move forward from this. What I'm going to do next is we need to actually set some values. We're going to need to create, I'm going to call this current run. I'm going to create two variables. You could call them state variables. They're going to track of how many batches we have hit. And they're going to find out which batch, as again, a batch is specified by the interruption that comes in dates, which batch has the most amount of numbers or the highest amount of members. So that's current run and then longest run. I'm going to explain what the difference between these two is. So current run is the one that is the batch that we're currently running through. And since we have reversed them, now we talk about the reverse slice. So which batch do we get started with? With this batch. So 9, 10, 11, 12, 13, 14, 15. How many items? And then there is like that gap, 16. So this batch has 1, 2, 3, 4, 5, 6, 7 items, right? So current run is 7. Then what I'm going to do is I'm going to put that 7 inside of the longest run. For now, I think that the first batch that I'm trying to go through is the batch that has the highest number of members inside of it. So then this current run is going to take a look at the second batch because there was an interruption. So 17, 18, 19, 20, 21. How many items? 5. Remember, longest run was 7. Is 7 greater than 5 or less than 5? It's greater. So the second batch that we found, this actually doesn't have more items than the longest run. So far, comparing these two batches, our very first batch has the most amount of numbers. Let's go to the, can we find another batch? Yes, because there is an interruption right here. So the final batch that we can see here has 3 numbers. Do I update the longest run? No, because I'm looking for the longest run. And the longest run is the first one that I got. This is 5, this is 3. I'm not going to update it. So that's why we need to have these variables in order to know which batch has the most amount of members. Now, we need to get started with this logs slice in order to go through its elements and increase these two values. But the way that I'm going to get started with this is exactly the way we did it here. We need to know what the first date is because this is all comparative. This is all comparative. So the first date is June 9th. How do I find out what the batch contains? as long as there are no interruptions. So up until here, I don't have any interruptions. So that means that's the first batch. But in order to find the first batch, I need to know what the first day is. So once I find the first day, I'm going to add to it 1 day. Remember, inside of the current streak, we removed 1 day from it because we started at the newest date. Is there a newer day than newest date? No, there isn't. So we started with the newest date, and that is newest. The only direction that you can go in time is backwards. And from newest date, backwards is -1. That's how we went with the current streak. But for the longest streak, we reversed that. We started with the oldest date. Is there a day older than the oldest date? No. That's the oldest. That's why it's called oldest. So, which direction in time can you go? From the oldest date, can you go back in time, or you have to go forward in time? Since that's the oldest, the only direction you can go in time is forward. That's why we're going to add 1 to that day. But to what day? To this first item. So here, I'm going to say previous date. You can see it even has the same name. The reason that it is previous is because this is something that we just calculated. This is always going to refer to the date that we have already calculated. And how do I select the first item of a slice? I'm going to pass in 0. So what is this going to give me? This is going to give me June 9th. Now, I want to move forward in time because I cannot go backward. How are we going to go? How are we going to do that? First off, let's select what date is necessary. Do we take a look at completed date, created at, or habit ID or ID? We just take a look at the completed date. I'm going to change this to, you know what? I'm not going to change this to anything. Let's just keep it. Let's just keep it as it is because, you know what? Let's change it. UTC. And then I'm going to truncate the time component away from this. Truncate, that's 24 times time.hour. So now this just gives me 1 date. And that is, what is that? That's the first member of this reversed slice. Remember, we reversed the slice in place. So that's this item. Now let's jump into the loop, into the most important loop. So I'm going to say for. Now, we just want to have one agent that starts at the start of the loop and at the start of the slice, and it goes to the end of the slice. But I'm going to copy this. I'm going to put it on top of this loop so we can actually have this as reference and we can keep going back to this. That's why I said we need to have a standard. It's easier this way. So we start I. What is the value of I? What do you think? Should I start from 1 or should it start from 0? It should start from 1. Why? Because we already talked about 0 right here. We got 0 and we put it inside of the previous date as the standard of comparison with the other dates. So 0 is right here. And when I say 1, 0, these are indices of the items inside of the slice. Indices. I selected the first index, which is 0. Do I duplicate my code? Do I do that again? No, I start from the next index. So June 9th is stored here, the index of which is 0. The next item is June 10th. What is the index of June 10th? It's 1. So that's why we start with 1. What is the condition? We're going to go as long as 1 less than the length of the locks. And we talked about this extensively. I'm not going to explain this again. And because we move from forward to backward, like from front to end, we go plus plus. Now, in the first iteration, what do I get? I get this. So logs. Now, instead of passing 1 and then passing 2 and then 3, we just pass in I. Initially, in the first iteration, I is equal to 1. What do I select from that 1? Now, keep in mind, I represents one individual item inside of the slice. So when I represents one individual item inside of the slice, I should have access to what? I should have access to the completed date. Why don't I have access to it? Let me see. For I is less than the length of the logs. Oh, this is a comma. This shouldn't be a comma. This is a semicolon. Very good. Now, because the syntax was incorrect, I'm going to do dot. There we go. We have completed date. And I'm going to do this UTC truncate again on that. It's not worth discussion. So what is this going to give me? We know I'm going to just explain the first iteration, and the rest is going to be exactly like what we did here. It's exactly this. Up until here, it's the same thing. But here we do one more thing and then that's it. But the rest is almost the same thing. But here, since we talked about newest, we went back in time because that was the only direction. Here we say oldest, we go forward in time. And that's it. That's the only difference. So the first iteration of this loop, I is 1, which date is that? That's J10. Okay? Now I'm going to store this J10 inside of this variable. And I'm going to call it log date. It contains J10. Now, what is my intent? My intent is to compare J9th with J10th to know if there is any interruption or not. How do I compare? Where is J9? J9 is included here. See? 0. It's included there. Where is J10? J10 is included here. How do I compare these? Well, I'm just going to compare them. I'm going to select the previous date. I'm going to move it forward 1 day in time using add date, 0 for year, 0 for month, and 1 there. And that's going to give me something that's called an expected date. So, given we are in the first iteration, what is previous date? Its previous date is J9. I'm going to go 1 day forward in time. Come on. What is that? That's +1. What is this going to give me? This is going to give me J10. Now you can see, here I have J10, here I also have J10. How do I compare if these two are the same thing? Well, we have another method for this. I'm going to say log date dot equal, remember, and I'm going to pass in the expected date. Expected date. Now, this is going to be an if statement. If these two dates are the same thing, which one of these am I going to increment? Now keep in mind, we're taking a look at these batches individually. So I'm going to increment current run. I'm going to select current run and I'm going to increment it by 1. Now, current run's value is 1. If I increment it by 1, it becomes 2. So that means the longest run in the first iteration of this for loop, the longest run in the first iteration of the for loop is current run. But that's not correct. It should be longest run. So if current run is bigger than longest run, we're gonna change the value of longest run to the current run. And that's where the entire thing is. So if current run is bigger than longest run, then we're going to say longest run's value is equal to the current run. Very good, right? So let's save this. What is this? Compiler, expected date. Let me just pass that there. Very good. So this is if these two are the same. Now, if these two are the same, what is the value of longest run at the end of this if statement? Right here. It's 2. Where does that 2 come from? See, June 9th, 1, June 10th, 2. Isn't that 2? Isn't that correct? It is correct. So we go to next iteration, next iteration, next iteration, next iteration, next iteration. And then we have seven iterations of this loop. Now keep in mind, we are not reversing this loop, therefore we need to go the entire length of the loop. So by the time we get to the 7th iteration and we're done, what we have is current run is going to be 7, but longest run is going to be 6. So we add 7 to as the value of this longest run, and longest run is going to be 7. And if we go to the next iteration, which is the 8th iteration, what is the value? It's 17. So what is this going to give me? This is going to give me J17. But the previous date always contains one less than that, or one more than the previous date. So previous date is going to be J15 plus 1. What is the expected date now? It's 16. What is the log date? It's 17. Is this condition going to hold true? No. Therefore, we're going to go into the else clause. As soon as I jump to the else clause, that means I have hit the end of one batch and the start of the next batch. So when I hit an interruption, that means another batch is starting. And if there is an interruption, do we count two batches together? No, we don't. Here we have 7 items. This is one batch. That's why we said batch 1, batch number 2, and batch number 3. Why are these batches? Because there were interruptions. So interruptions separate batches from one another. And when batches are separated, current run is going to reset because it just encountered a new batch. And a new batch starts from 1, exactly like this first batch started. So here, current run's value is going to be updated to 1. But what is the longest run? The longest run is 7. Then we keep adding these. So, and you can see you have several days that are consecutive, 5 days. So 5 times this if statement is going to hold true, but is this if statement also going to hold true 5 times? No. No. We increment, we're in the first time that this if statement holds true. In the second batch, we're going to increment the current run to 2. Is 2 bigger than 7? We know longest run is 7 from the previous iteration. No. So this if statement is not going to run. We're going to go next iteration. So eventually, this current run is going to be what? It's going to be 5. Is 5 bigger than 7? No. Now, the intent of this function is to actually calculate how many batches there are and what batch contains the highest amount of members. The first batch contains the most members, therefore that is the longest batch. And this is how this for loop is going to work. Now, this previous date, it has to adjust itself to the date that is the start of the new batch. It has to adjust itself. And where is that coming from? It's inside of this log date. It's exactly what I did here. Because after, if I don't update this previous date, remember, previous date is always going to be it's going to be J9. It's always going to be J9. But in the next iteration, am I comparing? So in the first iteration, previous date is J9. We add to it, that's J10. So it becomes J10. We know that. But in the next iteration, previous date is still J9. We add 1 to it, it's J10. But we are comparing it with J11. Is J10 and J11 the same? No. So our calculations are going to be incorrect. So every time we run through this for loop, this is where the for loop ends. We need to keep updating the previous date so it stays in sync with the log date. So now previous date, after the end of one iteration, keep that in mind, is going to be equal to the log date. Save this. And now what do we do at the end? Well, this is going to give us one number. And that's going to be what? What do we return? We return the longest run. And that's it. That's it. So I have actually explained this a lot, like really a lot. I'm going to keep all the comments here just in case you want to have them for your reference or you want to go back and forth. So again, these two functions, they were more in the area of solving some problem with programming. They had nothing to do with our API. So we just wanted to solve some issues, and I wanted to make sure that I'm explaining everything in depth. The next step that we need to actually go ahead and do is actually create 2 field resolvers. Remember, we need to get back to our GraphQL API. One of the field resolvers is going to calculate the current streak. The other one is going to calculate the longest streak, and then we're done with this API. And it's time for us to actually jump into the schema resolvers file and take a look at the 2 of the remaining resolvers that we need to implement. we can see that both of them are habit resolver. So they're going to select one habit and they're going to produce either the current streak for that habit or the longest streak. Now, I'm going to close, you know what, I'm going to keep this open just in case we need this. We're not going to go into the mutation. So let me just, can I collapse this? Sometimes I just have to wait a few seconds for it. Then I can collapse it. So these two files, we are no longer going to need them. Let's jump into the schema.graphql. So we can see that the current streak, it is available on the habit, as well as the longest streak. So that's another sign for us to jump into the habit.go file to the habit resolvers file. So I can't still collapse this anyway. Let me close these two. I'm going to close this one. I'm going to keep this open for now. Let's jump into the habit.go file. On top here, we have the total completions as well as the previous ones that we have implemented, right? And I'm going to cut or basically copy them, and then we're going to cut them later. Put both of them here. These should be very simple for us to implement. The first one is the current streak. So where did we specify that current streak? That was inside of the utilities. But can we just call that and not pass it anything? No, we need to actually take a look at all of the habit logs for one specific habit. That's why I kept this open. Get habit logs by habit ID. So as soon as I pass in the ID of the habit, I am going to receive a slice that contains all of the logs, aka the completed dates for that habit. So that's inside of the habit log repo, and this was get habit logs by habit ID. And we have already talked about why we don't go into the context. So, and here the context doesn't even have this habit ID, so we need to just go ahead and use this object, and from there we're going to select the ID. Now what is this going to return? This is going to return a slice of logs and error. Now what about the error? The error is going to be the same thing. If error is not nil, then for the current streak, you can see here this is int 32. We're just going to return 0. But what if there is no error? Then we need to count how many, or basically what is the current streak. So that's going to be a count, and that utility is available on utils dot. So this is calculate current streak, and to this, what should I pass? Calculate current streak requires us to pass in a slice of logs. Now, where is the slice? We selected that right there. So from here, we just need to pass it into this function. That's it. So I'm going to pass that there, and it's going to calculate all of the logs for us. And this is going to return something that's called count. Now, whatever the count is, we are going to return it, but we need to actually change its type to int 32. And we already talked about the total completion. It's the same reason here as well. And for the error, I'm going to return now. So that's the current streak. It's going to be almost the same thing. For the longest streak, it's just the utility is going to be different. That is going to be calculate longest streak. We are still selecting the same repository operation, which is get habit logs by habit ID. The error is going to be the same thing. What we receive logs is the same thing. We pass that into the calculate longest streak on utilities. We get a count. We convert the count. That's it. So let me save this. Let's jump right here. We're going to get rid of this. And you can see there are no other resolvers here, no field resolvers or query, mutation user, whatever. So we're effectively done with all of the resolvers. The important thing now is actually for us to go ahead and check this. So I'm going to jump into the DB. We know that for John, we have these 5 habits. So I need to go ahead and log in with the John's account. There we go. This is John. I'm going to log in, select all of these. And then, so we're going to select this query. Very good. Let's jump into the header. And this part, I'm just going to replace with this token. Very good. So I'm just going to click on this. We can see we have total completions, which is 16. Now, we could select logs and their completed dates, right? But right after the total completions, we should have access to the current streak as well as, so let me hit enter. That's going to be longest streak. Let's hit enter and there we go. So what is happening here? What is happening here? Let's see. We have 16 entries inside of the DB, inside of the habit logs table. We have 16 entries in total that specify which days this habit was completed. On which days this habit was completed. What is the name of the habit? It's habit 1. So habit 1 during its entire lifetime was completed or was carried out for 16 different days. The current streak is 0 because we do not have any entry, we do not have any log for this habit for today and yesterday. So today is June 26th. You can see the newest log is June 23rd. So if log is not today and log is not yesterday, then that's not current streak. But longest streak refers to the longest that we have gone with the habit during the lifetime of the habit without having any interruptions. So we can see it says 10. So there should be 10 consecutive days in which or during which I have implemented this habit, but I've not had any interruptions for a maximum of 10 days. So let's see. So I have 1, 2, 3, 4, 5, 6. You can see there are 6 days, 7, 8, 9, 10. Okay, so that's one batch. Remember the batches that we talked about. But then where is 11 to 15? We don't have them. We start with 16. Then after 16, we do not have 17 and 18. We start with 19. So 19, 20, 21, 22, 23. That's 5. So we have 5 in this batch, no interruption, 1 in this batch, and 10 in this batch. Which one is more? Which one has more days inside of it? Well, the first one. So that's why the longest streak is that. And we can see it actually works perfectly fine. So now, if we were to actually create some more logs, I'm going to cut this. That is going to be mutation. That's going to be check-in habit. I should have copied that ID. I should just, copy this, put it on the top. What am I going to do with this? Let me just write the mutation, then I'm going to get rid of that query. So that's check-in habit. That's going to require habit ID, to which I'm going to pass this. And we could just select the completed date. Let me get rid of the query, cut it, send this, there we go. So if you do not provide a date, the date is going to be today. Very good. Now let's add one for yesterday. So that's going to be 2026. There we go, 6/25. But we still have interruptions, right? So we have one for today, one for yesterday. But now let's take a look at our query. So I'm going to put the query here and I'm going to cut this part out. Run this. There we go. Now the current streak is 2. Why is it 2? Because we have an entry for today and then we have an entry for yesterday. But then there is a gap. The gap is that number 24. That's the gap. So if I were to paste that and cut the query from here, add 24, now 25, 26, 25, 24 is connected to these others. Let's run this. So now I'm going to paste this. I'm going to cut this part out. I'm going to run this. There we go. Now immediately you can see current streak is 10. So you can see it's actually working fine. It is changing exactly as we expect it to change. Now let's paste that part and This is good. I don't have to like type anything here. I don't have to type a lot of things here. So now let's try to increase the longest streak. We can see the longest streak ends at 11, sorry, at 10. So I'm going to add 11. I'm going to run this. And then I'm going to add 12. I'm going to run this. Very good. Now let's paste that and cut this part out. Send this. There we go. You can see now longest streak is exactly 12. So I think that's it. That's for everything that I wanted to show you about this API. What we are going to do at the end is, just as a wrap up, I am going to create a new account. We are going to create habits, create habit logs, and then we are going to try to also test the deletion of the accounts. With the deletion of the accounts, I could test right away. Since I have 2 items here, 2 members, I should be able to delete their account and their habits, and subsequently the habit logs, everything should be deleted. So let's go ahead. Let's do that. That's mutation. That's delete user. And as soon as I just hit enter, because we are authenticated with the token of John, that should delete that user. There we go. So John is now deleted. As soon as I refresh this, John is gone. As soon as I refresh this, these are all habits that belong to John. The habits are not gone for some reason. Habit logs are not gone. 23. Why? What is the reason? Even though I deleted John, let me take a look at the code. There is nothing. So we have actually tested this. User not found, delete. We tested this and it worked. Let me take a look at here. Select everything from users. We just have 1 user, and now we're going to select everything from habits. We still have these habits. So this is what I called like the orphaned habits. So these habits, they belong to someone whose user ID ends with 023, but we do not have that user inside of the DB. I'm going to try to, let me just come into error, close the server. So close this, clear this. Let me take a look at this. We have changed this code so many, and I don't see any error. So that's another issue with this. I don't see any errors. So it's very difficult for me to actually find out build errors log. Let me delete this. Repository utils, let's collapse that. Collapse the repository, the models, the middleware. We know that all of these, they actually worked. So I'm just going to collapse all of these. I could collapse the internal and the migrations. This is our script. Everything should be fine. Let's see. So we're trying to build this again. Playground. Very good. Let's log in with the information for Bob Smith. So that was Bob-Smith, right? Invalid. What is B-Smith? Okay. B. We can see this actually works. So there we go. Let me copy this. I'm gonna go to delete user. Pass that there. And there we go. So the user is deleted. There shouldn't be this user. We have these orphaned records. Now, I need to actually create a different user. Then we can just create a habit and delete all of the habits. I could run the migration. So let me do this. Migrate. So down. Let me see. Yes. All of the migrations. Now it deleted everything. We don't have these tables anymore. So if I just click on this, we don't have these tables. Refresh. There we go. We don't have this table anymore. And I'm going to run the migration, create these tables. Perhaps there is something that I'm missing. So now we have these. Now let's get started from the beginning. We are going to have register. I'm just going to test it with 2 accounts. The second account is just going to be so we know that one user cannot access the other user. So one is going to be Jane Smith, and then the email, the same email, jane-smith@test.com, and password is going to be pass@123 @123. Let's take a look at the name only. Let me add that inside of curly braces. Name. Perfect. Is the server running? No, the server is not running. Let's make sure server is running. Very good. Let's send this. Cannot field name on type. We could return token, right? What do we return from this register? It's just the auth payload. Okay. I'm just going to return that. Very good. So this is Jane. We created that account. That's user. There we go. This user is created. I'm just going to take a look at their user ID. Very good. I'm going to open habits and habit logs. Next up, we are going to create another account that is going to be John Smith. And much like before, that's going to be J Smith. Very good. Now, this is going to be login. First, I'm going to log in with John's account. We just have these information. I should be able to select name. Or just the token is enough, right? I don't need name here. String. Okay, very good. It's been so long, like I've been recording at least for, let's say 2 months, at least 2 months. Actually, this is the 3rd month. I just paused the video and checked it. So I've been recording videos for the past 3 months. Yep, April, May, and June. This is the end of June. So this is the 3rd month. So forgive me if I forget something. There's just after 3 months of interruptions, not being able to film this, you just kind of and have all the other things in life, job and family. So it just, you tend to forget everything. So what am I trying to do here? I'm trying to log in with this account. So I'm going to send this. I am going to get this. Now we are trying to create a habit. So that's create habit. Habit is going to have name. So that's habit 1, John. So I know it belongs to John. And the description for this is going to be description. Let me put that on another line. This on another line. I'm going to create 2 habits for each of the users. I think that's going to be enough. Habit 1, John DSC. Yeah. Let's just select the name. And we need to change this token. Let's run this. There we go. Habit was created. So if I come right here, we're going to see the habit. This is habit 1, John, and that's the description. Now let's change this to 2 and 2. Doesn't matter what the details of the habit are. We just want to create these two habits. Now I'm going to create the logs, then we're going to jump into the Jane's account because we are already authenticated here. So check in habit ID. We have already tested the total completions and everything. I just want to like test the update, this deletion of the account. Why didn't it work? I want to take a look at that. So check in habit, we are going to pass in this. Let's pass in habit 1. That's enough. So I'm going to pass that there, and this is, what are we going to select from this? Let's just select the completed date, which is going to be today. And then I'm going to add 2 more days. That's date 2026-06-25 and 1/4/24. Very good. Now let's log in with the Jane's account. That's going to be Jane-Smith login. Copy the token. Put it right here. Now, what is it that we want to do? Let me Control Z. We want to create habit for Jane. Habit 1, Jane. Send this, there we go. So we have one habit also for Jane. Let's create the second habit. And then we're going to create, so we should have something inside of the logs. Very good, very good. So you can see it's getting actually populated. And then we're going to have check-in habit ID. I'm just going to select the completed date. So refresh. This is a Jane account. Let's select the second habit of Jane to create logs for. The logs are going to be, let's put them on the same day. It doesn't really matter. That's 2026-06-25 and 24. Very good. Now let's try selecting a habit. So here is where I'm going to select a habit that belongs to John to try to create a log with Jane's account. So this habit, this belongs to John. There we go. You can see it says habit not found. It cannot do that. So habits are also secure. You cannot do that. We have already tested this token. So if I cut this, if I run this unauthorized, if I change anything inside of the token structure, it's going to say invalid authorization header format. So these errors, we have tested all of them. It's time for us to actually go ahead and delete user. So hopefully this time, if something goes wrong, we're going to see some error. So now we should see that Jane is gone. We just have John here. If I refresh this, there we go. Jane is also gone. We just have two habits. Both of them belong to John. And now if I refresh this, oh, nothing is added here because when I refresh this page, we added 3 for John, but when I added 3 logs for Jane, I didn't refresh this page. So this page doesn't actually change. But clearly you can see that the username ends at F44. So if I come right here, that's the habit ID F44, and these belong to this habit which belongs to John. Now we can further test this. If I were to log in with John's account to delete, let me log in first to delete the account of John, copy that, put that there, and that's going to be mutation, delete user. I'm going to run this. There we go. So now if I refresh this, user is gone, refresh this. Because we have that foreign key relationship, their habits are also gone. And once the habits are deleted, we can see the habit logs are also deleted. So we have effectively done that. Very good. So I think this is going to be it with for this API. I really enjoyed creating this video, even though just the recording of this took close to 3 months, like I would say like 2.5 months. It's going to take a few more days for me to edit this and upload this. But anyway, we covered a lot of things in this API. And during the last few minutes, we talked about the functionality of the API. We saw that there was some issue, but as soon as I ran the migrations, the down and up migrations again, perhaps that was just some leftover issue, because we have run gqlgen several times. So I just refreshed everything, and you can see it's actually working fine. And we talked about a lot of things. This video is like a way too big of a video that I intended. And for all of the code, everything is available for you. Of course, everything is like what I do here on YouTube. It doesn't matter how much effort I put into it. I never sell the code. That was never my intention, and that will never be my intention on YouTube. We're going to go from top to bottom with all of these files. So we had this main file, we had the DB file. These guides are very important. You're going to have the ability to actually like not write all of these commands that we ran one by one. You can just select these from here. We had the internal, where we spent most of our time here. We explained all the details of all of these files. We went with the graph. Graph was the most important, most difficult one. This is the middleware, the models, the repositories, the utilities. We talked about a lot. We talked a lot about the migrations and that script, and of course all of the other files that we have here. So with this project has come to an end. I hope you have enjoyed this video and you have learned valuable skills from it. That was the intention. When I write code for a tutorial and when I go ahead and record that, it's just everything else is blank, and it's I don't have to think about any other issue or problem in my life. It's one of the best times of my day when I get to actually write code for some tutorial or some video, and actually especially when I start talking about it and I start teaching it, that's actually the highlight of my professional day. So I really enjoyed creating this video, and I hope you learned something from this. If this video helped you in any way, I request that you hit that subscribe button and stay tuned for future videos. So I do wish you the best in life and career, and I'll see you in the next one.